Hello everyone, and welcome to this lecture on the collections module. So the collections module is actually my personal favorite built-in module, and it implements a bunch of specialized container data types. So we'll be learning about these various data types, and they're going to be counter, default dict, ordered dict, which is just an ordered dictionary. We'll look at a little more into quality of an ordered dictionary, and then we'll also look into named tuples. Alright, so let's go ahead and get started. As always, the Jupyter Notebook's available for you in case you want to read the notes along, but we'll go ahead and get started with the live code. Okay, so we'll start off with counter. So counter is basically a dictionary subclass which helps count hashable objects. And let's see how it can be used. So the first thing we're going to do is say from collections import counter. Okay. Now that it's imported, what we're going to see is that inside of the counter, its elements are stored as dictionary keys, and then the count of the objects are stored as the value. So let's go ahead and make a list here. I'll call this list L. And I'm going to put in a bunch of numbers, most of them repeated. Doesn't really matter here, but you'll see how counter works when I call it on that list L. So now what counter does is it counts the number of occurrences of each of these objects or elements in that list. So 2 showed up 5 times, 1 showed up 4, 4 showed up 4, 3, 3, 5, 3, 12 once. Okay, so that's so you can quickly count the number of elements in a list, and it basically acts as a dictionary. So let's look now at counter with strings. So I'm going to make a string S, and it's going to be a bunch of random letters here that I'm quickly typing, and then I'm going to call counter on S. And what that's going to do is count, again, the number of elements in this iterable here, which is a string. So S shows up 9, A shows up 6, B shows up 6 times, V shows up 4. Okay, now let's work with counter and the words in a sentence. So let's say you wanted to count how many times each word shows up in a sentence. So I'm going to make a string and say how many times does each word show up in this sentence? Word, show up. Well, shoe up. Put in show. And then we'll stop that there. Okay. So if I wanted to count the number of words and how many times they showed up, I could do this. I could say words. We can go ahead and split that string by white space, and then call counter on the words object that I just made. And note now the counter is going to be this dictionary that has counted up the amount of times each word has shown up. So that's going to be really useful if you ever find yourself trying to parse through some sort of text or even doing natural language processing techniques. Okay, now let's look at methods of counter. So if I say C is equal to counter of words, I can actually call various methods on it. So I can say, hey, what are the most common words? And then I can pass in an argument here. So I could say, show me the 2 most common words, and it'll return this list of tuple pairs. And I can even ask for the 3 most common words, etc. So I'm going to hop over to the Jupyter Notebook and walk through some common patterns that might be using when you use the counter object. So one of them is just the sum of the values. So you'll get the total of all counts. So if I go back here and ask for the sum of C.values, that will tell me the total words in that string. We can also do some other methods that I actually won't implement here because they might interact with each other. You could reset all the counts by calling the clear method on that counter object. You could call list on that counter object to get a list of the unique elements. You could call set to convert it to a set. Sometimes you may just want to convert it into a normal dictionary. You could call items on the counter object, and that will convert to a list of these elements and count pairs. You can also call the dictionary on list of pairs and counter, and that basically will convert from a list of element count pairs. Instead of to, it'll convert from. So you'll have basically this list of pairs, which you get out of C items. You could call a dictionary on it and call counter on it, and this is just the inverse of the C items. Then again, like I mentioned, you have most common, and you can actually use string indexing to get the least common elements with this sort of notation. So this notation will allow you to get the n least common elements. So you'd plug in whatever number you want there for n. And then finally, you can also remove 0 and negative counts by using this notation here. Okay, so that's it as far as the counter object. Up next in this section, what we're going to be learning about is the default dictionary. All right, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the second lecture in the collections module part of this section. So what we're going to be learning about now is a default dict, which is a dictionary-like object which provides all the methods that come from a dictionary, but also takes in a first argument as a default data type. And I'll show you what I mean by that in just a second. The most important thing to note is when you're constructing a default dictionary, it will never raise a key error. If the key doesn't exist, then I'll get the value returned by the default factory condition that you provide. So I'll show you what I mean. Let's go ahead and start by importing it. So we'll say from collections, import default dict. There we have it. All right, so let's see what happens if we start with a regular dictionary. So I'm going to make just a normal dictionary. I'm going to have a K1 string key with a value of 1. So there's our normal dictionary. If I call K1, I get the value 1 out. But let's say I call a key that's not in there. Let's say I ask for key 2 or K2. Notice we get an error, and we get a key error. So now let's see how that would work with a default dictionary. So the way I would create a default dictionary, I'll again call it the variable d. I call default dict, and here I'm going to pass in object. Whoops. Default dict. Okay. So now, if you notice, if I were to put in a key that doesn't exist in this dictionary yet, and remember this dictionary D, or default dictionary D, doesn't have any keys, I haven't assigned it any, and I call one, it will assign whatever the factory condition here for that value is. In this case, it's going to be an object. So if I say for item in D, print item, notice we do have a key there of 1 now. So we can also use this to initialize default values. And you can usually use that in conjunction with a lambda function. So I can say d equals default dict. I'm going to pass in a lambda function that will take in any arguments and just return 0. So it actually doesn't even really take in an argument, it just always returns 0. Okay, so that means if I assign a 1 here without actually putting an equal sign there, that will automatically assign, using the lambda function, a 0 there. And if I put in another key that says, let's say 2, then that also works. So now if I print out my default dictionary, I have a default dictionary, has this function, which is a lambda expression, which always returns 0 if there is no assignment there for that key. So 2 has 2 since I assigned it. Since I didn't assign 1, instead of throwing a key error, it goes by the default that you pass, which in this case was just return a 0. So I hope you can see now why the default dictionary is so powerful. Since it won't ever respond with a key error, it'll just create one with whatever the default condition was when you passed it. Okay, so that's it. Go ahead and check out the documentation for default dictionaries in case you want to learn more. But the main takeaway here is that it won't throw a key error. Instead, it will initialize with the default value that you place when you create the default dictionary. Okay, up next, we'll learn about ordered dictionaries. Hello everyone, and welcome to the ordered dictionary lecture. So in the last lecture we covered the default dictionary, and now we're going to cover the ordered dictionary, which is a dictionary subclass that actually remembers the order in which the contents are added. So if you remember when we were covering dictionary, they were mappings and they didn't retain any order as to how you added the keys or values to the dictionary. But with the ordered dictionary, you will retain the order. So let's go ahead and check out what a normal dictionary looks like. So if I create a normal dictionary using curly brackets, and then let's assign a key A to have the value 1. We'll assign a key B to have the value, let's say 2. Need to close off. And then finally, C to have a value 3. So if we take a look at that dictionary, we have A, B, C, 1, 2, 3. I'll do a couple more just to make sure there is some mixing up of the order in the mapping eventually. Tab 5. All right. So now if I say for KV in d.items, print KV, notice we don't get the order that we put the items in. So we get 1, 3, 2, 5, 4. So the order is being mixed up because a normal dictionary is just a mapping. It doesn't retain the order. But if we import an ordered dictionary from the collection, so we say from collections import order dict, we can say D is equal to an ordered dictionary. And now we're going to do the exact same thing. Copy paste this here, add the elements in that order, and you'll notice when we say for key value in D items, print key value, the order is retained. So something that's interesting with this sequence order is that since the regular dictionary only looks at contents when testing for equality, an ordered dictionary will also consider the order of the items as they were added. So for example, if I were to make a dictionary, let's say dictionary is D1, and let's put in A equal 1 and have B equal 2. Then I'm going to make another ordered dictionary. It's going to have B equal 2, D2 of B equal 1, of A. Alright, so you notice these dictionaries, as far as their key value pairs, are the same. So if I print D1 equal D2, it'll return true. But if I make these dictionaries not normal dictionaries, but ordered dictionaries, so I'll make D1 an ordered dictionary, I'll make D2 an ordered dictionary, and then run this Boolean statement again, it's going to be false because they were added in a different order. So it's definitely something to keep in mind as you work for ordered dictionaries, that technically speaking, these two ordered dictionaries are not true, or are not equal to each other. But if they were just normal dictionaries, they would be equal to each other. Okay, so up next, the last thing we're going to cover as far as the collections module will be the named tuple. Alright, I'll see you at the next lecture. Hello everyone, and welcome to the named tuple lecture. So in this lecture will be the last lecture in the collections module series, and we'll be learning about the named tuple. So let's first start out with a standard tuple. So if I say t is equal to parentheses 1, 2, 3, and then I can use indexing to grab elements from that tuple. And for most cases, that's usually enough. However, remembering which index should be used is sometimes hard to remember. So if you haven't seen this tuple in a while throughout your code, you may not know which index in case these values are each associated with a particular element or variable throughout your code. So especially if the tuple has lots of fields and it's been constructed far away, using just a normal tuple may lead to errors. So what a named tuple does it assigns names as well as a numerical index to each member in the tuple. And the way I like to think of tuple is that basically each kind of named tuple is almost like creating a class very quickly. So it's created by using the named tuple factory function. So I'm going to say import collections. Actually, let's just import from collections. So I'll say from collections, import named tuple. And then I'll show you the context for creating a named tuple. So I'm going to make dog, and I'm going to capitalize this because you can think of this as just quickly creating a new class. You call named tuple, and then there's going to be two arguments here. The first one is the name of the class that you're creating. So I will say it will be called dog. And then you're going to pass a string with the various attribute fields. So these are almost like the self.attributes of a class. And it's a bit strange as far as the syntax, but you pass it all as one string with spaces in between the names of each attribute. So a dog can have an age, a breed, and a name. Okay, and then I can create a dog just as if I had created a whole class for this. So I can say dog with an age of 2, a breed of, let's say, lab, and the name this dog has is Sammy, and I'm assigning it to the variable Sam. So just as if we had created an entire class with attributes, the name tuple basically acts the same way. So I can say Sam age as an attribute, call it off, and I can say Sam dot. Notice if I click tab here to see all the various methods, I have all the attributes, age, breed, and name, and then I also have count and index because it still has those tuples since it's a subclass of tuple. I can also just call by index if I remember what the index is for age. So 0, 1, 2. All right, so that's it for named tuples. So let's go ahead and do a quick overview by creating one more example. So remember, a named tuple is just like a normal tuple, except that it basically creates a new object type and it allows names for the various fields. So I can make another one called cat. It'll be a named tuple. The object type will be called cat. And then I pass one string with spaces in between the fields. So I can say fur, claws, and let's also pass name. So now that I've created my name tuple, I can make a cat object. I'll just call it C. And I can create a cat, and I will assign it fur will be, let's say, I don't know, fuzzy. Claws, let's say claws is a boolean, so I'll say false, no claws. And we'll put the name is equal to kitty. All right. Now if I just type out C, it's a name tuple, which is the object class cat, has fuzzy fur, no claws, false for claws, and the name kitty. And again, I can call attributes off of it, or I can use indexing as well, just as if it were a normal tuple. Okay, I hope you find as you advance more in your code that name tuples are a really nice quick way to assign variables and field names to where a situation where a normal tuple might get confusing or you might lose track. So this is the final lecture in the collections module. I hope you found the collections module useful. Go ahead and, if you want, Google Python documentation collections module, and you'll find a ton of more information, but the main ones you should know are named tuple, counter, ordered dictionary, and default dictionary. There's also decks, which are like a list-like container with faster appends and pops on either end, but you can go ahead and check that out on your own in case you're used to it from any computer science background. But again, like I mentioned before, collections is a super useful library, and I hope you find instances to use it in your code. All right, thank you, and I'll see you at the next lecture. Hello everyone, and welcome to this lecture on the datetime module. So Python is a datetime module that will help you deal with timestamps in your code. And the time values are represented with the time class, and they have attributes such as hour, minute, second, and microsecond. And they can even include time zone informations. So the arguments to initialize the time instance are optional, but the default of 0 is unlikely to be what you want. So let's go ahead and explore the datetime module. Okay, so first thing we're going to do is import datetime, and then let's go ahead and take a look at how we can extract time information from the datetime module. So we can create a timestamp by specifying datetime.time. So datetime.time, and the format goes like this. It goes hour first, so I'll put in let's say 5. Then it goes minutes, so let's say 5:25. Then seconds, so I'll just put 1 second. I won't put any microseconds. And next one would be microseconds. So I'm just going to put that in and call that my time t. So I created this time t, and then what I can actually do is say print t, and it prints the time, 5:25 and 1 second. And I can actually grab the separate components from it by calling those attributes. So I can pull out the hour, I can pull out the minute, I can pull out even those microseconds, which were 0 in this case since I didn't supply any. And you notice there's a lot of different things you can pull out here. The resolution, the time zone info, time zone name, those are all things you can add in. So if I look at datetime.time, notice I can pass in hours, minutes, seconds, microseconds, and then even time zone information, which belongs to a separate subclass. So something to note here is that a time instance only holds values of times, not a date associated with the time. So we can also check the min and max values a time of day can have in the module. So for instance, I can say datetime.time min. And so the minimum I have, if I print this out, is 00000, which makes sense, right? That's the earliest time you can possibly have. And I can also print out the maximum time, which is basically right before the 24-hour mark, which would bring you back down to 0. And then I can also check the resolution of a datetime instance by calling the resolution attribute. And so it can get down up to this resolution as far as microseconds. So the min and max class attributes, these reflect here the daily range, or the valid range of times in a single day. So now that we've learned about times themselves and timestamps, so hour, minutes, seconds, microseconds, and even time zone information, let's go ahead and look at dates. So we looked at the time part of datetime, and now let's go on to dates. Datetime allows us to work with date timestamps. So calendar date values are represented with a date class, and instances of the date class have attributes for year, month, and day. And it's pretty easy to create a date representing today's dates using the today class method. So I can say call a variable today, call datetime, and now I'm calling date, not time, off of it. And I can call an attribute called today, and then if I say print today, it'll say, in this case, October 6, 2015 is the day I'm actually doing this lecture. Okay, so what else can we check out? We can check out today dot a time tuple, which is just a different structure to have, and it basically is almost like a named tuple, and it gives you more information on the separate aspects or attributes of your date. What else can you do? You can actually call year, month, and day separately. So I could say today.year or .month or .day. You can call all those attributes separately. So as with time, the range of date values supported can be determined by the min and max attributes. So for instance, I could call datetime dot date and then check the minimum date possible. And if I print that out so we can see it in more layman's terms, there it is, 111. And then the max date you can ever have is December 31st, year 9999. And the resolution for a datetime.date object is 1 day. That's its resolution. So another way to create new date instances uses the replace method of an existing date. So for example, you can change the year, leaving the day and month alone. So I'll show you what I mean by that. I can create a variable called d1, call datetime dot date, and then let's go ahead and pass in the year, the month, and the day. And I'm going to go ahead and say print d1. So here we have 2015, March 11th, and notice I can use replace as such. I can say d2 equals d1 dot replace, and I'm going to say, whoops, d1 dot replace, and let's just change this year to, let's say, 1990. And now if I call d2, it's the exact same date as d1, except we replace the year with 1990. So this is actually a pretty useful method in case you just want to make adjustments on date objects that you already have. And real quick, what I'm going to show you is that you can actually perform arithmetic on date objects to check for time differences. So for example, if we just check back again what d1 equals, d1 is date time 2015 311, d2 is date time 1990 311. So I can actually perform arithmetic, so d1 minus d2, and it gives you the time delta. So this gives us the difference in days between those two dates. And you can use the time delta method to specify various units of times. You can ask it for days, minutes, hours, etc. So that's all there is as far as the basics understandings of using timestamps in your code. And if you hop over to the Jupyter Notebook, you can go ahead and check out some more examples, and it laid out in a little more detail here. So again, just to go over it, import date time if you ever want to deal with timestamps. If you ever want to deal with timestamps in the hour, minute, second range or microseconds, go ahead and use the time class on the datetime module. If you want to deal with dates, then you use datetime.date. And you can go ahead and read through the Jupyter Notebook or even the Python documentation to get more information on the various methods available in the datetime module. But other than that, I hope it's given you a basic idea on how you can use this in your own code. All right. Thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Python debugger lecture. So, you've probably used a variety of print statements to find errors in your code, but a better way of doing this is by using Python's built-in debugger module, and it's known as PDB. So we can go ahead and say import PDB, Python debugger. So the Python debugger module implements basically an interactive debugging environment for Python programs. And it includes features to allow you to pause your programs, look at the values of variables, and watch program execution step by step. That way you can understand what your program is actually doing, and then you can find bugs in the logic. Sometimes this is a bit difficult to show because it's basically going to require me to put an error into the code on purpose, but I'll use a simple example that hopefully illustrates just how powerful the Python debugger module is. It's something that's sometimes not taught to beginners at all, but it's really a really powerful tool to have at your side whenever you need it. So let's go ahead and try to implement it by creating a bug on purpose. So what I'm going to do is I'm going to go just make a list here. Let's just say x is equal to 1, 3, 4. We'll say y is equal to 2. And z is equal to 3. Then I'm going to set result equal to y plus z, so that makes sense. I will print result. And then what I'm going to try to do is make another variable called result2 that is y plus x. Now note here I'm trying to add an integer to a list, which doesn't make sense, but I'm going to assume it worked, keep going, and print result2. So what do I get here? I get type error, unsupported operand type S for plus ints and list. Okay, that's actually pretty clear, but in a larger code base, it may not be clear what's actually going on. So what you can actually do is with the Python debugger, set a trace. So what that would look like is you would come to the line where you saw your error and say pdb.set_trace, close parentheses. And now let's take a look at what happens when we run this module, or excuse me, this cell. So notice once the code runs up to where it hits that Python debug set trace, now I have an interactive debugging environment, and I can ask for values of variables to see what's going on. So for instance, if I wanted to check what X was, I could hit X, enter, and it tells me that X is the list 1, 3, 4. I could then check what Y is. I could then check what Z is. I can even do operations here. I can say, hey, what is Y plus Z? And I'll output 5. So it actually tells me what's going on, and I can do whatever operations I want on, whoops, since that's a list. So Y to the power of 2. It'll tell me an error if I try to do something that will pass an, or throw an exception, but it'll let me continue going with the debugger. And then if I finally figure out what the problem is, so let's say I was trying to do Y plus X, but it wasn't working, so I said Y plus X, and it outputted this error, and I say, okay, that's strange, well, what is X? And I figure out, oh, well, X is a list, now I have my error. Once I found it, I can then press Q, and it will quit for me. Alright. So that's just a pretty basic example. It's a little bit strange to use it in Jupyter Notebook, but it still works well for this a simple example. For more general debugging purposes and actually more techniques, you can go ahead and check out the Jupyter Notebook here. We break it down a little bit more of what's actually going on. And there's also a link here to the official documentation, which just gives you more general advice on debugging techniques. But the key here is almost always just setting this trace to right before where you think the error is occurring. And then when you run your code, use the debugger interactive environment there to try to find the source of your error. Okay, so that's it as far as the Python debugger. Remember, you have to say import pdb and then say pdb.setTrace in order to start up this interactive debugging environment. All right. Thanks everyone, and I will see you at the next lecture. Hello everyone, and welcome to the 𝗕𝗢𝗁 module lecture. So in this lecture we'll learn about timing your code and how to use the 𝗕𝗢𝗁 module to do that. So first thing you're going to want to do is check out this Jupyter Notebook. We go over two methods, importing 𝗕𝗢𝗁, which is how you would use the module in standard Python, and then we'll also look at a bit of magic functions that we can use in Jupyter with IPython. Okay, so let's go ahead and hop over to the live code. So the first thing you're going to need to do is import 𝗕𝗢𝗁. Alright, so now that it's imported, what we're going to do is use 𝗕𝗢𝗁 to time various methods of creating the string that looks like this. So I want to create a string that looks 0-1-2-3- all the way to -99. So we're going to use a bunch of different methods to make that string. So one way we can do it is by saying join, join the string n for n in range 100. Okay, so that's exactly the kind of string we want. So what's this doing here? It's saying for every n in that range, 0 to 99, go ahead and convert that integer to a string, and then join it with a dash in between. All right. So what we're going to do is now time this method. So now that we've imported the 𝗕𝗢𝗟𝗢𝗚 module, what we're going to do is say 𝗕𝗢𝗟𝗢𝗚. And what you do is you pass your entire expression, whatever it happens to be, as a string here. And then the second argument is the number of times you want to run this. So I'm going to run it, let's say 10,000 times. If you don't do enough times, it'll be too fast to get an accurate comparison to different methods. Okay, so this method took about 0.248 seconds. And it's going to be different depending on how fast your computer is. So don't be worried if you don't get numbers exactly like mine. Now let's try doing a different method with list comprehension. So we basically did a for loop in essence here. And what we're going to do now is try list comprehension. So I'm going to say try joining here and add the brackets to make it a list comprehension. Let's go ahead and run this. Let's actually run it. Let's run this as a separate line so we can keep everything in sight. So we'll run it as a list comprehension here. And notice it was a little bit faster. And what we're going to do now, finally, is try using the map function. So I'm going to do, say, .join. I'm going to map the string function to every number from the range 0 up to 100. And then what we're going to do is pass that in as a string itself into 𝗕𝗢𝗟𝗢𝗚. And the number of times I want this to run again, number equals 10,000 times. All right, now notice by far map is the most efficient way. So we can see that there's a significant time difference using the map function. So this is good to know, you should keep it in mind. But this is the way you would generally use 𝗕𝗢𝗟𝗓 in your own code if you weren't working in a Jupyter notebook. Now if you're working in a Jupyter notebook, the best way to do this is using Python's built-in magic. So we discussed built-in magic a little bit when we were going over Jupyter notebooks. But basically built-in magic is defined by a percentage sign. And it basically has 𝗕𝗢𝗟𝗓 built in. So what I'm going to say is 𝗕𝗢𝗟𝗓, and then just copy this method, and you don't need to pass them as strings anymore. And the interesting thing about 𝗕𝗢𝗟𝗓 is what it's going to do is going to perform the same code in that line a certain number of times. So it's going to do it through a couple loops. So in this case, it did it through 10,000 loops, and then it'll report back the best of 3. So in this case, the best was 28.9 microseconds per loop. Now remember, in this case, with 𝗕𝗢𝗟𝗓, it's telling you the total time it took to perform all 10,000 of those. Which makes sense if you see, 10,000 times whatever this number, or this number divided by 10,000, you have microseconds. All right, moving along, let's go ahead and use the magic function to test out the rest of these. So magic, percentage sign, 𝗕𝗢𝗟𝗓. And in this case, I'm going to check the list comprehension. And then what's really nice about using this magic function is that it gives you a better idea of how long it's actually taking to perform, on average, the command. With this normal 𝗕𝗢𝗟𝗓 method, you have to kind of decide a large number of times to perform it, and you don't get a good idea of how long each individual time is going. And if you're just doing 1 here on the number, you probably won't get an accurate average, unlike 𝗕𝗢𝗟𝗓 here. Now notice, this is where the magic function is really great. Here when we ran it with map, since map was so much faster than the other methods, Jupyter or IPython ran it 100,000 times through 100,000 loops instead of through just 10,000. So you'll notice if something takes a really long time to run, the Jupyter or IPython may just run it 3 times if it takes many seconds to run. If it's very fast, it will run it more times to get a better average. But basically we arrive at the same conclusion. The map function was the fastest method of them all. And like I said before, IPython will limit the amount of real time it will spend on its time-it procedure. So if you're running 100,000 loops that would have taken 10 minutes, IPython's automatically going to reduce the number of loops to something more reasonable, like 100 or 1,000, depending on how long it actually takes. Okay, so as always, there's the Jupyter Notebook with a more comprehensive breakdown of what's going on, and you can check out the documentation here for the time-it library. Go ahead and check out that link, and you can learn about a couple more methods and timers to use. All right, that's it as far as using time-it to time your code. I will see you at the next lecture. Hello everyone, and welcome to the regular expressions lecture. Regular expressions are text matching patterns, and they're described with some sort of formal syntax. So you'll often hear regular expressions used for finding repetition, for matching text, etc. And as you advance in Python, you'll see that a lot of your parsing problems can actually be solved with regular expressions. And they're also a common interview question. So if you're actually familiar with Perl, you'll notice that the syntax for regular expressions are really similar in Python. The module we're going to be using is the regular expressions operations module, which is just RE in Python. Here I have opened the documentation page for it. You can see it's pretty extensive, and there's a ton of stuff you can do with regular expressions in Python. We're just going to be going over the most useful functions it has. But again, I encourage you to check out the entire Jupyter Notebook that's associated with this lecture. But let's go ahead and get started with some live code so we can see how it works. So let's say I want to search for patterns in text, which is one of the most common uses for a regular expression. First thing I'm going to do is import the regular expression module. Next, I'm going to make a list of patterns. And these are just going to be two strings, term1 and term2. Then I'm going to make a large text string, and it's going to say this is a string with term1, but not the other term. So notice it has term1, but not term2. So how do you actually use the regular expression module? So one of the features you can use is search. So we can use the search method, and we can search for a particular pattern. So in this case, I could search for, just to show you an example, hello. And then the next argument you pass is the text you want to search. So I can say, hello world. I need to close off that parentheses. And notice how you get a match object. That's something I want you to keep in mind as we go throughout a larger example. So you're going to get a match object, and it's actually more than just a Boolean. So what I'm going to do now is hop over to the Jupyter Notebook and copy some code right here. And then I'll break down the code. You can go ahead and feel free to copy this code as well, just to save you some typing time. But what this code is going to do, it's going to say for pattern in patterns. So for every term in this patterns list, it's going to print searching for the pattern in that text. Then if search pattern text, so if that match object exists, then it's going to print match was found. Else, which means no match was found, it's going to print that. So if we go ahead and run this, you'll notice it was able to say searching for term1 in this string, match was found. Searching for term2, no match was found. Okay, so we've seen that the search method will take a pattern, scan the text, and then return that match object. If no pattern is found, a none is returned. So I can go ahead and check that out. I can say read.search, put in H here, and then give it a W, so there's no match. And we can go ahead and print whatever that is. You'll notice it's none. So a none is returned if there is no match. Now, let's go ahead and take a closer look at this match object. And what I'm going to do now is just say this match equals search of, let's just say patterns, the first term, and then the text string. And now let's check the type of that object, match. And you notice we get this match object. So it's actually a lot more, like I said, than just a Boolean. It also contains information about the match, including the original input string, the regular expression that was used, and the location of the match. So we can actually call methods on this match object. So for instance, I can say match.start, and it will actually tell me the index of the start of the match. So at index 22, the pattern started to match with the text. It can also show me the end, so I can say match.end, and likewise it shows me the index there as well. Alright, so that's just something to keep in mind as far as the match object that the regular expression module returns. There's a lot of methods, and I encourage you to go ahead and explore them if you find yourself needing to. So you can see there's a ton of methods here that you can use. Go ahead and explore those here or within the documentation. Alright, moving along, now we're going to see how we can split with regular expressions. This is going to be one of the most useful features of regular expressions. So it should look really familiar to you given the split methods we've already seen on strings. And let's go ahead and see what it looks like just purely in the regular expressions module. So I'm going to say split underscore term, which is going to be, let's say, at. And now I'm going to put a phrase in. So I'm going to say, what is your email? Is it hello@gmail.com ? All right. So let's say you wanted to split at this split term, at. So you can use the split method and say split term, give it the phrase, and it will return a list with the split, not with the split term included. So this should look really familiar given what you already know about splits in a string. So if I say hello world and I call the split method that string has built in, it's really similar. So the split returns a list with the term to split on removed, and the terms in the list are a split up version of that string. So make sure you can understand this example fully. So go ahead and create a couple more examples in case you're unsure of what's actually going on. The reason I chose the @ symbol here is that's sometimes an interview question as far as how would you split domain names from an email address. The answer is pretty much always regular expressions as far as one of the most efficient ways to do that. Now what we're going to do is move on and talk about finding all instances of a pattern. And with that, you can use the find all method. So I can say find all, and what it's going to do is return a list of all the matches. So for instance, the first thing you put is the pattern you want to match. So let's say I want to match the actual word match. And I'm going to put a string that says here is one match, here is another match. So right now there's two matches in that string, so it will return both instances of that. So find all will find all the instances of your match. So what might be interesting is then you can count the length of this and it will tell you how many matches there are in that string. Okay, so the bulk of this lecture is going to be on using the RE module syntax of Python. And what I mean by that is the regular expressions, it's going to support a huge variety of patterns that just simplify finding where a single string occurred. And we're going to do something called using meta characters. So let me go ahead and show you what I mean by that. Let's go ahead and jump back to the Jupyter Notebook because it's a little more clear there with some markdown text. So let's scroll down. Here we go. So finding patterns and this syntax, what does this actually look like? So before we began, as far as going through a different syntax, I created this function here, and it's called multi-refind, and it takes in patterns and then a phrase. So it takes in a list of these regular expression patterns and prints a list of all matches. So it goes for pattern in patterns, print, searching the phrase using recheck, pattern, then it says find all. Okay, so I'm going to go ahead and copy this function. You can go ahead and copy it as well and paste it here. And what we're going to be doing now is going through different syntax. And this is actually best explained through this IPython notebook. So there's repetition syntax. That's the first syntax we're going to be covering. So what I have here is repetition syntax, and there's going to be 5 main repetition syntaxes we can use. And they look a little something like this. You have a star, a plus, a question mark, curly brackets with 1 number, or curly brackets with 2 numbers. So let me break these down and how they actually work. And what I encourage you to do to get the most out of this lecture is just take your time and read the Jupyter Notebook, take the code like this, copy, and after reading the explanations in Markdown, go to your own live Jupyter Notebook, run it, and then check the results and make sure they make sense to you. So let's go ahead and start with the repetition syntax. So if you use a star or an asterisk, then what this basically means is take an S followed by 0 or more D's, which means basically take anywhere that starts with an S. So if we look at our test phrase, this particular pattern returned anywhere that started with an S. Then what the plus sign does, it says S followed by 1 or more D's. And I know this general syntax looks strange, but that's the way regular expression in Python work. So here we can see anywhere where there was an S followed by 1 or more D's. So we don't get all these single S's. Next output for repetition, or syntax repetition, is a question mark, and that will be S followed by 0 or 1 D's. So if we look at this, here's basically output of 0 or 1 D's, no more than that. So if you have these 2s or 3s, those don't show up in the question mark syntax. After that, there's curly brackets, which will just be allow you to specify how many repetitions you want. So this says S with followed by 3 D's, and this says S followed by 2 or 3 D's, and you can continue on as you go throughout your code. Okay, so go ahead and read over the general explanations for each of those, which are just basic explanations of what I just said, and go ahead and test out the code yourself here. So I know there's a lot to read here in the regular expressions, but the most important thing is that you just feel comfortable using this syntax: pattern, phrase, because you can always look up these exact test patterns as far as syntax later on in this Jupyter Notebook. So we went over the repetition syntax. So there's 5 ways to express repetition. And now what we're going to go over is character sets. So character sets are used when you wish to match any one group of characters at a point in the input. And we use brackets to construct character set inputs. So for example, this input for AB searches for occurrences of either A or B, which is a little weird because you might see brackets and think, oh, that's a list, where's the comma? But in this case, for regular expressions, there's no comma there. So here, you pass a string as a pattern with brackets, and it says either S or D. Look for either of those 2 patterns. So basically, everything where there's an S or D gets returned. And now I can add something like this. I can say S followed by 1 or more of S or D. So notice how I'm adding now repetition syntax to this here. And you can see the results here. So it's S followed by 1 or more S or D's. So it kind of makes sense that the first SD returns every instance, since it's just looking for S or D. And then the second bit will just return anything starting with an S in this particular case, since our input test phrase looks like this. All right. So moving along, let's look at exclusion. So we can use this caret to exclude terms by incorporating it into the bracket syntax notation. So, for example, bracket, caret, and then whatever terms you want will match any single character not in the brackets. So let's go ahead and look at some examples. So I have this test phrase that says, this is a string, but it has punctuation. How can we remove it? So I have a caret here, and then a bunch of punctuation, an exclamation point, a period, a question mark. I'm going to zoom in so you can see that. So here, what I'm doing is passing this caret, and then it's going to have exclamation, period, question mark, space, and then a plus sign. So remember, we add that plus to check that the match appears at least once which basically translates into finding all the words in that string, right? Because I'm saying return everything where this caret allows us to exclude those terms, which is just all the punctuation terms. So this is the kind of regular expression you can use to remove punctuation from a string. And note we get a list here that says this is a string, but it has punctuation. How can we remove it? Now there's no punctuation there. All right, we'll move along now to character ranges. So as character sets grow larger, typing every character that should or should not match can become really tedious. So what you can do is a dash expression. And I'll show you what I mean. So here are some test patterns we're going to check out. So let me zoom out so you can see them all. Whoops. Here we have sequences of lowercase letters. So we say A through Z. Here we have sequences of uppercase letters, capital A through capital Z. Here we can have sequences of lower or uppercase letters, so A through Z, capital A through Z. And then we can have, again, one uppercase letter followed by one lowercase letter. All right, so go ahead and then check this code out. You can go ahead and copy this and then paste it into your Jupyter notebook and check the results to see if they make sense to you. All right, so for instance, looking at this, this will return anywhere where a capital letter is followed by a lowercase letter. And these are the two results where that happens, this and let's. All right, so that was character ranges, which is basically just that dash notation. And then escape codes. So we've probably already seen a few of these, but something to keep in mind is you can use special escape codes to find specific patterns in your data, such as digits, non-digits, white space, and more. So for example, I've listed all these codes here and their meaning. So for instance, if you say find all and you put in this code /D, it'll think of it as a digit. /capital D is non-digit. Lowercase s is white space, capital S is non-white space. And then lowercase w is alphanumeric, capital W is non-alphanumeric. So something to keep in mind in strings, there already are escape codes built into strings. So for instance, if I say print hello \n new line, remember this \n is already an escape code telling Python, hey, this isn't an n, I want you to print this on a new line. So this is where sometimes regular expressions get hard to read. What regular expressions do, so that Python doesn't get confused that there's an escape character already in there, is it adds this R beforehand and then some single quotes. So if we look at this example, copy it and take it over to the Jupyter notebook, we can look for each of the test patterns. So this first one, /D plus, sequence of digits. So this will return any sequence of digits. Next one is going to return any sequence of non-digits. This is capital D plus. After that, we can get sequence of white space, non-white space. So here's all the white space, here's all the non-white space, and then alphanumeric characters and non-alphanumeric characters. So alphanumeric and then the non-alphanumeric. All right, hopping back to Jupyter Notebook. So you should have at least a solid understanding after completely reading this Jupyter Notebook. So I don't expect you to learn everything just from this quick overview video. But you should at least have a solid understanding of the general form. So you have a pattern and then the text you want to search. So if we look back to the Jupyter Notebook, it always goes like this. You have either the term, the split term, and then the phrase, or the pattern, then the phrase or text. So it always looks like that. Pattern that you're looking for, and then the text. And then where regular expressions really shine are all these basically special pattern codes that will look for like a sequence of digits, in this case, or this will look for a sequence of lowercase letters, etc. We can look at exclusions, character sets, and repetition. So I know that's a ton of stuff, and most people, unless you're using these regular expressions quite a lot in your work, don't memorize this. They will either look at a table or look at the documentation. So like I mentioned before, go ahead and take a look at the full documentation in case you ever need to look something up. And there's also a nice summary of tables at this source that I've linked to here, Python regular expressions, so you can check that out yourself. Go ahead and make sure you read through this Jupyter Notebook to fully understand regular expressions. But I hope this video helped you out as far as understanding the general syntax, where you have a read module, some dot methods, and then you check for the pattern and then the text. And then what makes regular expressions special in Python is that you have these various notations for syntax as far as exclusion, character sets, repetition, etc. And there's a lot more than that that you can check out in the regular expression documentation. Okay, thanks everyone. That's probably one of the most difficult lectures as far as the modules go. So I really encourage you to take your time and go through the Jupyter Notebook slowly. Okay, thank you everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the String I/O module lecture. So this is going to be a very brief lecture on what the String I/O module actually does, and then I'll let you go ahead and explore the documentation in Jupyter Notebook if you feel the need to ever use String I/O in your code. String I/O is sometimes confusing to beginners, but the best way to think about it is String I/O module basically implements an in-memory file-like object. And I'm actually not going to do any live code, I'm just going to walk through the Jupyter Notebook here. And then this object can then be used as input or output to most functions that would expect a standard file object. So the best way to show this by a simple example. So here you see I imported string IO and then created an arbitrary string with some message and says this is just a normal string. Now what's interesting is then I can use string IO and then you use the .stringIO method in order to create a file object out of a string. And we set that as the variable f, and then you can actually perform like read and write. So you can treat that object f just like you'd be able to treat a file. So you can say f.read, f.write, f.seek, all those things we learned back when we were dealing with files in Python in the very beginning of this course. So that's really all there is to it. You can basically just convert strings and be able to read and write to them as if they were files. So you can go ahead and check out the link here to the rest of the documentation. There's quite a few methods, and there's also a faster C string IO, which is just a C implementation of string IO, which will be faster, and it provides a similar interface just as string IO. So go ahead and check those out in case you ever need them in your code, but I can't think of any examples for you as far as typical code usage. Usually when you just are using string IO, it has to do with scraping from the web and trying to read strings from the web as files. So that's where you'll see it come into play during your code. Okay, so that's it for string IO. I will go ahead and see you at the next lecture. Thanks everyone. Hello everyone, and welcome to the Advanced Numbers lecture. So in this lecture we're going to go over a few more representations of numbers in Python, and then a few of the built-in methods that have to do with numbers in Python. It should be a pretty brief lecture, but an interesting one. So just going through the Jupyter Notebook, we're going to look at hexadecimal representation of numbers, binary representation numbers, and then a couple of built-in arguments, or excuse me, functions for numbers. So in case you're not familiar with hexadecimal formatting or binary formatting, I went ahead and linked the Wikipedia pages for both those formats, and you can check them out as far as the descriptions and how they actually work here. So I won't be teaching you what hexadecimal numbers actually are, what binary numbers actually are. You can go ahead and read about that on the Wikipedia page yourself. So I figure these two topics are only useful if you're familiar with the computer science topics or in your math classes and we're curious on how to do it in Python. So quick overview on how to do them in Python. For hexadecimal numbers, you can call the hex built-in function, and it will convert numbers into the hexadecimal representation of numbers. So for instance, if I call 12 there, it returns the hexadecimal representation of that number. And let's just do another one, such as 512, and there's another representation of it. If you're interested in binary representation of numbers, you can use the bin function, and that will return the binary representation of some numbers. So for instance, if we just go for some classics, such as 128 or 512, you can see those are the binary representations of those numbers if you're familiar with binary representation. Okay. Now let's go over some more common built-in functions. So we know that we can call to the power using 2 asterisks, but there's also a function for that. So you can call POW and it will do the same thing. If you put in 3 arguments, such as this, what will happen is the 3rd argument will be treated as a mod. So with 2 arguments, it's the equivalent of x to the power of y. X and y are your first and second respectively. But with 3 arguments, it's equivalent to x to the power of y mod z. And this just has to do with some efficiency cases, in case you're interested in why there's a whole built-in function for that. Now, there's also an absolute value function, which is ABS, which will return the absolute value of a number that you put into it. There's also the round function, and it will round a number to a given precision in decimal points. And by default, it's 0. So if I wanted to round, let's say 3.1, it would round it off to 0 decimal points. So for instance, to make it clear, if I also put in just 3, it rounds it off to 0 decimal points. Or if I put in 3.9, it rounds it off to 0 decimal points here to just 4. Okay. Interesting to note though, it always returns a floating point number, which is why you're seeing that 0.0 there. You can also specify how many digits you want after the decimal point. So for instance, if you had the longer representation of pi, let's say you only wanted to see 2 decimal places past the points, you can add that in as a second argument. Okay. That's really all there is for the advanced numbers. Should have been a pretty brief and straightforward topic. Main takeaways are there's the hex and bin functions for you in case you're interested in that. There's also these built-in functions, abs, and round, and also pow for power. And Python also has a built-in math library, which may be useful to play around in case you're ever in need of some more mathematical operations. Okay, and as always, here's the Jupyter notebook that goes along with this lecture for you to check out. All right. Thanks, everyone. I'll see you at the next lecture. Hello, everyone, and welcome to the Advanced Strings lecture. So string objects have a variety of methods we can use to save time and add functionality. And what we're going to do is explore some of them in this lecture. So let's go ahead and create a string called Hello World. And let's explore some different methods we can use. So let's start with changing case. So we can change cases to upper and lower case, and there's a couple methods we can use. One of them is the capitalize method, and what the capitalize method does is it capitalizes the first word in a string. We can also use the upper method, which you may have seen before, to uppercase every letter in a string, and then we can also use the lower to lowercase every letter in a string. There's also location and counting methods. So if I wanted to, for instance, count how many O's there are in a string, I can use the count method, and I can also find them. So I can say find the first occurrence of an O, and it'll return the index where that happens. There's also formatting methods, and these are a little strange, and they're also not used that often, but it still might be good to know them in case you ever run into them. First one we're going to talk about is the center method. So let's go ahead and check our string. It's still just hello world since we lowercased it again. And what the center method does is it allows you to place your string centered between a provided string with a certain length. So these are pretty esoteric, and I've actually never seen this used in code, but it's still a method you can use. So for instance, let's say you wanted to center your string, hello world, between a bunch of z's, and you wanted the total length of that string to be 20. Then this is what it would look like. So we centered hello world between z's, and the total length of the string is 20. Okay, there may not be too many use cases for that, and I've personally actually have never used it. This method that you may or may not use is the expand tabs method. So for instance, if I say hello t, and that will break it to a tab. Whoops. Let me make sure this is working. So this backslash t, when you print it, it will be an escape character for a tab. So it'll actually read hello tab hi. So this is going to be useful if you ever find yourself parsing through a lot of text data. And instead of having to print it, what you can actually do is just call the expand tabs method, and it will do the same thing. Again, not used that often. Let's go ahead and check out some other methods that check if the string is some sort of case. So for instance, I'm going to set a string just called hello, and there's a method called 𝗟𝗲𝗁𝗚, and this checks if all the characters in S are alphanumeric. And in this case, it's true. And what we can also do is just check if they're all alphabetic. So numeric doesn't count anymore. So we can just check is alpha, and that's also true. These are actually quite useful, and I have seen them used a lot, especially if you find yourself doing some sort of natural language processing techniques. Another couple of ways, or a couple methods we can use is lower, and this will return true if all case characters in S are lowercase, and if there's at least one case character in S. We can also check is space, and it will return true if all characters in S are white space. In this case, that's not the case, so it should return false. So is space, which will return true if all characters in S are white space. It's false since we have letters in there. Another method called is title. So we can check is title, and what that does, it'll only return true if S is a title case string, and there's at least one character in S. So uppercase characters may only follow uncased characters, and lowercase characters only follow cased ones. Another method is upper, and that will return true if all cased characters in S are uppercase. So is upper, this case it's false, but if I were to say, let's say hello, all uppercase, and then I asked is upper on that, then that is true. All right. One last method for checking cases is ends with. So I could check s.ends with, and let's say I wanted to verify that it ends with O. Yeah, and this is basically the same thing as just doing this, right? Checking if that last character in the string is equal to something, and it returns a Boolean. Okay, so now we're going to move on to some built-in regular expression operations. So strings have some built-in methods that can resemble full-on regular expressions operations. And one of them that's really commonly used is split. And we can use split to split the string at a certain element and return a list of the results. So let's check our string, which is hello. And let's say we wanted to split the string at E. Then split will return the result in a list, so everything before that E, and then everything after it. And remember, it only separates at the first occurrence. Excuse me, it'll actually separate at every occurrence of E. So just to make that clear, I'll show you an example. So if I have a string looks something like this, I could say splits at I, and it'll split it up at every instance of that I. Okay, there's also partition, which is pretty similar to split, but in this case, what partition does is it'll have the head, the sep, and the tail. So what it'll do is it will search for the separator, whichever you feed it in the argument, in S, that string, and return the part before it, the separator itself, and the part after it. And if the separator is not found, it returns S and two empty strings. So for instance, if I said partition of I here, this one is at the first instance of I, or whatever separator you put in. So it'll give you the first part, the separator, and then everything else that happened after it. So unlike split, which splits at every instance, Partition will only do it at the first instance, and it will also return the separator in the middle. So the front, separator, and the back. Okay, so that's it as far as the lecture and strings. Let's just go ahead and do a quick review. A lot of these were Boolean checks, so I know that was kind of hard to keep track of. It's probably better just to read along in Jupyter notebooks. But we went over methods for changing case, such as capitalize upper and lower. We looked at location and counting, such as count and find. We looked at a few esoteric formatting ones, such as center, also expand tabs. And then 𝗟𝗏 methods, so all the tons of methods to check if the string is in some case, such as is 𝑎lnum, is alpha, is lower, is space, is title, is upper, and ends with. And then we looked at some built-in regular expressions, such as split and partition. Okay. So you should feel comfortable using the variety of methods that are built into string objects, and you should definitely feel comfortable if you run into them when you're reading someone else's code. Alright, that's it for the Advanced Strings lecture. Thanks, I'll see you at the next one. Hello everyone, and welcome to the Advanced Sets lecture. So in this lecture we'll be learning about lots of different methods for sets that you may not have seen yet, and we'll start by going over the basic ones you already know and then dive a little deeper. So as always, there's a Jupyter notebook that has everything we're going to go over as well as many examples, so you can go ahead and check that out. So let's go ahead and look at advanced sets first. So in this lecture, we'll start with some of the basics. So we'll start with building our set, and then how do we add things to a set? Well, we just use the add method. So here I'm going to add 1 to my set, and I'll add 2. And remember, a set won't take any duplicate items. It only presents them 1. That's what makes it a set. So if I were to try to add 2 again, I only get 1, 2. So we know we can add with add. So we can also clear or remove all the elements from the set using the clear method. And that looks like this. So if I check my set, now it's empty. So another interesting method that you may not have seen yet is copy, which returns a copy of the set. So to show you that example, here I have set 1, 2, 3, and I'm going to set a variable called sc to a copy of that. And now sc is 1, 2, 3. So note, it is a copy, so changes to the original won't affect the copy. So if I say s.add, here is my original, there's the copy. Okay, so what about a couple more methods that you haven't seen yet, such as the difference method? So difference method is a super useful method, and it returns the difference of 2 or more sets. So the syntax looks like this. You provide your set, call difference, and then the set you want to check the difference between. So the only difference between s and sc is this 4 elements. So it returns the elements that are different. And so another really interesting related method is difference update. And what difference update does is the method returns set 1 after removing elements from set 2 if you have this sort of format here. So I just copied and pasted this from the Jupyter notebook. So the syntax looks like this. You have set 1, you call for the difference underscore update with set 2, and the method returns set 1 after removing all the elements that were found in set 2. So I'll show you an example of what this looks like. I'll create a new set, S1, create another new set, S2. This will have 1, 4, 5. And now, if I call S1 difference updates with S2, and then I'm going to call S1 again. So note what I get back, 2, 3. So the matching elements between S1 and S2 was the 1 element here, number 1. And what difference update did was it returned the first set after removing all the elements found in the second one, in which case it would have been 1, so you get back 2, 3. Another interesting method is the discard method, and it removes an element from a set if it's a member. So if the element's not a member, it doesn't do anything. So I'll show you what I mean by that. So let's go ahead and check out this set. We have S, which is 1, 2, 3, 4, and I can discard, let's say I discard the 2 elements, and if it's in the set, it'll get rid of it. If it's not in the set, say 12, nothing happens. So you don't get an error if it's not in the set. It's something to keep in mind. Okay, now let's go ahead and learn about the intersection method, another very useful method for sets. What it does, it returns the intersection of 2 or more sets as a new set. And the intersection is just the elements that are common to all the sets. So let's go ahead and redefine S1 and S2. So 1, 2, 3, 4, and then S2 is going to be equal to 1, 2, 4. Okay, and what I'm going to do is check for the intersection of the 2. And there's an intersection update method, which we'll learn about in just a second. So S1 and S2, the elements that are common to both of the sets is 1 and 2. All right, so intersection update will update a set with the intersection of itself and another. So if I try this method on S1, notice S1 is 1, 2, 3, but if I say S1 intersection update with S2, it will actually update set 1 to be equal to the intersection of set 1 with S2. So S1 was 1, 2, 3, and now it's going to be with intersection update equal to, that intersection. So now if I check S1, it's 1, 2. So let me just break that down because I know it's a lot of 1s and 2s that I'm saying. So originally set 1 was the numbers 1, 2, 3, and set 2 was the numbers 1, 2, 4. So the intersection, or the elements that are in common between them, are the numbers 1 and 2. That's their intersection. And with intersection update, it basically makes the first set equal to that intersection. So if I check it again here after the update, I just get 1, 2 back. Okay, so now we're going to check a method called 𝗜𝗧𝗔𝗟𝗓𝗏. So I'm going to create a few sets to show you how it works. So I'm going to create 3 sets, S1, which is 1, 2. I'll create S2, which is 1, 2, 4. And let's say S3 is equal to just 5. Okay, so this method was going to return true if the 2 sets have a null intersection. So for instance, S1 is disjoint S2 is going to return false, which makes sense because they do have an intersection. They have the elements number 1 and number 2 are in common between the first 2 sets. Now, for instance, S1 and S3 here don't have any things in common, so they don't have an intersection, which means they have a null intersection. So if I was to say S1 is disjoint with S3, I should get true because they do have a null intersection. Another interesting method is 𝗜𝗧𝗔𝗟𝗏, and the method reports whether another set contains this set. So if we look at what S1 equals, it's 1, 2. If we look at what S2 equals, it's 1, 2, 4. So you notice S1 is a subset of S2. And we can check that by asking 𝗜𝗧𝗔𝗟𝗏 with the 𝗜𝗧𝗔𝗟𝗏 method, and this will return true. And then basically the reverse of that is 𝗜𝗧superset. So the method reports whether the set contains another set. So I can reverse this and say is S2 is supersets of S1, and that's also true. So they're just the inverse of each other. All right, now we're going to learn about a method called symmetric difference, and there's also a symmetric update to go along with it. So symmetric difference will return the symmetric difference of 2 sets, and what that is, it's all the elements that are exactly in one of the sets. So you can think of this as basically the opposite of the intersection. So if we have S1, that's 1, 2, and we have S2, that's 1, 2, 4, then the elements that are only in one of the sets is that 4 element, right? So I can check for the symmetric difference, and that will return 4, since that's the element that's in exactly one of the sets. Okay, And then there's also a update to go along with that as well if you wanted to change S1 into just the symmetric difference, or 4. Moving along, I will now go over union. So the union method returns a union of two sets, and that's all elements that are in either set. And that will be here in this case 1, 2, 4, because 1, 2, and 4 are in either set. Okay, and last but not least, we'll go over the update method, and it updates a set with the union of itself and others. So that means if I said s1.update s2, if we check s1, it's now the exact same result as if we asked the union on itself and another one, s2. Okay, so you should have at least now a complete awareness of all the methods available to you for a set object type. I personally think the data structure is underutilized by beginners, so try to keep it in mind when you're trying to do comparisons or looking for unique values. The data structure itself is extremely useful, and let's just take a brief overview of everything we learned as far as methods. So we know about the add method, which adds elements to a set, the clear method, which removes all elements from a set, the copy method returns the copy of the set, the difference returns the difference of two or more sets, has that syntax. Remember, there's a lot of update methods which will change the first set in that method. The discard, which removes an element from a set if it's a member. If the element's not a member, it doesn't do anything, so it won't throw up an error. Intersection returns the intersection of two or more sets, which is just the elements that are in common to all of sets. Also has an update method. Is this joint returns true if they have a null intersection, so they don't share any elements. Is subset reports whether another set contains that set. Is superset the inverse of that. Symmetric difference will return all elements that are in exactly only one of the sets, and then you can update it as well. Union returns a union of two sets, all elements that are in either set, and then update will update a set with the union of itself and whatever others you pass in as arguments. Okay, so that's it for the advanced sets lecture. Thank you and good job. I'll see you at the next lecture. Hello everyone, and welcome to the Advanced Dictionaries lecture. So unlike some of the other data structures we've worked with, a lot of the useful methods available to us in dictionaries have actually already been explored throughout this course. So we're just going to touch on a few more methods for dictionaries in this lecture, and also dictionary comprehensions. So let's go ahead and get started with the live code. As always, the Jupyter Notebook's available for you if you want to check it out as well. Let's start by creating a very simple dictionary. We'll just have two keys, K1 with a value of 1, and we'll also have K2 with a value of 2. Okay, so here's our dictionary D, and what we're going to do is use that later on, but that's just to remind you for the syntax of a dictionary. If you remember from the list comprehension lecture, we were able to construct lists using list comprehension. So just like list comprehensions, dictionary data types also support their own version of comprehension. It's not super common to use it as much as list comprehension, but let's go ahead and still learn the syntax for it. So we'll start with a pair of brackets, and then what you do is you define the key and then the value in the same colon notation you would for a normal dictionary. And then you write whatever conditions you want. So in this case, what I'm going to do is say, have the key be x and the value be x squared for x in range 0 up to 10. So if you notice, we've actually been able to create a dictionary through this dictionary comprehension. Another question that might come up is, what if you want to assign keys that are not based on the values? Well, you could use zip in a manner like so. So I could say zip, maybe pass in a list. Here I'll just write a short list so I don't have to write too much. And then zip it, let me close off that string, with a range. Let's just do a range of 2 here. And then we'll do tuple unpacking. So we'll say key value, value squared, key, And looks like I accidentally forgot parentheses there. And there you have it. So again, this really isn't as common as list comprehensions. List comprehensions you'll see all the time. Dictionary comprehensions, it becomes hard to read, especially if you're trying to assign key names that are not based off values. So it's good that you're aware of it, but I wouldn't have it be your go-to throughout your coding. But who knows, if it's called for and it makes sense, go for it. All right, so next up, we're just going to review iteration over keys, values, and items. So dictionaries can be iterated using their iter methods. If you're using Python 2, so I can say for k&d dot iter, and you have iter items, iter values, iter keys. So here we have our iter items. Let's just go ahead and see what that looks like. Prints, we'll say k. And notice iter items actually returns tuples of both the keys and the values. We can also do just the values. And there we have it. And we can also do just the keys. And there you have that. You can also use view methods to view the items, keys, and values. So if you're using Python 2, you can say, we can actually grab all this, delete it, and just say d dot view items. That's the function, so you have to close it off. And it'll show you this object that's a view items. And then we can also say view keys. And then you probably guessed already, you can say view values. And there you have that. So that's really all the other methods that are in dictionaries that we haven't covered or seen throughout this course. So I wouldn't say dictionary comprehensions are super common. And depending on which Python version you use, iteration over keys may be different for you if you're using Python 3. You won't have to worry about the generation issues. And as far as view items, if you have a large dictionary, you're going to want to be careful calling this because you may just get a huge output. All right, well, that's it for the Advanced Dictionaries lecture. You should have been pretty familiar with some of these already. And we'll go ahead and stop the lecture here. As always, you can check out the Jupyter Notebook for some more examples. Okay, thank you everyone. I'll see you at the next lecture. Hello everyone, and welcome to the Advanced List lecture. So in this series of lectures, we're going to be diving a little deeper into all the methods available in a list. So these aren't officially advanced features, just methods that you wouldn't typically encounter without some additional exploring. So we've actually seen quite a few of these: append, count, extend, index, insert, pop, remove, reverse, sort. So we may have seen a lot of these already just by using lists and in the methods lecture itself. But let's go ahead and go over them just in case you need a refresher. Okay, so let's start by making a very simple list. I'll call it L, and I'll have 1, 2, 3 in it. You definitely should have used this method by now. It's append. Whoops. It's the append method, and of course, it just appends an item to your list. All right. So we discussed this also a number of times, the count method. So we can use the count method, and it'll count how many times an object occurs in your list. And it'll actually count whether it's in there or not. So notice how I counted 10, doesn't occur any times. 1 occurs once in my list. So moving along, here's one that you may not have heard of or may not have used yet. It's called extend. So many times people find the difference between extend and append to be unclear. So I'm going to show you by means of examples. So let's go ahead and make a list called X. It's just like Y, or just like the L list. It's going to have 1, 2, 3. I'm going to append another list to that. And this list will contain 4, 5. And I'm going to say print X. Okay, so what happened here? So remember, append just adds the entire element to the list. So what it's doing here is it's adding this and appending this list to an element in itself. Now, what happens if you wanted to extend this list into your original list? So that's where extend comes in. So now I'm going to show you again But in this time, we're going to use extend. So I'm going to say x dot extend and pass in a list again with just 2 elements, 4, 5. Then I'm going to say print x. So notice the difference here. You're actually adding in the entire list. So your extend will append each element in that iterable, and that's the key difference there. So again, just to cover, append is going to append elements, just the entire iterable, all the elements in it. And what extend does is append elements individually from the iterable. All right, so let's move along. Let's take a look at our L list. It has 1, 2, 3 in it, or 1, 2, 3, 4, excuse me. And index is another method that we've probably seen already. So what does index do? Index will return the index of whatever element is placed as an argument. So let's find the index of 2, and it's 1, right? Because indexing starts at 0, 0, 1. The object that the 1 index is 2. Something to note here is that you will get an error if you try to index something that's not in your list. And I'll tell you very clearly, value error 10 is not in list. All right, let's move along with insert. So what does insert do? Insert takes in 2 arguments. It takes in index and the object. So this method places the object at the index applied. So for example, let's just make sure we know what L looks like. L looks like 1, 2, 3, 4. And what I'm going to do is in that list, I'm going to insert at index 2 a string called inserted. So note the order here of the arguments. You put in the index first, and then the object you want to insert. So what does my list look like now? Notice how it has the inserted at the 2 index. So 0 index, 1 index, and at the 2 index, it's placed this string inserted here. So again, you put your index in first, and then the object you want to insert second. Okay, might be useful if throughout your code you really want to make sure that you know the particular index of an object. Okay, moving along, you've definitely already seen pop, which allows you to pop off the last element of a list. So again, here's the list, and I can pop, and by default it's the last element in that list. So I set lpop equal to LE, and LE, notice it was 4. And again, remember that change is permanent. It's in place on your list. Okay. So something else to note is that you can pass in an index into pop. So I could say pop 0. Notice how it's 1. So now L looks like this, 2 inserted 3. So what's another method for a list that we can use? Remove is another method. So the remove method removes the first occurrence of a value. So for example, I have my list, and let's say I want to remove that string inserted. So I pass in the value, and it will now remove it in place. So I want to show you one more example with this, just to make sure you get the idea that it's only removing the first instance of it. So here you notice my list is 1, 2, 3, 4, 3. There's 2 3s in it. So if I say l.remove 3, it's only going to remove the first instance of it. So that's something to keep in mind with remove. Another method we can use, if I see L here, is reverse. And as you might guess, reverse just reverses your list and reverses the indexes for them. So note that this occurs in place, so it will affect your list permanently. And we can also use a sort method on our list, and sort will sort your list also in place. So those are all the methods on a list. Some of them we've covered a lot, some of them might be new to you, but just go ahead and again review the Jupyter Notebook, make sure you understand everything. So let's just go a quick rundown of everything we learned. So append, you've definitely used this method. It appends an element to the end of a list. Count, we've discussed this as well, but it'll count how many times that object takes place in your list. Whether or not it actually occurs in your list, it won't return an error. Extend, here's the tricky one. Remember, in extend, appends each element in that iterable, so it appends here 4 and 5, not just the list with 4, 5. Index will return the index of whatever element's placed in as an argument, but remember, it has to actually be in the list, otherwise you get an error. Insert takes in 2 arguments, first the index and then the object. So here we inserted at 2, this word or string inserted, and notice now it's inserted in the index 2. Pop, we've seen that already, allows us to pop off the last element of a list, or we can also pass in a specific index if necessary. Remove, the remove method removes the first occurrence of a value, so we just saw an example of that. Reverse, as you know, reverses a list, and sort will sort your list in place. So both reverse and sort are in place and will affect your list permanently. Okay, that's it for the advanced lists lecture, which is basically just all the methods on a list, and some of them you wouldn't typically encounter without some additional exploring. Okay, thanks everyone, and I'll see you at the next lecture. Hey everyone, welcome to the Advanced Python Objects test. So this will actually be probably a pretty brief test, but an interesting one. As always, just go to the Advanced Python Objects test notebook. You can click the download link on the right and fill it in yourself. I'm just going to go over the problems quickly so there's no confusion. First problem that you're going to do is convert the number 1024 to binary and hexadecimal representation. Problem 2, I want you to round 5.232222 to 2 decimal places. That was a lot of 2's. Okay, next, moving on to the advanced strings. Here, I want you to check if every letter in the string S is lowercase, and use the methods you learned in this section of the course. Problem 4, what I want you to do is check how many times does the letter W show up in the string below. After that, advanced sets. Problem 5, I want you to find the elements in set 1 that are not in set 2. Then I want you to find all the elements that are in either set for problem 6. In advanced dictionaries, problem 7, I want you to create this dictionary right here. So note the pattern, what's going on, and then I want you to use dictionary comprehension to create that dictionary. Then advanced lists, just reverse and sort the lists below. Okay, that's it, and good luck. Honestly, if you're this far into the course, you may not even feel like you need to be tested. So if you feel that way, go ahead and feel free to skip this advanced Python objects test. But hopefully it should be pretty straightforward to you by this point in the course. Okay, thanks everyone. Hello everyone. In this lecture we're going to go quickly through the solutions of the advanced Python objects test. Okay. So first one you had to do is use bin and hex functions in order to do those conversions. After that, you had to use the round function in order to round. Problem 3, I was expecting you to use the isLower method. And then similarly in problem 4, it was another method for a string, count, and then W. Advanced sets, the methods here were difference for problem 5 and union for problem 6. Advanced dictionaries, this one might have been tough if you didn't see the pattern, and also dictionary comprehension in general is a little strange, but this was the solution for the dictionary comprehension. It was just cubing all those numbers, and the key was the number, the value was the number cubed. Okay, advanced lists, hopefully these are pretty straightforward. Should have been just from the problem itself, reverse and sort. Okay, so that's just a quick overview. Go ahead and check out the Jupyter Notebook if you want to see the code yourself. Okay. Thanks, everyone. Welcome, everyone, to this bonus section on Python GUIs, or graphical user interfaces, with 𝗟𝗲𝗁. So we're going to show you how to build simple graphical user interfaces with Jupyter. And because we're going to do this exclusively with Jupyter, that's why we consider this bonus material. There are lots of libraries out there for graphical user interfaces, each with their pros and cons. There's the built-in tkinter, which doesn't look that great, but it's built into Python. There's also solutions like PyQt, which then, if you actually want to use it as a product, there's some licensing issues you need to deal with. But there's the open source 𝗟𝗲𝗁 and widget styling structure within Jupyter, so that's why we decided to use it for this kind of bonus material section. So we're going to explore how to build out interactive elements. These are things like buttons or sliders that you can have directly in a notebook for someone else to play around with. You're going to want to keep the lecture notebooks handy because there's a lot of reference code and information there for you. So let's get started with our very first lecture in this topic, where we're going to discuss the interact functionality. Let's open up a Jupyter notebook. Okay, so here I am at a Jupyter notebook. As a very quick note, for the notebooks that go along with this lecture that are hosted at the repo, you actually won't be able to see the sliders that we create or any of the interactive elements that we're going to be creating. That's because this is just hosting the code itself. It's not actually running it. So NBViewer or GitHub won't actually be able to execute the code here. They're just showing you the code itself. So keep that in mind if you come visit to the GitHub and you're wondering why you don't see sliders here. You need to download this notebook and run it with Jupyter Notebook in order to actually see or view the widgets and interact with them. So keep that in mind. And again, this is all under bonus material, Introduction to GUIs or GUIs. So let's get started with the interact function. In order to do that, we need to say from 𝗟𝗲𝗁 import interact, and you can use tab autocomplete here, interactive, and also fixed. And then we will say import 𝗟𝗲𝗁 as widgets. So once we're done with those imports, we're going to create probably the most basic interact function. So at a most basic level, what interact does is it auto-generates a user interface control for some sort of function argument. And then it calls the function with those arguments that you can allow yourself to manipulate interactively. So to use interact, we first need to define a function that we actually want to play around with or explore. So we're going to create the most basic function possible, which is just, well, it's not the most basic function possible, but it's definitely a basic one. You take an x and we return back x. So super simple function here. And then we're going to call interact, and you pass in the function itself, and then you set some default value for the arguments of the function. In this case, there's one argument. And then when we run this, we should see a slider here. So then note how as I'm sliding, I have this x value, and this is my input x that I have highlighted here, and this is my output x. So if I scroll around or slide around, I get to see the actual results. So let's explore this concept further. Let's imagine I wanted to return the square of x. If I rerun my function and rerun interact here, now I'm returning back the square at the bottom. So I can see here as my slider goes from -7 to 25, I'm just returning the square there. So I can see here how I can vary the input and then see some corresponding output. Let's go back to that simple function where we just return x. So we saw that we get a slider when we're working with integers. Let's see what happens when we pass in booleans. So with booleans, it auto creates a checkbox, which makes sense because booleans are either true or false. So here, now we automatically created this checkbox. Mark it check for true, unmark it for false. And then if we actually pass in a string, such as hello, then I get back this auto text box. So right now, this function is just accepting x and returning x, and interact is smart enough to know what kind of feature it should show you based on the data type that's being passed. So for integers or numbers, it passes in a slider. We just saw for booleans, it passes in a checkbox, and then for strings, it passes in a little text box here. So I can type whatever I want, and you'll notice that this function is just returning x. So lots of cool functionality here. Now what we're going to do is, instead of passing in this function into interact, we can actually do all this with a decorator. So let's see how we can do that. I'm going to click exit here to kind of end this. I'll come back to a function. Let's create a new function called g, and g takes in x and y. And then all it does, it just returns back a tuple of x and y. Again, a very simple function. Now what we could have done is pass this function into interact again, and then provided something for x and something for y. But we can do all of this with the decorator. And if you're unfamiliar with decorators, make sure to go back and review the decorators lecture. But there's a decorator called interact, and here we can pass in the default values that we want to start off with. So I can say something like x is equal to true, and y is equal to a floating point, let's say 1.0. And now when I run this, I actually get back these options. So I can say true, false. Notice my output here, and then I have this slider. Now let's imagine we actually wanted to keep one of these values fixed. We didn't want everything to be manipulated by the user. What we could do is pass in this parameter into the fixed function. So what we would do here is just say y is equal to fixed 1.0. Make sure my parentheses balance up. And then when you run this, you no longer have the option to pass in y. It's been fixed at 1.0. And this also works inside the interact function. So if we rerun func here, and I say x is equal to hello, and I say fixed hello, then when I run this, I don't get the option of that text box anymore. It just fixes this parameter to always be whatever that default was. So that's how you can use the fixed function. And so now we have the interact function as well as the interact decorator. Now let's talk about widget abbreviations. Recall that when we said interact, passed in our function, and then said x is equal to, let's say, 1, we get back this value of a slider, and I can go to some minimum and to some maximum. But notice what's happening here. I can only go to a minimum of -1 and to a maximum of 3. And if I were to expand this to 10, suddenly I can go to a max of 30 and a minimum of -10. So what happens is your minimum is defined by the x, and your maximum is defined by x times 3. So you may be wondering, well, how do I actually change my minimum, my maximum, and even my step size or my starting value? What you can do is, instead of just saying x is equal to 10 and have it automatically create this integer slider for you, you can call widgets, int slider, and then you can pass in, if you do shift tab here and expand this, you'll actually see the arguments you can pass in. You can pass in minimum, maximum, step, and value. So let's do that as well. And remember, this is an integer slider, so our step size needs to be an integer. There's also a float slider in case we want that. But now I can say my minimum goes to -100, my maximum goes to +100. We can create a step size of 1, and then our starting value of 0. So now I have all these options with the integer slider. And if I rerun this, notice I'm starting at 0, I have a step size of 1, and I can go from -100 all the way to +100. So these are the widgets that you can specifically call if you want more options in the functionality of the widgets, instead of just the ones that are auto-created for you. Now, because sliders are so commonly used with widgets, there's actually ways to abbreviate all this functionality here. And the way you do that is by calling interact, pass in your function, and say x is equal to, and it's very similar to arrange. What you do is you have a tuple here where you have a min, max, and a step size. So I could say go from -100 to 100, step size of 1. And then when I run this, notice back, I get back the same thing from -100 to 100, or I can go from -10 to 10, rerun this, and here's -10 to 10, step size of 1. This is known as an abbreviation of this widget right here, because now I'm just passing in an abbreviated tuple instead of calling integer slider. This is an integer slider, and if we wanted this to be a floating point slider, all you had to do was specify one of these to be a float here. And then if we specify the rest to be floats as well, so let's say 0.1, and we rerun this, now Jupyter Widgets realizes, oh, he wants a float slider, so then we have the floating point slider here. And notice now our step size is 0.1, and we're going from -10.0 all the way to +10.0 in step sizes of 0.1. Again, using this abbreviated format. And as always, you can do this with the interact decorator as well. So if I say at interact, I could say x is equal to, and then say 0.0 to 20.0, step size of 0.5, create a function. Let's just have this function be h, and we can have some default value like 5.0, and then just return x. So then when I call it, I have the default value of 5.0. It goes down to 0.0 all the way up to 20 and step sizes of 0.5. Okay, so this is widget abbreviation again, lots of different options here. Those were the abbreviations for integers and floating point sliders. You can also have drop-down menus, and those are abbreviated as well. remember that if I said interact, pass in my function, and I said x is equal to a string, such as hello, it just has a text box here automatically generated. So hello, how are you? And it's just returning back that string. If you pass in a list of strings as an abbreviation of a full call, it will create a drop-down menu. So we can say hello, option 2, comma, another string, option 3. And now when we run this, we get back this nice little drop-down menu. Option 2, hello, option 3. So this abbreviation of using a list with strings is a drop-down menu. And we have a little table in the notebook so you can reference this and not have to memorize what tuples stand for or what lists stand for. But when you get used to it, it's pretty straightforward. These tuples are sliders. The list with strings is going to be a drop-down menu. And there's also, when you pass in a dictionary, let me show you what happens. We'll say interact, our simple function, say x is equal to 1, 10, and then we'll say 2 goes with 20. And when you run this, you get back a drop-down menu 1, 2, but then the actual output is equal to the value here. So your drop-down menu is the key, and your output is the actual value. So notice the difference here between that list and that dictionary being passed in there. Now, in addition to this interact function, IPython, or Jupyter in general, provides another function called interactive instead of interact. And it's useful when you want to reuse the widgets that are already been produced or access the data that is bound to the user interface controls. So, unlike interact, the return value of the function will not be displayed automatically, but you can display a value inside the function using IPython.display. So to show you what I mean by all this, say from IPython.display, import display, and let's create a function here. Simple function f just ticks in a and b, and then instead of just returning a plus b, we're also going to then call display on a plus b, and this will allow us to use the interactive function. So then I can set w equal to interactive, pass in f again, and we'll say a is equal to 10, b is equal to 20, and if I check what type w is, notice it's now an interactive object. So the widget is an interactive, which if you look at the documentation is a subclass of something called a VBox, which is just a container for other widgets. Now the children of interactive, if we check out the children attribute, these are actually two integer sliders here, as well as an output. So it's basically building out a larger UI for you using the interactive functionality. So then if you actually want to finally see what W actually looks like, what it was defined by this interactive function, you can call display on W. Let's make sure I spell that right. And then you get back both sliders. So you get 27, -2, and you get to see the sum. So 27 minus 2 is 25. And now you can see how we can use the interactive functionality to save something as a variable and then just display the variable later on. Okay, so that's really it for the interact and interactive functionality. Let's very briefly go over everything we just covered. The main idea here is that you're going to be able to create functions that take in some sort of input and return some sort of output. Then if you want your user to have some sort of interface to change the possible inputs and then see the outputs, you can use the interact function, or you can use the interact decorator. And then we saw how we could specify actual widgets inside of the interact call itself, and we saw how there's abbreviations for them, such as the tuple for a slider, or the list for a drop-down menu, or a dictionary for a drop-down menu that has a connection to some key value pairs. Then finally, we saw how we could use the interactive functionality in order to save this to a variable so I can later display that variable and again see the inputs and the outputs. Last thing I want to note here is when you're using the Jupyter Notebook, you may have noticed that there's this report here that the output is some sort of function. If you don't want to see that, all you have to do is have a semicolon here, and then when you run this, you will no longer see that output. And that's what's essentially happening when you call display on this W. You don't see that little output cell. Okay, we'll see you in the next lecture where we begin to discuss more capabilities of widgets. Welcome back, everyone. In this lecture, we're going to continue building off our previous understanding of interact and interactive to begin using full widgets. Let's get started by opening up a Jupyter Notebook. To begin using our widget framework, we need to say import 𝗓𝗫𝗁 as widgets. So widgets have their own display functionality. When you say widgets, let's make sure we spell that right, dot, and then the actual type of widget you want. You notice that there's tons of options here. We're going to show you a few of them, and we'll start off with the first one that we've kind of already talked about, which is the integer slider. So if I just call this by itself, I get back an integer slider with some sort of default from 0 minimum to 100 maximum, and then I believe it starts at 0 there. Now right now we're just calling the widget directly in a cell and seeing its output below. But if I want to call it or line up a bunch of widgets to call later on, what I need to do is call display on the widget that's been defined. So what I need to do is say w is equal to this particular widget, and then from ipython.display import display, and then I can display my widget. And so now I have this variable that I can display wherever I want, an integer slider. If you do Shift Tab here and expand it, it will tell you the various parameters, value, min, max, step, that it takes. So if we want to do multiple display calls, for example, if we want to display the same widget twice, the displayed instances in the front end will actually remain in sync with each other. So let me show you what I mean by that. If I say display W again here, and I start moving them around, these are actually in sync because they're referring to the same widget. W is just connected to a singular integer slider, so now I can see how these widgets are connected. If I want to close a widget, what I need to do is call its close method. So I can say w.close, and now this widget has been closed, and I no longer see it in any of the cells where it was being displayed. Now widgets also have properties, so all of the IPython widgets share some sort of similar naming scheme, and to read the value of a widget, you can query its value property. So what I want to do is reconnect that widget, so say w is equal to widgets.integer slider, and then display w. And while w is being displayed, that means I can play around with its current value. So if I do w.tab here, I can see that it has some variables that I can call. And one of them is the value, so I can see the current value it was at when the cell was run. Note, this is not going to be updated if I start moving it around. I would have to rerun this to then check on the current value. I can reset the value though, saying something like w.value is equal to 50, and when I rerun this, notice that it's connected to this current display, so this display suddenly goes back to 50 when you reassign that value. So in addition to value, most widgets actually share keys. So you can call w.keys, and you'll get back a list of keys here. So this is the entire synchronized list of stateful properties. And by stateful properties, I mean these are the properties that are connected to the state of the current display. That way, we can actually grab that property and reassign it, and it should affect the current widget display. So here I can see, for example, underneath my keys, I had a max value. So I could say w.max, and let's set that equal to 2000. So now when I run this and I come back up here, if I scroll all the way back up, it's now been changed to 2000. So I can grab the list of keys and then see the stateful values here that I can play around with. A lot of these we won't really need to play around with. The main ones are like max, min, step, and then other options depending on what kind of widget you're actually playing around with. So we can then link two similar widgets. So if you ever need to display the same value two different ways, what you can do is link two different widgets together. Let me show you what I mean by that. Let's create a widget A that is float text, which means if I just display A, I get back this text box, which takes in floating point values instead of just normal text. Then I'm going to create inside the same cell widgets, and I'm going to create a float slider. And now let's display, let me close this off right here with the X. Let's display A comma B here.
And when we run this, notice right now they're not linked. If I raise this up and down, I don't see a change in value here. And if I change the text box value, I don't see a reflected change here. What I can do is link them up by saying, after the display, my link is equal to widgets, and you can call it JSLink for JavaScript link. And what you do here is you say, grab the name of the widget and the string key of what you actually want to connect. In our case, we want to connect the value. So what we're going to do is pass in the string value here, and then you pass in a list of what else you want to connect as a tuple, where it's a widget, and then the key you want to connect, so value. So if I run this now, and I start moving this up and down, notice how they're connected. So if I type in a number here, it's going to be reflected in the slider itself. So if we go to 100, you can see how it's changing. Or if I slide this, you'll see how it's changing. So again, you create two widgets, you display them, and then you can link. And it doesn't have to just be for two widgets, it can be for two or more. You call widgets.jslink, and then you pass in tuples of the widget name, and then the key of what you actually want to link. So what we could do here is, instead of linking value with value, even though it's a very common link, we could link a max together. So I could say, link the value of A to be the max of B. And then when I rerun this, notice right now my value is 0, so that's the max of my slider. But if I change my value to 1000, then suddenly my slider can go up to 1000. Then if I change it back to 100, then I can only go up to 100. So this gives you an idea of how you can link the different keys of one widget to the different key of another widget. And it's just widgets.jslink. If you want to unlink the widgets, it's actually quite simple. You just call myLink again, and then call the method unlink, run that, and now they're no longer linked. If I start moving this around, or if I start changing this, it doesn't actually affect this original link anymore. Okay, so let's quickly review what we just covered. We talked about widgets. We've actually already seen a lot of this in the previous lecture, but we saw how we could call display on a widget in order to see it. And then we also noticed that widgets themselves have these keys that allow us to view their stateful properties. And again, the stateful properties, that term is just to say that's a property that shows up when you view the actual widget. So it's a state property that you can then edit or change. And then you can link widgets together using this widget.jslink, and then pass in the widget itself, and then what you want to link, in which case what key you want to link, such as the value, or here widget B, link the max together, and if you ever want to unlink them, you just call unlink. That's it for this lecture on widgets basics. Up next, we're going to talk about widget list. We'll see you there. Welcome back, everyone. In this lecture, we're going to have a reference of a list of all the widgets available to you. So we're just going to actually run the corresponding notebook that goes along with this lecture, because we're just going to show you every possible widget. That way later on, you can come back to this lecture or come back to the notebook and reference it when you're thinking of a particular widget. So let's go through that notebook now. All right, here I am at the widget list notebook. It's the third notebook underneath the bonus material introduction to GUIs folder. And if you want a complete list of all the GUI widgets available to you, just import ipywidgets as widgets, and then for item, and here's the call, widgets.widget.widget_types.items, and then you can print out item. If you just print out the item itself, it'll give you this large information in the tuple about the actual class it's in. So just say item indexed at 0, and then you'll get back the actual items themselves. So you can see here there's checkboxes, there's the sliders we were talking about, color pickers, date pickers, math. There's a lot of stuff here, and what we're going to do is just explore a lot of these. So first off, there's 10 numeric widgets in IPython. So these are all designed to display some sort of numeric value. There's the integer slider, and we've also shown you all the various parameters that can go with this. So the integer slider, you can name it. So notice here how it has test as a string. So that's the description, and you can edit that to change what text shows up here. And you can also see that it has an orientation. And if you have the float slider, very similar thing, except it's float. And you notice that it has some sort of precision, so the step size can be a float, unlike the integer. We can also display these vertically, so there's an orientation. You display it vertically, you get this sort of output. There's the range slider. for an integer. So this allows you to actually grab a range. So notice here how there's two dots now, a start and a stop, and you can see which one you have selected, if it's filled in or not. Same thing for float, start, stop. You can have a range there, and it'll display back the range. There's integer progress. So you can see here it's kind of like a loading bar. So you could have something like this technically be updating as you are running some sort of program. So you can see here as a description, loading. It doesn't have to be loading, it can be whatever you want. There's also a bar style, so you can replace it with these strings right here if to see it in a different color. So if you say success, it will change it to green. If you say warning, it will change it to orange. And these colors are just from Bootstrap. So if you're not familiar with Bootstrap, it's this very popular front-end styling that you can use. And a lot of these keywords come from that Bootstrap library. So that's integer progress. Same thing as float progress. You can see here it's loading. And then there's bounded integer text. So the numerical text boxes that impose some limit on the data. So you can see here we have text, and then we can say 8, hit enter, and then it would end up connecting with whatever widget you had, or whatever function the widget was connected to. And then we have just integer text and floating text. Then there's also Boolean widgets. There's basically 3 widgets that are designed to display a Boolean value. There's the toggle button. So click them on and off. You can see here it's shaded. Again, you can use these sort of Bootstrap codes to change the actual styling as far as color is concerned. So now we have green, click on and off. We also have the checkbox, which we've seen before, check on and off. And then we have valid, which provides a read-only indicator. So you can't really interact with this. It'll just say whether or not it's valid. So this is to show something. If it's false, it'll have an X there. And if we change this to true and run this, you'll see it has a check mark. Then we have selection widgets. So several widgets here allow you to select from a list. You can see we have options as a parameter that we can later link up to our functions. So you have the drop down 1, 2, 3. You can also use a dictionary here instead of a list. So 1, 2, 3, and the output will correspond to the value going with that key. We have radio buttons that we can choose from. So pizza topping, pepperoni, pineapple, anchovies. We have select. So this is again a similar drop down. We have selection slider. So you can see here as you go, you get the different options. So not super popular, but it's there for you. Then the next one we have is toggle buttons. So if you run that, you get to see these different buttons you can toggle: slow, regular, fast. You see here you have the options you can toggle on and off. You can have multiple with select multiple. So here I can say use shift to select multiple, or you can also do control or command depending on your operating system. We have string widgets. We have the normal text box, which allows you to type stuff out there. We also have text area. So this one allows you to expand it to a larger area. We have label widgets, which is useful if you need to build some sort of custom description next to a controller. So here we can see we're actually using what's known as LaTeX. So I can write E = mc² using LaTeX. If you're familiar with that, you can have that option. If you're not familiar with it, it's not really a big deal. It just basically allows you to really customize the text here. But as we just saw, a lot of those widgets already have a description parameter for that. Then there's HTML. This allows you to basically just put straight HTML here. So I can see some HTML, hello world. HTML math. So if you're familiar with HTML math, you can put that in as well. Basically just allowing you to display HTML in case you prefer writing your own raw HTML here. There's images. In this case, we actually don't have this image, but you would be able to connect it to an image and it would see it. Right now I get file not found because I don't have a PNG file there, but you would just connect it and it would display that image for you. I'm going to comment this out for now. Then we have the button, which is just, again, click me, click off. Very similar to the button we saw earlier. Okay, those are a list of all the widgets. There's even more widgets described in the Widget List Advanced Notebook, so just use that one as a reference for yourself. We'll see you at the next lecture, where we're going to be discussing widget events. Welcome back, everyone. In this lecture, we're going to learn about the various ways to style widgets, and we'll discuss how to use the style versus the layout functionality of the IPyWidgets system. Let's open up a Jupyter Notebook and get started. First off, before we continue, I want to mention that there's actually quite a bit of information in this widget styling notebook, as well as discussion on style versus layout. A lot of what we're going to talk about here assumes some knowledge of HTML or CSS as far as the terms are concerned. So if you're already familiar with HTML and CSS, a lot of these terms such as border, margin, padding, top, left, bottom, flex box, those are going to sound familiar to you. If you're totally new to that, just keep in mind that the layout and styling is based on HTML and CSS, so you may want to learn about those first through just some simple web tutorials or another course of mine on Django web development, and then come back to understand layout here fully. We are going to show you some examples that should make sense even if you don't know HTML and CSS that well. We're going to get started by importing ipywidgets as widgets, and then from ipython.display import display. Then I will create my widget slider that we've seen before. So an integer slider, and then let's display that integer slider. So right now, this is the default integer slider display. But let's imagine that I actually wanted to change the size of this slider. I wanted to change the way it looks. What I can do is grab W and then grab layout off of this. And if you hit tab here, you'll notice that you have a bunch of traits based off of CSS that you can adjust. So for example, you can adjust the margin to go with the string auto, and calling layout again, you could adjust the height of this slider to be defined by a certain number of pixels, like 75 pixels. And now when you run this, you'll notice that we've been able to shift this around with the margin and the height. So the layout here basically allows you to center the slider and then increase the height. So the slider changes positions on the page immediately, and layout settings can be passed from one widget to another widget of the same type. So I'm going to say x is equal to widgets.integer slider, and let's give this a value of 15, and I'll give it a description too, saying something like new slider, and then I will display x. So here's my new slider. Looks like it has the default styling, but if I wanted to change the layout to match W's layout, all I would need to do is say x.layout is equal to w.layout. And then we have centered our new slider. So before we investigate the actual style attribute, it should be noted that many widgets offer a list of predefined styles that can be passed in as arguments or parameters during their creation. And these are based on bootstrap terms, such as primary, success, info, warning, and danger. What I'm going to do here is, since we've already imported widgets, I will call widgets.button. Oops, let's make sure I spell widgets right. Widgets.button, and then I will pass in a description here. We'll say ordinary button, and then we can say the button style is equal to an empty string. So if I just do that and run that, I have this ordinary button, and we've actually seen this one before. What I could do though is give it a style based on a bootstrap code, and these codes are linked to in the notebook. So danger is kind of this danger red, but there's other things like warning is an orange, or you have info, which is another color, this kind of teal color, etc. And you can check out the various labels over here, primary, success, info. So now let's talk about the style attribute. So those are the built-in ones that are based off of Bootstrap. So while the layout attribute really only exposes layout-related CSS properties for top-level elements, the style attribute is used to expose non-layout related styling attributes. So those are things like custom colors. So I'm going to make a couple new cells here. So I will say B1 is equal to widgets.button, and I will say description, and we can say something like custom color. And then I will grab B1, and instead of calling layout off of this, I will call style, and then call button color. And then say light green. And there's a bunch of string codes you can use here. And if I just call B1, now I see this custom color. And if you're interested in the list of all the style attributes available for any particular widget, so certain widgets will have button colors, such as buttons. Other widgets, such as sliders, aren't going to have button colors. But if we check out B1 style keys, we get to see a keys of everything we can edit. So not a whole lot here. We can edit the font weight, the button color, and that's really all there is for buttons. Now, what we could do as well is if we had a new button, such as B2 is equal to widgets button, I could set the style of B2 to be completely equal to the style of B1. Notice here I'm not actually calling style button color, but I'm just saying the entire style of B2 should match the entire style of B1. So then when I call B2, I get back light green here. So it doesn't actually say anything because I didn't pass in a description. So let's say description is equal to new, and then when I run this, I get to see the new there. So finally, we'll create some other, let's say, slider here. So I'll say widgets, integer slider. Let's give it a description to be something like my handle. And if I check what S1 looks like, it's just this normal slider. But let's go ahead and check out its style. We'll say S1 style. And if you call S1 here style.tab, you should see a bunch of options, and you can then call keys to see a list of everything. So for example, we can change the handle color. So let's grab that, say handle color, and set that equal to, let's say blue. Run that, and now I can see that little handle is now colored blue. And pretty much any major string is going to be accepted. I should say any common string. So you can see black is accepted. We could go with light blue. We could go with light blue, and that would be accepted as well. And as a quick note, if you come back down here to the notebook all the way down, we have some traits here that are common for widgets, such as button color and font weight. Those are common for buttons. Description width, handle color, those are for all the sliders. And then for the progress bars, you may want to affect the bar color or description width. There's lots of other ones that really only have description width as an adjustable trait. Okay, so you now should have an understanding of how to style widgets. Keep in mind, you don't have that much access to a lot of the styling, and that's because when you're working with Jupyter, Jupyter has to be able to only color the button here or the handle here and not affect everything else that's showing in your browser. So it's quite a challenge for the people who are developing IPy widgets to give you access to this sort of styling without screwing up everything that was being rendered in your browser. All right, coming up next, what we're going to talk about is how to create a custom widget. So we're going to explore just a huge custom example to see what do all of these widgets and functionality look like in practice. We'll see you there. Welcome back, everyone. In this lecture, we're going to show you a custom widget example, and we're actually just going to be running the notebook directly for this example. So you can go ahead and download the notebook and then run through it. For this notebook, you will need to install a few extra libraries, and those are NumPy, Matplotlib, and SciPy, and we'll show you those in just a second in the notebook. But let's open up the notebook and explore this example. Okay, here we are at the custom widget. This is basically going to be an advanced example of what's possible in the custom widget to try to give you some ideas of how you would be able to connect these widgets to external libraries. And in order to explore those external libraries, we're going to need to work with NumPy, Matplotlib, and SciPy, and you can install all of those using conda install and then these names, NumPy, Matplotlib, or SciPy, or pip install NumPy, pip install Matplotlib, or pip install SciPy at your command line. And if you're really interested in this sort of thing, of the more advanced aspects of Python, basically you've already finished the course by now if you're viewing this lecture. You can check out the class Python for Data Science and Machine Learning Bootcamp if you're interested in visualization and differential equations, machine learning, data science, analyzing data with Python, and that sort of thing. Here we're just going to show you one final advanced example of how you would be able to use widgets with some of these more advanced libraries. And to do that, we're going to be exploring the Lorentz system of differential equations. Basically, this is just a system of equations that are connected based on the behavior of 3 different parameters, and we're going to connect those to widgets to actually modify those parameters and see how that changes the visualization in real time. So we have a couple of lines here. Matplotlib inline, that allows us to actually view this visualization in the notebook setting. Then we have our IPy widgets and IPython display. Here we have interact and interactive, which we've already talked about. We have display in HTML, which we've also already discussed, and then clear output, which we discussed during Milestone 1 project. And then we have some tools here from those external libraries, and this is really just for visualization purposes. We have NumPy as NP, we've downloaded and installed SciPy, and then we have Matplotlib. And Matplotlib is basically a plotting library for Python, which will allow us to plot some of this out. So then we're going to run this. And here is what we're going to do. And you can basically take this idea and apply it to any sort of function that's returning anything. What we have here is a function called 𝗬𝗓𝗏 that takes in various parameters that relate to the Lorentz equations, and then it creates a figure. It's going to set the limits of that figure. It has another function here that is actually going to compute the time derivative of the Lorentz system using some math. Then we choose some random starting points. We actually solve the equation that we saw up above, or that set of equations. We choose some different colors, and then we end up just plotting everything per line. I definitely wouldn't expect you to understand any of this because this is all NumPy and Matplotlib. This is more just to show you what is possible with Python. And if you're really interested in this, you can check out that other course that's linked in the notebook. So let's run that cell, and it's going to return t and x of t. And then we're going to call the function solve. So once it's solved, it looks like this. Notice here it's taking in parameters angle and n, but if we wanted to see how those different parameters actually affected some sort of function, all we would need to do is call interactive, pass in that function itself, and then pass in our options. Here, remember, we're using tuples as sliders. So those are the widget abbreviations. Then we're going to display W, and when we run this, we get to see all these sliders here, and we actually see how they affect the equation itself. So for instance, we can change the angle, and that will make it look like it's rotating because we're changing the angle that we're plotting at. Or we can change the number of lines using n just 2 or n all the way up to 43, and we can explore that again with the angle or with the max time, see how that affects things. Change beta, change sigma, you can change rho. There's lots of different parameters here. The main idea being is you just have a function that's returning something, and then you pass in whatever parameters that you want to play around with. And this is a really advanced example of that, but we've already worked with tons of functions that return something and that take in parameters from the user. And if you ever wanted a slider parameter or those text checkboxes, text entering, etc., all those other widgets that we discussed, you would just pass them in here, and then they would be connected to whatever function you passed in. And this is kind of an advanced example of that. Now the object returned by interactive is actually a widget object, so then you can grab the result off of that and grab the arguments. So we see here, this is the arguments right now, and then we would be able to explore those further. So you'd be able to plot out histograms of wherever you actually were in that particular time period. And then if you edited some of the more advanced parameters, sigma, change this around, n, and then you rerun these again, notice now you have the different angles that you had on. Then you could just keep going with this and make new histograms to plot them out. All right, that's it for this lecture and really this section of the course. I hope this helped you realize what is actually possible using GUIs and IPy widgets. The main idea being that once you have a function that's going to return something, you can easily give user interaction by just setting those parameters and then connecting them to some sort of widget. In this case, they're all connected to sliders, but we've already explored the many other widgets available, such as buttons, checkboxes, text boxes, expandable text boxes, straight HTML, and then we also saw how we could style and lay out our widgets. Okay, I hope you have fun exploring your own use cases for graphical user interfaces in the Jupyter Notebook system.
Hello everyone, and welcome to the lecture, How to Approach This Course. This lecture will go over the basics of how to get the most out of this course. Now, people who are taking this course hopefully fall within 3 categories. Beginners who have never programmed before, programmers coming in from another language, or intermediate Python programmers. Now I'm going to discuss how you should approach this course depending on what category you're in. First, beginners who have never programmed. Complete beginners should read the notebooks before watching the screencasts. Then, watch the screencasts and follow along. Then, you should take the quiz or test or corresponding homework assignments to check for your understanding. Afterwards, make sure to review the written notebook to make sure you fully understood the lecture's material. Now, if you're a programmer coming in from another language, you should read the lecture notebooks and follow along. Then, if something isn't clear, go ahead and watch the screencast. Afterwards, you should take the quiz, test, or corresponding homework assignment and make sure you can check your understanding, either through the screencast or through the notebook. Finally, for intermediate Python programmers, You should read the notebook and make sure you know the topic. If you're an intermediate Python programmer, you can probably skip the first few sections of the course where we discuss Python basics. Once you're at the advanced topics, I would recommend you read the notebooks and watch the screencasts to get the most out of this course, and do the corresponding either test, quiz, or homework assignment for that section of the course. Now, discussion questions. If after watching the screencast or checking the notebook something doesn't make sense, feel free to start a discussion in the forums. Remember to check if there is an FAQ, frequently asked questions lecture, corresponding with the lecture. As this course gets populated with more students, more FAQ lectures will begin to pop up throughout the course. Also, remember to use the search feature in the discussion section for faster results. Alright, that's it for this section of the course. Up next, we'll learn how to install Python on our computers and go over the basic course environment. Thank you, and I will see you at the next lecture. Hello, and welcome to the Python 2 versus Python 3 lecture. In this lecture, we'll be going over some of the differences between Python 2 and 3, and some more background of how we approach this in this course. A bit of a historical background. Python 2 was started in the year 2000, with Python 2.7, its most current form, being released in mid-2010. Something to note is that Python 2 will lose support in 2020. Now, what does losing support mean? That means really just security updates at this point. So that doesn't mean if the year 2020 comes around, Python 2 will just all of a sudden stop working. It just means that any developers currently working on Python 2 for security updates will stop in the year 2020 and shift towards Python 3. Now, some background on Python 3. Python 3.0 was released in 2008. More and more libraries are beginning to support Python 3. Not all of them, but most of them do. So the question is, which programming language do you choose? Python 2 or Python 3? Well, the answer is both, kind of, and I'll explain why. This course uses Python 2, but you will learn Python 3 syntax throughout the course. They're very similar with just a few key differences. We will do this through the use of Python 3 alerts. I'll explain more on those later, but for now, let me explain the reasoning of why learning Python 2 currently, while learning the differences of Python 3, is the best course of action currently. So the current environment still uses Python 2 significantly, so the best approach is to learn Python 2 but understand the differences in Python 3. I'm going to show you some survey results that back this up. So this survey was a survey of a large amount of programmers currently using Python. First question was, do you currently write more code in Python 2 or 3? The majority of the answers were still more Python 2 code at 68%. Now, the other question, and this is a significant one, is which Python versions do you regularly use? You'll notice 2.7 has 81%, almost double of 3.4 responders. So the majority of people are still using Python 2 more on a regular basis. Now, what keeps people from leaving Python 2 to Python 3? The majority of the answers were dependencies or a large code base or legacy code. What that means, if you were to get a job right now as a Python programmer, it's more likely than not that your code base will be in Python 2. So it's important to understand how to code in Python 2 and understand the differences for Python 3 for future work. So now I'm going to show you an example of what a Python 3 alert looks like in this course and the notebooks, so you can get an understanding of how we're going to be learning Python 2 and the changes in syntax for Python 3 as we go along. So I'm going to cut now to one of the Jupyter notebooks for this course. So here's an example of one of the notebooks that goes along with your lectures. In this lecture, we're discussing numbers. Now, we'll break down what Jupyter notebooks actually are and how to access these notebooks, etc. further on in the course. But right now, I just want to show you how we address the differences in Python 3. So you'll notice every lecture, for instance this one, numbers, has a corresponding Jupyter notebook. Now, this notebook has information for you to read, as well as example code statements for you to fully understand what's going on in the lecture. And now this is what a Python 3 alert looks like. So for your first lesson, I'll briefly do an overview of division in Python 2 versus Python 3. You'll notice here in this example, I'm saying 3 divided by 2, and Python 2 outputs the 1 instead of 1.5. So in the notebook and in the screencast video, I will make a point that we have a Python 3 alert, where I will explain the differences between Python 2 and Python 3. So, just a brief overview of division. In Python 2, this slash symbol for division performs what's known as classic division, meaning it's truncated decimal points off. So 1.5 becomes 1 if you're using Python 2. Now, in Python 3, a single slash performs what's known as true division. So you would get 1.5 if you had inputted 3 divided by 2 if you were using Python 3. Then I continue on with showing you options on how to avoid this error in Python 2, including specifying things as floating point numbers or getting imports from a module called future in Python 2, which imports a lot of the Python 3 functionality into Python 2. Now we'll discuss this in a lot further detail later on in the course. But that's the way we're going to address Python 3 in the course. This course will be done in Python 2. I will encourage you to install Python 2, or if you already know Python 3 syntax, you can feel free to install Python 3. But if you're beginning programming and you have never programmed before, go ahead and download Python 2 so you can follow along exactly as I do in the screencast videos, since I will be using Python 2. And then just keep in mind the differences when a Python 3 alert comes up. Now, if you've already learned Python 3 syntax through some sort of website or book such as 𝗕𝗢𝗟𝗓𝗏, then I would encourage you to, if you feel comfortable using Python 3 syntax, download the Python 3 version of the installation we covered later on in this course, and keep in mind the differences between Python 2 and Python 3 when they come up. Okay, so in conclusion, we use Python 2 in this course, but make note of the differences of Python 3 versus Python 2. The reason for that being is because the current environment and legacy code is still in the majority in Python 2. Later on, around the year 2020, you'll see a major shift, and a major shift is already starting to happen as far as library support to Python 3. But at this moment in time, it's still important to know Python 2 and the differences in Python 3. After taking this course, you'll feel comfortable coding in either Python 2 or Python 3. Okay, thank you very much, and I will see you at the next lecture.
Hello everyone, and welcome to the Python Setup lecture. It's time to get Python onto your computer. Whether you're using a Windows, Mac OS, or Linux computer, the installation process is actually pretty straightforward. But make sure you give yourself 20 to 30 minutes for this particular step to make sure you have enough time to download and finish the installation. Now let's go over just a few things before we get started. In this course, we're going to be using Python within a development environment where we actually type out Python commands. And for learning, we're going to be using the Jupyter Notebook system, which we'll discuss later on. Also later on, we're going to have a whole lecture on other IDE options, and IDE stands for Integrated Development Environment. So if you're an experienced programmer and maybe you're using another development environment or a text editor, for instance Sublime Text Editor, and you prefer that, we're going to be going over those options in a later lecture, and you can feel free to use them for this course. The easiest way to install Python in the Jupyter Notebook system that we use throughout this course is using the Anaconda distribution. And we're going to be visiting the Anaconda distribution site, explaining what it is, and using it to easily install Python onto your computer. All the sites that I'm going to be showing you in this lecture can be found as a resource link, so check out the curriculum for the links. Let's go ahead and get started. Go ahead and open up your browser. I suggest using Google's Chrome browser, and type in jupyter.org into your URL, or just Google search for Jupyter, JUPYTER.org. I'm going to jump to my browser now and meet you at this website. Alright, here I am at jupyter.org, which is the main page for Jupyter. And just to show you a quick glimpse of what Jupyter is, you can scroll down on this page where it says ready to get started, and where it says try it in your browser, click on that link and you can open it in a new tab, and it will take you to this page right here, https://try.jupyter.org. And this is what a Jupyter Notebook server looks like. We're going to be running Jupyter later on locally on your computer, but if you ever want to just quickly try it out over the internet, you can check out this website. And then you can come here where it says New, and on this website you have a variety of options, including other programming languages such as Ruby or R, and then you'll see some Python options. So you can click on one of these Python options. Here I'm clicking on Python 3, and it will load up a Jupyter Notebook. This is what a Jupyter Notebook looks like. Here it's untitled, but you can click on this to rename the notebook. So we can say, my first notebook, hit enter, and in this little cell, you can actually type in Python code. So for instance, if you're following along with me, your very first Python command can be print, and then we'll have an open parentheses. Note the auto completion there. And I'm going to just zoom in with Control or Command plus on this web page, and we can type in hello world inside quotes, and that makes it a string. And we'll be going over all these commands later on. But I just want to show you that within this cell, I have some Python code, and I can click here on this little run button, and it will run the code, state a number showing that it's been run, and you can see the output directly below. And this is what we're going to be using to quickly iterate and learn about code. And there's actually notebooks assigned for every lecture. So later on in this lecture, I'm going to be showing you how you can access all the notebooks that go along with each lecture of this course. But just to show you another quick example, you can use this as 1 plus 2, hit Shift Enter, and then you will see that we have an output, 3. All right, now let's show you how to actually get this sort of notebook system working on your computer. Come back here to jupyter.org. You can continue on to read about Jupyter, and it's currently used at a lot of companies such as Google, Microsoft, Bloomberg, IBM, etc. So a lot of big companies and a lot of big universities, Cal Poly Berkeley, and even national institutions such as NASA. But coming back up here, we have the Install the Notebook button. Click here on Install the Notebook, and it will take you to this page. Now, the jupyter.org website is updated quite often, so don't worry if your page doesn't look exactly like I'm showing it here. It should look like something similar to this. But basically, you have a prerequisite, and that is Python. So even though Jupyter runs a lot of programming languages, Python is going to be a requirement, either Python 3 or Python 2. And what they recommend is using this Anaconda distribution to install Python in Jupyter, and that's what we're going to be doing. So again, for new users, which is you and us, we're going to install Anaconda. So click here on this link, you can open in a new tab, and that's going to install Anaconda, and it's also going to install the Jupyter Notebook system all in one step. And it's actually going to download a bunch of other libraries for you that you may find yourself using in the future. So if we come here to that tab we just opened, it'll say download Anaconda now, and you'll notice that you have several links for yourself. You have the Windows, the Mac OS link, and Linux. So click on whatever operating system you're using. So I'm going to come down here to Windows, and you notice it's basically just tabs here, OS X and Linux. If you're on a Windows computer, make sure you choose the correct version. So here we have a 64-bit and 32-bit version for Python 3.5, and then we have a 64-bit and 32-bit version for Python 2.7. If you're running a newer computer, as long as it's not a very old computer, it's probably a 64-bit computer for Windows. If you're running an older version of Windows, maybe like Windows XP or Windows 7, double check to make sure you have a 64-bit computer. If you have an older version of Windows, such as like the ones I just mentioned, you may have a 32-bit computer, and you can actually check on your control panel. If you have a 32-bit computer, that's totally fine too. Just click here on the 32-bit installer. So if you're using Windows, just click on whatever installer you need. If you're using Mac OS X, you just come here and click on one of these graphical installers. Don't click on this command line installer, that's a little more complicated. Click on one of these graphical installers instead. And then if you're on Linux, you can just click on one of these installers and then just follow the directions here. Basically, if you're on Linux, you download the installer. You don't have to do step 2, but once you downloaded the installer, in your terminal window, you just type in this bash anaconda for 3.5 and bash anaconda for 2.7. So install this for Linux. For Mac OS X, basically you just download the graphical installer and then double click the downloaded.pkj file and follow the instructions there. For Windows, what we're going to be doing is clicking on one of these installers and then double clicking that .exe or executable file. All right, so as far as the version we're going to be using in this course, like I mentioned previously, we actually teach both versions of Python, Python 2.7 and Python 3.5. They're very similar with just a few key differences, and in order to show those key differences, it's easier to show them by using Python 2.7 and then showing you what's changed in Python 3.5, because later on you'll see we can actually import functionality from Python 3 into Python 2.7. So if you want to follow along with the course exactly, then I would suggest you install Python 2.7. However, if you just want to go along with Python 3, since we do cover both versions of the course, you can go ahead and just click on this Python 3.5 version. It's really up to you. If you're super new to programming, then I would suggest following along exactly with the course and using 2.7. If you've done maybe just a few lines of Python code or programming in another language, then 3.5 should be fine as well. Like I said, we cover both versions in this course, so it's really up to you which one of these you want to download. To follow along exactly with the course and the easier way to show 2.7 and 3.5 differences, I would suggest then for newer users just installing Python 2.7. So I will click now on this 64-bit installer and it will download it for me. You'll get a prompt here, thank you for downloading. You actually don't need to put in your email, so just say no thanks. All right, now that that has finished downloading, we can double click on it. Again, for Windows, it's a .exe file. If you're on Mac, it's going to be a .pkg file. Either way, you're going to just double click on this and then open it up. And here we have the setup, and you basically just follow the instructions here. So we can click Next, accept the license agreement, say just me or all users. Depending on whether or not you have the admin password, you may not be able to do all users. I'll just say just me for now. And then the destination folder, just leave that as the default. This is where it's going to actually install Anaconda in Python. So we'll see C, users, whatever your username is, and then Anaconda 2. Then click Next. Now on this screen we have the advanced installation options, and there's basically two options here. One is to add Anaconda to my path environment variable. Make sure that this is checked, and that way we can call Jupyter Notebook from the command line later on. And then the next one is to register Anaconda as my default Python 2.7 or Python 3.5, depending on which version you downloaded. I would also recommend that you select this, but if you already have multiple versions of Python on your computer, maybe you've done another course and have already downloaded Python, you will get a pop-up. So for instance, if I click here, you'll get some sort of warning saying something like a version of Python is already present. We recommend that if you want Anaconda registered as your system Python, you unregister that one first. So this will happen if you already have a version of Python registered on your computer. So if you already have multiple versions, just leave that unchecked. And then we'll click Install, and it will install Anaconda and Python for us. So I will skip forward in time until this is finished installing. Alright, so this is finished installing. I'll click on Next, and then just click Finish here. You don't actually have to learn more about Anaconda Cloud. That's just a service that's offered if you want to have a cloud environment. So just click Finish here. And then the next step is to actually start Jupyter Notebook. Now, if you're on a Mac OS or Linux computer, you're going to open up your terminal. So just do a search for the word terminal, and that will open up your terminal. If you're on Windows, you'll use your command prompt. So on Windows computers, just come here and then search for command prompt, and you should see a couple of options. You'll probably see Anaconda command prompt. You'll probably see your built-in command prompt. If you're an advanced user, maybe you used something like PowerShell before, any of these options is fine. Just click on command prompt here, and you'll get something that pops up. It probably won't be as big and as large fonts as I have here, but I just have this so that way it's a little clearer what I'm typing for you, the viewer. Again, if you're on a Mac OS or Linux, you just open up your terminal. Then, inside your command prompt or terminal, type in Jupyter, that's Jupyter, space, notebook, and then hit enter. And what this is going to do is it's going to start a Jupyter Notebook server. If it's your first time running it, it may take a little while. Eventually, you will see something that looks like this, and the last two lines should say something like, the Jupyter Notebook is running at http localhost 8888, and then you can use Control-C to stop this server and shut down all kernels. And kernels is basically what's going to be running the Python, and we'll show you that in a second. Now, your browser should automatically pop up at this address, http://localhost:8888/. If you do not get the browser pop up automatically, you can just type it in yourself. So you can come here, open up a new tab, and then type in localhost:888. Once you've typed in localhost:8888, you should see something that looks like this. And as a quick note, even though this is opened in the browser, this is not actually connected through the internet. The development environment is just hosted by your browser, but it doesn't require any sort of internet connection. Unlike the 𝗟𝗲𝗁𝗁𝗁𝗁.org website, which we saw earlier, which is over the internet and actually doesn't save any of your work. In this case, we're running everything locally, and it will save our work when we run it. So to start a new notebook, just come over here where it says New, and you should see a couple of options. You'll probably see something like Python conda root and Python default. You won't see all the options we saw earlier with Try Jupyter because those are other what are known as kernels, and you have to install those separately. You can click on either of these two options, Python conda root or Python default, and then it will open up a new notebook for you. And as I mentioned before, you can click here to name your notebook. So I can say my notes, hit enter, and you can then type in Python code, which we're going to be learning about in this course. But to make sure everything worked for you, just type in something like 1 + 2, and then do Shift Enter to run that cell, and you should see the output here. Later on, we'll discuss other things you can do with these cells, such as click on a cell, and over here, put it in Markdown, and then you can type in actual text, such as, hello, this is text, do Shift Enter to run it, and then you will just have text here. So this is just text, not actual code, and you can see that it doesn't have an in or out symbol here. All right. So that's basically it as far as the installation. If you have any questions, you can refer back to the previous lecture where there's a written out guide of everything I just did here, or you can just post a question to the Q&A forums in this course. If you get stuck on anything, I would recommend that you check out the previous guide and the frequently asked questions lectures first. If you still can't find your answer there, then you may want to do a search in the Q&A forums if you're stuck on something. And if you still can't find your answer, please feel free to post to the Q&A forums where I'm happy to help out. All right, so that's it for the installation. Let's move on and talk about other development environments. Thanks everyone, and I will see you at the next lecture. Hello everyone. In this little FAQ lecture, all we're going to be doing is explaining how to download the notebooks. So if you click the link in the FAQ, it will take you to this page, nbviewer.ipython.org/github/jmportilla/complete Python bootcamp. And you'll notice it says tree master. So at this section, you can see each individual lecture file, and it's a .ipynb file. That stands for IPython notebook. That was the previous name of the Jupyter notebooks, but the file extension remains the same as the old version. So here you can see each individual lecture lines up with the lecture name. So for instance, if you're going to go to the numbers lecture, you can just either search for numbers or scroll down here in alphabetical order and click the corresponding lecture. And then here you can see all the notes that correspond with it, as well as this Python 3 alert. Now, to download the notebooks, you go here to the top right, and you'll notice this last link here will say download notebook. You can go ahead and click that, and it will download the notebook for you, and you can save it wherever you want. Now, something to note here, if you save it and you want to open it, you'll need to save it to the exact same directory where your current Jupyter notebook is. In order to find out where your current directory is, go open your Jupyter notebook and in the cell type pwd. Pwd will print your working directory, which is where you should save these notebooks. Okay, that's it. Thank you very much.
and I'll see you at the next lecture. Hello everyone, and welcome to your first coding lecture. So in this lecture we're going to be learning about numbers and more in Python. And we're going to cover the different types of numbers that we can use in Python, some basic arithmetic using those numbers in Python. We'll also learn about some differences between Python 2 and 3 when it comes to division, and we'll get a quick peek at object assignment in Python. So here I have open the Jupyter or IPython notebook. So you can scroll through this notebook, check it out if you want to go in a little slower at your own pace. There's tons of information here, and we'll be going over all this in this lecture video. Okay, great. So let's just get a quick presentation on the two types of numbers we're going to be working with, which are integers and floating point numbers. So I'll do a quick break to the presentation. Okay, here we are at the presentation now. And there's a lot of different types of numbers in Python, and we're going to focus on two types right now: integers and floating point numbers. So integers are just whole numbers, positive or negative. So for example, 2 and -2 are just examples of integers. And floating point numbers is the other number type we're going to be concerned with right now. So floating point numbers have a decimal point in them, or they can use an exponential e to define the number. So for example, 2.0 or 2.0 there and -2.1 are examples of floating point numbers. Also, for e2, either capital E or lowercase e, is an example of a floating point number in Python. And all that means is 4 times 10 to the power of 2. We'll mainly focus on those 2.0s and 2.1 type of floating point numbers, the one with decimal points in them. Okay, so let's go ahead and hop back to the code. Okay, and we're back to the Jupyter Notebook. And now I'm going to hop over to our live code session. All right, so here I'm just going to be going over the code that we go in the notebook. So let's go ahead and check out how to do some basic arithmetic in Python. Here I have my cell, and for addition, all you do is you type the number in and put in a plus sign, so 2 plus 1. Remember, Shift Enter to run your cells. And there you go, that's how you can do addition. So for example, 2 plus 2, again, just 4. All right, subtraction, it's also pretty simple, just a simple dash sign there. And we can do another example, and 3 minus 2. So right now, when we're first looking into Python, we can go ahead and think of Python as just a calculator. So multiplication, the symbol for that used in Python is an asterisk. So there you have 2 times 2, or 3 times 2 is 6, etc. Okay, so here's where we have to kind of keep close attention as we go into division. And the reason I say that we have to pay close attention is because of the following. So let's say I wanted to do 3 divided by 2. So what would you expect 3 divided by 2 to be? Probably 1.5, right? So if you notice, I'm using Python 2 right now. You can see up here in the right hand corner. And the output is 1. So why did this happen? And if you hop over to the Jupyter Notebook, you'll notice you get a Python 3 alert here. So what's going on? So the reason we're getting this result is because of Python 2. In Python 2 and Python 3, you perform division using this / symbol for division. But the difference is in Python 2, this symbol performs what's known as classic division. And that means that the decimal points are truncated off. So 1.5 gets truncated to 1. In Python 3, however, this single / for division performs what's known as true division. So you would get a 1.5 if you had inputted 3 divided by 2 using Python 3. So what do we do if we're using Python 2 and want to avoid this kind of floating point error? So there's different methods. One method is that you can specify one of the numbers to be that floating point number. So I can say 3.0 divided by 2, and then you'll notice we get out 1.5, the expected result. And that can work for either number. So 3 divided by 2.0. The difference being just one of them has to be defined as a float. Some other things you could do in Python 2 is also cast one of the numbers to be a float. And what casting does is it uses a function that basically turns integers into floats. So what that would look like, and we haven't learned about functions yet, but we'll get a quick sneak peek, is you can call float like this on one of those numbers. So it's float parentheses 3 parentheses divided by 2. And what that's basically doing is it's casting that integer 3 as a float. So if I check what's going on there by itself, I get 3.0. Okay, so there's one other thing that we could possibly do. And again, this is just a kind of a sneak preview because we haven't gone over functions or modules yet. But a really interesting module that Python 2 has is called __future__. And it'll actually allow you to import some capabilities from Python 3 into Python 2. And we'll go over what this is actually doing and how it's working later on in some lectures. But with this line, division, let's see. So right now I've written down from space __future ___ space import division. If I go ahead and run that line, what that's done is it's imported division from this future module. And what that basically does is now it treats division as if it were using Python 3. So you notice I can just say 3 divided by 2, and now that's corrected to 1.5. So let me just reiterate the 3 different things we can do here. You can make sure one of the numbers is a float, or you can actually cast one of the numbers to be a float to make that happen, or you can run this line from __future ___ import division, and that will take care of the rest of the divisions you do throughout Python 2. So my suggestion is running this line. We'll learn later on in lectures about modules and what this is actually doing and how this is working. But right now you can just kind of treat it as this magic line. So if you're ever going to be dealing with division a lot in your code, you want to go ahead and put this at the top if you're using Python 2. Okay, so moving on to some more arithmetic. How about we check out powers? So for instance, 2 to the power of 3. So the way you do that is by doing double asterisks. So 2 asterisk asterisk, the power of 3 is 8. I can say 4 to the power of, let's say 5, that's 1024. And we can also, if we want to do roots that way, so I could say like the square root of 4, is the same as 4 to the power of 1/2, in this case 0.5, and that's the same as the square root of 4. You can also do square roots by importing the math function, but importing the math module, excuse me, but we'll look at that later on in the course. Okay, so moving along, we can also learn about order of operations that are followed in Python. So your standard order of operations are followed. So what I mean by that is if I say 2 plus 10 times 10 plus 3, so order of operations indicates that multiplication has to occur first before addition. So this 10 times 10 is going to happen before the 2 and 3 get added. So Python's not going to follow this reading left to right. It's actually going to follow order of operations. And I can see that occur due to the 105 result we get there. Okay, so what if I want to specify some orders? I can use parentheses, just as you're writing a math equation in perhaps like a TI-83 calculator. So if I wanted that 2 plus 10 to occur first, I can use parentheses to specify my custom orders there. Okay, so that's the basic arithmetic. Let's do a quick overview. Addition is just the plus sign. Subtraction, just that dash, that minus. Multiplication is that asterisk symbol. Division, /. Careful to note that if you're using Python 2, you're not going to perform true division. You're going to perform classic division, unless one of them is a float or you use this from future import division line. Okay. And if you're interested in some more details on that, you can go ahead and read this Python 3 alert in a little more detail in that Jupyter notebook. All right, so moving along, I'm just going to give you a really quick introduction to assigning labels to objects to create variables. So what I mean by that is I can use a single equal sign to assign labels to objects. So to show you an example of this is I can say A is equal to 5. Sorry about that. And so now I've set a label A as a reference to that number 5. So if I call A in my script again anywhere, Python's going to treat it as if it was the number 5. And I can also add those objects together. So I can say, for example, variable A plus A, and it's going to treat it as if it was 5 plus 5. So an interesting thing that we note in Python is what happens if we reassign this label. So if I say now A equals 10. So Python lets it write over. So now if I reference A, it's 10 now. So you can write over those assigned labels on those variables. And we'll go in on the next lecture into a little more detail in case you're jumping in from another language on how Python actually deals with these labels. But for the basics right now, you can just treat it as you choose your variable name, an equal sign, and then whatever object you want to label that. Okay, and you can also use the variable label itself to reassign the variable. So what I mean by that is I can say A equals A plus A. And what Python will do is now it'll say, okay, so A is now equal to A plus A. So what was A originally? Now it was right now 10. So A is not going to be equal to 10 plus 10. So if we check that out, there we have 20. Okay, great. So you might be thinking, okay, so what are the rules on creating these variable names? And there's a couple rules that they have to follow. So I'll jump over here to the Jupyter notebook where I have them all. Okay, so these names, they cannot start with a number. There can also be no spaces in the name. If you want to specify some spaces, probably use a underscore instead. They can't use any of these symbols right here. All of these symbols are forbidden, and it's usually considered best practice that the names are lowercase. So let's go ahead and go over a super simple example of how we can use these labels and these variables that we make to clean up our code a bit. So these variable names help us keep better track of what's going on in our code. So to give you a small example, I'm going to make a variable called my_income. And I'm going to set it equal to the number 100. And then I'm going to make another one called tax rate. Tax_rate, and I'll set that equal to 0.1. Great. And so now, finally, I'll say my _taxes that I have to pay is going to be equal to my _income multiplied by my tax rate. Great. And if I've run that cell, now I've defined my taxes as my income times my tax rate. And if I call it to see what that value is, it's 10. So 100 times 0.1, that 10% tax rate, my taxes are $10. Great. So what have we learned? We've learned some of the basics of numbers in Python. We've also learned how to do arithmetic and use Python as a basic calculator. And we wrapped it up with a quick introduction to variables and how we can create them and label them in Python. So next up, we're going to learn a little bit more of how this variable creation and labeling works. But go ahead and feel free to just mess around with Python. I think one of the best ways to get a quick introduction to Python is just treat it as a calculator. And then with the introduction of variables and labeled names, you'll slowly get more and more complex with your code. But go ahead and mess around with different additions, multiplications, powers, etc., divisions. Make sure you really understand how to do all those operations, because numbers is going to be one of the main building blocks we work off of in our code. So keep in mind the difference between integers and floating point numbers, differences between Python 2 versus 3 when it comes to division, and all the different arithmetic you can use Python for. Okay. So that about sums up our lesson. Remember, there's always more to read in the Jupyter notebooks if you want to go into a little more detail over anything. All right, guys, thanks, and I'll see you at the next lecture. Hello, everyone. In this lecture, we're going to be going over just interactive command prompts, IDEs, integrated development environments, what they are, what are different practices for running Python code, and we'll get a quick introduction on why we decided to choose Jupyter Notebook for this course in general, and what other options are out there. In future lectures, we'll get a deeper dive into Jupyter Notebooks in general, but for now, I just want to show you a couple things. So, you might be wondering, how do I actually run Python code? We saw a little bit earlier with the with the IDLE that comes in with Python, or idle, it's sometimes known as. Let's go ahead and try that again. So here I'm on Windows. What I'm going to do is type in anaconda command prompt. If you're using a Mac, you can just use the terminal for this. So if you're on Mac, just go ahead and open up the terminal. Now, most users are on Windows, so I'm going to say anaconda command prompt, open up my command prompt, and here what I'm going to say is Python. And if I type out Python, what happens is I'm actually running Python within this command prompt, or within the terminal. And now I can put in Python commands. So I can say print hello world. I can do 2 plus 5, it'll return 7. Now I can actually interact with Python and work with Python. If I want to quit, I just say QUIT, open and close parentheses, enter, and now I'm back in my terminal line. So if I try to say print hello world now without calling Python, you'll notice I get an error. That's because I'm not actually running Python. I'm just exploring the command prompt or the terminal on my computer right now. I'm not actually running Python. So what are our options for running Python code? I'll go through a couple of options and different ways to run Python code in general, and then I'll settle at the end on the Jupyter Notebook and discuss it a little bit further. So what's a way we can run Python code? Well, the first way is what we just did, right? I can type in Python, and I can run Python code this way. So I can say 4 plus 5, etc. And I know you guys don't know any Python yet, but don't worry. Hopefully these are simple enough commands that you can see what's going on. Now, you can imagine if I have some really long code, I don't want to have to type it in here line by line. So what would I do then? Well, I could get a text editor. So any text editor would do. Right now I'm just using a simple notepad. And I can type in print hello world. And what I'm going to do now is file, save as, and I'm going to save it as first underscore program.py. And I'm going to save it in the same directory that was showing up here in Python. So I have C users, my username, anaconda. Okay, so that's where I'm going to save it. So let me find that location. OSC, scroll down to users, my username, go to anaconda, and I'm going to save it right here. And notice I'm going to save it under all files type, so it takes the .py. And this is actually now going to be a Python code. So I can come back here. I'm going to quit the Python instance that's running. Notice now I'm back on just normal command prompt. And then I can type Python space, and then I can actually say first underscore program.py. And if I hit enter, you'll notice I can put hello world out there. So this is how I could theoretically run larger programs. I could type it all, if I knew the syntax, into this text file. So I'm going to print some more stuff here just so you realize it's actually working. File save. And then if I press up on my arrow key to get that code again, just that statement of Python space first_program.py, and I hit enter, you'll notice now it's running everything I put into the text file. So this is one of the most basic ways to write a .py file and have Python run it. You go to your command prompt or your terminal if you're a Mac user, say Python space, make sure you're in the location. So here I'm at C users, my username anaconda. You have to be at the correct location for this to work. Say Python and then whatever that .py file is, and it will automatically run it for you. So you might be thinking, this looks kind of ugly. I don't really want to use Notepad all the time. So what are better options? And this is where your options will really spread out and you have a ton of them. So I'm going to go over a few of them and then end up on the one we'll use for this course. So one option is just to use a nicer text editor. So some text editors that are really common are Sublime Text. So Sublime Text is a free text editor, and it'll actually highlight, and you can see some videos going on here, highlight code syntax and help you out a lot in that fashion. It has a lot of features and is one of the most common text editors used. Another common text editor is Notepad++. So here I've just Google searched Notepad++. It's another common text editor, and depending on how you save your file, so if I save a file as .py, it'll actually do highlighting. So you can see here there's some highlighting based on what the syntax is. So that's one version. Just get a nicer text editor. Then there are other integrated development environments, IDEs, that are specifically for Python. Some of them include WingWare, Python IDE. So it's an intelligent development environment for Python programmers. Another one is Komodo. So Komodo is actually more of a text editor that just like Sublime and Notepad that you can also use. There's PyCharm, which is another Python specific IDE. And then there's Spider, which if you're coming in maybe from a language such as MATLAB, Spider will feel like a really familiar environment feel to you, and it's based heavily on scientific computing. And then another one, which is a little different, is Jupyter. And this is the one we're going to be running our course in. So if you go to jupyter.org, remember we've already installed Jupyter through Conda install Jupyter or Conda update Jupyter. I'm going to go ahead and scroll down and say try it in your browser, and I encourage you to do the same thing. So this is what Jupyter looks like when you run it in browser or run it in your own notebook. And you can click here, top right. I'm going to zoom in a bit so you can see better. And future lectures, you'll notice Jupyter, it's way more zoomed in, so I apologize if you couldn't see. But what's nice about the Jupyter Notebook is it supports other languages such as R, Julia, Bash, Haskell, Scala, Ruby. So if you ever decide to work in other languages, Jupyter Notebook's really nice in that way. Here I'm going to create a new notebook using Python 2. So I clicked new there. And you'll notice what's really nice about this that I think makes it ideal for teaching Python and learning Python is if I say, you'll notice I have a little cell here in. If I say print hello world and then click run, so run cell, you'll notice the output is actually put right below that cell. So you have an input and then an output directly. This is a really nice system if you're just starting to learn Python because you can directly interact and see what code comes out when you have code in. It's also really nice because it's really easy to share these notebooks. I can name these notebooks, so I can name this first program, save it, upload it to the internet, share it. You'll notice there's going to be Jupyter notebooks for every single lecture in this course. And this makes it an ideal environment for learning Python. It's a lot nicer, it's a lot more direct. You can download the notebooks that I've made for you, and that's why we're going to be using it for this course. Now, will Jupyter scale to much larger programs? No, it won't. So if you begin to want to go into full stack web development with Python, you'll eventually have to abandon Jupyter notebooks and go for something a little more heavy duty, such as PyCharm or other text editors. What is Jupyter really good for? Jupyter is really good for, like I said before, learning and teaching Python. It's also been extremely popular in the field of data science. So there's a lot of features that Jupyter has that we'll talk about in the next lecture that allows you to really take into account a lot of the new data science modules and libraries for Python. And that's personally why I really like it and use it. And it's really common just for ad hoc analysis and quick data analysis in the data science field with Python. So that's where you'll see it used in a more professional state. It's also really nice just to make games with it. Again, if you're making a more heavy-duty game, you'll eventually abandon Jupyter. But for right now, for this course, it's the ideal learning environment, and I think you'll really learn to love Jupyter, and you're going to be a big fan of it by the end of this course. Okay, so I've talked a lot about Jupyter, but haven't said much of how it actually works, how you can run it on your own computer. So let's go ahead and go to the next lecture where we can learn about Jupyter, which were previously known as IPython notebooks, just to let you know. And let's learn more about how we can make Jupyter run on our own computer and how they work there and the various features of it. Okay, thanks, and I will see you at the next lecture. Hello everyone, and welcome to the strings coding lecture. So in this lecture we'll be learning about strings. Right now I have opened a live coding notebook, and as always there's an entire corresponding Jupyter notebook for this lecture. For a quick overview of the notebook, it goes over creating strings, printing strings, some differences in printing between Python 2 and 3, string indexing and slicing, string properties, string methods, and then some print formatting issues. So here's what the notebook looks like. You can go ahead and check it out on your own, and everything in this notebook is what we're going to be going over in this lecture. Okay, great. So let's go ahead and just jump right in and get started with some coding. Alright, so strings in Python are used to record usually text information, such as a name. And the way you can create a string is by using single quotes or double quotes in the most basic format. So I can put in a single quote here and then say hello and end it, close it off with another single quote, shift enter to run that cell, and now I have a string there. You can also do an entire phrase like a sentence. So I can say this is also a string, close it off, and you have a string that way as well. Now something important to note in Python is that what Python realizes here is that this string is a sequence, and we'll go over that further in just a little bit. But the way Python is thinking about this string, if you will, is that it's seeing every single letter here as part of a sequence, including the spaces. And when we learn about indexing and slicing strings, that will become a little more clear. Something I also want to note is we've been using single quotes, but we can also use double quotes to create a string. So here I have a double quote, and I can say this is a string, and you can see that works just as well. Now, why would you use double quotes versus single quotes? The reason for that is, let's say you have a string where you wanted to say I'm a string. Now if you notice here, I'm using a single quote in this I'm, so that's going to return an error because of an invalid syntax. So that's one of the instances where you're going to want to use double quotes if you have a single quote within your string. And now that will be fine. And you can also do the opposite. You could, let's say, this is a quote. And you can see that the double quotes are now within this string. Great. So now let's learn about printing a string. So because we're using this Jupyter Notebook setting, if we just run a cell that only has a string in it, it will automatically output the strings. But the correct way to display strings in your code, if you're using idle or another IDE that we've gone over before, is through printing a string. So we can declare a string such as hello world, and let's say we wanted to put in multiple strings. So I say hello world 1 and hello world 2. So if you notice here in this Jupyter Notebook setting, only the last string was displayed. So the correct way to output these strings is using a print statement. And the way that works in Python 2 is by writing the word print, space, and then whatever string you want to print. So here again, I'll do it. Print, space, and then the string. So now, you'll notice here, it's actually printing the string. And these quotes, these single quotes that we saw earlier, have gone away. And this is the main way you want to output or display strings in your code. Alright, some other things to know is that there's special backslash characters we can use in order to print certain things. And what I mean by that is, let's say I wanted to print a new line, such as a space or something. And the way you can do that is by using a \n notation. So I'll show you what that looks like in practice. So I'm going to put a string that says here is a new line. And I'm going to put that \n, and here is the second line. So if you notice, this \n is an indication to Python to not treat this as a regular n, but actually treat this as a new line symbol. And so what that does is it prints out everything until it hits that new line, and then it prints everything else afterwards. So it's able to break up your print statement into multiple lines. Another feature that uses that backslash is T, which stands for tab. So if I run this, it'll actually insert a tab, those like 5 spaces in between where that \T was. So that's just something to be aware of. Okay, so if we hop over to the Jupyter Notebook, you'll notice there's a Python 3 alert when it comes to printing. So let's go ahead and take a better look at what that's actually talking about. So Python 3 alerts. There's something to know. If you're using Python 3 versus Python 2, print is a function, not a statement anymore. So if you noticed earlier, we've been printing things with print, space, and then that string. So in Python 2, your print statements are actually going to be print functions, and they're going to look like this. They're going to say print, parentheses, whatever string you want to print, and then close parentheses. That happens to be a point of confusion because a lot of times you start tutorials that are either in Python 3 or Python 2, and one of the very first assignments you have to do is print hello world, and people get confused based on what version they're using. So you can go ahead and fix this. If you're using Python 2 but want to use the print function, just as before, you can import from the future module. And we'll go over modules later on in the course. But if you want to be printing using Python 3 functions instead of Python 2, you can put this line in your code from __ future _ space import space print _ function, and that will import this functionality into your Python 2. So up next, we're going to be learning about string basics such as length and string indexing. So I won't go ahead and import this. I'll keep using the Python 2 notation, but if you're using Python 3, just keep in mind this is what your print functions are going to look like. And if you're using Python 2, you can import that functionality with that statement. All right, so let's go ahead and move along to some string basics. So we can use a function called len to check the length of a string. So I can say hello world, close it off with single quotes, and then I can put that inside a length function, len. And the way that's going to look is len, open parentheses, whatever that string is, close parentheses. And if I run that, it counts the length of the string. So keep in mind, as I said before, the strings are a sequence. So that means that Python can use indexes to call parts of that sequence. And that also means that Python is taking into account that middle space as part of its count. So if you count this here, there's 10 letters, but that space counts as another part of that sequence. So the total count of that length of that string is 11. All right, so let's go ahead and assign a label and create a variable here. So I'm going to say s is equal to hello world. And so now if I call that S either by printing it or just calling S there, S is been assigned hello world. Great. So let's go ahead and start indexing. So indexing uses brackets in Python. So the way this is going to work is I can say S, open bracket, the index number, close brackets, and that will return the first element. So something to note in Python is that indexing starts at 0. So like I said before, each of these letters and spaces in this string is part of a sequence. So Python is thinking of this capital H as being in the 0 part of the sequence, E as being in the 1 part of the sequence, 2, 3, 4, so on and so on. So let's say I wanted to get that second letter, which if we're counting from index 0, that's going to be bracket 1, then that can be E there. Great. So we can also perform slicing, and slicing grabs everything up to a designated point. And the syntax for that is using a colon. So I'll show you a quick example. So let's go ahead and grab that S, colon, or whoops, sorry, open bracket, 1, colon, close bracket. So before we actually run this, let's break down what Python's going to say. It's going to say, for this S object, which is hello world, grab everything from that one index, and this colon means onwards. So this will grab everything from 1 all the way to the end. And since indexing starts at 0, that's going to be ELLO space world. And if you notice, something to keep in mind is right now there's no change to that original string. We're just grabbing part of it with this notation. Okay, so you can also say grab everything up to something. So let's say I wanted to grab everything up to the 3rd index. Well, that will give you HEL. So to keep in mind, it's everything up to the 3rd index. So if I look at hello world again, let's just go ahead and show S. That's 0, 1, 2. So if I say colon to 3, that says grab everything, that's what the colon stands for, up to that 3rd index. Remember, it's up to, it doesn't actually include it, which is why we only get 3 letters back. The 0, the 1, and the 2 index. So just to reiterate, here we're telling Python to grab everything from 0 up to 3, not including the 3rd index. So you'll notice this a lot in Python. A lot of the statements and usually a lot of the indexing statements are in the context of up to but not including. Okay, so hopping back to that colon notation, if I wanted to grab everything, then I can just say a colon, and that says grab everything. So something that's really nice about indexing is that we can also go backwards. So if you imagine that this string is almost like a loop, if H is 0, then -1 or 1 backwards would be the last letter or element in that string. So I can say S bracket -1, and that will return D. So that's the last letter. So 1 index behind 0, it loops back around and grabs that D. I can also use that same notation to, let's say, grab everything but the last letter. So I can say grab everything but that last letter there. So that will be hello world without that D at the end. Another thing we can use indexing and slice notation is to grab elements of a sequence by a specified step size. So if you notice right now, the default is 1. But we can use 2 colons in a row and then a number to specify a frequency to grab elements. So what I mean by that is a quick example. I could say, whoops, square brackets, colon, colon. So that means grab everything up to everything. And that 3rd number is going to specify the frequency, so in step size. So right now, this will be everything. So grab everything, that colon, colon. in step sizes of 1. But I could also say go in steps of 2. So I could say : step size 2. And now that's pretty much going to grab every other element or letter in that string. And something you can also do is use that same notation to print that string backwards. So I can say grab from the beginning of everything to the end of everything, but your step size is going to be -1. So that's actually telling Python to traverse the string backwards. And it's actually gone and printed out that string in reverse. So this is just a simple notation for reversing a string. These double colon notation methods are not super common, but this reversing of a string is a pretty quick and common way. At least this particular line is pretty common. But these other ones are not super common, but it's important to know them in case you ever find yourself needing them in your code. All right, so let's go ahead and learn about some string properties. Something that's important to note is that strings have a property known as immutability. And the way you spell that is immutability. Immutability. So what this means is that once that string is created, the elements within it can't be changed or replaced. So for example, remember S currently stands for hello world. And let's say you wanted to try to change the first letter to X instead of H. You might think you'd be able to say, hey, that 01, set it equal to X. But if you notice, we get an error. And the type error is string object does not support item assignment. So as you go along in learning Python, these errors are going to be super helpful to find out what you're doing wrong in your code. So something that's always important to remember for strings is that they're immutable. Once it's created, you can't go around changing the particular elements in the sequence. What you can do, though, is concatenate strings together, so you can add on to them. You can't just change what's already there, though. So what I mean by concatenating is, let's say you have S, you can use the plus symbol to concatenate strings together. So I can say S plus, and then let's go ahead and make another string. So I can say concatenate me, which is basically just saying to stick it onto it. And here I have hello world space concatenate me. So while I can't change particular elements in that string, I can add on to it. So that is allowed. And I can also reassign S completely. Just as we saw earlier in some previous lectures, I could say S equals S plus concatenate me. And now if I run that and I check what S is, now S is equal to hello world space concatenate me. Great. Some other arithmetic symbols you can use for strings is the multiplication symbol. So for instance, if I say letter is equal to the string just Z, and then if you notice I call letter as that variable and I get Z, then if I say letter times 10, Python's going to print that letter 10 more times, or 10 times the original amount, whatever it happens to be. So then if I say, let's say letter equals ZZ, print out that letter check, and now I print it 10, so now it's double as many times. Okay, and now we're going to wrap up our method with a quick introduction to built-in strings. Built-in string methods. So objects in Python, they usually have built-in methods, and these methods are basically just functions inside the objects, and we'll go into all that in much more depth later on, but they basically allow us to perform actions or commands on the objects itself. So let's go ahead and create or reassign S again, just to say hello. And here I have S equal to hello. And the syntax for methods on objects is going to be whatever that object label name is, in our case S, dot, and then you call the method on it. So one of the most simple methods for strings is to uppercase a string. And that method is known as upper. Close parentheses there. So basically what this is doing is it's saying, okay, take my string s, that period or decimal point is an indicator that I want to call a method on that object, and then the method I'm using is upper. And I'm going to say close parentheses because I'm not going to add what are called arguments into that method. And so what that does is it basically uppercases that entire string. So the reason we're using Jupyter Notebooks, and that's super awesome, is you'll see if I click tab right after that decimal or a period, I get a list of all the different methods I can use on my strings. So if you want, you can go ahead and check out the advanced string lectures, and we'll go over and break down a lot of these different methods that are super useful for strings. Okay, so a couple more methods I want to show you is lower, and I can close parentheses there, and that will lower that string again. So you'll notice here that capital H is now lowercase h. Another thing is I can split a string, so I can say s.theSplit method, close parentheses, and if you notice here, nothing happened. It's returning a list, which we'll learn about in a little bit. But I can say split by a particular element, so I can say split by e, and now you'll notice it's returned a list of that string, but it's split it where that e occurred. So I have h as an element and now LLO as another element in that list. And we'll be going over lists in just a second. Great. So that's about it as far as strings in general. We'll be working with them a ton in Python. So go ahead and review the Jupyter Notebook that goes along with this lecture. Make sure you understand everything. And we'll be recovering and re-going over strings as we move along in the course. Great. And like I said earlier, if you want to learn more about some of these methods, go ahead and check out the Advanced Strings lecture. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the Print Formatting lecture. In this lecture, we're going to cover the various ways to format your print statements. As always, there's a full Jupyter Notebook that goes along everything we're going to cover. So we'll be covering the various formats of strings in Python 2 and Python 3. We'll also go over floating point number syntax. We'll look at some conversion format methods. We'll look at multiple formats, and then we'll look at the string.format method, which is probably the best way to use print formatting in Python. Okay, so let's go ahead and get started with some live code. First thing we're going to do is what we just covered in the string lecture, which is just a basic print statement. Again, remember, this is for Python 2. So I'm going to say this is a string. If you're using Python 3, this would be a print function, which we covered in the last lecture. Continuing on, let's say we had a variable that we wanted to insert into this string. So I'm going to make a variable called s, and it will be called string. And now what I want to do is place that string within another string, or really place that variable. So I'm going to say print place my variable here. And the syntax looks like this. It's going to be %s, %, parentheses, and then the object variable label. So if I click Shift Enter here, it's inserted that string variable into my other string. And I want you to notice here, I could have named this variable anything. So I could have said x here, and as long as it matches up x, it'll still work. What this S stands for is string. So what this is actually doing, it's transforming whatever object you have in these parentheses in front of the %sign into a string so it can place it in the string. And because it's transforming it into a string, I can actually put in numbers here as well. And if I run this cell, you'll notice it still works. And it's the same with floating point numbers. So for instance, 13.13, if I run it, it takes 13.13 here as x and transforms it into a string that I can put and format into my string before I print it. Okay, so that's one method of putting your variables into your string. Let's go ahead and check another one that's more specific to floating point numbers. So I'm going to say print floating point number colon, and the format's going to look something like this. It's going to have that same percentage sign, but it's going to have two numbers with a decimal in between. So I'm going to say 1.2 and then an F for floating point number. And then we'll close off that string with a single quote. And here we'll pass in a floating point number. So let's say 13.145. All right, so let's take a look at what happens. So if you notice here, it got cut off to 13.14. So why is that? If we notice these two numbers here, the first number is the total minimum number of digits that this string should contain. And I'll make that clear in just a second by enlarging that number. But what we want to focus on right now is the number that comes after the decimal. So this placeholder number stands for how many numbers to show past that decimal point. So if I were to change this to 3, it will show 145 when I run this cell. And likewise, if I change it to 1, it will only show one number when I print that cell. Now if I make it a very large number, such as 10, it's going to fill in the rest of those numbers with zeros. So again, this number after the decimal point tells you, or tells Python, how many digits will I show past that decimal point if it's a floating point number. Let's go ahead and remain it with 3, or have it stay with 3. Now, this first number is the total minimum number of digits that the string should contain. At least that's the way you can think about it. So if I put 1, nothing's going to change. But let's say I put in a very large number, such as 25, and click enter. Notice how we fill in a bunch of white space. So since you're telling Python, I need this entire digit here to take up 25 essentially characters, it's going to fill in the characters that are not there with white space. So you can go ahead and just arbitrarily leave this as 1 if you're not really concerned about your print formatting for floating point numbers. If we hop back over to the Jupyter Notebook, I've put in quite a few examples for you to really get an idea of how this affects your print statements. Okay, let's go ahead and move on to conversion format methods, which we've actually already seen one. So these two methods will just convert any Python object into a string. So the first one that we've already seen is convert to string, and that's just that %s. And then what I will do is just pass in any object, such as an integer, and it converts it into a string. The other formatting tool we can use is %r, and it will actually do the same thing. But the difference between them is they use two separate methods. One uses something called str function, and the other one uses this repr function. So don't worry about those specific functions right now. We'll learn about them later on and how those two separate methods are different. But I just want you to be aware of R and S as print formatting options. Okay, so let's say you wanted to put in more than one variable into your string. How would you do that? Well, you can use multiple percentage signs. So I can say print, let's say first, %s, second, %s, and then third, %s, and then I will finally call a percentage sign, and here have parentheses. And what I'm going to do now is pass in objects in the order I want them to show up. And this is something that we're going to look into further in just a tiny second. So if I say hi as my first object, and I'll have this one say 2, and this one just pass in a number 3, and I run that cell, what Python's going to do is it's going to take them in order. So this first percentage sign is going to be assigned the first item in this, which is a tuple, which we actually learn about in later on. And then the second one takes in 2 in order, The third %s takes in 3, converts it into a string, and then places it and formats it into your string. This is kind of a classic method that you see used a lot when you're reading other people's code. But the best Pythonic way to do this is using the string.format method. And I'll show you why. So let's say we wanted to print first, seconds, %s. Now, if I actually wanted the same object to go to both of them, I'd have to write it out twice, something like this, in order to make sure the code doesn't have any errors. But with the format method, it's actually a lot cleaner, and I'll show you why. So I can say print first, and I'm going to use curly brackets here, and I'm going to put in some arbitrary variable label, and you'll see why in just a second. And then I'm going to say seconds, and again, I actually will put in the same label. Close off my string, immediately afterwards, put in a period, and call the format method on that string. And then I will pass in the variable x, which let's say I wanted it to be a string called inserted. And notice here, I only have to define this variable once for it to get inserted multiple times. And this sort of syntax is really powerful in case you want to mess around with the order. So let's make another variable here called y, which we'll call just 2 exclamation point, so it's really clear where it is. And what I'm going to do is now change this to third, put in seconds in the middle, curly brackets y, curly brackets. So notice the syntax here. I put in curly brackets and then the variable name, and then the dot format, I just define what each variable is. And now if I run this, you'll notice I get first, inserted, second to third inserted. So this is really nice since I don't have to worry about everything being in the right order anymore. I just have to worry about the variables having the correct names when I call them. And this is really the way you should be print formatting as you go along throughout this course. It's the more Pythonic way of doing things. Okay, so that's the basics of string formatting. And just to remind you, Python 3 uses the print function, not the print statement. So I've already shown you how we can change that with an import method. So let's go ahead and bring it out here. So I'm going to say from, future, from future imports print function. And if I call that, now I can say print some string, hello, it prints. So this would be the case if you're using Python 3. Now again, I'm using Python 2 here, so I had to do this import statement. And we'll learn about import modules further on in the course, even though we already covered them a bit in the last lecture. Alright, so what if I wanted to do the same formatting? It would be pretty much the same, just within the context of that function. So I would say 1 x dot format colon x inserts, just some strings so that it's really obvious. Close off my parentheses, make sure they all match. Enter, and there you have it. So this is what it would look like if you're using Python 3. Again, in case you're confused about prints functions in Python 2 versus Python 3, make sure you go back and visit the string lecture where we cover the differences between both of them. Okay, so let's do a quick overview of what we learned, and let's hop back over to the Jupyter Notebook. So in this lecture we covered print formatting. We saw how we can format with strings using the %s notation and syntax. Remember, this %s will just format strings into your print statements by converting any object type into a string. We also saw the specific syntax for floating point numbers if we wanted to declare exactly how many numbers we wanted or how many characters we wanted, either after the decimal point or just in total. Remember, white space will be filled if you don't have enough characters in that floating point number. Then we looked at two conversion format methods, %s and %r, that actually convert any Python object into two separate methods. We looked at multiple formatting using this syntax. And then finally we learned about the dot format method for strings, which allows us to just define variables, and here you can see more examples in the Jupyter Notebook about that. But what's nice about this is we only have to worry about calling the variable names inside these curly brackets instead of maintaining the order as we did in that previous %sign method. Okay, so that's it as far as print formatting. Make sure you take your time throughout this lecture and go ahead and read the Jupyter Notebook if anything was not clear. All right, thank you very much, and I will see you at the next lecture. Hello everyone, and welcome to the lists lecture. So in this lecture we'll be learning about the list data structure in Python. And we discussed earlier that strings are a type of sequence in Python. And we're going to learn now that lists can be thought as probably one of the most general versions of sequences in Python. So let's go ahead and get started. Here I have opened the Jupyter Notebook, and we're going to learn about creating lists, indexing and slicing lists, some basic list methods, and then nesting lists, and we'll get a quick introduction to list comprehensions. So this is a quick overview of everything in this Jupyter Notebook. You can go ahead and check it out. But let's go ahead and dive into the live code. All right, here we go. So now we're in the live code. Let's go ahead and assign a list to a variable. So I'm going to create a variable name called my_list, and I'm going to create a list. So lists are constructed with square brackets, and then they have commas separating every element in the list. So for instance, if I wanted to make a list of the numbers 1, 2, 3, so right now in this format, my list is everything in between these two brackets, and it allows me to keep track of this sequence of elements, 1, 2, and 3, and they're all separated by commas. Shift Enter to run that cell. So we just created a list of integers. So if I say my_list, and I can remember to do tab to autocomplete, there I have my list output. So as I mentioned, this is a list of integers, but what's nice about Python is lists can actually hold different object types. So for instance, I can create my list, and I'll set it equal to a new list. And this list is going to contain a string, an integer, 23, and even like a floating point number, so 1.2, and let's put another string in there for good measure. There we go. And now if I call my list again, you can see the list is holding different object types. So it's holding a string, it's holding integers, floating points. So lists can hold different object types. You can go ahead and mix and match them within the list. So just like strings, there's a length function, and the len function also works for lists. So I can say len of my list, remember tab autocomplete, and there I get the list's length is 4, and that's because there's 4 elements. There's the string, 23, 1.2, and that O string. Okay, so let's go ahead and jump into indexing and slicing. So indexing and slicing is going to work just like we explored indexing and slicing in strings. So let's go ahead and make a new list, or just reassign that list label. So I'm going to make a list of 1, that's string 1, 2, let's say 3, and then let's go ahead and put in some integers to mix it up. So 1, 2, 3 in strings, and then 4, 5. Remember, each of the elements is separated by a comma. So since this is a sequence, I can index and grab stuff in that sequence. So if I say my list, that variable name, with brackets and then 0, that's going to grab the element at index 0. And in this case, it's just that first one is that 1. So just like in strings, the notation is the same. So whoops, let's say I want to say my list, and let's say I wanted to grab index 1 and everything past it. I can use that same colon notation. So my list, grab everything at element 1 and then everything past it. So that's 2, 3, 4, 5. Because remember at index 0, that's the 1 string. So let's say I wanted to grab everything up to index 3. I can say my list, and I'll say everything up to element 3. So :3. And that returns 1, 2, 3. Great. So we can also use the plus symbol to concatenate lists, just like we did for strings. So if you remember from the string lecture, I could say hello plus space, let's say world, and that would concatenate it into a single string hello world. So I can actually do the same with lists. So I can say my list, and that's just the 1, 2, 3, 4, 5 there, and I can concatenate it with another list. So I'll create a new list and concatenate it. So what I have here right now is this variable, my list, my underscore list, representing my list, and I'm going to add or concatenate this list consisting of a single item, which is just a string here, and that's denoted by those square brackets. There we go. And if you notice, when you concatenate it, it basically kind of just appended it to the last item on that list. Now again, it's important to note, since we're not reassigning anything here, if I just copy and paste my list here, that list hasn't been changed because I'm not reassigning it. Okay, so if I wanted to make the change permanent, I would have to reassign it. So I'd have to say my list is equal to my underscore list plus, let's say, permanent add. And now if I check what my list is, here I've added it permanently because I've reassigned it using that equal sign. All right. So we can also use the multiplication or the asterisk symbol for duplication, just like we did in strings. So I can say my list multiplied by 2, and that's basically going to just double my list. So 1, 2, 3, 4, 5, permanent add, and then again 1, 2, 3, 4, 5, permanent add. And you'll notice the output is just a singular list of the elements twice over. So again, that's not permanent since I'm not reassigning anything. If I just call my list again, I get that original list. Okay, so if you're familiar with another programming language, you might start to draw parallels between arrays in another language and lists in Python. But lists in Python tend to be more flexible than arrays in other languages, and there's usually 2 good reasons for that. They have no fixed size constraint, so for instance, this list, it can be as big as we want and we can keep adding to it. So I don't have to set any restrictions beforehand. I don't have to say, hey, this list is going to be 5 elements long in the sequence. Python allows us to just keep adding and growing to that list. And like we saw, what's nice about lists in Python is that they have no type constraint. So you saw earlier I was mixing strings and integers and floating points and different object types into that list. So let's go ahead and explore methods for lists. So I'm going to say L is equal to the list, square brackets, 1, 2, 3. So here I have my list, L, equal to 3 elements, 1, 2, and 3, in that sequence. So one method we can use is the append method. It's going to be one of the most common methods you use on a list. So again, the way methods work is you take that variable or label name, put a dot, and then type in the method you use. So in this case, the method I'm going to use is called append. And then append looks like this, has closed parentheses, and the argument you pass into it is the item you want to add to the end of the list. So for instance, I want to add a string called append me. And if I look at the list now, L, you'll notice I've appended to the end of that list that append me string. So just to reiterate again, since we're using the Jupyter Notebook and it's such a great tool for learning, if I say L dot and then click on tab, it'll give me a list of all the available methods. Go ahead and check out the advanced list lectures for a breakdown of a lot of these methods, but we're going to go over a few of them in this lecture as well. And again, I can say L.append, and since we're using the Jupyter Notebooks, I can say Shift Tab, and it will give you the doc string and some additional information. So it'll tell us 𝗟.append, you put in the object, and you can append object to the end. Great. So right now we have L is equal to 1, 2, 3 append me. Another method that's commonly used in lists is the pop method. So you can use pop to basically quote unquote pop off an item from that list. So by default, pop takes off the last index, but you can also specify which index to pop off. So what I'm going to show you is just a quick example. So I can say L.pop, and that basically returns that last element in your list, and it also permanently affects your list. So it just says, okay, I'm going to grab off that last item, pop it off, and then return it back. So let's go ahead and say I'm going to say x is equal to L.pop, and I can also specify which index. So by default, the index is -1, which would be your last element in that list, but I can pop off whatever index I want by passing it through. So let's say I wanted to pop off the 0 index item, which in this case would be 1, that very first item. So here what I'm doing is I'm saying L is my list, call the pop method on it, that .pop, and then I'm passing the index I want to pop off, which would be 0, which corresponds to that 1 element. And I'm using the equal sign to set that equal to a variable here. Great. So if I check out what x equals now, x is equal to 1, and if I check out my original list, L, I notice now it just consists of 2 and 3. Okay, great. So it should be noted that lists indexing will return an error if there's no element at that index. So for instance, right now my list consists of the elements 2 and 3. So let's say I call index at 1, that should return 3. Remember, indexing starts at 0, so 0, 1. But let's say I said index of 99. So that's going to return an error, and if we read the error right here, it's an index error, and that's because the list index is out of range. So that makes sense. We can't index something that's out of range in that list. Okay, so let's go ahead and make a new list to explore 2 more methods, sort and reverse. So I'm going to say new underscore list is equal to, and in this case I'm going to use strings, just letters. So I'm going to say A, E, let's say X, B, and C. And the reason I'm not just doing the straight alphabet is because I'm going to show you how to sort and reverse some of this. So go ahead and make a new list that looks like that. Let's go ahead and make sure everything worked. Okay, so here's my new list. Remember, we're just using square brackets. The elements are separated by commas. So what can I do as sort and reverse methods? So if I check out new list dot and tab, because I'm in Jupyter Notebook, I can see that there's a reverse method here. So let's go ahead and click enter and see what happens. As you might suspect, it reverses the order, and it's a permanent change to the list. So now it's reversed the order of that list. And what if we wanted to sort that order? Then I can say tab, let's go down to sort, and now if we check out that list, it's been sorted into alphabetical order, A, B, C, E, X. Great. So in the case of numbers, if that list was full of numbers, it would sort them in ascending order. All right. So another great feature of this data structure in Python that is the list is that they support nesting. And you'll notice a lot of data structures in Python support nesting. So that means you can have data structures within data structures. So for this example, we're going to do a list inside of a list. So let's get a quick look at how this works. I'm going to make 3 lists. I'm writing right now, well, let's say L_1 is equal to 1, 2, 3. I'm going to say L_2 is equal to 4, 5, 6. I'm going to say L_3 is equal to 7, 8, 9. Okay, so I've created 3 lists, and I can actually make a list of lists. So I'm going to make another object called matrix, and I'm going to set it equal to a list of lists. So I'm going to say this matrix is a list itself, but I'm going to put in the elements as lists. So I'm going to say L_1, L_2, comma, L_3. So now I can treat this as a matrix, because if you notice here, I have my list, which is the matrix, and the elements inside of it are actually lists as well. And this is what we mean by nesting data structures. So I have a list inside of a list, and this can keep going deeper and deeper. So you can have a list inside of a list, which is inside of another list. So we can again use index to grab elements, but now there's going to be 2 levels to that index. So the items in the matrix objects, and then the items inside of that list. So I'll show you what I mean by that. So let's say I have my matrix object, which is just that list of lists, and I say index 0. So what's that going to return? That's going to return the first element in that matrix object, which will be 1, 2, 3. All right. So now that I have this first item in the list, I can actually index it again because it is a list. So I can say grab the first item in that matrix object, and then grab the first item or element in that list itself by putting another pair of brackets there. So you can see that I have multiple levels to this indexing, and I'm just kind of exploring them there. So I encourage you to kind of play around, see how I can get this number 5. How would I do that? So in matrix, that's the second list or element, so I'd have to say 0, 1. And then within that one, that list, it's 0, 1 again. So that should return 5 there. And for another quick example, let's say I wanted to get 7. How would I get that? Well, we note that it's the item at the second index, right? 0, 1, 2. So it's that third item at index 2. And then 7, it's the first one, so that's at index 0. And if we get that, there we have the 7. Excellent. So I'm going to give you one last topic in this lecture, and that's going to be list comprehensions. So Python has a pretty advanced feature called list comprehensions, and it allows for quick construction of these lists. So I'm just going to give you kind of a quick sneak peek at what this looks like, but don't worry if you don't understand it, because we have a whole entire lecture devoted to list comprehensions. But in case you're familiar with another language, or you've kind of gone through a tutorial of Python before, I'll show you how we can build a list comprehension by basically deconstructing a for loop within brackets. Now I know we haven't gone over loops or anything, so if this doesn't make sense to you, don't worry about it at all. We're going to go over loops, statements, list comprehensions in much more detail in the future. But just for a cool sneak peek, let's say I wanted to create that first column of that matrix. I could say first underscore call as my object name, and set it equal to row for row in matrix. Now I know if you haven't seen any for loops or any statements, this doesn't make too much sense, but don't worry about it. What this is basically breaking it down is I can create a list by kind of writing a flat for loop within the brackets. So we'll have lectures devoted to this in further detail, but just to give you kind of a sneak peek at what this is doing, I just created an object that consists of the first column of that matrix, that 1, that 4, and that 7. Okay, so what that basically did is just said, hey, for every element or row in that matrix, grab the 0 index of that row. And then using this list comprehension, I can actually make a list out of it. Okay, so that's a little sneak peek. We'll hit that in much further detail in the future. But just a quick overview of what we've done. I'm going to hop over back to the Jupyter Notebook. We've understood how to create a list using brackets and separating the elements by commas. We understand that a list can hold different object types, such as integers and strings all mixed together. We can use the len function to check the length of a list. We can use indexing and slicing just like we did for strings because it's a sequence. So we can use those square brackets on that list variable to go ahead and grab things from that list. We can concatenate lists using the plus sign. We can use the multiplication or the asterisk sign to multiply or duplicate lists. And then we went over some basic list methods, the append method, the pop method, sort and reverse. And then we saw a quick introduction to nesting lists. Okay, so that's it. You can go ahead and check out the advanced list section later on in this course to go over some more details of those methods. But that's about it for lists for right now. All right, thanks guys. Hello everyone, and welcome to the coding lecture for dictionaries. So with strings and lists, we've been learning about sequences in Python, but now we're going to switch gears and learn about mappings in Python. So if you're familiar with other languages, you can sort of think of dictionaries in Python as a hash table. So right now I have opened the Jupyter Notebook, and we're going to be going over how to construct a dictionary, various ways to access objects from a dictionary, learn about nesting with dictionaries just like we learned about nesting with lists, and then we'll learn about a few of the basic dictionary methods. Okay, so let's go ahead and get started with the code. So like I mentioned earlier, dictionaries in Python are mappings, and what mappings basically are is just a collection of objects that are sorted by a key. So unlike a sequence that stores objects by their relative position, so if you remember in a list, for example, I can make a list L, 1, 2, 3. So remember, I could access things from that list by indexing. So that's how a sequence works. What a mapping is going to do is it's going to store objects with a key. So it's an important distinction since mappings aren't going to retain order like lists and strings did. So let's go ahead and see how we can construct a dictionary. So in Python, a dictionary consists of a key and then an associated value. And the value can be pretty much any Python object. So I'll make my first example dictionary by saying my_dict as the variable name. And we make dictionaries in Python with curly brackets. So if you just put shift above your square brackets, you should get these curly brackets on your keyboard. And then the way we can construct the dictionary is, the most basic example is you put in a key name, usually a string, pretty much always a string, and then what the value you want. So in this case, I'm going to put in values, and there's a colon separating the key and the value. And then we have commas separating the various key and value combos in our dictionary. So then I'm going to put colon and put in value 2. So this is probably the most basic version of a dictionary you can have in Python. So if you notice, the way we construct it is I have these curly brackets, and then I have a key, colon, and the value that's associated with that key, and then comma for every key value combo throughout that dictionary. So if you remember, we could use square brackets to access index elements in lists and strings. In this case, we're going to use the keys for a dictionary with the same bracket notation. So I have this bracket notation, but if you notice, if I put 0, it's not going to work. It's going to say key error. And that's because it's not a sequence, it's a mapping. So what I end up putting is the key instead. So if I put in key 1, it outputs the value that's associated with that key. So another important note is that dictionaries, just like lists, are super flexible in the type of data types they can hold. So for example, I can get my_dict, and I'm going to create a new dictionary now. I'll put K1 for key 1. And I can put a number, such as like an integer. I can also mix data types, so I can say key2, colon, put in a floating point number there, and let's say K3, I can set that equal to a string. Close off with another curly brackets. And so now I can say my_dict, and I can call any one of those keys, and it will return the value associated with that key. So let's try calling another item. Let's try getting that third key out there, which is string. Cool. So what's really interesting now is, based on the value that gets outputted from that key, I can then call different methods on that value. So right now, if you notice, my_dict with the K3 key is this string, which is also labeled string there. So I can actually perform different things that I'd be able to do on a string, such as index, which would output s there. Or maybe I could reverse it like we did for strings, which is : -1. And then I can even call different methods. So I can say maybe like upper method, if you remember, uppercase. So what this is basically doing is it's returning that string, and I can do anything I want with that object that I'd be able to normally do with a string. Great. So we can also affect the values of a key as well. So for instance, right now, if you notice, my dict k1, remember that square brackets, that k1 key is equal to 1, 2, 3. So if I say k1, let's say 1, 2, 3 minus, let's say 120, that's going to be equal to 3. So that makes sense. Right now I'm just calling that number and subtracting 120 from it. But if I, let's say, copy and paste this, you'll notice it doesn't actually affect that value permanently. But what I can do to affect that value permanently is use an equal sign. So I can say my underscore dict of k1 is equal to my underscore dict k1 minus 120. And now what that's done is it's actually changed the value that's associated with that key. And so now it equals 3 permanently. So now if I print out my dictionary just by calling it, you'll notice that I've permanently affected the value associated with that k1, that first key. Cool. All right, so now what I want to mention is that you'll notice while you're doing your various coding exercises throughout the course, you may be trying to do this type of operation a lot. This take a value, set it equal to either addition or subtraction from the value itself. So some sort of self-subtraction or self-addition, or even like a multiplication or division. So what's really nice about Python is it actually has a quick syntax for you to do self-subtraction or self-addition or multiplication and division. And what that looks like is you basically put the operation before the equal sign. And I'll show you a quick example of what I mean. So remember, right now we have my dict, the k1 key is equal to 3. So if I say my dict k1, k1 plus 100, now it's going to be equal to 103. So I can use a quick syntax to do this, to basically fast forward through this notation. And the way that works is I end up taking this plus sign here, putting it behind the equal sign, and then get rid of this notation there that's self-referencing it. So this is the exact same thing that plus minus performs the exact operation that we just did before. And you'll notice as I ran both these cells, now it's at 203. So you can go ahead and check out the Jupyter Notebook for some other examples. So for instance, if I wanted to do a self-subtraction, I just do minus equals and then the number I want to subtract itself from. You can also do multiplication equals and then division equals as well. Great. So that's just a nice syntax so you don't waste a lot of time rewriting the same object over and over again. So I can just say minus equal and then 120 here in this case. All right, so moving along, we can also create keys by assignment. So for instance, if we started off with an empty dictionary, we could continually add to it. So I'll show you what I mean by that. I'm going to make a label or a variable called D, and I'm going to create an empty dictionary. And I can create an empty dictionary just by putting curly brackets with nothing inside them. So D is now just an empty dictionary. So the way I can create a new key is through assignment. And the way I do that is I can say D, and we'll have the key be called animal in this case. And I'll set it equal to a value. In this case, I'll have it be equal to dog. And we can do this for any type of object. So I could say again, let's say D answer for a key, and I can set this equal to 42, for instance. And now if I check out what my dictionary looks like, I've actually added in those keys and the values associated with them. So this is how you can add new keys and new values to your dictionary through this sort of assignment. Okay, so now we'll look into nesting with dictionaries. So hopefully you've seen right now that Python is super flexible with nesting objects and calling methods on them. So now we're going to look at a quick example of a dictionary nested inside a dictionary. So remember we were able to nest lists, so we can actually do the same thing with dictionaries. So I can say D is equal to, and we'll make, let's say, K1 be one of the keys, colon, and in this case, that K1 key is going to refer to another dictionary. So let me close off that first dictionary, and now I'm going to have another dictionary. I'm going to call this key nest key. And to show you how deep we could go, we could even create another dictionary inside that one, and then say like subnest key, colon, and then let's just put a string in called value there. And you notice this is almost like quite an inception of dictionaries. So how can we grab that value, this string right here? How would we go about doing that? So first off, I have my dictionary, and my dictionary actually only consists of one key, K1, this most outer dictionary. And the rest of it is just dictionaries nested inside. So if I say D K1, what does that return? That returns those two nested dictionaries. So I can go again and say nest key off of that return dictionary, and now I have that subnest key in that value. And then one more time, I can say subnest key, and finally I get out that value. And then again, I can call different methods on it. So I could say upper, and then it returns a capitalized version of that value. So hopefully you can see just how powerful nesting with dictionaries could be within your code. So you're probably never going to go this deep for basic codes, but it is really useful to go at least one nest deep as you get better at programming. Okay, so what we're going to do now is go over a few of the dictionary methods that are built in. So let's go ahead and create a new dictionary. I'm going to say, I'm actually just going to call an empty dictionary to go over how we can construct it again. So I'll say K1 is equal to 1. I'll say D of key 2, so K2 is equal to 2. And then I'll make one more key, and I'll have its associated value be 3. And now if I check out what my D, that dictionary, is equal to, it's equal to K1 of 1, K2 2, K3 3. Great. So now I have my full mapping, where I have 3 keys, K1, K2, K3, and then 3 values associated with each of those keys, 1, 2, and 3, respectively. Okay, so there's different methods. If I put D, and since I'm using Jupyter Notebook, I can actually click Tab, and these are a bunch of the different methods that are available to us for dictionaries. You can go ahead and check out the Advanced Dictionaries lecture if you want to learn about all of them. But in this case, we're going to look at some of the basic ones. So for instance, D underscore keys, close parentheses, since I'm not adding in any arguments there, will actually return a list of all the keys. And there's a similar method for the values in the dictionary. D.values will return all the values. And you notice here, they're out of order from what we originally printed out that dictionary. And that's important to note because remember, dictionaries are never going to hold a specific order. Since they're mappings, the way they keep track of things is through the keys and the value combinations. So there's no such thing as indexing a mapping. So we could index lists and strings since those are sequences, but we can't index a dictionary. What we'd have to do is call things by its key. So it's not a direct index of like D0, D1, etc. It's you're referencing things by their keys. Okay, so we have D.keys method to grab a list of all the keys, D.values to grab a list of all the values, and if you wanted a combination of those, we can say D.items. And that will return a list, something called tuples, or sometimes called tuples, of all the items. So if you notice here, we have a list, and we have this notation of these parentheses that are all the pair combos. So we'll learn about tuples or tuples in an upcoming lecture. And that's about it as far as just this beginner's introduction to dictionaries. So let's just go over everything we covered in this lecture really quickly. Remember, dictionaries are mappings in Python. They're different than sequences because they don't retain any order. So we refer to the values or the objects within that dictionary through their keys. In order to construct a dictionary, we use this curly bracket notation with the key name, a colon, and then the value name. And then we can call values by their keys using that bracket notation. Continuing along, dictionaries are super flexible in the data types they can hold. For instance, here I have a list inside of a dictionary, numbers, we can have dictionaries inside of dictionaries, and then you can call items from that dictionary, and then index or methods on those values as well. So we also learned about this quick notation of self-subtraction or addition. Remember, we could do that minus equals instead of doing something like this, which was that object self-reference minus. So that should save you some time with your coding. And then to create a new dictionary, you can create new keys through assignment, just like we did here with that equal sign sort of assignment. And then here's the result. You can nest dictionaries, we went over that, and keep calling the keys to go further and further in those nests. And then we went over a few dictionary methods, the keys, the values, and then items. So hopefully by now you have just the basic, a good basic understanding of how to construct dictionaries. There's a lot more to go into here, but we'll be constantly revisiting dictionaries throughout the lectures. All right, great. So let's go ahead and move on to the next lecture. Hello everyone, and welcome to the files lecture. This is going to be a pretty brief lecture, and we're just going to go over how to interact with external files on your computer. And in this case, we're going to start with the very basics, the .txt text files. So in order to deal with other types of files, such as audio files or Excel documents, you'll most likely have to either download or import from a particular library or module for Python. And we discuss modules later on in the course. Okay. So here's the Jupyter notebook that corresponds to this lecture. You can go ahead and look through it, but I'm just going to go ahead and jump straight into the live coding. So in order to work with files, we need one. So what I've gone ahead and done is I've created a file called a .text file called test.txt, and I've saved it to the same directory where my Jupyter notebooks are. So if I say pwd, which stands for print working directory, and run that cell, it gives you the location where your Jupyter notebooks are. So go ahead and make a .txt file and just print a simple line in it. So if you're on Windows, you can use Notepad, which is built in. Just say anything here. This is a line, and then go ahead and save that as whatever name you want. In this case, I've saved it as test.txt. And save it into the directory where the pwd tells you to. Okay, so moving along, how do I open that file? So I'm going to create a variable just called f. I'm going to say that equals, and this is where the open function comes into play. So we can open a file with the open function, and I'm going to say test.txt, and I've opened the file. And now if I want to read the contents of the file, I can call the read method on that file. And I wrote, this is a test line. Great. So something interesting that happens is if I try to read that file again, you'll notice nothing pops out. So why is this happening? So the reason this happens is because you can imagine that you have a cursor, kind of like the one I have blinking in this cell. So remember, we've already read the file once, so Python, in a sense, has the cursor at the very end of the file. So you'll have to reset that cursor to the beginning. And the way you can do that is by using the seek method and pass the argument in 0. So that will send that cursor back to the beginning of the file. And if I say read again now, it says this is a test line. So one more time, I can press seek to return to that beginning of the file. Another method you can do to read the lines of a file is the read lines method. And what that does is it goes through every line in the file and then treats it as an element and returns a list to you, with each line as a different element, a giant string in that list. Okay, great. So I'm going to go quickly, kind of a sneak peek at iterating through a file. So we've gone over magic functions when we were introducing the Jupyter notebooks, and in this case we're going to use a magic function called write file. And what this is going to allow us to do is, instead of having to open the notepad or any other Sublime text editor or whatever you happen to choose, I can actually create a text file straight from the IPython cell. So I can say first line, second line. So what this cell has right now is 2 percentage signs to let you know that this write file statement is a magic function. So this only works in Jupyter notebooks. And then space, and then whatever name I want that text file to have. In this case, it's going to be new.txt. And then I have 2 lines in my file, first line and second line. So if I go ahead and run that cell, Jupyter Notebooks has told me it's writing new.txt. Perfect. So what if I want to iterate through this text file? Here's where I'm going to give you a sneak peek at a for loop. So what I can say is for line in, and now I'm going to open that file, which was called new.txt. Remember, I pass in the entire file name, including the extension, as a string, colon. Notice how there's a white space, an indent here. That's going to be important. Don't worry if you don't understand what's going on now. We go over for loops in much more detail in the future. This is kind of just a sneak peek. And then I can say print line. So the logic here is I'm saying for every line in this object, this file object that I'm opening here, I want you to go ahead and print that line. So let's see if this works. Perfect. So just as we expected, it's printed the first line and the second line. So a couple things to note here, and this is just to get you start thinking about different statements and for loops and stuff like that, is I could have called this anything. I could have said for words in open, print words. It still would have outputted the exact same thing as I have here. So you'll be able to have flexibility in what you call each of those elements in those iterables. Something also that's important to note is read lines, if you have a very large text file, could have problems because the Python is right now storing this list entirely in memory if you call read lines. So if you have an entire series of novels or something and you call read lines on it, that might be problematic. So make sure you just call .read on the file if you have a very, very large text file. Okay, so that's actually about it. Remember, we just briefly went over how to open .text files and how to read the elements in them. If you want to go over some more details that are in the Jupyter Notebook, such as reading and writing to a file, we go over that. You can go ahead and check that out. Reason we're not going to go over right now is that we're not really going to use this until much later on in the course. So this is just a brief introduction and a little sneak peek into for loops. Okay, so that's it for this lecture. Up next, we're going to go through learning how sets and booleans work in Python, and that will be the last lecture in this section, and then we'll wrap it up with an assessment test. Okay, great job everyone. Hello everyone, and welcome to the Sets and Booleans lecture. So in this lecture we're going to learn about 2 more other object types, and one is a data structure, sets, and the Boolean object type, which is basically just a true and false display in Python. This is the Jupyter Notebook that corresponds with this lecture, so let's just go ahead and start coding and go through it. Okay, so sets can be thought of as an unordered collection of unique elements. And that's the important part, the fact that those elements inside of that set are unique. So you can construct a set using the set function notation. So it's going to look something like this. So I'm going to make a set, and I'm going to label it with the variable x here. So now x is a set. Great. Right now it's an empty set. So how do I add elements to that set? So I use the add method, which is going to be x or whatever variable you decided to call your set, dot add for add, and you can add whatever objects you want to it. So I'm going to say x dot add 1, and if I check now what my x is, it's going to look and add that 1 into that set. So something interesting here, you notice that the notation is curly brackets. So this actually does not indicate that it's a dictionary, although you can draw analogies as a set, almost like being a dictionary but with only the keys. Because remember, in a dictionary you can't have multiple keys being the exact same thing, you can only have unique keys. And you can kind of think of as a set as just a dictionary but only keys that are unique. So let's go ahead and add a different element to our set, which is called x. So let's go ahead and add the number 2 to it. Now I check that I have 1 and 2 in my set. So what happens if I try to add the same elements that's already in there? So we know 1 is already in there. So what happens? So you realize there's actually no change. It won't place another 1 in there like it would if it was like a list or something. And that's because a set's only concerned with the unique elements. So you can actually use that set function to cast something like a list with multiple repeat elements to get the unique elements. And I'll show you an example of what I mean by that. So I'm going to say L is equal to a list. And in this list, I'm going to have a couple 1s, a couple 2s, a couple 3s, and then like a 4. So notice how I have repeated items or elements in that list that occur more than once. So if I take that list and cast it, remember we kind of use casting as a term back for using float and casting numbers as floats. So if I use sets of L, notice that the set's going to grab all those unique values. So 1, 2, 3, and 4 are the unique values in that list. And that's basically the gist of sets. So remember, sets are only concerned with the unique elements, and you can create them by calling this empty set function, and you can add to them with this dot add method. So sets are going to be a super useful tool, and we'll come back to them later on throughout the course as a really unique tool because of this feature that they are only concerned with unique elements. Alright, let's go ahead and move along to Booleans. So Python comes with Booleans, which are basically predefined true and false displays, almost like integers 1 and 0. So it also has a placeholder object called none, and let's go ahead and walk through a couple of examples of this. So I'm going to say A is equal to true. Run that cell, and now if I show A, it shows out true. And we can also use comparison operators to create Booleans. So we haven't gone over specific comparison operators. We'll go over them. There's an entire section on this course for them, but I'm just going to show you a quick example. So I can ask, is 1 greater than 2? And the output will be a Boolean, which is false, since 1 is not greater than 2. And we'll go over all these different symbols and what they mean later on in the course. And let's go ahead and switch this. Let's say, is 11 greater than 2? Then the output of the Boolean is true. Okay. So we can also use none as a placeholder for an object that we don't want to reassign yet. And what I mean by none is the actual word none with capital N there. And now B is going to be a placeholder, and you notice nothing popped out when I set that cell to run, since it's literally none. And then I can reassign it to maybe a string, and now B is equal to A, or the string of A. Okay, so that's it. It's just a super basic understanding of sets and Booleans. We'll touch upon them later on throughout the course. So just a quick review, if we hop over back to this Jupyter notebook, sets are an unordered collection of unique elements. You construct them using this set function, and you can add to them with this add method. And remember, they have curly brackets, but that doesn't mean they're a dictionary, although you can draw analogies as a set being a dictionary with only keys. Okay. Remember, you can also use set to cast another data structure such as a list to only get the unique values out of it. Then we went over Booleans, which are basically just true and false, and we went over none use as a placeholder. Okay, so we'll learn way more and see Booleans a lot more when it comes to comparison operations later on in the course. And we'll also go over them throughout the course. They're going to be super useful to have logic within our code. Okay, so that's about it, and I'll see you at the next lecture. Thanks. Hello everyone, and welcome to the lecture on tuples. So sometimes some people call them tuples, some people call them tuples. I'll be referring to them as tuples throughout the rest of the course. So in Python, these tuples are very similar to lists, except they are immutable. So that means they can't be changed. So right now I have open the Jupyter Notebook, and in this lecture we're going to be going over constructing tuples, some basic tuple methods, their immutability, will drive that point home, and then a quick side talk on when to use tuples. Alright, so this will probably be a pretty brief lecture since a lot of the syntax will feel pretty familiar. So how do you construct a tuple? So if you remember, you can construct a list using square brackets. So here I have a list of 1, 2, 3. With a tuple, it's almost the same, except you're going to use parentheses and commas. And so now T is a tuple there. So just like a string or a list, you can use the len, the length function, to check its length. So that will give you how many elements are in that tuple. And then tuples, just like a list, can also mix object types. So I can put in a string along with an integer into my tuple, and there's no problems there. Let's go ahead and show that tuple. Alright, so again, a tuple is a sequence, just like a list, and we can index it just as we've seen before. So T of 0, that brings out that string, and if I want to access that 2, it's in one index. And it also supports slicing. So let's say I wanted to grab the last one, I could use a -1. So indexing, all that syntax is the same as it was for strings and lists. Now, there's a few basic tuple methods that I want to introduce to you guys. So remember, for a method, you take your variable name, put a dot or a decimal point, and then you write the method name, and if it takes any arguments, you usually have parentheses there. So in this case, index, you can enter a value that you know is in the tuple, and it's going to return the index. So if we look at my current tuple, that T, it has a 1 string and a 2 integer there. So let's say I wanted to figure out what the index of that item was. I could put it in. So to show you again, let's say I wanted to know the index of 2 there. It responds with 1 as the index. So that makes sense. Another method we can use is the dot count. So that will count the number of times the value appears. So you put in the value that or the element that you know is in the tuple, and it tells you how many times it appears in that tuple. So for instance, if I make a tuple right now, that's 1, 1, 2, 3. So I know 1 appears twice. So if I say t.count, and I want to count how many times 1 shows up, it responds with 2. Okay, great. So something that we're really going to stress with tuples, and the thing that really makes tuples unique, is that they're immutable. So that means you cannot change the items inside the tuple. You can't reassign the items inside the tuple. So to show you what I mean, remember we have our list L, which is 2, 2, 3. I'm going to change it to 1, 2, 3. Okay, so we have a list that's equal to 1, 2, 3. Don't worry about this change to 2, 2, 3. That occurred because I paused the video and was playing around with it. Anyways, so right now we have a list that's equal to 1, 2, 3. And let's go ahead and make our tuple T equal to a tuple that's 1, 2, 3. So if you remember, the list, since it's mutable, it will support object or item assignments. So I can say L of 0 is now equal to, let's say, a string called S. And now there's no problems there, it's been reassigned. Now if you try to do the same thing with a tuple, it's not going to work. So here I have my tuple, which is 1, 2, 3, and if I were to try to reassign the 0 index there, which is a 1, let's say I try to make that equal to something else, like that string S, it's going to say a tuple object does not support item assignment. So this is really important to know. Tuples cannot be mutated, so they're immutable. So You might be wondering, so why would I bother using tuples when they have fewer available methods than a list? So if we check out this list and then check out all the methods on it, there's append, count, extend, pop, remove, sort, and we go over those in the advanced list lectures. But if I look at my tuple and press tab, there's actually only two methods, count and index. So there's fewer supported methods in the tuple. So you might be wondering, well, why would I use that instead of using a list? And the key to that is their immutability. So if you're in your program, you're passing around an object and need to make sure it doesn't get changed. So you got to make sure the sequence doesn't get changed. The tuple can be your solution for that. So an example of that might be if you have a tuple representing the dates of a calendar, which you know are not going to change throughout your code, you might use a tuple in that sort of context. So definitely keep tuples in mind when you want something to be immutable. Okay, so that's it for this quick lecture. Let's just jump back to the Jupyter Notebook so we can review everything. We went over how to construct a tuple, so you just do that with parentheses and commas, just like a list, except instead of square brackets you're using parentheses. You can check the length with the len function. You can also mix object types in a tuple. You can use indexing just like we did for strings and lists. There's only two tuple methods, index and count. And we went over their immutability, so you can't support item assignment in a tuple. Alright, so that's actually it for tuples. And we'll see you at the next lecture. Thanks, guys. Hello, everyone. And this is just going to be a quick overview of the Objects and Data Structures Assessment Test. So you can go ahead and go to NBViewer or GitHub, as we described earlier, to get a copy of this notebook. If you're an NBViewer, you can just click right here at the top right to download it. And I'm just going to go over the questions, make sure you understand all of them and what they're asking. So in this question right here, test your knowledge, first thing I want you to do is just write a brief description of the following object types and data structures we've learned about. So number, string, lists, tuples, and dictionaries. Don't worry about sets and booleans for this question. Okay, so then there's going to be a couple questions for each of the different object types or data structures we learned about. So in numbers, first question, I want you to write an equation that uses multiplication, division, and exponent, addition, and subtraction to equal 100.25. So this is just test your memory of the basic arithmetic commands. So go ahead and feel free to work backwards from 100.25. So you can start with like just dividing 100, then taking a power to it, or it's a square root, etc., etc. All right, next question. I have here 2/3. So I want you to explain what you believe the cell below is going to output, and how can you change the answer if it is correct. So remember that discussion we had of the division between Python 2 and Python 3. That's what that question is getting at. All right. Then next thing, I want you to answer these questions right here. What's the value of these expressions? And do it in your head without typing code. This has to do with order of operations to make sure you understand. And then you can type the code out to check your answer. All right. Next question, what is the type of the result of the expression 3 plus 1.5 plus 4? After that, what would you use to find a number's square root as well as its square? So I'll let you go ahead and fill in that cell once you're there. Next section is going to be strings. So given the string hello, so you can see here s equals hello, given an index command that returns e, so you can use the code below. So basically give some sort of index so I only get e out. Then I want you to reverse the string hello using indexing. So you can go ahead and code that there. And then again, given the string hello, I want you to give two methods of producing the letter O using indexing. So I expect you to be able to come at least with two methods to produce just the letter O out of that hello string. Okay, moving along, we have lists. So questions here, I want you to build this list, 0, 0, 0, 3 zeros, using two separate ways to build it out. After this, I want you to reassign the hello in this nested list to say goodbye. So that's going to check your understanding of index levels for a nested list. Then I want you to sort the list below. See if you remember how to do that. Moving on, we'll have dictionaries. So using keys and indexing, grab hello from the following dictionaries. So this is going to get progressively harder and harder. Right now this one should be pretty simple for you, so I want you to use keys and index calls with brackets to grab hello out of this dictionary, then out of this dictionary, then out of that dictionary, and then out of this dictionary. So you notice the nesting gets harder and harder. Okay, then I want you to answer the question, can you sort a dictionary? Why or why not? Tuples, what's the major difference between tuples and lists? And how do you create a tuple are the questions there. Sets, what is unique about a set? Use a set to find unique values of the list below. And then booleans. So for the following quiz questions, I have a brief table here of all the comparison operations. So I want you to go ahead and read through this. There's an entire section devoted to comparison operators, but this will be a nice little preview for you to read. So go ahead and read this, but basically what it's saying is here we have the operator, the description of what it does, and a quick example. So for instance, this equals equals is an example of checking if the two operands are equal. So then the condition becomes true. So A equals B in this case is not true, but A equals A would be true. And then the greater than, less than, etc., etc. So I want you to go ahead and look at these, and before you run the cell, answer what the Boolean you believe will be. Okay, so don't worry too much about these operators if they're confusing you. As far as the comparison operations, then you can go ahead and feel free to skip this section and wait until you complete the comparison operators section of the course. Okay, then there's one final question. So given these two nested lists, what do you think will be the output of this cell block? And then run it to check your answer. Okay, that's it, and good luck on your first assessment. Okay, thanks guys. Hello everyone, in this video we'll be going over the Objects and Data Structures Assessment Solutions. Okay, so the first question was write a brief description of all the following object types and data structures we've learned about. So for the full answers, all you had to do is review the Jupyter Notebook. So if you go to the Solutions Notebook, I've put links so you can go ahead and check out the introductions of each of those Jupyter Notebooks where they describe, in layman's terms, numbers, strings, lists, tuples, and dictionaries. So let's go ahead and move on to the numbers section. First thing I wanted you to do is write an equation that uses multiplication, division, exponent, addition, and subtraction to equal this kind of arbitrary number. So your answer is probably different. All I did was work backwards, but this was just so you made sure you understood what minus to the powers, parentheses, division, multiplication all looked like and how they worked. So this is what I did, and that equals 100.25. Next, I wanted you to explain what the cell would produce, 2 divided by 3, and what can you do to change it so the answer is correct. So if you notice, we have 2 divided by 3 and we have a 0 there. And remember, that's because Python 2 performs classic division for integers, and you need to use floats to perform true division, such as 2.0 divided by 3. We also discussed on how to use import from the future module to also change that. Or you could just use Python 3 and then you wouldn't have to worry about that. Next, answer these 3 questions without typing code, then type code to check your answer. So you can go ahead and check your own answers here, but this was just to make sure you understood order of operations in Python. What was the type of the result of the expression here? The answer is going to be a floating point number. As long as there's one floating point number in the entire equation, your result will be a floating point number. After that, what would you use to find a number's square root as well as its square? You can just use 2 asterisks in a row to do a power, and then use a fraction to do a square root. There's also a math module in Python that will allow you to do square roots, and we'll talk about that later on in the course. The strings section, basically I just wanted you to play around with indexing, so writing out commands to grab letters from strings, making sure you understand that indexing starts at 0, reversing strings, again with slicing and indexing, and then given the string, give 2 methods to print the letter O. First one was just going in reverse with -1. Second one, I just went straight forward with index of 4. After that, it was lists, and I wanted you to build a list 0, 0, 0 2 separate ways. One way is just the standard, write out the list in between brackets. The second way you could have done it was by doing a list of 0 and multiplying it by 3 to get 3 of those. After that, I wanted you to reassign hello in this nested list to say goodbye. So the index to reach that item was 2, 2, because it was a list nested inside of a list. After that, I wanted you to sort this list, and you could have done that with a sorted function or the method sort. Then for dictionaries, this was basically just keys and indexing to grab hello. First one was just pretty simple. You just had to do the simple key. Second one, a little trickier. Had to do 2 keys because it was a dictionary nested inside another dictionary. Third one, pretty tricky. This is actually harder than I expected. It was the key, an index, nest key, and then 2 indexes later to get hello. This one was a little crazy. It was a key and index, a key to index, the key 𝗕𝗢𝗄𝗓, and then 2 indexes to reach hello there. After that was, can you sort a dictionary? Why or why not? No, you cannot sort a dictionary because normal dictionaries are mappings, not sequence. So don't remember what order you put in items in. Now, later on in the course, we'll talk about something called an ordered dictionary, which is a subclass of dictionary in Python in a specific module called collections. So you'll learn about a specific type of dictionary that you actually can remember order. Moving along with tuples, what's the major difference between tuples and lists? Hopefully you were able to answer this with just tuples are immutable. That's the big difference. How do you create a tuple? Remember, it's just parentheses and then commas, just like a list, but instead of square brackets, you're using parentheses. For sets, what's unique about a set? Remember, they don't allow for duplicate items. So to use a set to find the unique values, you could just cast that list with the set function. For booleans, don't worry if you didn't fully understand this. There's a whole section on comparison operators coming up next, but I just wanted you to get kind of a sneak peek. You can go ahead and check out these various pieces of code. They should have been hopefully pretty straightforward if you already knew some math notations, such as 2 greater than 3 or 2 less than or equal to 2, etc. So you can run those cells and check your answers. Final question was, what is the Boolean output of the cell block below, right here? So it's going to be false, and we can check that through indexing. So L1, index 2, 0, would have been, if we look here, that would have been this list, first item, so that's 3. So then you're basically asking, is 3 greater than or equal to? And if we look at that second list, it's going to be index 2, key 1, so 4. So is 3 greater than or equal to 4? That's false. Okay, great job on your first assessment, and I'm excited to continue on with the course, and I'll see you at the next lecture where we talk about Python comparison operators. Great job, everyone. Hello, everyone, and welcome to the comparison operators lecture. In this lecture, we will be learning about comparison operators in Python. So these operators are going to allow us to compare variables and output a Boolean value. We've already seen a few of them throughout the course, but now we're really going to dig deeper. And if you have any sort of background in math, these operators should be pretty straightforward. So if I look at the Jupyter notebook that corresponds with this lecture, I have a table of comparison operators and then a couple of examples for most of them. Okay, so let's go ahead and zoom in into this table and just tackle them one by one. So the very first one, operator, is 2 equal signs in a row. And what that means is if the values of the 2 operands, whatever the 2 objects you are comparing, are equal, then the condition is true. So in this case, A equal B is not true. But if A equal A was written, then that would be true. So as long as these 2 objects are the same, then equals will output true. If they're not same, it'll output false. So moving along, the opposite of that is exclamation mark equals. So that means if they're not equal, then the condition becomes true. So this statement basically says A is not equal to B, which will output true. Another way to write this is with a less than and a greater than sign back to back. So that's the same as this operator right here, but in most cases I would encourage you to use exclamation equals mark. That's what most people use. Okay, then as far as like greater than or less than or equal to, etc. So for this symbol right here, this means greater than. So A greater than B, And then similarly, you have less than, so A less than B. And depending on which the values, so for instance, numerical values, you can say is 2 greater than 1, that will equal true. Is 3 greater than 10, that will be false, etc. And then if you want to do greater than or equal to or less than or equal to, you just add an equal sign to those symbols. Okay, so let's go ahead and see these guys in action by jumping over to the live code. Alright, so comparison operators. Let's go ahead and dive in. So remember we have the equals operator, and we can go ahead and play with that. So I'm going to say 2 equals 2. Is that true? Yes, it is. So 1 equals 1. Is that true? Yes, it is. What about 1 equals 0? Well, that's false. Okay, so now let's go ahead and practice with not equal. So switching to not equal. Remember that was exclamation mark equals. So is 2 not equal to 1? That's true. Is 2 not equal to 2? That should be false. Remember we have the other way of saying it, which isn't as common, but we can still use it, which is the less than and greater than sign put back to back. So is 2 not equal to 1? That's true. Is 2 not equal to 2? That's true. Or I mean, excuse me, that's false. 2 does equal to 2. Okay, so like I mentioned, the more common ways with the exclamation mark equal sign. So moving along, we're going to now go with greater than. And that's just going to be 2 is greater than 1. That's true. Is 2 greater than 4? That's false. And similarly, we have less than, so I can say 2 less than 4 and 2 less than 1. That's false. And then we have greater than or equal to, so I can say is 2 greater than or equal to 2? Yes, because 2 is equal to 2. Is 2 greater than or equal to 1? That's also true because it's greater than 1. And I can also do less than or equal to. So is 2 less than or equal to 2? Yep. Is 2 less than or equal to 10? Yes, it's less than that. So that all works out. Okay, so hopefully that should have been pretty straightforward. If you have any sort of math background or basic math, this greater than or less than sort of operations should just pretty much make sense. If you have any trouble with it, you can always go back to this Jupyter notebook and read the table in more detail in case you need any refreshers on what these comparison operators do. Alright, so that's it for this lecture, and I'll see you at the next lecture. Thank you. Hello everyone, and welcome to the Chain Comparison Operators lecture. So one of the nice features of Python is this ability to chain multiple comparisons to perform a more complex test. And you can use these chained comparisons as a shorthand for some larger Boolean expressions. So in this lecture, we're going to learn how to use chain comparison operators, and we're going to introduce 2 important other statements in Python, which is the and the or statements that I have highlighted here. So let's go ahead and jump into the live code so I can show you some examples of chain comparison operators. Okay, so you remember that we have just normal comparison operators. So I can say, is 1 less than 2? That's true. Is 2 less than 3? Well, that's also true. So what I can do is I can actually chain these. I can say, is 1 less than 2? And is 2 less than 3? And that will output true. So that statement will check if 1 was less than 2 and if 2 was less than 3. So another way we could have written that is with an and statement in Python. So I could have said, is 1 less than 2 and is the condition 2 less than 3 also true? So that checks, make sure that basically the and is used to make sure 2 checks have to be true in order for that total Boolean check to be true. Let's go ahead and see another example. So 1 less than 3, we know that's true. 3 greater than 2, we know that's also true. So I can chain these together. I can say 1 less than 3 and is 3 greater than 2. Whoops, sorry. Greater than 2. And that's true. So another way I can write that is with the AND statement. So I can say is 1 less than 3 and is 3 greater than 2. And that will output true. So it's important to note that Python is actually checking both instances of the comparisons. And we can also use OR to write comparisons in Python. For example, I could say 1 equal to 2, which we know is false. 2 less than 3, which we know is true. So what if I wanted just either of these statements to be true, just one or the other? And that's where the OR statement comes in. So I can say, hey, check if 1 is equal to 2, or also check if 2 is greater than, let's say it's greater than 1. So as long as one of these statements happens to be true, then we'll get a true. So OR means it's only checking that one of the instances happens to be true because we're using the OR operator. So it needs one or the other to be true. Let's take a look at one more example just to drive the point home. So we know 1 is equal to 1, and I'm going to write OR 100 equal to 1. So it just needed one or the other to be true, and 1 equals 1 was true. So that's just it as far as chain comparison operators. Just a quick overview. You can go ahead and check out the Jupyter Notebook if you want some more detail on what we just did. But that's basically it. So you should have a comfortable understanding of what and the OR statements are doing in your code. But you can basically treat them as these chain comparison operators. So go ahead and go to the quiz for this section to check your understanding. All right, that's it. Thanks, everyone. Hello everyone, and welcome to this quick introduction to Python statements. As always, there's a Jupyter Notebook that is associated with this lecture, and it's also called Introduction to Python Statements. So what are we going to do in this lecture? In this lecture, we're going to get a quick overview of Python statements. And what we're really going to try to do is emphasize the differences between Python and other languages, such as C++. And there's two main reasons for taking this approach, this comparison approach. And that's because reason number one, if you're coming from a different language, this is going to really rapidly accelerate your understanding of Python. And then number two, if Python is your first language, learning statements in this fashion will allow you to be able to read other languages more easily in the future. So you'll be able to jump from Python into Java or C++ or another language much quicker if you learn about Python statements through this comparison context. So let's look at Python versus other languages. What we're going to do is create a simple statement that says if A is greater than B, so if a variable A is greater than a variable B, assign the number 2 to A and the number 4 to B. So let's take a look at what this would normally look like in another language. So a lot of times the syntax for other languages would look something like this. It would say if, and then you'd have your check case, A greater than B, within some sort of parentheses or brackets. And then you'll have curly brackets with statements on what to do. So if, in parentheses, if this case is true, you might have a bracket here, and then you'd have lines with semicolons afterwards, separating each statement. What does this look like in Python? You'll notice the syntax is a lot cleaner and a lot simpler. This is one of the main beauties and what people really enjoy about Python. So you'll notice here we just have a direct statement. If A is greater than B, colon, you'll notice some white space here, which we'll make clear in a couple more slides in the future. You'll see it resets A is equal to 2 and B is equal to 4. So what are the differences here? Let's go ahead and compare them. What Python does is it gets rid of these parentheses and these curly brackets by incorporating two main factors, a colon and white space. So in Python, your statements are ended with a colon here. So if A is greater than B, colon, and then white space is used, this indentation here, to describe what takes place in case of the statement. So in Python, you'll notice white space is extremely important and it's fundamental to your code. And as we learn about statements throughout this section of the course, we'll really emphasize good practices and good indentation throughout your code. So what are the other differences here? Another major difference is the lack of semicolons in Python. So a lot of times in other languages, semicolons are used to denote that a statement has ended. But in Python, the end of a line, so once you stop typing on a line, is the same as the end of a statement. In other languages, you're required to put in a semicolon, but in Python, that's not the case. Another reason why Python is so nice and so clean. And lastly, just to end this brief overview of the differences, let's take a closer look at the indentation syntax in Python versus other languages. So in other languages, you might have some syntax that looks like this. If parentheses x, if parentheses y, you'll have a code statement and a semicolon, else, another code statement, semicolon. But in Python, you have this very clear structure that's driven by code indentation and the use of white space and these colons. So that means code readability is a really core part of the design of the Python language. And that's why you'll feel that Python is a very easy language to learn in comparison to other languages, because its readability is driven really at the core of Python with white space and indentation and this sort of colon Python statement syntax. Okay. So that's it for this quick introduction to Python statements and how they compare to other languages. What we're going to do now is start coding out different Python statements and learning about the various statements we can do, and we'll get a better understanding that way. Okay, so thanks. I will see you at the next lecture where we'll start coding some Python statements. I'll see you there. Hello everyone, and welcome to the if, elif, and else statements lecture. So this is going to be our first lecture in the statements portion of this course. So we're going to go ahead and hop over to a quick presentation to kind of just explain the basics of an if statement. Here I have open the Jupyter notebook, and we're just going to be going over this quick introduction. All right, let's go ahead and hop over. Okay, so if, elif, else statements. So if statements in Python allow us to tell computers to perform alternative actions based on the certain set of results. So verbally we can imagine as if we're telling the computer, hey, if this case happens, perform this particular action. So we can then expand on this idea a little further with elif and else statements, which elif kind of, you can think of it as else if. So it's basically telling the computer, hey, if this case happens, perform some action. If another case happens, then perform some other action. Else, if none of the above cases happen, perform this action, etc., etc. So let's go ahead and hop over to the Jupyter notebooks so we can get a look at the syntax format. So here in the Jupyter notebook, we can see that the syntax for if, elif, else statements looks a little something like this. So you have if space case, so some sort of Boolean check to see if something's true or greater than or equals to, etc. Then perform a particular action, so a certain piece of code. Then elif will be another if case to perform some other action. Or else, if neither of these cases occurred, and you can have more than just two elif statements, you can have as many as you want, then finally perform that third action. So we're going to go and walk through some quick examples, and in this case we're just going to be using straight Booleans as the check statements. So let's go ahead and start with a very simple example. So I'm going to say if space true colon, and if I click enter, notice how there's an automatic indent done for me, which I can just do with tab. So start thinking about that white space. We'll cover it more when it comes to for loops and things like that, but this white space is actually necessary for Python to understand what you're typing. So I'm going to say if true, print it was true. So it was true, so that makes sense. So what if I say if false, print it was true? Nothing happened because it's false. It doesn't let you do anything, since that's only going to happen when the case is true. So now to take this example a little further, I'm going to add some else logic in. So let's go ahead and say x is equal to false. I'm going to say if x, because remember we're doing some sort of Boolean check here, I'm going to say print x was true. Else, So in any other case where x isn't true, I'm going to say print, let's see, I will print when x is anything not true. Okay. So right now we have this print statement going. I will print when x is anything not true. So since x is false, we had the else print. So let's go ahead and change this to true and see what happens. And you notice x was true as printed out here. Okay, so let's go ahead and break down what's going on right now. And I'll go over a little bit more in formatting and syntax. So I set x equal to true, and I said if space x, so some sort of Boolean check has to occur on this line, colon, and notice how when I start my next line I indent. So that lets you know that whatever is going on here occurs with that if. So if we hop over back to the syntax here, notice that we have our statement, some colon, an indent, and that tells Python perform anything that's indented here underneath that if statement. And then elif goes back and lines up with that if, and else also lines up with that if. And then the indented actions perform only when the case above it takes place. Okay. So then we have an else, and then it says print, and depending on what x is, if it's true or false, we'll get a certain print statement out. Alright, so to get a fuller picture of how far if, elif, and else can take us, we're going to write out a nested structure. So take careful note of how if, elif, and else line up in the code. And just a quick note, I say elif, some people will say elif, so feel free to say it however you want. So now we're going to introduce a little bit of comparison syntax for Python. So I'm going to go ahead and say LOC is equal to bank. So I'm saying LOC, that variable is equal to banks, and that's going to stand for location in my code. So I'm going to say if loc, which is for location, is equal to, and notice how I'm putting double equal signs. So we went over some comparison methods earlier, and the double equal sign is just to check if loc is equal to something. If you use a single equal sign, that means you're trying to reassign something, which won't work in this case. So I'm going to say if loc is equal to autoshop, print welcome to the auto shop. And then I'm going to say elif loc is equal to, let's say, the bank, colon indent, print welcome to the bank. And in any other case, which will be my else statement, note how I don't have any booleans there because I'm saying in any other case that wasn't predefined, I want to just print a question, where are you? And in this case, when I ran that cell, it said welcome to the bank. So that makes sense because my location was bank. So if I set this equal to auto shop, it says welcome to the auto shop. If I set this to something else such as mall, since neither of these if statements get activated as true, the else occurs and asks me where are you. So it's important to note how the nested if statements are each checked until a true boolean causes the nested code beneath it to run. And you should also note that you can put as many of these elif statements as we wanted. So we could have also put in an elif loc double equal sign to mall, and it said print welcome to the mall. Okay, and if we ran that, then we say welcome to the mall, since right here this occurred as a true boolean. So let's just create two more simple examples of the if, elif, and else statements. So I'm going to say this person, so a variable called person, is equal to Sam. And I'm going to say if person double equal sign Sam let's say print hi Sam. Whoops. And then else print, let's say, what's your name? Now notice what happened here. I have to use double quotations since I'm using a single quotation with the what's in order for that string to work properly. Alright, so if you notice here I have person equals Sam. If person is equal to Sam, hi Sam, what's your name? Since person was equal to Sam, then this Boolean check right here, person equal to Sam, and I'm going to go ahead and copy and paste that. So person equals Sam, that's going to return true since that variable is equal to the string Sam. And since this happened to be true, then the nested code beneath it will run. So just a quick note on indentation. It's important to keep a good understanding of how indentation works in Python, and it really maintains the structure and order of your code. We're going to touch in on this topic again as we go through all the different statement types in Python, and we're really going to hone in on it when we start talking about building your own functions and methods. So right now, just keep in mind that I'm indenting here whenever you see a colon. So that says, based on what happens up here, indent space, right here, this code's going to run. All right, so just a quick overview of what we went over here. Quick and a brief overview of if, elif, and else statements. So those if statements in Python allow us to tell the computer to perform alternative actions based on a certain set of results. This is what the syntax looks like. You have if, bunch of cases that check for booleans. Once one of those is true, then you perform one of the actions. Then you can have an else statement that says if none of those happen to be true, then perform some final action. Okay, there's a couple more examples here in the Jupyter Notebook you can check out, but other than that, we'll go ahead and move on to the next lecture. Hello everyone, and welcome to the lecture on for loops. So in this lecture we're just going to learn about for loops, and you can see here I have the Jupyter Notebook, and the for loops are going to help us iterate through any items that are a sequence in Python, or really any items that you can iterate over. So you can see here I have the Jupyter Notebook. We're just going to go through a bunch of examples, and we'll introduce 2 new topics along the way, and these are all the examples we're going to work through. So let's go ahead and cut to a very brief presentation just to break down what a for loop is, and then we'll get started with some live coding and the for loops. Okay, so let's go ahead and jump over to the presentation. Great. So for loop statements. So a for loop can act as an iterator in Python, and what it does is it goes through items that are in a sequence or any other iterable item. So if you remember these objects we covered in the objects and data structures section that we've learned about that we can iterate over, those items include strings, lists, tuples, and then we can also iterate over the built-in iterables in dictionaries such as keys or values, and we'll break down that topic later on in this lecture. So the general format for a for loop in Python is going to look a little something like this. You're going to say for item in object colon. Next line you're going to indent and say statements to do stuff. Now if you're in any IDE or if you're in Jupyter Notebooks, this sort of indentation is taken care of automatically for you. So again, the format is going to be for item in your iterable object colon, and then you're going to have some code to do stuff. So that variable name that I used, item, is actually completely up to the coder. So you're going to be able to just choose a name that makes sense to you, and hopefully you choose one that you're going to be able to understand when you're revisiting your code in the future. And then that item name can also be referenced inside of your loop. So for example, if you wanted to use if statements to perform checks. So that's the presentation. Let's go ahead and hop back to the Jupyter Notebook. Great. So we're back, and we're going to go ahead and get started through a very simple example. So now we're going to start with some live coding. I'm going to make a list, and this list is just going to be the numbers 1 through 5. So I have my list L. So L is equal to 1, 2, 3, 4, 5. And now I'm going to say a for loop. Let's say I wanted to print every element in that list. I could say for elements in L colon. I'm going to click enter. It's automatically going to indent for me. I'm going to say print elements. Shift enter to run that cell, And you'll notice it went ahead and printed each of those elements. And to drive the point home that we can actually name this item, variable name, whatever we want, I'm going to go ahead and switch it here. For num in L, print num. And you notice it's the exact same thing when I run it. So what's nice about this is within your for loop, before it, you don't have to worry about predefining that num. And you can then reference it inside of your for loop. Okay, so let's go ahead and do something a little differently here. What I'm going to do is I'm going to say for num in L, print something. Oops. So what this is going to do is you're going to tell Python, hey, for every number or every element in that list, I want you to do the code below, which is print something. So it should print something then 5 times. And there you have it. So you can imagine we could have lots of code here in this space, and it'll do it for every element that's in that iterable or that list. Okay, so that's our simplest example. So we're going to build on top of this, and we're going to write an if statement within that for loop that can check for even numbers. So in order to check for even numbers, I'm going to introduce a new concept called the modulo, which is spelled modulo. And what this is going to allow us to do is get the remainder in division, and it uses the percent symbol. So I'm going to show you an example. So imagine I have 10 divided by 3. So what would the remainder be? Well, 3 times 3 is 9, and so 3 goes into 10 3 times, remainder 1. So that means when I type this in, 10 modulo 3, or sometimes called mod 3, 1 is my remainder. So I have 3 remainder 1. And let's say I wanted to do just another quick example, 18 modulo 7. So 7 can go into 18 2 times with a remainder of 4, because there's going to be 14, 7 times 2 is 14, and then in order to get up to 18 you have a remainder 4. So that's what we output there. And let's just drive the point home with 4 mod 2. So 2 actually goes in evenly into 4, so you have no remainder, 0. Okay, so go ahead and make sure that this makes sense to you by typing in examples, but basically all that modulo is doing is it's just giving you the remainder that's left. Okay, which remember, that's not equal to the decimal point after the number. That's just a remainder, as in a super basic kind of elementary division. All right, so moving along, we can notice that if this number is fully divisible with no remainder, then the result of the modulo call is 0. So that means we can use this test for even numbers. So we can think that if we get a 0 output from this percent sign or modulo 2, if that's equal to 0, that means it's an even number, right? Because if 2 goes into your number evenly, then you know that number is even. And if it outputs a 1, then you know you have an odd number. So let's go ahead and go back to that for loop we were doing. So I have L, which is 1, 2, 3, 4, 5. And go ahead and say for num in L, colon, and then I'm going to have an if statement. I'm going to say if num modulo 2 is equal to, and notice how I have 2 equal signs because I'm making a comparison statement here. So I'm saying if that number is absolutely equal to 0, colon, print the number. So let's go ahead and break down what this is going to do. It's going to go through each of those items in that list, and then it's going to say, okay, grab that item, which in this case is a number, perform mod or modulo 2 on it, check if it equals 0, and if that's the case, then print that number. So go ahead and see if that works. Awesome. So you notice we only printed the even numbers. And so what would happen if we set this equal to 1? Let's go ahead and find out. We only print the odd numbers. Excellent. So let's go ahead and build on top of this and add an else statement. So I'm going to set this back to 0, so it only prints odd or even numbers, excuse me. And I'm actually going to change this. I'm going to say print here is an even. And remember, this sort of print statements are for Python 2. And then I'm going to say else print odd number. So take a moment, make sure you understand what is going to actually output from the cell, and then check if you're right by running it. Okay, great. So let's go ahead and do one more edit to this code. So I'm going to say, let's say I want to actually print the number if it's even. So I'm just going to print the num here, and then if it's odd, print an alert that was an odd number. Let's go ahead and run that cell, and you notice I get odd number to odd number for odd number. Keep this in mind, because on your test there's going to be a question that kind of uses this sort of logic. It's going to be called the 𝗕𝗧𝗁 question, and it's actually a really common interview programming question as one of the first screens you do. Okay, so moving along, we're going to go with a totally different example now. So another common idea during a for loop is keeping some sort of running tally during the multiple loops. And for example, what we're going to do is create a for loop that sums up that list. So let's go ahead and make a list. Actually, we already have our list, L, 1, 2, 3, 4, 5. And I'm going to make a variable called list underscore sum. And I'm going to set it equal to 0. Okay, and then I'm going to do a for loop that says for num in L, take my list sum, and I'm going to set it equal to the current list sum plus that number. And then after the for loop has run, I'm going to print list sum. And notice how this statement right here is outside of the for loop because it's not indented inside of it. Okay, let's go ahead and run that. And I get 15. So that makes sense. So basically what happened is 1, 2, 3, or yeah, 1 plus 2 plus 3 plus 4 plus 5 is going to be equal to 15. So let's break down what's going on in this cell so we really understand it. I'm setting a variable, list sum, and I'm setting it equal to 0 outside of the for loop before the for loop takes place. And then I'm saying for every number in that list, go ahead and take the current list sum and then add that number to it and reassign list sum. So it's doing this code again and again for each of these numbers. And you'll notice list sum is then acting like a current running tally for your current sum. Okay, great. So read over that cell, make sure you fully understand what's going on. And something I want to note that we've gone over before is if we're editing a variable by itself, we can also use this sort of notation, this plus equals. And you'll notice if I run that cell, it's going to equal the exact same thing. Okay, great. So let's go ahead and move on to another example. So we've already looped through lists, and now we're going to loop through a string. So I'm going to say S is equal to this is a string. Okay, perfect. So remember when we index strings, Python thought of them as a sequence. So now when we iterate through them, we'll also be accessing each of those items in the string. So I can say for item in S, that's string, print item. Shift enter, and you'll notice it's going along the 0, the 1, the 2, the 3, almost as if it was indexing it, and then it's printing every single item in that sequence. This is a string. Great. So right now, if I was to do this in my own code, I would have called this something that makes sense to me. So for instance, letter makes a lot of sense since I know I'm going through the letters, and I'm going to say for letter in S, print letter. And you notice the output is exactly the same. Okay, so now let's go ahead and look at how a for loop can be used with a tuple. So I'm going to make a tuple. I'm just going to call it tup. And remember, tuples are with parentheses, and I'm going to use 1, 2, 3, 4, 5. And I'm going to say for t in tup, print t. So you notice it's iterating it just like as if it were a list. It just cares that it's a sequence. And we can also, again, call these whatever we want. Okay, great. So something that's interesting about tuples, and this is where we're going to get a little more advanced than in a typical lecture, we're going to learn about something that's called tuple unpacking. And to fully show that, what we're going to do is create a list of tuples. So I'm going to redefine L to be equal to a list, and what I'm going to have it do is create some tuple pairs in that list. So 2, 4 is going to be an element in that list. 6, 8. So you notice I'm kind of nesting these tuples inside of that list. And then 10, 12. Okay, so what's going on here? I have L, which is a list of tuple pairs. And to show you what that looks like, let's go ahead and index the 0th item. That's going to be that pair, that tuple. And I can, again, if I wanted to, index again and say that's just 2, so 0, 0. And then I could say 1 to grab 4. So let's say we wanted to grab 10. Hopefully this is familiar to you. That would be the second index of that list, and it's going to be that first item. And there we have 10. Okay, so now that we have that sort of logic down, we can actually do what's called tuple unpacking. So if you're iterating through a sequence that contains tuples, and the item can actually be the tuple itself. So during the for loop, we will be unpacking that tuple inside of a sequence, and we can access the individual items inside that tuple. So I know that was a lot, so let's just go ahead and show you an example. So first I'm going to say for tup in L, print tup. Okay, so that makes sense, right? I'm printing every element in that list. And now I'm going to show you how to do it with unpacking. So if I know what my data structure looks like inside that, and it's a tuple, I can actually write something that looks like this. I can write that item that I'm iterating with as a tuple. And I can say for this tuple in L, print, let's just want to print the first ones, the 2, 6, 10. And now what this is called tuple unpacking. So with tuples in a sequence, we can access the items inside of them through this unpacking. And the reason that this is really important is because a lot of objects will deliver iterables through tuples. And what we're going to do now is start exploring iterating through dictionaries so we can take this concept a little further. So just to break down what we did, we said for tup in L, we printed tup, and that will output the entire items in that list. But if I state that item to look like a tuple, this T1, T2, and remember I have to match it up exactly to what all those items look like in the list, so the items have to be uniform, then I can print things from that actual tuple. So I could do something like this as well. Or then I could perform operations on it. So I could say maybe I wanted T1 minus T2, and I get -2 for all of them, or let's say I wanted the sum of them, 6, 14, 22, etc. Okay, so let's go ahead and expand on that idea by working through a dictionary. So I'm going to say D is equal to, let's go ahead and make a quick dictionary here. I'm going to make 3 keys, K1, K2, and K3. Great, so now I have my dictionary, 1, 2, and 3, with 3 keys, K1, K2, K3. And I'm going to say for item in D, that dictionary, print item. So what do you think is going to come out? It's actually just the keys. And notice how they're also out of order. Remember, dictionaries are mappings. So what's going to happen here is that this is only producing the keys. And what do we do if we want to get the values, or both the keys and the values? So we're actually going to have a Python 3 alert. So let's go ahead and jump back to the Jupyter Notebook. Okay, so jump back to the Jupyter Notebook to fully discover this Python 3 alert. So if you're using Python 2, the method we're going to use to iterate through the items is called .iterItems. So if you're using Python 2, you should use .iterItems to iterate through the keys and values of a dictionary. So what this does is basically creates a generator, and we're going to learn about generators later on in the course, and that's going to generate the keys and values of your dictionary. So to see it in action, I'm just going to walk through the code here. I have d.iterItems, and we can see that this creates a generator. So calling the items method returns a list of tuples. And then you could iterate through that list of tuples of the keys and the values. Now, if you're using Python 3, what you want to use is .items. So that's going to .items for Python 3 is going to be the same as using iterItems in Python 2. It's basically a really similar change as when we were learning about range and xRange, which we'll cover in more detail throughout this course. But a lot of the changes in Python 2 to Python 3 were turning things into generators, so you wouldn't have to store things in lists. Okay, so you might be wondering why this worked in Python 2, and that's because of the introduction to generators in Python during its earlier years. So go ahead and read this in the Jupyter Notebook. Hopefully you already have before coming to this lecture, but it's just a little more of a breakdown as to what's going on here. But let's go ahead and say a quick tuple unpacking for a dictionary. So I'm going to say for kv in d dot iter items prints k prints v. And there I'm printing every key and every value. And it actually doesn't matter whether or not you have these parentheses in there. It's going to work the same. So that's actually up to you. I just put them in there because it might be a little more clear that you're doing tuple unpacking. But if you're reading someone else's code, more than likely you're going to read it like this, just without any parentheses, the k and the v, or whatever the items happen to be in that tuple. Alright, so that's it for this lecture. Go ahead and make sure you go over all the examples in the Jupyter Notebook. They're really similar to the ones we did in this lecture, but just make sure you understand the context of a for loop and how to make your own for loops. Alright, thanks guys! Hello everyone, and welcome to the while loops lecture. So what we're going to be learning about in this lecture is how to use the while statement in Python, and it's actually one of the most general ways to perform iteration. And what happens is the while statement will repeatedly execute a single statement or a group of statements until a true value occurs. So you can see here, if we zoom in, that the general format for a while loop is you have while, then some sort of test condition, and then as long as that test condition hasn't been or is still being met, then you have whatever code is executed. And then if you want, you can have an else to have a final code statement. So what we're going to be doing throughout this lecture is just going through some of these examples. So you can see here I have the Jupyter Notebook open, and we're going to be going through these examples. And then we're also going to be learning about the terms break, continue, and pass. Then we're going to be working through some more examples there. Okay, great. So let's go ahead and check it out. So we're going to hop over to the Jupyter Notebook. So now we're at the Jupyter Notebook for the while loops, and let's go ahead and look at a few simple while loops in action. So I'm going to say make a variable called x equals 0, and then you'll notice the formatting looks pretty similar to a for loop, except we have a while statement. And I'm going to say while, notice the syntax highlighting, x is less than 10, and here we can say do some code. So if I just said right now print hello and clicked enter here, this loop would go on forever, right? Because nothing is affecting x, and x will always be less than 10 as long as x is 0. So I'm not going to actually run that. What I'm going to do is say, I'm going to say print x is currently space, and then I'm going to print the value of x. And then what I'm going to say is I'm going to add 1 to x for every instance in that loop. So let's go ahead and see what happens. So if you notice, while x was less than 10, I said, okay, well, print this statement, x is currently, and then we printed x. And then the next step was x add 1 to it. So after that, it became 1. And then, was this statement still true? Yes, at 1 is still less than 10. So this while loop basically keeps performing until the condition is met. And in this case, once x was greater than or equal to 10, or basically no longer less than 10, this loop stopped. Okay, so hopefully that should be pretty clear. And notice how many times the print statements occurred and how the while loop kept going until that true condition was met, which occurred once that x equals 10. So you can see it actually stops at that 9 because once you had 10 there, none of this code executed. So it's important to note that that occurred and the code stopped. So let's go ahead and see how we could have added an else statement to this. So I'm going to make another cell here. I'm going to say x equals 0, and I'm going to say while, let's go ahead and just zoom in one more. I'm going to say while x is less than 10, print x is currently, comma x, and then I'm going to say go ahead and add that 1 to it. And now I'm going to have an else statement. So this is going to occur after the while statement condition is met. I'm going to say print all done. So let's go ahead and run that cell and see what happens. So you'll notice we have x equals 0, and after I met that condition on that while loop, I did my else statement. I printed all is done, or all done. Okay, great. So hopefully this is pretty straightforward to you. Basically what we have is this while condition, and the while loop will just keep running until the condition is met. Alright, so now we're going to learn about break, continue, and pass. So that's going to be the words, break, continue, and pass. So break, continue, pass. Alright, so let's go ahead and hop over to the notebook so we can explore it a little further. So we can use break, continue, and pass statements in our loops to add additional functionality for various cases. And these three statements are defined by, first off, break. So what happens is break, if you put that in your loop, it's going to break out of the current closest and closing loop. What continue is going to do, if you type that in, it's going to go to the top of the closest and closing loop, and then pass does nothing at all. So when we're thinking about break and continue statements, the general format is going to look a little something like this. You can have a while test condition and then some code, and you can say maybe if another test condition, break, or if another test condition, continue, and then you have an else. So you'll notice the break and continue statements can appear anywhere inside the loop's body, but we will usually put them further nested in conjunction with an if statement to perform an action based on some sort of test condition. So to explain all that, we're going to go ahead and explore some more examples. So let's go ahead and do that. So again, we're going to start with that same example we've been working at. I'm going to say x equals 0, and then I'm going to say while x is less than 10, print x is currently space comma x, and then I'm going to add another print statement. I'm going to say x is still less than 10, adding 1 to x, and then I'm going to do that. I'm going to add 1 to x. So notice what's going on here. I'm saying while x is less than 10, print the current x, and then also print a statement that verifies or just tells you x is still less than 10, I'm adding 1 to x, and then I go ahead and add 1 to x. And now what I'm going to do is add an if statement here. And what this if statement is going to do is it's going to say if x is equal to 3, go ahead and print some sort of alert. So I'm going to say, hey, x equals 3. And then I'm going to go backspace to come back and line it up with that if, and I'm going to say else print continuing. dot dot dot. And I'm going to say continue. Okay, so let's go ahead and break this down, what's going on in this cell. I'm saying while x is less than 10, print this statement, which is going to print out your current x. Then I'm going to say print x is still less than 10. Then I'm going to add 1 to x right here. And then I'm saying, okay, now if at that point in time, if x is equal to 3, print this statement. Else, if it's any other number that's not 3, go ahead and print continuing, and then we continue on with this outside loop. Okay, let's go ahead and run that and see what happens. So let's take a look at the output. I print out x is currently the number, x is still less than 10, adding 1, and then continuing. And if you notice, hey, x is currently 2, x is still less than 10, adding 1 to x. And at that point in time, I've added 1 to x, so it's going to say, hey, x equals 3. So you get that little alert there. And it's going to say, hey, x is currently 3, it's still less than 10, I'm adding 1, and at that point it's 4, so it's going to go ahead and continue going. All right, so you're going to have to note how we have that printed statement when x is equal to 3, and then the continue being printed as we continue through that outer while loop. So let's go ahead and put a break once x is equal to 3 so we can get a sense of how break works. So I'm going to go ahead and go back here, and I'm going to say, okay, put in a break statement. And remember what the break statement does is it's going to break that code for the outer loop. So now I'm going to run this cell. And if you notice, once that statement's true, so hey, x is equal to 3, print this, and then break. So it stops the outer loop that it's nested in. And then you have the hey equals 3, and it doesn't continue going because of that break. So note how the other else statement wasn't reached, and continuing afterwards was never printed. So these are pretty brief examples, but hopefully you have a comfortable understanding of this while statement and how to read and write it. Okay, so I want to make a quick word of caution. If you have something that is always true, you can run into danger of having an infinitely running loop. So if I were to say something like while true, print, let's say, infinite. And I'm not going to actually run this cell. Because if I ran this cell, I would just get an infinite print statements. And if you notice here in this Jupyter notebook, you'll notice it's actually a super long notebook because I've run a quick sample of infinite loop by always having that true. Okay, so make sure you do not do that in your code. Always, before you implement a while statement, make sure that there's at least some sort of break statement that you'll hit, or you're affecting the test condition where you won't have an infinite loop occur. Okay, so that's actually it for this lesson on while loops. So just to reiterate, the general format of a while loop, you have a while, some sort of test condition, and then your code statement. And then you can have an else for when you finish that while loop, you can have final code statements. So we went through a quick example using 10, and we kept adding to it. And then the next example, we had an else statement. And then after that example, we learned about break, continue, and pass. So a quick reminder, break is going to break out of the current closest enclosing loop. Continue is going to go to the top of the closest enclosing loop, and then pass does nothing at all. All right, so we'll be revisiting while loops and then break and continue statements as we go on throughout the course. So don't worry, we'll be covering this more and more as we get more and more complicated programs throughout the course. Okay, so that's it for the while loop. I will see you at the next lecture. Hello everyone, and welcome to the lecture on the range function. So in this short lecture, we'll be discussing the range function. And we haven't developed a very deep level of knowledge on functions yet, but we can understand the basics of this pretty simple function, range. It's going to be extremely useful, and you'll see a lot throughout the code. So here I have the Jupyter notebook open. This is what we're going to be going over. And what's interesting is there's going to be a pretty interesting Python 3 alert that happens, and we'll be exploring what that means later on. So let's go ahead and just get started. Right now I'm working in Python 2, and we're going to use range. So what the range function allows you to do, it allows you to create a list of numbers ranging from a starting point up to an ending point. And then you can also specify step size. So if I just write range and then click Shift Tab, since I'm working in IPython, it's going to go ahead give you the doc string here. So you can say range stop, give a list of integers, range start, stop, step size. So this is basically what we're going to be going over. So I have the range function, and I can give it a starting point and a stopping point. So let's go ahead and run that. And then it outputs a list of integers from that start, up to that stop, but not including it. So if you notice, I have from 0 all the way up to 9. And you can kind of think that this relates up with 0 indexing. A lot of times it's confusing for beginners. They expect to have a 10 in the output list. But remember, it's up to, not including. Okay, so moving along, another thing you can do is just specify for, the 0 there by default. So I could also just put 10, or let's say 11, and you can kind of think of this as if you put in range with just a singular number, it's going to give you from 0 up to, but not including, that number. Okay, and just to drive the point home that we're outputting a list, I'm going to say a variable x is equal to range from 0 up to 10. And then if I output x, it's going to be a list. And another function we can use to check the type of object it is the type function. And so for the type function, you just put in type, and in parentheses you enter the object, and it outputs the type. So we get a list out. And let's go ahead and just explore this a little further. I'm going to say my start can be, let's say, the number 5. My stop will be the number 20. And I'm going to say, give me range from start to stop. And you'll notice I start at that number 5 and output it, and I go up to, but not including, my stop number. Okay, so we notice how it went up to 20, but not actually produced 20. So it goes up to, but not including, just like in an indexing. Something we're going to explore now is step size. So we can specify that as a third argument. So I'm going to go ahead and change my start to 0, so I get the numbers 0 through 19. And then as a third argument here in my range function, I can specify a step size. So here, if I enter the third number to be 2, I'll go in steps of 2. So basically all the even numbers up to, but not including 20. So this is a useful tool later on in your code when you want to produce lists of a certain range or at a certain step size. Range is going to really allow you to do that very quickly. Okay, so that's not it. We'll have a Python 3 alert, so let's go ahead and jump back to the Jupyter Notebook. And this is going to be a bit of a sneak peek at introducing generators. Let's go ahead and jump to a quick brief presentation on what is actually going on here. Okay, so we're at the presentation, and we're just going to go over a brief explanation of range and xrange, and Python 2 versus Python 3 and how to deal with these functions. So you might have been wondering, what happens if I want to do a huge range of numbers? So if I said range from 0 to 1 billion, can your computer store that all in memory? And that's a great question. So you can imagine if we had put range 0, a billion, your output is going to have to save every single one of those numbers in a huge list. But maybe you just wanted to do a for loop for each of these numbers and didn't actually need to save the entire result. So that's where generators come in. And we'll have an entire section devoted to generators. But right now I'm just going to give you kind of a sneak preview and a quick explanation of what they are. So you can think of a generator as allowing the generation of these objects, or it's sometimes called generated objects, and they're provided at that instance, but it doesn't store every instance generated into memory. So if you use the generator for creating that, basically that output of numbers, you wouldn't have to store each single one of those numbers. So for instance, if you wanted to get all the numbers from 0 to a billion, use them once, and then toss them aside, that's where a generator could come into play. You wouldn't have to save those billion numbers in a list. So, like I was saying, this means a generator is not going to create a list to generate like range does, but instead provide a one-time generation of all the numbers in that range. So, specifically for Python 2, Python 2 has a built-in range generator, and it's called xRange. And it's recommended to use xRange for for loops in Python 2. So in Python 2, the normal range function is going to output a list, and it's going to save all those numbers into memory. xRange will generate elements, but not save them into memory. Now, if you're using Python 3, the normal range is already a generator, and you don't need to worry about using xRange. You'll only ever just use range, and that's it. Okay, so let's go ahead and hop back to the code and see some examples of what I'm trying to explain here. So let's go ahead and start off with a simple for loop example. So I'm going to say, let's go ahead and make a list equal to 1, 2, 3, 4, 5. And I'm going to say for num in L, my list, go ahead and print that number, that num. Okay, perfect. Now you remember earlier we set x equal to this output of the range function, and we were able to get a list. So now let's go ahead and do that. So instead of that L, I'm going to go ahead and say range from 1 to up to but not including 6. So I'm saying now for num in that range, remember that output's a list, go ahead and print that num. Shift enter to run that cell, and you notice it gets the exact same result. And let me go ahead and change that slightly so you can see that it's actually running. Okay, so change that back to 6. So that's an example of just a regular range function in Python 2. Now, something to note is that Python is actually saving this and creating an entire list with these numbers. So what if you wanted to do some gigantic range? You wouldn't want to run this because now you're going to take up a huge amount of memory with that gigantic list. So that's where the xRange comes into play. So if I use xRange, I'm going to generate those numbers but not actually save them. So let's go ahead and see what this looks like. I'm going to go xRange from, let's say, the numbers 1 through 10. I run this, and you'll notice the output is really similar. It's the same almost, just the fact that the range is different. So let's go ahead and go back to 6. And you'll notice as far as this for loop's concerned, nothing's really changed. But now let's go ahead and just look at what's going on if I were to type xRange 1 through 6 by itself. Notice my output is just xRange. And let's go ahead and check the type of that. So I'm going to say x is equal to the xRange 1 to 6. And if I ask for the type, you'll notice now the type is xRange. It's actually a generator now. And if I were to set, let's say, x2 as range 1 to 6, and I check the type of x2, that's actually a list. So the main takeaway here is that for Python 2, if you're using range in the fashion of a for loop and you actually don't need to save that entire list, go ahead and make sure you use xRange to not have to waste memory. For really small, let's say like anywhere in the thousands or tens of thousands, that's not going to be a big deal, especially with how much RAM computers have these days. But it's good practice to use xRange and to know what's going on when you're reading someone else's code. Now, if you're using Python 3, basically you don't have to worry about this anymore, and range is the xRange. Okay, so one last thing. Remember, x was xRange type. So what would happen if we tried to cast this as a list using the list function? Then we have the output that we would have gotten from range. So we can actually confirm this by checking that x2 is equal to this xRange casted into a list. Okay, so I know this was a little advanced, but don't worry, we're going to go over iteration and generation in much more detail, but I just wanted you to be aware of essentially this Python 3 alert, where there's a difference between range and xrange in Python 2, but in Python 3, this range function has become that generator, and it's not going to save that entire list into memory. And if you wanted to save that entire list into memory, you'd have to cast it using something that looks like this, list. Okay, so that's it for range. Just a quick overview. If you ever find yourself trying to make a list of integers in some sort of sequence, keep in mind range and xrange are good options there, and you'll see them a ton in your code and in other people's code. All right, that's it for this lesson, and I'll see you at the next lecture. Hello everyone, and welcome to the comprehensions lecture. So we've already seen some sequence operations and list methods in Python, but Python also includes this more advanced operation called the list comprehension. It's super useful, but it's one of those things that sometimes beginners have a hard time being able to read. So what list comprehensions allow us to do is build out lists using a slightly different notation. So you can think of this as essentially a one-line for loop that's built inside of brackets. So we're going to go ahead here. I have the Jupyter notebook open. We're going to go ahead and work through several examples so we can make sure we understand what's going on. So the first thing I'm going to do is do a building out of a list, basically, an old-fashioned way using for loops, a way we know how to already do. So I'm going to create a list, and I'm going to make an empty list that's just brackets. And then I'm also going to create, I'm going to say, for letter in word, and I'm just going to pass in that string word, take my list and append that letter to it. And then I'm going to say, outside of the for loop, at the end of that, print L, that list. So what's going to go on here? I'm going to build my empty list out. I'm going to go through every element in the sequence that is this string, so that's going to be every letter there, and I'm going to append that letter to the list. So let's go ahead and see what happens there. Okay, so I've built out that list, and it's basically every element is one of the letters in that string. So now I'm going to show you how to build this out using list comprehension. So list comprehension, the format is you basically kind of flatten out this for loop within a list, so, or at least within the brackets. And I'm going to say letter for letter in word. And that's it. That's the syntax for list comprehension. So you begin with what you actually want the list to consist of. So I want the list to consist of the letters. So for letter in word. And that's it. You don't have to worry about this sort of append structure because you're in a list comprehension. It knows that it wants the letters there based on what you've put in. So now if I check what L is equal to, it's the same. And let me go ahead and just make a new object called LST, so we really make sure that it's the list comprehension that's doing it. And there you have it. So it's the basic idea of list comprehension that you're kind of flattening out that for loop. So if you're familiar with mathematical notation, this might kind of feel familiar. So sometimes in mathematics, just to type, let's say, something out, so I'm going to change this to a markdown cell to show you what I mean. Sometimes in mathematics you have this kind of notation where you say like x squared colon x in, and then you have some sort of set of numbers. So maybe you've taken some more advanced math classes and this sort of notation makes sense to you. So that's basically what you're doing in list comprehension, where this colon stands for 4. And you're going to say something like x squared for x, and then in some sort of iterable. So that could have been a range like that. So let's go ahead and actually build out that example that we just talked about. So I'm going to square numbers in range and then turn it into a list. So I'm going to say LST is equal to brackets. I'm going to take an x and square it for x in range 0 up to but not including 11. So what's going on here? I'm going to take every x in this range and I'm going to square it, and that will be the result of my list. So that's list comprehension. And also, quick note, we could have done xRange here. Since we're using Python 2, that's going to be the same thing. Okay, so again, let's just break down what's happening here. And something that's a little confusing when it comes to list comprehensions, sometimes you feel like you have to know already the results. So when you're writing a normal for loop, you kind of start more on this end first, and then put in whatever object or output you want. And in list comprehensions, you actually start with the output you want, and then define how you're going to get it through some sort of for loop. Okay, so in this example, we're saying take my x, square it for x in range blah 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 0 to 11, and then we have brackets there. Okay, so let's go ahead and do another example that checks for even numbers in a range. And now we're going to basically introduce an if statement in our list comprehension. So let's go ahead and make an example that checks for even numbers in a range. So I want a number. I'm going to just type it out, number, and I'm going to write that I want even numbers from 0 to 10. So I'm going to say give me the number for number in range, and I'm going to want up to but not including to 11. Remember, default for range starting is 0. And since I only want the even numbers, I'm going to write an if statement here. I'm going to say number for number in range if that number, remember we can check through evens using the modulo, modulo 2 is equal to 0. So if I run that, now I have a list of even numbers from 0 to 10. So let's go ahead and quickly break down what's going on here. I'm saying number for number in that range, keep that number and build out the list if that number, when it's modded modulo 2, is equal to 0. And let's go ahead and deconstruct this list comprehension to make sure we really understand it by building out a for loop with it. So the way I would do this in a for loop, I would say list, build out an empty list, and then say for number in range 11 if number mod 2 is equal to 0, append it to my list. Append that number. And now the list, you'll see, is the same thing. So the reason list comprehension is so popular in Python is that once you get used to list comprehension syntax, this kind of thing becomes a lot cleaner and more Pythonistic than this for loop. Now, it's kind of debatable what is easier to read. Frankly, a lot of times, depending on how complicated a list comprehension can get, I actually still find this kind of for loop easier to read, but sometimes it's more efficient and just cleaner looking syntax to have everything in a singular list comprehension. And as you start getting more and more comfortable with list comprehensions, you'll find yourself using them more and more. All right, so now we're going to do a more complicated example. So we're going to make an example that converts Celsius to Fahrenheit. So I'm going to start with a list called Celsius, and it's just going to contain some temperatures that I'm making up that are in Celsius. So 0 degrees Celsius, 10, let's put in some floating point numbers, and let's say 34.5. Okay, so I have my list of Celsius temperatures. And now I'm going to use list comprehension to convert those into Fahrenheit. So I'm going to create a list called Fahrenheit and create my brackets for the list comprehension. And let's build out what we actually want to do. So temp for temp in Celsius. So what's that going to output? Well, that should output basically a duplicate list of the Celsius, right? If I just grab every temperature there, that's the same as Celsius. Whoops, misspelled it. Celsius. Okay, so right now Fahrenheit should look exactly the same. Okay, so what do we want to do with this temperature? So if you look up the conversion equation, what I actually want to do is take temperature. I want to divide it by 5. Actually, wait. I want to take the temperature and multiply it by 9 divided by 5. And I'm going to go ahead and put 5.0 so we don't have any floating point errors since I'm working in Python 2. And then I'm going to add 32 to that number. And I'm going to go ahead and wrap that in parentheses to make sure there's no order of operations error. Okay, so let's go ahead and see if that works. And there you have it. And you can quickly check, hopefully if you're familiar with both Celsius and Fahrenheit, you know that 0 degrees is the same as 32 degrees in Fahrenheit. So you can see that this matches up. So let's go ahead and break down again real quick what we just did. I'm saying take my temperature, multiply it by some factor, add 32 for it, and do that for every temperature in Celsius. And then because this statement is in brackets, it's a list comprehension and it's going to build out a list for you. Okay, great. Now moving on to a more complicated example. We're going to perform a nested list comprehension. And as you start nesting list comprehensions, it might get more and more debatable how useful and how clean it is, but it's important that you are able to at least be aware of them and read them. So what we're going to do is make one list comprehension. I'm going to say, let's go ahead and do that squared comprehension we were talking about earlier in range 11. Okay, so now my list is every number squared, but I can actually nest that list comprehension. So that's already a list, kind of the same way Celsius was a list earlier, and now I can do something for every item in that list. So let's go ahead and square it again. So I'm going to say x squared for x in, and since I have a list here, Python's going to treat that list comprehension we just made as an already completed list since it's nested inside this list comprehension. And now I should get every number to the power of 4. Great. And you can see that worked out. So you could keep nesting list comprehensions, but just be careful and make sure that you yourself can always go back and read them. And as always, you can use just comments. So I could say here, final result is x4 from range, let's say 4 num in range 11. So if I came back to this later, I would understand what's actually going on. Okay, so later on in this course, we'll actually learn about something called generator comprehensions. And I know I've slowly been sneaking in previews and dropping hints about generators. But after this lecture, you should at least feel comfortable reading and writing pretty basic list comprehensions. So let's go ahead and hop back to the Jupyter Notebook and just make sure we got everything. So remember, list comprehensions, they're basically like deconstructed for loops that are flattened out within brackets. And you can do list comprehensions on any iterable or anything you can do a for loop for. So if you find yourself making a for loop that's just building out a list, keep in mind that maybe a list comprehension is a cleaner way of doing it. Okay, and again, all these examples are in the Jupyter Notebook, so you can go ahead and feel free to explore them later. And we'll be using list comprehensions later on in some projects down the road. Okay, thanks everyone. Hello everyone. In this lecture, we're actually just going to be going over the questions on the statements assessment test, just to make sure you understand everything. So let's go ahead and get started. So this first question here, I want you to use these 3 different methods, for, split, and if, to create a statement that will print out letters that start with S, given this string. Okay. Next up, I want you to use range to print all the even numbers from 0 to 10. After that, I want you to use list comprehension to create a list of all numbers between 1 and 50 that are divisible by 3. Then I want you to go through this string below, and if the length of a word is even, go ahead and print even. Then I want you to write a program that prints the integers from 1 to 100. But for multiples of 3, I want you to print fizz instead of the number. And for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print 𝗕𝗧𝗁𝗁. Now, this is a really common question, and it's one of the first basically screening tests for a lot of interviews, just to make sure you actually know syntax of a language. So make sure you really understand that question. After that last question, I just want you to use list comprehension to create a list of the first letters of every word in this string below. Okay, so it's a pretty short assessment test, and the reason for that is we're going to be using a lot of this knowledge as far as statements and assessment or statements go throughout the course. So you're going to be seeing this over and over again. Okay, so best of luck and great job. Hello everyone, and welcome to the lecture on the statements assessment test solutions. So let's go ahead and take a look at them. I'll do a brief overview of the solutions, and you can check out the Jupyter Notebook to take a more detailed look. First up was use for, split, and if to create a statement that will print out the letters that start with S. So what I did was say for word in this string, call the split method on it, and that will return a list of all the words because I'm splitting by the white space. And then I said if word index of 0, so the first letter of that word, is equal to S, go ahead and print that word. Next up, use range to print all the even numbers from 0 to 10. So I said range, go from 0, 11, remember because indexing starts at 0 and it goes up to 11 but not including 11. And then I did spacing by 2, or that was my step size. Next, for list comprehension, to create a list of all numbers between 1 and 50 that are divisible by 3, I just said x for x in range 50, if x mod 3 is equal to 0. Equal because it's a Boolean check. After that, I wanted you to go through the string below, and if the length of the word is even, print even. And I'm going to refresh this real quick to show the answer. Okay, I refreshed, so sorry if there was a jump or a glitch there, but now I have the solution. So for going through the string below and checking if the length of a word is even, I said for word in st split. If the length of that word mod 2 is Boolean check equal to 0, print, and you could have printed whatever you wanted here. I just printed the word plus this arrow saying has an even length. 𝗕𝗧𝗁𝗁, you can go ahead and check out this answer. Should have been pretty similar to what we discussed in the lecture. And then at the end, I wanted you to use list comprehension to create a list of the first letters of every word in the string below. So what I did was say word index 0 for word in st.split. So go ahead and check out this Jupyter Notebook and check out the details of the code in case you're confused on anything. And as always, feel free to start a discussion question in case you want more clarification. All right, thank you, and I'll see you at the next lecture. Hello everyone, and welcome to the methods lecture. So in this lecture we're going to be going briefly over methods and how methods are essentially functions built into objects. So let's go ahead and jump over to a quick presentation. Okay, so let's get a quick overview of methods. So methods are essentially functions that are built into objects. At least that's the way I like to think about them. And later on in the course, we're going to learn about how to create our own objects and methods using something called object-oriented programming, or otherwise known as OOP, and we'll use classes in order to make that happen. But for now, let's just focus on methods on objects that we're already familiar with. So methods will perform specific actions on the object and can also take arguments, just like a function. So in this lecture, it's going to serve as just a brief introduction to methods and get you thinking about overall design methods that we'll touch back upon when we reach OOP, or object-oriented programming, in the course. So you've already used methods throughout the course, but now we're actually just formalizing what we're actually doing. So methods are in the form of this syntax, where you have the object, or the variable that's referring to that object, dot, and then the method name, and then parentheses and additional arguments. Sometimes you pass an argument, sometimes you don't. It depends on the method. So you'll see later that we can think of these methods as having an argument called self that refers to the object itself. Don't worry if you don't understand that now, but just keep that in the back of your mind, and you'll see how that really comes into play when we learn about object-oriented programming. And now we're going to jump over to the code, but the main purpose of this lecture, since you've already used methods, is just to plant a seed where you're thinking about methods and how they interact with objects, because when we learn about object-oriented programming, then it's going to click really well on what object-oriented programming is and how you're making your own methods and your own objects. So let's go and jump to some quick code to the Jupyter Notebook. Okay, so here's the notebook that's already laid out, and we're just going to go through some pretty quick examples, and you've probably already seen a lot of these before. So methods. Let's go ahead and see a quick example of methods on a list. So I'm going to create a simple list, 1, 2, 3, 4, 5. And fortunately, with IPython and the Jupyter Notebook, we can quickly see all the possible methods using the tab key. So I can hit L dot and then tab, and here I have a list of all the available methods for a list. So let's go ahead and try out a few of them. Let's try out the one that we're already familiar with, append. And append allows us to add elements to the end of a list. So I'm going to say append. Let's go ahead and add 6 to the end of that list. And now if I check that list, there I have 1, 2, 3, 4, 5, 6. Okay, so again, in order to grab that list of methods, remember this only works with IPython and Jupyter Notebooks, I can click tab and I get the list. I can click append or just hit enter once it's highlighted. And then if I want to know more about the specific method, I can hold shift tab, and then I get this little docstring pop up. Then I can click the plus sign and it'll tell me what it does. So from the docstring it says an appends object to end. Okay, so let's go ahead and do another one. We'll hit tab and let's go ahead and move down one so we're at count. So now what does count do? Well, let's go ahead and use the built-in help. So I can say shift tab for the docstring, and so lcount takes in a value and returns an integer, and it returns the number of occurrences of the value. So count, let's count how many times 3 appears on that in that list, and you'll notice it appears just once. Okay, so let's say you're using some sort of other IDE or some other coding environment that's not Jupyter or IPython based. How could you get the help on these built-in methods or built-in functions? You can actually just use the help function. So I could say help on that method, and it'll output the docstring, and hopefully that will help you. So what I want you to do now is feel free to play around with the rest of the methods for a list, and later on in this section in your quiz, it's going to involve using help and Google searching for the different methods on all the types of objects and data structures that we've learned about. So the only thing I want you to really get out of this lecture is to know if I want to find the method on an object, it's just a dot or a decimal point. I click tab and I have the list of methods, and then I can click shift tab to get some more information on it. Okay, so that's it for methods, just super basic. I want you just to feel comfortable calling them on the objects or data structures that you've made, and keep in mind just the syntax here and what it looks like, because when we go into object-oriented programming, you're going to feel this connection with methods and how you're actually building them out. And a lot of times in other tutorials that I've seen, that connection is lost on beginners. So keep in mind that you're calling a method on your object or data structure and then passing in arguments to it optionally. Okay, so that's it, and feel free to read up on the Jupyter Notebook if you want some more details on it. Okay, great, and I will see you in the next lecture. Hello everyone, and welcome to the functions lecture. So in this lecture we're going to be learning about functions and getting our first introduction on how to actually make our own functions. So we've seen a few functions in the past, such as len, remember that length function, and now we're going to learn how to build our own functions. So let's go ahead and get started with a quick introduction to functions. So what are functions? So Formally speaking, a function is a useful device that groups together a set of statements so that they can be run more than once. And they can also let us specify parameters that can serve as inputs to the functions. So you can remember the range function allowed us to put in parameters such as start, stop, and step size. So on a more fundamental level, the functions allow us to not have to repeatedly write the same code again and again. So if you remember back to that lesson with strings and lists, when we were using the function len to check the length of a string or of a list, if that's something you're going to want to do a lot, you're going to want to create a function so you don't have to repeatedly write out manually some sort of count for loop. Okay, and then finally, these def or def statements. So def is a built-in keyword telling Python that you're about to create a function. And instead of going through the syntax here in a PowerPoint presentation, we're actually just going to hop in straight to the code and check out the full syntax. So let's go ahead and hop over to the Jupyter Notebook. Okay, so we're back at the Jupyter Notebook, and now we're going to go ahead and hop over to some live code to check out the syntax. So how do you build out a function in Python? So you first off start off with the def, the def keyword. And if you're using an IDE that highlights the correct syntax in Python, you should see it highlighted. And then you do a space, and then you enter the name of your function. And the rules as far as naming your functions are going to follow the same rules of naming variables. So I'm going to say name of function. So space, the name of your function, you can name this whatever you want, and then parentheses, colon, enter, and right now this is going to be a super simple function. It's just going to pass. It's not going to do anything. And that's your very first function. Okay, so now I can actually call this function, and if you're using Jupyter Notebooks, you can do tab to autocomplete, and I won't pass anything since it doesn't take any arguments. Shift enter, and nothing will happen. Okay, so let's start building on top of this. So we began with that def, then a space, followed by the name of the function. And remember, we're trying to keep the names relevant. So for example, len is a good name for that length function. But you also want to be careful with names. You don't want to call a function the same name as a built-in function in Python. And if you go to the Jupyter Notebook, I actually have a link here that goes to all the built-in functions. So if you open this link, let me zoom in a little more so you guys can see it. Python has a bunch of built-in functions, such as the len function right here, length. And we'll be exploring these as we continue on throughout the course, but you want to avoid any of these names. So instance, like abs, all, any, base string, etc. Usually just make your function name more specific than it has to be, and you'll be unlikely to overwrite any of these built-in functions. Anyways, continuing on, we have our function, name of the function, then came a pair of parentheses, and that's where you're going to input arguments, and you'll separate the arguments with a comma. So you remember when we're using the range function, you inputted the start, the stop, and the step size, and they were separated by a comma. And then finally you have a colon there. And then you start a next line and you have to indent. So this indentation is actually important for Python, since Python makes use of what's called a white space to organize code. A lot of other programming languages don't do this, so keep that in mind, that this white space and this spacing and indentation is actually one of the most important parts of organizing your code in Python. Okay, so let's build up on top of this. Let's actually pass in some arguments, and I have to label them here. So I'm just going to label them arg1, arg2, and again, pass. I'm not going to do anything with those functions, or excuse me, with those arguments. And if I run that cell again, notice now I get an error, that the name of function takes exactly 2 arguments, and I'm giving it 0. So it's required now that I input 2 arguments. So if I input 1 and 2, I don't get an error, but again, nothing happens. So let's build out the function even more. We want to do something. So let's go ahead and rename this function. Let's call it my addition func. This is a really long name, but hopefully you can guess what we're going to do. We're going to say print arg1, arg2, whoops, we want to print them being added together. And I'm going to get rid of that pass now since we actually want to do something with them. So now, if I run that cell to save that function, name a function, now I'm going to change this to my addition func. And notice how I use tab autocomplete for convenience there. And now if I run this cell, it actually takes in the arguments and does the code that's indented beneath the colon there. So something else you might see for functions is something called a doc string. So if you remember the range function, if I clicked Shift Tab, a doc string came out that had some information, range stop, list of integers. So you might be thinking, well, where's that information actually saved? So to create a doc string, you create a comment using triple quotation marks to enclose it. And then you say, here is whatever you want to say in your doc string, since this is just a giant string. Here's my doc string. I'm going to click Shift Enter to run. And now you'll notice if I click Shift Tab here, my doc string is actually recorded in Python. So if I call help on that function, that doc string is going to help you. So right now we're going to avoid doc strings just so our code is a little cleaner. But as your functions get more and more complex, doc strings are going to become increasingly important so you remember what a function actually does. Okay, so let's go ahead and get rid of that. And we're going to start off and back up a bit and start with a really simple example of a function. So let's go ahead and make a function called say_hello, parentheses, colon, indentation. And then all this is going to do is it's going to print hello. Now if I run say hello, I don't pass any arguments because it doesn't take any. It goes ahead and says hello. So now we're going to create a function that greets people with their name. So what do we want to do here? I want to say def space, and let's go ahead and make a function called greeting. And it's going to take one argument, and I can actually call the arguments whatever I want. Just like if you remember when you're iterating through a for loop, you can call those items whatever you want. I can call these arguments whatever I want. And I'm going to say def greeting name, and what I'm going to do is I'm going to print hello space, and then I'm going to concatenate or add on that name. And I should have used 2 double quotations, that's why that was being highlighted. Okay, so what is this going to do? It's a greeting function. I have def space greeting, and then it takes name as an input argument, colon, and the indented code is what's going to run once we call that function. So it's going to print hello and then plus name. So it's going to concatenate the string that we put into the name into the whole phrase. So I'm going to run that cell to save my function, and then I'm going to say def greeting, and let's just put in a string. I'm going to put in Jose, so I should expect hello Jose to come out. And notice I have invalid syntax. So what's going on here? Well, what's going on is I accidentally called def again. So remember, when you're calling your function, you just call the function name. You don't actually call def. Def is what you use to define your function when you're creating it. And then later on your code, you don't call def again. So that was just to throw that in there. So I'm actually just going to call greeting, just like we were using print hello. Greeting Jose, hello Jose is the output. Okay, so now we're going to introduce the return statement. So let's go ahead and see an example of using a return statement, and then we'll break it down a little further. And what return is going to allow us to do is return a result that can then be stored as a variable or used in whatever manner the coder or you want. Okay, so let's head back and create an addition function again. I'm going to call it add num. And what it's going to do is it's going to take in 2 numbers. I'm going to call it num1 as an argument and num2 as an argument, colon. Click enter, my indentation return is automatic. And now I'm going to introduce a keyword called return. And what return does is whatever is put in front of return, that's what your function is going to output. So remember, range outputted a list, and that's because it returns the list. So now I'm going to return num1 plus num2. So note, I am not printing the addition of these two numbers, I'm returning it. So now what happens is I can say x is equal to add num, and let's say we'll pass in the arguments 2 and 3. So 2 is that num1, 3 is that num2. And it's returning the sum of them. And now I can set that sum to a variable. So let's go ahead and run the cell. And if I call x now, it's going to be equal to that sum. I can also just say print that value, and it would work the same. Okay, excellent. So let's break it down a little further and ask ourselves, what happens if we were to input two strings into this function? So we have our add num, but remember, we're just specifying this with a plus sign. So if we were to put in two strings, let's say 1 and then 2, what it's going to return is 1 concatenated with 2, since they're strings. 1, 2. And I can even set that equal to a variable, and then if I print x, I get the concatenation of those two strings, basically them being stuck together. And why is that happening? It's because we don't declare variable types in Python. So if you're familiar with other languages, a lot of times you have to do something like call a var and declare the variable to be some sort of like integer, etc., etc. If you're learning Python as your first language, it's really nice because you don't have to worry about that. But one of the issues with that is for this kind of function, we could pass in strings and integers or floating point numbers, etc., and still get results out, maybe even if we didn't want that to happen. So later on, we're going to learn about adding in checks to make sure a user puts in the correct arguments into a function. So now we're also going to start using break, continue, and pass statements into our code. Remember that we introduced these during the while lecture, and now they're going to come back again. So let's go ahead and go over a full example of creating a function that checks if a number is prime. And this is kind of a common interview exercise, so we're going to head and go and break it down for you. So I'm going to clear this cell. I'll clear this cell as well, clear this one as well. Okay. So let's go ahead and start with def. That tells Python we're making a function. And I'm going to say is underscore prime. And there's my function. And I'm just going to say pass. So right now if I call is prime, nothing happens. Okay, perfect. So let's start building on top of it. I want is prime to take in a number, right? Because we're going to take in a number and then check if it's prime. So save that. And now is prime is going to take an error or give out an error since it needs an argument there. So I'm going to go ahead and pass in a number, 2, and we don't get an error. Perfect. So now let's keep building out a little more. So we'll start with that docstring, which remember is the triple quotes way of writing a comment. And I'm going to say this is a quick description of this function. This function checks for prime numbers. That's one way of writing a docstring. Sometimes some people write docstrings with kind of this sort of format, and they'll label it input output so users know. Let me zoom in a bit for you guys so users know what's going to be inputted and outputted. So we know we're going to input a number, so I'm going to say input a number, and we are going to output a print statement whether or not the number is prime. Okay, so let's zoom back out real quick so you saw that. So now we have this docstring. I'm going to save it. Is prime with that 2 runs fine, and if I click Shift Tab, now my docstring is actually pretty clear. So input a number, output a print statement, whether or not that number is prime. Okay, so we're going to dive into math a little bit, but we know a number is prime if that number is only evenly divisible by 1 and itself. So what we're going to do is write a function to check all the numbers from 1 all the way to that number and then perform modulo checks. So I'm going to say for n in range, and let's start from 2 since we know 1 will always be go into a number. We can say from 2 to num, if the number we put in divided by any of the numbers from 2 all the way up to that number is equal to 0, then we know it's not prime. And then we're going to break out of this loop because we don't need to check anymore. And I'm going to head back 1. So let's say after we go through all those numbers, none of them had mod 0. That means no numbers from 2 all the way up to the input number go evenly into that number itself. Then I'm going to say else. So if mod never 0 occurred, whoops, I'm going to print the number is prime. Okay, now let's see if this works. Let's go ahead and input a number we know is prime, 13. Okay, and now let's input a number that we know is not prime, 12. Perfect. So we know this is working. So there's other ways to do this exact same function, and there's actually better methods of checking for primes. And I'm going to kind of leave it to you as a homework assignment to go ahead and try to use either the math module to check, or use your own Google abilities to check out what's a better method of checking for prime numbers. And just to give you a quick hint, if you scroll down to the bottom of this Jupyter notebook, their better version is example for you there. But let's go ahead and break down exactly what happened here so we understand all these various pieces that kind of really build out your first true function that brings in a lot of what we learned in the past together. So let's break this down completely. So we're checking if a number is prime. So I'm making a function using def to tell Python I'm about to make a function. I'm going to say is_prime is the name of my function, parentheses, num, that's the argument it takes in, colon. Then I have my doc string, which is basically a description of what's going on in the function. After that, notice all the code is indented at least 1 so it lines up with that name. That means all this code is going to run when I call that function. And now what I'm doing is I'm going for every n, which is going to be a number, from range 2 to num. And remember, since I'm in Python 2, I could have also done xrange to not create a list. If you're using Python 3, you can only use range, which is going to be the same thing as xrange in Python 2, but that's a small detail, don't worry about it. So I'm saying for n in range from 2 to that num. So what is that doing if I were to just to check it outside of the function? Let's say 2 to 12. It's creating a list of all the integers from 2 up to that num. Actually, up to but not including that num, which is important since we're checking for primes. And then I'm going to say if the number itself, so in this case if 12, divided by any of these numbers leaves you with a remainder of 0, then I know it's not prime, right? So if 12 is divisible by 3 evenly with no remainder, then I know it's not prime. Then I'm going to print not prime, and I'm going to break, which is going to break out of this for loop and ends my calculations. Else, if that never occurs, then I know the number is prime, and I'm going to print the number is prime. Okay, so that's our first lesson in functions, and functions is going to be something we come back to a lot during our code, and it's going to be one of the basic building blocks of our code, so you'll see it over again and again. So go ahead and check out the reading and this Jupyter notebook, and make sure you fully understand at least how to read and understand how a function is built out in Python. Okay, so thanks for watching this lecture, and I'll see you at the next one. Hello everyone, and welcome to the Lambda Expressions lecture. So in this lecture, we're going to be learning about lambda expressions, what they are, and how to use them. So we're going to start with a brief presentation, just describing lambda expressions purely in words, and then we'll learn how to do it in the live code session. So one of Python's most useful tools, and a lot of times it's really confusing for beginners, is the lambda expression. And what the lambda expressions basically allow us to do is create anonymous functions. So just quickly make ad hoc functions where you don't want to spend the time defining an entire function using a def statement. So what is lambda? Lambda's body is going to be just a single one-line expression. It's not going to be a block of statements. And the lambda's body looks really similar to what we put in a def's body return statement. So you can simply type the result as an expression instead of explicitly returning it. And then because it's limited to just like a one-line expression, it's going to be less general than a def function. So when are you going to use lambda? You can only squeeze design to limit program nesting. So the issue with lambda is that it's designed for coding simple functions. If you want a larger task to be done, you're going to have to use def. Okay, so the best way to learn how to use lambda expressions is to slowly convert a normal def function into a lambda expression. So let's go ahead and hop over to the code to see how that's done. Hey, okay, now we're at the lambda expressions Jupyter notebook, and I have it open here, and this is basically what we're going to all go through in a couple of examples during this lecture. So let's go ahead and get started. And what we're going to do is go ahead and jump to a live code session. So I'm going to make a really simple def function using just normal syntax. So I'm going to say def space. I'm going to name my function square. It's going to take in num as an argument. It's going to set a variable called result, square that number, and then it's going to return the result. So that's my simple function. It's just squaring numbers. So if I call it square 2, it releases 4. Okay, so let's go ahead and continue breaking this down, and you'll see that we're going to slowly form it into a lambda expression. So how can I keep reducing this function? If you notice, I'm returning result and setting result as a variable, but I actually don't need to do that. I could just return this nums to the power of 2, right? So I could just say return num to the power of 2, and that's going to be the same thing. I don't need to save this variable if I'm just going to return it. So let's go ahead and make sure that worked. So square, let's do 4 this time, and we get out 16. So that makes sense. Okay, so how can we put this all into one line? So Python, I know we've been making a big deal of white space for functions, but I could actually write this in one line in this fashion: def square num colon return num to the power of 2. Now this is kind of bad styling, but it is okay syntax wise to do that. Although I wouldn't recommend doing that normally, but we're doing that just to slowly convert it into a one-line lambda expression. So again, let's go ahead and do square of 3, and we get 9. So notice how in this format it still works. We have kind of this one-line function. So this kind of form is the form that a lambda expression is going to try to replicate. So when you're using lambda expressions, you're basically going to write kind of a one-line version of a function. And the way we would convert this square function into a lambda expression would look like this. I would type lambda num colon num to the power of 2. So the syntax is you write lambda, you write what it's going to take in, and then you write colon and what you want the output to look like. So this is one of the most basic versions of a lambda expression. And notice how when I run that, Python's going to treat it as a function. So I can actually get the function back by assigning a label to it. And as we've gone over a little bit throughout the course, we can actually assign labels to functions. So I could say square is equal to that lambda expression. And now if I call square, you'll notice it works just as it did for the full function. And just to make sure that it's actually taking its results from this lambda expression, let's go ahead and put square 2, put square 2 on 10, and notice you get the exact same thing. So that's the simplest breakdown of a lambda expression, and I'm just going to go over it one more time. You can think of a lambda expression as basically kind of this one-line condensed version of a function, where you have lambda, what you're taking in, and then what you want to do with it, separated by a colon. Now usually you actually don't save lambda expressions to a variable, since you want what's called a anonymous function, which means you never spend the time to actually save it. You usually run it within a context of your code where you just need something to quickly perform some sort of expression and then not worry about it later. So let's go ahead and go through a couple of more examples and really drive this lambda syntax into our head. So I'm going to say, let's make an example to check if a number is even using lambda expressions. So I would say lambda, I want to take in a number, num, and how do I check something is even? Remember, if the mod is equal to, the mod 2 is equal to 0, then you know it's even. So I'm going to say num mod 2 equal to 0. And there's my even function, or function to return a Boolean, right? So I can set that equal to even, that lambda expression, and now I can check if numbers are even. So just like we did earlier, where we converted a function into a lambda expression, let's work backwards now and convert this lambda expression into a function just to drive the point home. So what is this lambda expression actually trying to do that a function would? Well, it would look something like this, right? Even, take num, return the Boolean if num mod 2 is equal to 0. And that's going to be the exact same thing as that lambda expression. So you notice now, instead of writing this entire syntax of def, we can just actually have one-line lambda expressions throughout our code if we ever need just to do a quick function. Okay, let's go through a couple more examples. So let's say I wanted to make a function that grabs the first character of a string. So what would that look like? Well, I have lambda. I'm going to take in some s, some string, and I know the first character is just going to be the 0 index there, right? So again, I have my function. We can go ahead and save it if we want. Give it a variable. And now I'm going to say first of hello, and you notice it returns that 0 index. Okay, so let's move along. Let's see how we could reverse a string. We've seen this a couple times throughout the course. But remember, to reverse a string, you take it in, that s, and then you can actually just go through it backwards through indexing. Hopefully you remember this from your indexing lecture. There's our function. Let's go ahead and set it to a variable label called rev, and say rev hello. And you'll notice it's reversed. Okay, so moving on to a little more advanced, we can, just like a normal function, accept more than one argument into a lambda expression. So let's go ahead and see what that looks like. Let's say I wanted to add two numbers together as a function. So let's say I made a function, now this is just a normal DEF function, called adder. And it took x and y, and it returned the sum of them. So if I say adder, I could say add, let's say 10 and 12, we get 22 back. So now let's break down this function that takes in multiple arguments and turn it into a lambda expression. So I would say lambda. I'm going to take in 2 arguments, and you'll notice I separate them by commas, just like I would in a normal function. And then what do I want to return? I want to return x plus y. And that's it. And then I could say, call this adder. And now if I call adder in my code, you'll notice I can say 30/30, and I get 60 out. So lambda expressions are really going to shine and be used a lot when they're used in conjunction with 3 main functions: map, filter, and reduce. And each of those functions actually has its own lecture, so feel free to explore them if you're more interested in lambda functions, but you'll be introduced to these 3 functions specifically since they have a lecture each. Okay, so there's a really great blog post that I highly recommend you read after you go through this lesson, and it's called, it's at this site called Python Conquers the Universe, and it also has a great breakdown on lambda expressions and some more explanations for common confusion. So if you click that link in the Jupyter Notebook, it'll take you to this website right here, Python Conquers the Universe, and he says yet another lambda tutorial. There's actually a ton of tutorials out there for lambda, so you can check out his own links as well. But again, he goes over basically the necessities of what lambda is good for. And right now, you may not think that you'll be using lambda a lot instead of just writing a full def function. But you'll notice as you go throughout your code and don't need an entire function, you just need a quick expression, lambda will come in super useful. So as far as this blog post, he goes more into why you should use lambda and more of the theory behind lambda than actual coding. But I think it's a great blog post, and I highly recommend you read it after you go through this lesson and understand how to build your own lambda expressions. So let's go over quickly what we learned in this lecture. So we learned about lambda expressions, how they're pretty useful as anonymous functions and these ad hoc expressions. And we noticed that they're made of a single expressions. They're not a block of statements like you usually would for a full def function. So we have this def square function, and we slowly broke it down until we got a lambda expression that served a similar purpose. And then through our own lecture here in the live coding, we then created a lambda expression and kind of did the reverse, broke it back into, or built it back into a full function. And then we went through a couple of examples of lambda expressions. So just to reiterate, remember, a lambda expression takes the form lambda, some item or object, and then what you want to do to that item or object. So you could maybe check the length of it. And in context, usually you don't save, let's call this length check. You don't save a lambda expression to a variable like this. You use it in conjunction with map, filter, and reduce, which I know doesn't make a lot of sense right now since you're not familiar with these functions, but you'll see that when you're using it with map, filter, and reduce, you'll actually just end up passing this lambda expression as the argument instead of saving it to a variable. So now we can do length check. Let's say a string. How many cars does this string have? 37. Okay. So go ahead and make sure you understand at least how to read a lambda expression and how to build out simple lambda expressions. Don't worry too much about implementing these in your actual code. As you get more and more advanced in Python, you'll suddenly feel like, hey, maybe I can use a lambda expression here instead of writing this full function. Okay, so that's it for this lecture on lambda expressions. Hope you enjoyed it. Hope you got something useful out of it. And I'll see you at the next lecture. Okay, thanks everyone. Hello everyone, and welcome to the Nested Statements and Scope lecture. So we've gone over writing our own functions using lambda expressions, etc. But now it's important to understand how Python deals with the variable names we actually assign. Before we start this lecture, what I want you to do is read and code through the entire Jupyter Notebook for this lecture. This is a super important topic for fully understanding the more advanced Python programming features. So what I want you to do is read through the entire Python Jupyter notebook, read through all the code, code it out yourself, make sure you understand it, and then come back and we're going to explain those ideas further. Okay, so let's go ahead and get started. Through a quick introduction, so like I mentioned before, we've written our own functions. Now let's understand how Python deals with the variable names we assign. So when you create a variable name in Python, that name is stored in what's called a namespace. And variable names also have what's known as a scope. And the scope determines the visibility of that variable name to other parts of your code. So let's see a quick example of this. Here, we have the cell block that was in the Jupyter notebook. So as I mentioned before, you should have gone through the Jupyter notebook already and typed out this code yourself. So we have the cell block, we have x equals 25, and then we have this function printer, which sets x equals to 50 and then returns x. So what do you imagine the output of printer is, and what do you imagine is the output of print x? So the output of that print x statement is 25, and the output of print printer is 50. So if you notice here, you basically have two different x's, one for printer and one in a more global scale or scope, which we'll learn about in a second. So what we really want to figure out is, how does Python know what x to refer to in your code? And this is where scope comes in. So Python has a set of rules it follows to decide what variables, in this case x, you're referencing in your code. And what we're going to do is break down some of those rules. Okay, so this is what I just said. Let's go ahead and break it down through name assignment. So name assignments will create or change local names by default. And name references search at most only 4 scopes. The 4 scopes are local, enclosing functions, global, and built-in. So let's go ahead and start with a quick definition of all these scopes. First, local scopes. So names assigned in any way within a function, such as a def function or a lambda expression, and not declared global in that function. That has a local scope. So if we go back real quick, that x equals 50, it's defined within a function, printer. So currently that has a local scope, which is why when you call printer, it returns 50. Okay. Next, if it couldn't find it in local, it looks for enclosing function locals. So the name and the local scope of any and all enclosing functions, such as def or lambda, from inner to outer. And we'll see an example of that in a further slide. After that, it checks for global. And those are names assigned at the top level of the module file or declared global in a def within a file. And we'll talk about the global statement in just a second. After that, it checks for built-in names in Python. Those are names that are pre-assigned built-in names in the Python language, so such as open, range, syntax error, etc. So let's go ahead and break down a few examples of all 4 of these. So first with local. So for instance, if you have an expression here, x is local to that lambda expression, or any function. Next, enclosing function locals. This one's a little different. So here I have an example which you've already coded through. I'm assigning name is equal to this is a global name outside of any function. Then I create a function called greet and name equals Sammy. And then, this is something a little new that we haven't seen yet, I put a function within that function, I enclose it, and I have a function called hello, and it prints hello plus name. Then I call hello in my greet function, and then at the end I call greet. So if you notice, it prints hello Sammy. So what happens here is, if we work inside out, we have this hello call, and if we look at the function hello, it says def hello print hello name. So what Python's going to do is it first looks for a local scope. Is name defined anywhere within this hello function? It's not. Okay, then let's go to enclosing functions. Is hello enclosed within another function? It is. It's enclosed within this greet function. It looks for the name variable there, and here it is, name equals Sammy. So now that it's found it, it brings it back here. It won't actually go all the way out to this global because it's found it already in the enclosing function. All right. Next up, global. So globally, if I were to just say print name, since I defined it earlier here with outside of any function, this is a global name, it'll print this is a global name. And then built in, we've seen a ton of examples of these, such as len, which is the function length, etc. So you want to be careful not to overwrite any built-in names. All right, so moving along, local variables. When you declare variables inside a function, they're not related in any way to other variables with the same names used outside the function. So variable names are local to the function. And this is called the scope of the variable. And all variables have the scope of the block they are declared and starting from the point of definition of the name. So we kind of just went over this, but let's go ahead and break it down a little further. So here's one more example. I've assigned here x is equal to 50. This is a global variable. It's global in scope. Then I have a function, func, which takes in x. It prints x is x, resets x equal to 2, prints changed local x to x. Then we're going to call that function and print x is still. So what happens here? I say x is 50. So that's this line right here, print x is. So the function takes in 50, it says x is 50. Locally, it changes x equal to 2. It does not change the global variable, which then it says changed local x to 2. But outside the function, even after we call the function, if I were to print x, it still stays 50. So it only affects that change on a local level. Now what if we wanted to change that on a global level? So if you want to assign a value to a name defined at the top level of the program, not inside any kind of scope such as functions or classes, which we'll learn about later, then you have to tell Python that the name is not local but it's global. And we do this using the global statement. So let's see what that looks like. So here, it's the same code you've gone through before in the Jupyter Notebook. I have assigned x is equal to 50. And now, this is where it gets interesting. Within my function here, I say global x. And this basically tells the function, hey, I'm looking for the global name of x here. Whatever changes I do will affect x globally. So then I print, this function is now using the global x. Print, because of the global x, is print out x, resets x equal to 2, print ran func change global x to x. So outside of the function, what I first do is I print before calling func x is, so let's see the output. Before calling that function, x is 50. Then we call the function, and this function is now using that global x. Because it's global, it knows x is 50. It resets the global x to 2, and then even after calling the function outside of the function, x is now equal to 2. So with that global statement, I can affect name changes to variables that have a global scope using that global statement. And I'll use that a lot throughout the project of the blackjack game that you'll see later on this course to really nail it in that global statements allow us to take in global variables. Okay, so in conclusion, one last thing I want to mention is that you can use globals, a built-in function, parentheses, and locals, another built-in function, to check what your current local and global variables are. And another thing to keep in mind is that everything in Python is an object. So I can assign variables to functions just like I can with numbers or any other type of objects we learned about in the first section of this course. So we're going to go over again this whole idea of everything in Python as an object a lot more in the decorator section of this course. But I just want to mention to you now so you have a feeling of what to expect. Okay, so let's hop over to the Jupyter Notebook really quickly. So again, you should have gone over this entire notebook before seeing that slide presentations, and go over this code and make sure you really understand what's happening here. So the things that are important to understand, it's important to understand for this cell block why x is printed as 25 here with this command and why it's printed as 50 here with this command. That's crucial for your understanding of how variables and nested statements and scope works in Python. Once you have a good feeling of why that's happening, you need to make sure you have a good feeling of why this is happening. Why is hello Sammy being printed instead of hello, this is a global name? Make sure you understand that. And then finally, make sure you understand these last two examples. This one right here, why x equals 2 is printed only when you call that function, and then x is still 50 globally. And then you also need to understand, after reading all this example here, why x is 50, and why, since we called global, x is equal to 2 resets the global x to 2, even outside of the function. Okay, once you understand those examples, you pretty much have a full understanding of scope in Python, and you're ready to go. So take your time with this lecture. This should take you about a whole day if necessary to really understand what's going on, but make sure you take your time to really understand nested statements and scope. Okay, thanks everyone, and I'll see you at the next lecture.
Hello everyone, and welcome to your first milestone project. In this lecture, we're just going to discuss what your milestone project assignment is and the various notebooks in the repository dedicated to your first milestone project. With that being said, let's go ahead and jump to the repository and check out the assignment notebook for milestone project 1. So here I am at the Complete Python Bootcamp repository. If we just zoom in here, you can scroll all the way down to the M section for milestone, and you'll see a couple of milestone project notebooks. We're going to go ahead and check out Milestone Project 1 Assignment Notebook. That should take you to this notebook here. In this case, I actually have it open in GitHub, not an NB viewer, so I can get the latest version. But the Milestone Project 1, first off, I just want to congratulate you on making it to your first milestone project. You've already learned a ton, and you're definitely ready to work on a real project. For this assignment, you're going to create a tic-tac-toe game. You can feel free to use any development environment you want, but just keep in mind that the solutions presented are going to be in the Jupyter Notebook format. The requirements for this milestone project are 2 players should be able to play the game, both sitting at the same computer. The board should be printed out every time a player makes a move, and you should be able to accept the input of the player position and then place a symbol on the board. You can feel free to use Google to help you figure anything out, but what I don't want you to do is just Google tic-tac-toe in Python. Otherwise, you won't learn anything because you'll just find a bunch of solutions online. Keep in mind, this project can take anywhere between a few hours, or several days. There's 4 Jupyter notebooks related to this assignment. There's the assignment notebook, which is the notebook we're looking at right now. There's a walkthrough steps workbook notebook, a walkthrough solution notebook, and then an advanced solution notebook. What I encourage you to do is just to try to start the project on your own right now without referencing any of those notebooks. I'll go over what these notebooks are in just a second. But what you should really try to do right now is just start from scratch, a fresh notebook, and see if you can actually program out, or see how far you can get programming out a full tic-tac-toe game. If you get stuck, you can check out the next lecture, which is a text lecture with helpful hints and steps to follow. If you're still stuck after that, then check out the Walkthrough Steps workbook, which breaks up the project in steps for you to solve. If you're still stuck, then check out the walkthrough solution videos for more help on approaching the project. You should note that there are parts of this that are going to be a struggle, and that's good. I have complete faith in you that you've made it this far through the course and you have all the tools and knowledge to tackle this project. Remember, it's just totally open book, so take your time, do a little research, and remember, most of all, have fun. With that being said, let's go ahead and check out the Walkthrough Steps workbook notebook. So I jump back to my repository, Complete Python Bootcamp, and I'm going to go through the Walkthrough Steps workbook Milestone Project 1 notebook. This one actually has the solutions. But let's say you got stuck, the helpful hints lecture, you're still stuck after that. You can check out this Walkthrough Steps workbook, and if you click it, it'll look something like this. It's called Milestone Project 1 Walkthrough Steps Workbook. And below here is a set of steps for you to follow to create the tic-tac-toe milestone project game. So you'll see here, there's a bunch of cells for you to fill out, and there's actually steps telling you what functions to make. So for example, the first step is write a function that can print out a board, set up your board as a list, etc. So as you follow these steps, it will guide you in filling out the functions you need for actually creating the tic-tac-toe project. If you're still stuck after this, then you can check out the full solution notebook and the videos for it. in which we're going to actually walk through and solve all of these problems through a live coding section, do all of the steps, and teach you every step necessary to complete the tic-tac-toe game. After that, if you're interested in a more advanced solution using a couple topics we haven't actually covered yet, you can go back to the Jupyter Notebook viewer and click Milestone Project 1 Advanced Solution. There's the complete walkthrough solution, which is the solution for all of these functions to make a working game. And then there's the advanced solution, which uses some topics we haven't covered yet, but are still nice to know in the context of the tic-tac-toe game. Okay, that's it for this lecture. Again, if you want the actual assignment, click on the assignment notebook. If you want some more hints, check out the next lecture for a text lecture consisting of helpful hints. If you want even more hints in a notebook format, you can click the Walkthrough Steps workbook and begin to fill out the functions defined here for you and follow the instructions. Still stuck after that? Then check out the videos for the complete walkthrough solution. Okay, with that being said, best of luck and have fun. Hello everyone, and welcome to the Milestone Project 1 Complete Solution Walkthrough. In this lecture, what we're going to be doing is going through the entire walkthrough solution, each of those steps, solving those functions. So we're going to be going through each major function. Try to solve and create the function on your own first, but let's go ahead and jump and get started to the Jupyter Notebook and see what's going on. Okay, so here we are at the Milestone Project 1 Walkthrough Steps workbook. What I've done is I've downloaded this Jupyter Notebook to my local computer so we can actually go through each of these steps, fill out the functions, and make sure we match up correctly with the solutions notebook. So if you want to follow along with the actual code I'm going to be doing, you can go to the other notebook, which is Milestone Project 1 Full Walkthrough Code Solution. And this is basically what we're going to be doing. I'm going to be typing this out and explaining the logic along the way. Let's go ahead and get started. So again, if you want to follow along here, what you should be doing is you should have downloaded this notebook, Milestone Project 1 Walkthrough Steps Workbook, and be following me working through it. And before we do each step, I'm going to really stress that you should pause the video and really try to solve this on your own. It's going to be really helpful if you give it a fair shot at solving it on your own. Okay, with that being said, first thing we're going to say is from __future, import the print function. I'm just doing that so I can always use the print function. So for example, I can do something like this. Hello. Instead of using the print statement, which would have looked like that. That's just to make sure whether people are using Python 2 or Python 3, all the code matches up. So if you're using Python 2 like I am right now, go ahead and put this line here. If you're just using Python 3, you don't have to worry about this line. You can just use the print function naturally. One other note that I want to make sure you guys realize is Python 2 users, you'll notice throughout some of the functions we're going to be asking for input from the player. Python 2 users should use raw input to get the player input. Python 3 users should just use input. We'll go over that later on when we actually use those functions. Alright, so what's our first step? First step is to write a function that can print out a board. We're going to set up our board as a list where each index, 1 through 9, corresponds with a number on a number pad. So you get a 3x3 board representation. Here, what I've done is I said from ipython.display import clear output. That just allows us to clear the output. So I'll show you an example of that. If I say print hello, I get hello here. Let me go ahead and run this. So I've imported clear output. So I just ran the cell, but now I'm going to say clear output. No, just no other arguments, close the parentheses. And you'll notice it will basically print hello and then clear the output so you don't get anything out. And if I add another print statement after that, like world, then I just get world out because it printed hello, it cleared the output, and then printed world. It happens so fast that you only end up seeing world at the end. But I just wanted to clarify that's what clear output is doing. That's for Jupyter Notebook. You may need to use another output or clearing of output if you're using a different IDE or development environment. This is what you have to do for Jupyter Notebook. Say from ipython.display import clear_output. Okay, you can go ahead and Google search for your particular developer environment what you should do to clear the output. So first thing we're going to do is write a function that can print out the board and set up our board as a list, where each index, as I mentioned, corresponds to a number on the number pad. First thing I'm going to do is say clear_output. That way, every time I call display board, all the previous output is cleared, and then I can actually print out a board. Alright, so here again I'm going to stress that you pause the video and really try to think, how can you display this board? Alright, now let's go ahead and continue. Hopefully you've had a good shot at this now. But when I say print board, all you have to do is, let's go ahead and practice printing an empty board. So an empty board might look something like this. If I say just a string that looks something like this, then right below it I'll print maybe another string that looks something like this. Maybe it has a couple more dashes there. But this is basically all this step was trying to make you do. Just print out a board right now. And then later on we're going to, in just a second, we're going to add what we would need to add to take in a board and print it out. But let's go ahead and just practice this. If I call display board, let's see, and pass in a board, in this case I'm just going to pass in an empty list. You notice we get a very simple board, and we're actually missing a couple lines here, but we'll get to that in a second. What we're going to do now is go ahead and assume that our board is a list that looks something like this. The board is going to be a list from 0 to 10, and it's going to have corresponding strings. So we'll ignore the 0 index, so don't worry about that. But it's going to look something like this, where each of these indexes matches up with some sort of position. So if I do something like this, blah, 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 all the way on, what we're going to do is have a board that looks something like that. So I'm going to go ahead, and there's a lot of print statements here. So I'm going to copy them from the solution notebook, which you can do as well. And then I'm just going to go ahead and call this and explain what it looks like. I'm going to go ahead and make a board. I'm going to say it's X, so we're just going to have all X's, and let's multiply this by 10 and say display board, call in the board. Let's go ahead and see what that looks like. Alright, so now we have a board full of X's, and I can edit this list so that I have zeros in there too, or O's I should say. So I can do something like X, X, then let's have copy paste this. Let's do O's. And if you notice, I get my list index out of range because I need to have one more there. The reason for that is because we're using 1 through 9 so that the numbers correspond with a number pad. So if you notice up here, I'm indexing 9. And that's because we're always just going to ignore the 0 index. So this can actually be pretty much anything you want it to be. It's just always going to get ignored for this particular displaying of the board. That way, if you notice here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks and it matches up with the numbers of a number pad. So that's the function display board. Let's go ahead and break it down one more time. Just zoom in what's really going on here. We're printing a line. That's the top of the tic-tac-toe board. Here is where we're actually taking the string values from that list and then adding empty strings plus those vertical dash marks in order to construct the board. Okay, so that's our display board function. Again, we're just taking in a board. We're assuming that it already has 1 to 9 correspondence with some sort of number pad. And then we're just printing out the values so that we get something that looks like this. You can choose however you want to display the board itself as far as dashes or lines, but this is the basic premise of what this function and step was trying to get you to do. Okay, so we've done that. Let's go ahead and go on to the next one. Next one is write a function that can take in a player input and assign their marker as X or O. What we want to do is think about using while loops to continually ask until you get a correct answer. Alright, I encourage you, again, to pause the video now and see if you can solve this on your own. Alright, let's go ahead and get started. I'm going to say marker equal to just an empty string. That way I actually define my variable inside this function called marker. And what I'm going to say is while not marker equal to either an O or marker equal to an X, I'm going to ask for the user's input. So I'm going to say marker is equal to raw_input. And for this input function, it's going to be raw_input for Python 2, just input for Python 3. I can say whatever I want the actual line to be. So I can say player 1, do you want to be X or O? Question mark. And what I'm going to do is then call upper on it to automatically uppercase it so that it matches with uppercase O or uppercase X. And then I'm going to say if the marker is equal to uppercase X, I'm going to return a tuple in this case. Again, you have some flexibility on what you want to return. The way I've constructed this is so that it returns a tuple. So I can later on use something called tuple unpacking, which I'll show you much later on in this solution. But this is basically assigning player 1 and player 2, or the reverse, player 1 and player 2, based on that tuple position index. Let's go ahead and explore this function, make sure it makes sense to us. Alright, so I call player input, and I'm just going to run this. And then I see a little, you see it has an asterisk here, that means it's running, but that actually means because I have input, it's waiting for an input. So we get this little dialog, it says player 1, do you want to be X or O? So that's coming from this string here in raw input. And I'm going to say X, and then you notice it just returned X and O as their output. So that makes sense. Let's go ahead and run this again, type in O. Notice how whether I put a lowercase o or if I put an uppercase O, it still works because I called upper here. Let's go ahead and check, what if I put in the wrong type of value? If I put in a 2. You'll notice because it says while not the marker is equal to O or X, it's just going to keep asking for this raw input. So that's a great way to use a while loop to keep asking if you get the wrong type of inputs. And then once I actually put in a correct one, it returns the correct tuple assignment there. You'll see later on why we actually return tuples in our function. Alright, so that's it for player input. Let's go ahead and move on to step 3. But before we do, just let me break this down one more time. We're setting a variable called marker as an empty string. It's just, there's no space there. Then we're saying while not marker is equal to O or X, which is the reason we set it as an empty string. So we don't set it beforehand as O or X, otherwise this while not loop would never execute. We say raw input, player 1, do you want to be X or O? So if I just take this line, just to make sure you guys understand what raw input is doing, it's just going to, if I just say answer equal to raw input and run this cell, say player, do you want to be X or O? And I put in some value here and click enter. Then if I check what my answer is, it just sets it equal to a string version of whatever you put in. What's nice about this though, using raw input in Python 2, if I put in a 2 and click enter, it'll automatically still keep it as a string. So just keep that in mind. Again, if you're using Python 3, this should be input. Python 2, this should be raw_input. So that's all that function's doing. And then upper, just to remind ourselves, if I have something like hello and call upper on it, it will just uppercase everything. Alright, that's it for our player input function. Step 3 was to write a function that takes in the board list object, a marker X or O, a desired position numbers 1 through 9, and assigns it to the board. All right, this was actually really easy, even though it was difficult to describe what's actually going on. But all we should have done for this is say board at that position and set it equal to marker. You're just assigning that index position on the board list to that particular marker value. So that's all we had to do there. All right. Step 4 was to write a function that takes in a board and a mark, X or O, and then checks to see if that mark has 1. This one's a little bit more complicated. And it's a simple idea, but it just takes up a lot of typing. So what you have to think about is how can you write a function that takes in a board and a mark, X or O, and then checks to see if that mark has 1. All right, go ahead and pause the video, see if you can figure this out on your own. Okay, so what we're going to do here is how can I win? Think of how I can win at tic-tac-toe. Either everything across the top matches, across the middle, across the bottom, diagonals, and then up and downs. So what I can do here is show you an example of what one of these would look like. I essentially want to do this. I take in that board list and a mark, and I want to check, let's say I just wanted to check across the top if they all matched up. Then I could say this, return board value at 7 equals that mark, and board value at 8 is equal to that mark, and board value at 9 is equal to that mark. And this would check if everything in the top row was the same. This would then check if the top left corner at 7 was equal to the mark, if the top middle was equal to the mark, and if the top right was equal to the mark. So that's checking across the top. So what we're going to do is keep doing these checks for every single possible win that you could do. And I'm just going to go ahead and copy this from the solution notebook because it's quite a few checks. There's a couple of ways that you can be more clever and get around this. I just went ahead and copied this here. But really, there's going to be a lot of typing here. And you can see here how we're checking it. And this one's also a diagonal check. All right, so we're using parentheses to make sure we mark everything, and then we're using the keywords or and to check everything. So each of these in parentheses is its own separate check, and then we're saying or to keep checking every other version of 3 matching in a line. And then we're just taking advantage of indexing here across our board to check for the wins. All right, and that's going to be down the left side. So that's step 4. What we're going to do is go ahead and stop the video here. Coming up next in the next video, we'll go through step 5, step 6, step 7, step 8, and we'll see if we can get to step 9 and step 10 in a reasonable time. Otherwise, we'll do a third video for that. But just to review what we've done so far, we went ahead, learned about from future print function, learned about raw input and input for Python 2 versus Python 3. We discovered how we could display the board, learned about clear output for Jupyter Notebook. We understood now how we can display a board and print it out in Python. Then we wrote a function that would ask the player for input and then assign a marker and then return tuples in our case. This you could do in various ways depending how your final logic game structure is going to be. Here we wrote a function that takes in the board, the marker, and a position, and then just uses list indexing to assign that marker at that position of the board. And then we wrote a function that takes in the board, a mark, X or O, and then checks to see if that mark has 1, which we can do like this by checking each possible combination across top, middle, bottom, etc. Okay, with that being said, thanks everyone. Hopefully these steps aren't too hard for you, but I do hope that this walkthrough guide does help you and that you find this video helpful. Again, in the next video, what we're going to do is going over the next couple of functions. Thanks, and I'll see you at the next lecture. Hello, everyone. Welcome to the Part 2 lecture video for the Milestone Project 1 walkthrough solution through all the steps in that workbook. So in the last video lecture, we went ahead and went over step 1, display board function, step 2, the player input function, step 3, the place marker function, step 4, that win check function, and then step 5, which is writing a function to use the random module to randomly decide which player goes first. Let's go ahead and now begin that task. I'm going to zoom in just a little more so it's a little more clear. So as I mentioned, you may want to look up random.randint. Let's go ahead and see what that does. If I wanted to find out more about this function, I could just do Shift-Tab with my cursor inside the parentheses, and then I get the document string, also known as a doc string, and it says return a random integer in range a, b, including both endpoints. Okay, great. Since I'm only going to have 2 players, then what I'm going to say is if random.randint, and I'll just say 0, 1, is equal to 0, since it's including both endpoints, the only 2 integers available are 0 and 1, so it's basically a coin flip here. I'll say return player 1. Else, I'll say return player 2. And that's all we're going to do for that particular function. And if I just go ahead and say print choose first, in that case it was player 1, in that case it was player 2 again, player 2 again, player 1. So that makes sense, right? It's basically a coin flip for who's going first. Okay, the next function we're going to do, it's actually quite simple. It's just write a function that returns a Boolean indicating whether a space on the board is freely available. I can actually do that really simply. I can say board at position double equal sign, check if it's a string, and then just return this. So this will return a Boolean saying, okay, is the board at that position, that indexed, so that number between 1 and 9, is that element equal to a space? Just return true or false. So it'll return true if it is equal to a space, false if it's not. All right, step 7 is write a function that checks if the board is full and returns a Boolean value. I'm actually going to take advantage of space check to do this. So I'll do the following. I'll say for I in range 1 to 10, I got to do 10 because it goes up to but not including 10, and I want the numbers 1 through 9 here. I'll say if space check, then I'll say board at that position index. So I'm checking for all the numbers here. If that ever comes up as true, meaning there is an empty space, I'm going to return false here because the board isn't full yet. Otherwise, I'm just going to return true. And the reason I don't put an else statement here is because I want to actually run through each of the possibilities here. So basically what's going to happen here at full board check is I'm saying for I in range 1 through 10, which is just in this case going through the numbers 1 through 9, if the board at that index, if space check ever equals true, meaning there was a space there, I'm going to return false because that wasn't a full board. If I go through this entire for loop and I never return false, then I'm just going to return true because I know now the board is full. And that's why we don't use an else there. All right, it's time to go to step 8. Step 8 is write a function that asks for a player's next position as a number between 1 and 9, and then uses the function from step 6 to check if it's a free position. If it is, then return the position for later use. Okay, let's go ahead and think about how we can do this. I'm going to go ahead and make a variable called position and set it equal to an empty string. And what I'm going to do is I'll say while position, I'm just going to put a dot 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 for a second there to show you what I'm going to actually do. I'm going to say raw input. I'm going to ask the player to choose your next position. 1 through 9. And then what I want to do is continually ask this person or player to choose the next position until it's a valid topic. So I'm going to say while position is not in, And this is where we're going to do a little trick here. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Dot split. Let me show you what that's actually going to do. That's going to take that string and it's going to split it into a list. So what split does, it's just a method on that string, and it automatically splits on empty spaces, in this case, in between the numbers, and then returns a list. Okay, so we have that. So that's going to check if the raw input is actually there, or one of these string numbers. And then I'm going to say or not space check. And in this case, what I'm going to do is I want to make sure the number isn't already taken. So I'll say space check, board, and then cast that string into an integer by using int. And let's go ahead and put a colon there. So what I'm doing is, let's just read this along. I'm saying while position not in this list, meaning the player hasn't actually put the right number in it. Maybe they put in a different number, or they put in the wrong string. They just said hello when you asked them, choose your next position, etc. Or we'll do a space check on that position casted as an integer, meaning the space is taken. I'm going to say, please choose your next position. Basically, I'm going to keep asking this person for the next position over and over again until they give me a value that makes sense. And then once they do, I'm just going to return that value position as an integer so I can use it later on. Okay. Step 9 is to write a function that asks the player if they want to play again and returns a Boolean true if they do want to play again. So I'm just going to say return, because I'm using Python 2, I'll use raw input. Python 3 users should use just input. I'll say, do you want to play again? Question mark. Enter yes or no. And you could have a couple of if statements here, checking if string is equal to yes, or while string equals no, etc. In this case, I'm just going to kind of do a little trick here. I'll say dot lower, and I'll say dot starts with y. And that's basically what it's going to do is I'm going to go ahead and run that and then show you something. So let's say I have a string here that's just hello. This is a little bit of information from the advanced strings lecture, which is why I'm going to go over that starts with. There's tons of methods you can do on a string. But if I just wanted hello, I can ask starts. Well, let me set this as a variable, my string, just so it's really clear. So my string is hello, and then I can say my underscore string. And if I put in tab, that gives me all the methods available on this. There's one called starts with. And if you're interested in more of these methods, you can check out the advanced strings lecture. But starts with, we'll just go ahead, and if I click shift tab, it'll say return true if that string s starts with the specified prefix, false otherwise. So if I just put in h, it returns true. And then if I turn for something like n, it returns false. So in this case, I expect the user to say something like yes, but maybe they put uppercase or lowercase yes, or they say like yeah or yup kind of thing. So even if they just say yup, if I say starts with dot y, it'll say true. And if I say lower first, and then I say starts with, now I don't even have to worry if they say like yup, something like this with a capital, because I've already lowered cased it. And I could do the same thing if I just said something like upper and then only checked for uppercase wise. So that's what's going on with these lines right here. And it'll make more sense when we actually implement step 10, which is the hard part. We're going to use a bunch of while loops and the functions we've just made to run the actual game. All right, since this is quite a bit of code for this block, I'm going to leave that for the next video. As a quick review of what we did in this video, we went ahead, made a function that randomly chooses which player goes first. We wrote a function that returns a Boolean indicating whether a space on the board is freely available. We wrote a function that checks if the board is full and then returns a Boolean value. And then we also wrote a function that asks for a player's next position and then uses that space check function to check if it's a free position, and then we return it for later use. And then step 9, we just wrote a function that asks the player if they want to play again and returns a Boolean true if they do want to play again. Alright, so for step 10, we'll do that in the next lecture, but basically we'll take everything we've just done, all the functions we've just made, and use a bunch of while loops to actually run a tic-tac-toe game. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the final lecture on the Milestone Project 1 walkthrough solution. So we've gone over all the steps and created all the functions we need. What we're going to do now is put it all together and use while loops and the functions we've made to actually run a game. Let's go ahead and just clear this. First thing we're going to say is just print welcome to tic-tac-toe. Then we're going to say while true so that we continually run the game until something goes false. So I'm going to go ahead and reset the board. So I'll make a variable called the board, and I'm going to make it just 10 empty spaces here. And then I'm going to use player input. If we just go back real quick to player input so we can remember what it looks like, remember it returns a tuple of x and O or O and X, depending on what the player 1 chose. So in that case, I'm going to say player 1 underscore marker and player 2 underscore marker is equal to player underscore input. And this is using tuple unpacking to basically make player 1 marker and player 2 marker the outputs of that player input function. And then I'm going to say turn variable is equal to choose first. So that's going to be a variable we can say, remember choose first returns a string. So if we go back up, make sure we understand that. Choose first either returns player 1 or player 2. So we're going to do some checks to see if turn equals player 1, if turn equals player 2, etc. And then I'm going to say print turn, which is a string, plus another string will go first. So depending on this random, I'll say, oh, player 1 will go first or player 2 will go first. And then I'm going to make one more variable called gameOn, and I'll set it equal to true. And I will make gameOn false if the game ever is a tie or somebody's won. Now I'm going to make another while loop, and I'll say while game on if turn is equal to player 1, so remember it's player's 1 turn right now, I'm going to say display board, and I'm just going to pass in the board itself. Remember the board is just this empty list here. So display board, pass in the board, and then I'm going to say position is equal to player choice on the board. And then I'm going to say place marker function, and I will pass in the board, player 1's marker, and the position. Alright, so what are we doing so far? I'm saying while the game is still on, I set it as true right now. If it's player's 1 turn, display the board, so print it out. Set the position equal to the player choice, so I'm going to ask the player what position they want to do. And remember, if we look back to player choice, I continually ask until I get something that makes sense using space check and other functions that split on the list. And then I'm going to say place marker on the board, player 1's marker at the position. Where player 1's marker, remember, comes from player input, so we know it's either X or O. Alright, then once we put the marker on the board, I want to check if somebody's won. So I will say if win check the board and player 1 marker. I'm just using tab there. I'm going to say display underscore board. I'll show the board. And then I will print, let's just print congratulations. Player 1 has won the game. So if that win check ends up being true, player 1's won the game, and I'm going to say game on now is equal to false. Because if somebody's won, then the game is no longer on, so this entire while loop will collapse. Otherwise, I'll say else. We also want to check if there's a tie. So I'll say if full board check, given the board, display board, the board, and then I'm going to go ahead and print the game is a draw. And I will go ahead and just break out if the game is a draw. Else, so else means nobody won, the game is in a draw, so I set turn equal to player 2. And just remember that these strings need to be exactly the same as the strings you output for the random choice function, which if we look up is right here. So those strings need to be exactly the same as these on the choose first. Otherwise you'll get errors. Okay, so we just did player 1's entire turn. Player 2's turn, player's 2 turn, is going to look pretty much almost exactly the same. So again, we're just going to, we can actually just copy and paste this and then do the appropriate changes. So in this case, I have display the board, that's going to stay the same. Position, again, I'm going to ask the player for his choice. And in this case, when I say place marker, I'm going to place player 2 marker, which again I got from player input. And I'm going to put it at the position that they chose. After that, I'm going to do again a really similar thing. I'm just going to say check for wins and check for ties. So can you just copy and paste that and do the appropriate changes. Instead of player 1 marker, I'm just going to do player 2 marker. And instead of congratulating player 1, in case if player 2 wins, I will congratulate player 2. And again, I set game on equal to false. And here, if the game has not yet been won or is not a draw yet, I set turn equal to player 1. And then since the game is still on, we come back here to this if loop. Again, we ask for position, check if there's a win, check if there's a tie. If not, turn becomes player 2, meaning if we come back here, it's no longer player 1, so we go to else here. This could also be if turn equals player 2, but in this case, since there's only 2 players, we just have an else. And now the only thing left to do is ask for that replay, which should line up with this while loop up here. So let's go ahead and zoom out a bit so we can get the whole picture. So I'm going to say while game on, if turn player 1, else, and now I'm just going to say if not replay, because remember replay just asks if they want to replay again, I will break out of this while loop, the true one. Okay, so let's actually try and play this out. I'm going to say cell run all, just to make sure all the functions and the cells defined below or above this have taken into place. Let's make sure it all works out. I'm going to say X, choose your next position, 1 through 9. And just a quick note, sometimes in the Jupyter notebooks, inputs will hop from top to bottom depending on the print order. It should hop back to the bottom in just a second if I choose 1 here. And it did. Okay. Let's choose O's position. We'll put him in the center. So 1, 2, 3, 4, 5. And X is going to go, let's say, top corner. 1, 2, 3, 4, 5, 6, 7. O, we'll try to block that there. So choose next position. We'll say 1, 2, 3, 4 for O. Let's say X goes to, this has to block that one actually. 1, 2, 3, 4, 5, 6. And O will now, let's say, put top. So that's going to be 8. Then X needs to block that one, so that's 2. Looks like we're going to have a tie game here. We'll make it tied and we'll check out the wins. So we'll put that one at 9. Actually, let's check the win first. So right now we're going to force this to be a win, 1, 2, 3. Let's see what happens. So we say, congratulations, player 1 has won the game. Do you want to play again? Enter yes or no. remember, we could say, yeah, click enter, and we will play again. Because remember how we implemented this replay again, it just checked that first letter and then lowercased it and checked if it equals lowercase y. So do I want to be X or O? I'm going to go ahead and be O. It's going to say choose your next position. Let's make sure our while loop is working. So if we scroll back up, remember for checking next position, we had to check whether it was an actual number, and we also had to check whether the board was clear there. So I'm going to try to mess this up. I'm going to say hello, and you notice it's just going to keep asking me until it can set the actual position. So if I say 34, that's also no good. If I say false, that's also no good. If I say print, I don't know, this might really break it. Print hello, nope, that won't break it. Now if I click 1, that's good to go. So now I'm going to choose X's position. Again, if I try to say something else, it's not going to work. If I try to choose a position that's already taken, it's also not going to work. It's going to keep asking me until I actually put in the correct values. So let's go ahead and try to get a tie here now. 0x, 0x, 0x. So hopefully I don't screw this up. Okay. And X should go at 9 to block that. And then finally, the only one left is 7. So, oh crap. Looks like 0, 1. I just want to make sure that our game is a draw check is all working out. So let's try this one more time. I guess I'm just too good at tic-tac-toe against myself. Do I want to play again? Yes, I do. Do I want to be X or O? Let's do X. Okay. 1. So it looks like player 2 is going first. 3. Okay, so where should, I'm on X right now. X should go on 9. Make sure to block them there. Okay, and then O should go at 8. Make sure to block them there. And now X, it doesn't matter where they'll go, so I'll put them at 4. And then O is going to go at 7, since that's the only space left. And it looks like we successfully checked that the game is a draw. Do I want to play again? Let's check to make sure if I put in no. Basically anything that didn't start with yes would have broken that loop. Okay, that's it for the game. Let's go ahead and just really make sure we understand each and every step of the full game by zooming in on it. So I print welcome to tic-tac-toe. I have my while loop true, so that's going to keep running until all the way down here I break if not replay, so if they decide not to replay. I create an empty board using a list. I use the player input function to set my player 1 marker and my player 2 marker. I use tuple unpacking in order to do that. I set a variable called turn equal to choose first that randomly returns either player 1 string or player 2 string. Then I print blank will go first. So either player 1 or player 2 will go first. I create a variable called game on, which is true or false. Then I say while game on, meaning the game has begun, it's on. If the turn equals player 1, I show the board, ask for the position, and then place the marker at that position based off of player 1 marker for the player 1 loop. Once I place the marker, I want to check if that person's won or if there's a tie. So I display the board. If there's a win check, if that ends up being true, I display the board and say congratulations, player has won, and then I set the game on as false. The game's over. Else, I say if full board check, display the board, print the game is a draw, and I break. Otherwise, I set the turn equal to player 2, which is the reason why I don't say game on equals false here, because I also want that else turn player 2. Very similar thing for player 2, except now it's player 2 markers across. Once a break has happened or the game on has been equal to false, then it will say, do you want to replay? And that's all there is to the tic-tac-toe game. All right, so again, make sure you walk through each of these steps, understand the functions, and then really understand how everything's working together. But that's it. Congratulations on completing your first milestone project, and I will see you at the next lecture. Thanks, everyone.
Hello everyone, and welcome to your lecture on object-oriented programming. Now, object-oriented programming, or otherwise known as OOP, tends to be one of the major obstacles for beginners when they're first starting to learn Python. So there's many tutorials and lessons covering OOP, so feel free to Google search other lessons And I've also put some links to other useful tutorials at the bottom of the Jupyter Notebook. If we scroll down here, there's 4 really nice other great resources on object-oriented programming to serve as extra learning material for you as you learn about object-oriented programming. So for this lesson, we're going to construct our knowledge of OOP by building on the following topics. We're going to start by learning about objects themselves and remembering what it means to be an object. Then we'll learn about using the class keyword. Then we'll create class attributes. We'll create methods within a class. We'll learn about inheritance. And then we'll learn about special methods for classes. We're going to take this very slowly and methodically, and most likely this object-oriented programming lecture will be broken up into smaller chunks so they're easier to digest, if you will. Okay, so we're going to start by remembering about basic Python objects. And before we begin with the live coding, I actually really encourage you to just go ahead and read through the entire Jupyter Notebook here before you actually see this video, just so you at least see everything once before jumping into the live code. Now, go ahead and after you're done reading this notebook, because there's actually a lot of text here for you to read that'll help your understanding, which I'm going to explain right now throughout the video lecture, but it's nice that you've at least seen it once before. Okay, let's go ahead and hop over to the actual coding now. So let's start the lesson by remembering about basic Python objects. So for example, let's make a list. Remember list, just use brackets. There we have our list. And remember how we could call methods on a list. So we have our object, L, which is a list, and I can call various methods on it. So I could say count how many times 2 shows up. And what we're basically going to be doing in this lecture is exploring how we could create an object type like a list. So we've learned about how to create functions, such as remember square, where you return that num to the power of 2. So we've learned about how to create functions, but you can imagine what would happen if you wanted to create an object like a list. Like how would you actually code that in Python? And that's where object-oriented programming is going to come into place. So in Python, let's go ahead and start learning about objects. So in Python, everything is an object. And remember this from previous lectures, we can use the type function to check the type of object something is. So for instance, I have an integer 1. And if I use the type function on that, it'll tell me what type of object it is. It's an int object. That's its object type. What if I wanted to check the type for this list that I just made, which is 1, 2, 3. It's a type list, so that's the type of object it is. And let's just really drive the point home. Let's go ahead and make a tuple. 1, 2. It's a tuple. Let's go ahead and make a dictionary. Say K1, 1. Tells you type is dict. Okay, so now we know that everything in Python is an object, and we can actually use type to check the type of object something is. So we know all these things are objects, so how do we create our own object types? And that's where the class keyword comes in. So we'll be using the class keyword in order to create our own object types. Okay, so I'm actually going to stop this first part of the lecture here. Make sure you read through this entire Jupyter Notebook before continuing on with the other lectures in the object-oriented programming series or section of the course. And keep in mind that in Python, everything is an object. And to drive that point home, I will show one more example of everything being an object. So remember we could create functions, square, again, return num to the power of 2. So even that square function in Python, it is an object itself. And what type of object it is? It's a function object. So keep in mind that everything in Python is an object. And now we're going to learn how to use the class keyword to create our own objects. And object-oriented programming in Python is going to be highly dependent on that class keyword. Okay, so make sure you read this entire Jupyter Notebook before continuing on, and then you'll come in fully prepped for the upcoming videos. Okay, and just a quick reminder, there's also at the bottom of this Jupyter Notebook 4 other great resources on object-oriented programming. And the reason I'm stressing so much that you read this and take your time with it is that a lot of people get stuck on object-oriented programming when they're first learning about Python. And it's a bit of a learning curve, but once you get it, you'll feel that it suddenly clicks and you understand why you're using object-oriented programming. Okay, so in the next video, we'll explain about class. Hello everyone, and welcome to part 2 in the object-oriented programming video series. So in the last lecture, we learned about objects and how everything in Python is an object, and you can check the object type using the type function. So now we want to know, how do we make our own objects in Python? And that's where the class keyword is going to come into play. So user-defined objects are created using this class keyword, and you can think of class as almost like a blueprint that defines the nature of a future object. And then from these classes, we can construct instances. And an instance is going to be a specific object created from a particular class. So if you remember in this above example here in the Jupyter notebook, we created a list called 𝗓, and so 𝗓 was an instance of a list object. So let's go ahead and hop over to the live coding to create a very simple example of a class. So we put the class keyword, and then whatever your name of the class you want to be. So in this case, we're going to have a sample be the name of our class. And by convention, class names are capitalized, unlike function names which are lowercase. And then we pass in this parameter object. And I'll explain that in a later lecture because that actually has to do with how Python was developed to begin with. But for right now, just remember, whenever you're making a class, you have the keyword class, the name of the class, and then you type in object as a parameter that you pass through. And this, as far as this white space syntax, this should look pretty familiar and similar to functions. And then all we're going to do for class is just pass. Okay, and that's our very first class. So let's go ahead and make an instance of our sample class by calling sample. And there you have it. And so now X is, if we check its type, whoops, its type is main sample, which basically tells you that it's a sample class type. So like I said, by convention we give classes a name that starts with a capital letter, and now right here we have X, which is a reference to a new instance of a sample class. In other words, we instantiate the sample class. Inside the class we currently have pass, but what we're going to do now is define attributes and methods. So if we hop back over to the Jupyter notebook, there's two things we can do within a class. Put in an attribute and put in a method. An attribute is a characteristic of an object, and a method is an operation we can perform with the object. So we've already seen methods, and we've actually already dealt with attributes, you just didn't know it yet. And to show this, we're going to create an example class called dog. So for instance, an attribute of a dog may be its breed or its name, while a method of a dog may be defined by like a bark method, which returns some sort of printed sound out. Okay, so let's go ahead and get a better understanding of attributes through an example. And the syntax for attributes is going to look a little something like this. It's going to be self dot the name of the attribute, and then you set it equal to something. And there's a special method called init underscore underscore init underscore underscore parentheses, and that's going to allow us to basically initialize or instantiate the attributes of an object. So the syntax is going to look like this, what I have here in the cell, and I'm going to go ahead and live code it and break it down for you. So let's go ahead and create a dog class. So I start with my class keyword, capital letter, dog, and then I pass in object. Basically, you can think of that as Python telling it, oh, you're making an object. That's not exactly what's happening there. It's a little more complex than that. But for right now, you can just think of it that way. And now we start with a method. And when you put a function inside of a class, you refer to them as methods. And this underscore underscore init is known as a special method. And that's because it's going to initialize the attributes of a class. And every single method within a class is going to have the word self in it. SELF, self. And something I want you to keep in mind is we've already used the term method before. You can remember when we had lists, we had methods such as count, like we saw in the last lecture. So what's basically happening right now is you're making methods for your own object that you're creating. Now this underscore underscore init underscore underscore is what's known as a special method, and it's going to allow us to put in attributes for our class. So right now I'm going to create this class, dog, take an object, and I create this first method, and what I'm going to do is create an attribute called breed for the dog. Self.breed, and I'm going to set it equal to breed. Go ahead and run that, and then create an instance of dog with the breed equal to lab. And now if I check what Sam is, main dog, great. So now let's fully break down what we just did above. So we start with class, the name of the class, and then we input object. After that, we start constructing our methods, which basically look like functions, but since they're within a class, we call them methods. And we have this special method, this underscore underscore init underscore underscore, and it's called automatically right after the object has been created. So remember, this will always be your first method when you're creating your classes. And as you create classes, you'll see why. So each method in the class definition begins with a reference to the instance object. And what that means is you always start with this self reference. That's by convention that you use that self keyword. It actually doesn't have to be self, but it's never not self. So always use self as the first argument for these methods. That basically tells you, hey, this method within your class is referencing dog first. Okay. And then when continuing off of that, each method in the class definition begins with a reference to the instance object. And like we said, by convention, that's self. So in this case, breed is the argument, and the value is passed during class instantiation. So we say self.breed equals breed. So when I'm creating that instance of the dog class, I can't just do dog, because in it needs an argument. And notice how it says it takes exactly 2 arguments, only 1 was given. But you might be thinking, hey, I actually gave it zero arguments. Well, that's not true, because self by default is given there because it lets that method know you're referencing that dog object. So then we say breed is equal to whatever you want it to be. And notice we're actually not checking that breed is a particular type of object. I could actually just pass a list there or a number, but here it makes sense that I want a breed. So let's go ahead and do another breed. Another breed of dog we can do is like a husky. So now Sam is an instance of this dog object type, and its breed, that attribute, is equal to husky. And it's referencing that attribute with the self.breed. And it's going to be equal to whatever you put in as breed there. Okay, so let's go ahead and make that Sam equal to dog. So this object label, Sam, references that dog object. And now, and this is why I stressed methods so much earlier in the course, so you can kind of draw the parallel here. I just did tab completes, and if I call breed on Sam, it returns husky. And notice how I'm not putting parentheses like we saw in some other methods. That's because this is an attribute of the object, not a method on the object. This init, or this def, and then whatever keywords you see here, those will be methods. But right now, self.breed is an attribute of the dog object. Okay. So in Python, there's also class object attributes, and those class object attributes are the same for any instance of the class. So I'll show you what I mean by that by creating a new class object attribute. So I'm going to place it right before any methods, class, object, attribute, and I'm going to make something called species mammal. Whoops. Okay, so notice right now I'm not saying self.species, I'm saying just species. And that's because if I put this outside and before this init method, it's going to treat it as what's called a class object attribute. And that means no matter what kind of dog object we make, its species is always going to be mammal, which makes sense, right? No matter what the breed of a dog is, it's always going to be a mammal. So if we go ahead and run that cell, now we have Sam, the dog. Its breed is still husky, but you'll notice now if I put tab here, it also has a species attached to it, and it's mammal. And that's what's known as a class object attribute. So now let's create some more attributes for this dog. So what else can a dog have? A dog can have a name. So then I'll pass a name when I start making the dog, and I'll say, okay, self.name is equal to whatever name I pass for that dog. So now if you notice, if I only pass husky, I'll get an error, because now it takes 3 arguments and only 2 are given, self and breed. So now I'll put a name for my dog, and I'll name it the same label I was using. I'll name it, I'll name it Sammy. There you go. And now Sam, which is a dog object, is also going to have a name, Sammy, that string that's attached to it. Okay, and what I want you to again note is that the class object attribute, that species equals mammal, is defined outside of any methods in the class. And by convention, you always place them first before this init method. Okay, so I know we kind of went over a lot, and this is actually the end of this part 2 of object-oriented programming, the class keyword. So let's really break down everything that we just did. I'll hop back over to the completed Jupyter Notebook to make sure we understand what we did. So remember, when we want to create a new object type, we use the class keyword, we space, then we capitalize whatever we want the name of the class to be, and we pass an object as a parameter or an argument there, colon, and in this case we just did pass the simplest class or object type you can have. And then when you create an instance of it, you call the class, no arguments, and you can check its type and check that it's part of the class, that main sample. Okay, so that's how we create classes. And remember, classes can basically have attributes and methods. So we've already seen the ways we can create attributes. And there's a special method which we'll always do when we're creating a class called __init__. And that's going to allow us to initialize the attributes of the object. So it's always going to be first as far as your first method. Now we also saw class object attributes, such as the species here, and those come first if you decide to have them even before that init method. They're not always necessary, but if you do decide to have these class object attributes, then you will use them. Okay, so moving back up here, we say def, so it basically follows all the same syntax as a function, and you can almost think of it as a function, except that since it's inside a class, it's called a method, because it's a method on that class object. __init, we pass in self, and then you start passing in whatever you want the attributes to be. So we saw breed in this particular example, and then back here we also passed in name. And just to drive the point home a little further, maybe I say fur, and I can have fur be a Boolean or something. Maybe I always say, okay, in most cases dogs have fur, so I can actually set these just like we did for functions. I can set default argument. So I'll say self.fur is then equal to fur. And by default, fur is actually always equal to true. So that means when I run this, I actually don't have to pass it. And if I check if my dog has fur, you'll notice it equals true. Now I could have passed fur equals to false. Let's say for some reason this dog didn't have fur, and now fur is equal to false. So as far as the syntax and convention here, this should feel very similar to functions. The main difference being this self, the fact that you're creating attributes off of these input arguments. And the reason we're using self here instead of just like breed equals breed is because due to scope, Python needs to know, hey, are you actually referencing some global variable breed, or do you want me to set this dog's object attribute self.breed equal to that breed input? Okay, so I encourage you to play around with this particular class right here, this dog. Make up at least one or two more attributes. Make sure you fully understand, and I also want you to set a new class object attribute that would be true for all dogs. Okay, so make sure you fully understand how we set attributes using this special method, this init method. And coming up next, we'll look into methods more broadly, just as functions defined within the body of a class. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the third video in the object-oriented programming section of this course. And in this course, we're going to dive deeper into methods. So I've used that term methods, and you can think of it as basically when you're constructing those function syntaxes within that class, that DEF. And to put it more formally, you can think of methods not just as functions defined inside the body class, but they're used to perform operations with the attributes of our objects. And methods are used in the encapsulation concept of the object-oriented programming paradigm. And encapsulation basically allows you to divide responsibilities in programming, and it allows you to handle really large applications. So for the most part, you can basically think of methods as functions acting on the object that take the object itself into account through that self argument. So what we're going to do now is create a circle class or a circle object using the class keyword. And we're going to be using a ton of methods, and this should really drive home a lot of what we've been learning about as far as objects, methods, and instantiation. So I'm going to create a class called circle, capital C. I pass in the object as a keyword, and now I put pass. So we have our really basic circle class. So what do I want to do first? If you remember from the last video, we had class object attributes. And that was the species class object attribute for that dog class. So remember, all dogs are mammals, so we would put that first. So here, I'm going to put any, remember, class object attributes. So something that's true for any instance of the class. So what's true for circles? Well, for circles, in general, we know pi is always a constant, right? And so I'm going to put as a class object attribute, pi is equal to 3.14. And I'm going to actually embed that into the circle class. Now, it doesn't make a whole lot of sense that pi is part of the circle, but it's nice that we can have it as an instance of this class object attribute to show that it's the same no matter what kind of circle or how large of a circle you're building. So I've rounded it off to the 0.14 two decimal places. And now what I'm going to do is get started with, remember, our special method, the first one, this __init, this initiation method. Remember, I always put in self whenever I'm putting a method inside a class. And let's just say pass here. And let's go ahead and make a circle called C. Okay, so we have our circle, super simple. So what do we want to add to this circle? Well, we know circles have a radius, right? Now a radius would be an attribute of a circle. So I'm going to put in radius, and by default I'll set the radius equal to 1. So in case I don't pass a radius, it'll automatically set that to 1. So now I'll say self.radius, the attribute of the circle, is equal to radius. Okay, so now if I have my circle, I just ran all 3 of these cells. If I put tab, I can ask for pi from the circle, and it'll always give me back 3.14, no matter how big the circle is. And now I can also ask for tab radius, and the radius of this circle is 1. Now I could have made another circle with a radius of whatever I wanted, maybe 100. And note now when I run that cell and I ask for the radius, it gives me 100. But when I ask for pi, still, since it's a class object attribute defined outside of any of these methods so far, it's going to be the same no matter what other attributes the object has. Okay, so now let's start another method. So again, methods are basically functions within an object that have a reference to the object itself. So let's make a method that calculates the area of a circle. So I'll call this def area, and I always pass in the self arguments. And so what is the area of a circle? Well, the area of a circle will be, and I'm going to put in comments here, it's going to be the radius squared, right? Multiplied, I'll put an asterisk here, by pi, right? Pi r squared is the radius of a circle. Or excuse me, is the area of a circle. So if I ask for the area of my circle object, I'm going to want to return radius squared times pi. But remember, radius isn't clear enough for Python here. It needs to know which radius, and that's why I'm going to input self.radius. Since radius isn't actually defined anywhere except as a class attribute. So self.radius lets Python know, hey, take the radius or this attribute of this current object. And we can do the same with pi. And now this will work well. And actually, excuse me, for this self, this .pi, remember it's not a normal attribute, it's a class object attribute. So it's actually going to call from circle. So if I run that, create a circle for radius 100, now I can ask for its area, close parentheses since this is a method, not an attribute, and it returns the area for me. Okay, so let's break down what's actually happening here. From the top, I have my class, capitalized circle, pass an object. We have class object attributes. These are referenced for any instance of circle. It'll always have these be true. So circle.pi will always be 3.14. Okay, then I have my init, this special method, which initiates all the attributes of my class. And in this case, I only have one other than self, which is the radius. And then I have a method within my class as well, which looks just like a function. And in this case, it only takes in the self argument. And it's going to be the radius squared times pi. So I'm going to return the self.radius, this attribute, squared, times this class object attribute, which is circle.pi. Okay, perfect. So now let's go ahead and build on top of what we're thinking about. And let's say I wanted to reset the radius. How would I do that? I could make another method. I'll call it set radius. It'll take self as an argument, and it will also take, let's call this new radius as an argument. And what is this going to do? It's going to be a method you can call on your circle, set radius, that takes in an argument, a new radius, and then it will reset its self.radius attribute. And the way we can do that is just by saying self.radius is then equal to that new radius. Okay, so I ran that cell. So now let's make a circle C that has a radius of 10. Let's go ahead and check its area, 314. And now if you notice, I have this set radius. And if I put Shift-Tab, it tells me the type, string form, file. I can actually add a doc string in here, just like I could for a function, and say this method takes in a radius and resets the current radius of the circle. Okay, perfect. Let's go ahead and take that, run that cell, create the circle, check its area again, and now if I click Shift-Tab here, you'll notice I can expand it, get the definition, and see this method, the doc string there that I wrote. Perfect. Okay, so now set radius. What's my current radius? Well, I have C, right? And I can track its attribute. Its current radius is 10. So I'm going to use my new method I just created to set the radius to, let's say, 20. And now, if I check the radius of my circle, it's set to 20. So that's how we're basically building out our own methods for the objects we're able to create. And one more, let's just say we wanted a method for getting radius that was strictly a method, not an attribute. I could just say something like get radius. Remember, all methods within a class have to take self as an argument, and I will just return self.radius. So this is essentially the same as just calling radius, but I just want to make it explicitly a method instead of an attribute. So I'm going to create a circle again, check the area, its radius is 10, and I can also now use getRadius to get the same number out. Notice how radius, since it's an attribute, doesn't have the parentheses, but since getRadius is a method, it does need these parentheses to signify I'm not passing in any arguments. Okay, so I want you to notice how we use the self notation throughout this class to reference attributes of the class within the method calls. And go ahead and review how the code above works by creating your own methods. So what I want you to do is to make sure you fully understand this, is create a new method here called def perimeter. It'll take in self, and I want you to fill in the code here that returns the perimeter of the circle. That will be the method. And then what I also want you to do is, instead of creating a method, see if you'd be able to take perimeter in as an attribute. How would you do that? See if you'd be able to somehow either calculate it or reset it based on what the radius in that class object attribute was. So see if you could say self.perimeter. What would you put in here? Question mark, to make that work. Okay, so I know we just went over a lot, and we're going to go over it just as a basic rundown, but really take your time with this. I know it's hard, and I know it's confusing, but it'll eventually click. So don't worry if you're still a little confused on what's actually going on. So just to cover what we did in this lecture, we went over methods, and generally you can think of methods as just functions defined inside the body of a class that take in a self argument so they know they're referring to the object class. So here we have what's known as a special method, this underscore underscore init underscore underscore. It always takes in self, and then it takes in any parameters you want to initialize that version of your object, in this case circle. Before that, we put in any class object attributes we want, and those are attributes that will be the same for any instance of this circle class or circle object. And then nitty gritty, the methods themselves. Here we created a method called area that just returns the area of the circle based on both an attribute and the class object attribute. Then we created a method called setRadius, and we created a doc string for this one, and it said this method takes in a radius and resets the current radius of the circle. Again, always takes in self, and in this case it took in new radius as an argument, and it just reset the attribute radius to the new radius. Okay, and what I want you to do is go ahead and create a new method for getting the perimeter out, and then I also want you to see how would you do that if you just wanted to do the attribute version, just set perimeter as a straight up attribute since the beginning. Okay, so again, take your time with this, and I'd like to emphasize that at the bottom of this Jupyter notebook, I know I said this in the first lecture of this section, but there's some great resources here. These 4 are very good for continuing your understanding of object-oriented programming, how classes work, and usually you have to see it explained a couple of different ways for it to really click. All right, so that's it for this lecture. In the next lecture, what we're going to be doing is going over inheritance, which is a way to form new classes using classes that have already been defined. Okay, thanks, and I'll see you at the next lecture. Hello, and welcome to part 4 of the object-oriented programming section of this course. So now we're going to learn about inheritance. And inheritance is a way to form new classes using classes that have already been defined. And then these newly formed classes are called derived classes. And the classes that we derive from are called base classes. So you have your base classes, and then you can create derived classes from them. So a lot of important benefits of inheritance is that you're able to use code again and reuse it, and then you can reduce the complexity of your overall program code. Okay, so let's go ahead and break down this idea in the form of a live coding example. So what I'm going to do is incorporate some of our previous work from the dog class. But first, I'm going to create a new class, call it animal. And hopefully you remember the syntax for creating class. You'll use the class keyword, capitalize the name of your class, pass in the object keyword. Okay, so now let's go ahead and create the initialization method, underscore underscore init underscore underscore, pass in self. And now what I'm going to say is just have it simply say print animal created. So note, I am not actually passing in any attributes. It's just going to be a basic print animal created statement there. So that means if I say a is equal to animal, animal created is printed, but notice a, if I click dot tab, it actually has no attributes associated with it. So this is just a super simple example of a class, and you usually wouldn't have print statements like this within your initialization method, but this is just to show you later on how inheritance is actually working. So I'm going to add 2 more methods, one called 𝗓𝗏𝗁, and it's going to take in just self, and it's going to print animal. And again, these print statements are just to show later on how the inheritance is working. And then one more method called eat. Again, all methods within a class always take self as an argument. And then I'm going to print here, print eating. Okay, so here I have my pretty basic animal class. And now I'm going to create or recreate the dog class. But if you notice, I'm not going to pass object. I'm going to pass in or inherit the animal class, that base class. And so the syntax for this, when I initialize it, I'm going to have my init method, going to take in self again. And what's going to happen is I'm actually going to initialize an animal instance by calling the init method with self attached. And then I'm going to say print dog created. And then I'm going to put in 2 more methods called 𝗓𝗏𝗁, in this case for the dog class, self. It's going to print dog. Then one more, I'm going to say def bark. It's going to take in self, and it's going to print, say, woof. Okay, so I had my animal class, and I'm going to zoom out a bit so we can see both of them at the same time, my animal class and my dog class. And let's go ahead and create an instance of the dog class or dog object. So what do we think is actually going to happen when I click this? So let's kind of work backwards here. I have my dog. Remember, it's inheriting from animal. And when I initialize the dog class, I call the initialize method on animal, which prints animal created. But I also print dog created since it's within the dog class. So I should see the printed statements animal created, dog created. And so that's what we get out there. Now what happens if I say D, who am I? Is it going to say dog or is it going to say animal? Well, something to note here is that since I'm calling dog and dog has its own who am I method, that's going to overwrite any instances of the inherited who am I method. So it will say dog. But if you notice, I don't have an eat method within my dog class, but I do have it within my animal class. And since it inherited the animal class when I constructed dog, it will still have the eat method available to it. So I can eat and then it'll print eating. But I can also have additional methods that I only have existent in the dog class. So let's break this down again. In this example, we have two classes, animal and dog. The animal is the base class and the dog is the derived class. And the derived class inherits functionality of the base class. And this is shown primarily through this eat method. And the derived class can modify existing behavior of the base class. So I modified it by overriding using the whoami method within the dog class. Okay, so that's inheritance. So remember, it's a way to form new classes using classes that have already been defined. It's a bit of an advanced topic for a beginner to learn, but it'll help you be able to understand how inheritance works when you're reading someone else's code. And then as you progress more and more and start using classes and object-oriented programming more, you'll be able to see instances where, hey, I'm going to create a class that's very, very similar to another class I just created. I might as well inherit it instead of creating an object again. All right. So lastly, in this series of lectures, we're going to learn about special methods. We've already gone over one special method, this init method, which initializes your attributes and everything that's going on with your class. But we're going to learn about some other special methods. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to part 5 of the object-oriented programming section of this course. And finally, we're going to learn about special methods. So classes in Python can implement certain operations with special method names. And these methods are actually not called directly, but by Python-specific language syntax. So, for example, when we make a list, and I say 1, 2, 3, and I say something like print that list, Python knows what to do with it. And that's because it has a special method. And same thing with like the length of a list. Python knows how to incorporate that. So there's special methods that Python has built in that have to do with specific language syntax when you call either certain things like delete, print, or checking length. And I'll show you what I mean by that through an example. So what we're going to do is create a book class. Remember, I pass an object here. And I'm going to initiate it. And this itself is a special method that's pretty much always used for classes in order to create a class. So I'm going to have 3 attributes for my book. It's going to have a title, it's going to have an author, and it's going to have a number of pages. And so let's go ahead and fill those in. I'm going to say self.title is equal to whatever title the user inputs there. Self.author, that attribute is equal to whatever you pass in as the author, and self.pages is equal to whatever you pass in as the number of pages. And I'm also going to put a little print statement here for visualization purposes, just to show that a book has been created. Okay, usually you probably wouldn't have print statements there, but it's just for helping our understanding. Okay, Now let's go in and explore some special methods. Okay, so I just fixed that quote there. Now, these special methods, well, the first one we're going to explore has to do with printing. And to show you what I mean, I'm going to run that, and I'm going to set b equal to an instance of the book. The title of the book will be Python. The author, I'm just going to put Jose for the author. And the number of pages is going to be 100 pages long. So notice since I have that print statement and I run that cell, it tells you a book has been created. So remember I could print a list and Python knew exactly what to print out. So what happens if I try to print this book? If you notice, Python's actually just going to print out the definition of whatever B actually is, the fact that it's a main book. And then it's also going to print out some information on exactly where it's being held in memory. But what if I wanted to actually print out some information of this book? Well, that's where the special functions or special methods come into play. And the special method that has to do with printing is called __str, which stands for string. It takes in self as an argument. And you'll notice special methods are set apart with that set of underscores, the __. And what I'm going to do is with this special method, I'm going to return the title, the author, and the pages. And here I'm just using some formatting. You can use whatever formatting as far as the print formatting that makes sense to you. And I'm going to input the attributes that correspond to the title, author, and the pages. And then, whoops, this should be a period. Self.author, and then self.pages. Okay, let's zoom out a bit so you can see the whole thing. Okay, so that's all that string is doing, that special method. So now, if I create a new book has been created, and I print B, you'll notice that it calls this special method when you call the print function in Python. And that's really what special methods, how they come into play. They have to do with built-in functions in Python and what they actually produce. So let's explore another method. So I'm going to go ahead and remove this one. Another special method is length. And I can do __, len, __. And this is what Python's going to use when you call the length of an object. And in this case, I just actually want to return the number of pages, right? Because that's the most fitting thing for the length of a book. So I can say return self.pages. I create a new book. Let's just verify 101. New book's been created. And if I print the book, you'll notice I'm back to that original instance where it tells you where it's stored in memory since I removed that special method. But if I check the length of the book now, length of B, it'll actually return the pages. So that's a special method used in conjunction with that length function. And then finally, another special method I can use is the del or delete method. So you can delete objects from memory if it has that method in it. And I'm going to say print book is gone since we deleted it. So now if I create this book, B, let's go ahead and say B, find out what the title is. Title is Python. I can call the delete method or statement on B, and it's printed out a book is gone. So now if I try calling the title, it says B is not defined, so that makes sense. Okay, so these special methods, remember they're defined by the use of their underscores, and they allow us to use specific functions in Python on objects created throughout our class. So that's it as far as this general section and lectures on object-oriented programming. I know it was a lot, and I know it's sometimes hard to understand, but really just take it slowly. Make sure you copy exactly what I'm doing. Take your time with it. And again, like I've mentioned before, check out a lot of these more great resources on this topic. It'll take a while for this to really start cementing itself in your mind. But what we're going to do is for the next milestone project is utilize object-oriented programming really heavily so you get a good feeling for it. Okay, so in the next video, I'm going to explain your milestone project to you. Thanks, guys. Hello, everyone, and welcome to the object-oriented programming homework assignment. So in this homework assignment, you're going to have two basic problems, and you're going to be filling out some skeleton code that I've written for you. So this first class is called line, and what it does is it takes in two coordinates, and what you're going to do is fill in the attributes here, and you're going to fill in two methods, distance and slope. And what's going to happen is your coordinates are going to be tuples. So here I've written coordinate 1, which is a tuple 3, 2. So x is first and y is second. So you can have x, y coordinates. And then coordinate 2 is also a tuple 8, 10. So x and y. And you can create a line using coordinate 1 and coordinate 2. So remember how we assign attributes to your class using the special method init. So that's what you're going to fill out. So your example output's going to look something like this. And I want you to fill in two methods, distance and slope. So I want you to be able to call the distance method on this line object, and it will return the distance of that line, and the slope will return the slope of that line. You may have to look up the distance and slope equations on the Google in case you forgot or aren't familiar with it. But that's the basics here, and you're going to fill out the attributes and those methods so it returns the distance and slope given two coordinates as tuples for this line class object. That's problem 1. Problem 2, you're also going to fill in the class, and it's going to be very similar. You're going to have a cylinder class. It's going to be instantiated or initialized with a height and a radius. You're going to fill that in to fill out the attributes, and it's going to have two methods, volume and surface area. So the volume method will return the volume of the cylinder, and the surface area will return the surface area of the cylinder, given a height here of 2 and a radius of 3. So that's it. You're going to have to fill in those methods and make sure those volume methods and surface area methods work, as well as just the attribute assignments in your class. Okay, that's it for the homework assignment. Good luck and good job. Hello everyone, and welcome to the solutions lecture for the object-oriented program homework assignment. So you had two problems. One was filling in this line class method, and the other was filling in the cylinder method. So I'll show you my own solutions to it. Yours may be a little different, but hopefully the classes were simple enough that they should look pretty similar. So the first thing I had to do was assign these attributes using self. So I said self.coor for coordinate 1, set it equal to that input, and then self.coordinate 2, set it equal to that second coordinate input. So that's how I initialized my class. After that, for the distance method, what I did was unpacked the tuple using x1 and y1. You may have used indexing to do that. And then I did the same thing for x2 and y2, unpack that tuple. And then the other things I did here for slope, I did the exact same thing. You may have had this unpacking or assignments in another part of your code, but I had them within each method just duplicated for readability. And then here I just returned the distance formula now that I have the x and y coordinates. So x2 minus x1 squared, y2 minus y1 squared, and then the square root of that whole thing. And then the slope is just rise over run, and I casted it into a float to make sure there were no issues there. Okay. So moving along to the second problem for cylinder, again, I just assigned the attributes height and radius with the inputs height and radius, and I also put in a volume and a surface area method. So volume was just one line return, and it took the height, multiplied it by pi. I just used 3.14 as an estimate of pi by the radius squared, so height times pi r squared. And for the surface area, to make it a little more readable, I defined the top as pi r squared, so that's the top of the cylinder. And then the total surface area is going to be 2 times the surface area of the top, so the top and the bottom, and then 2 times pi times the radius times the height. And you can go ahead and look up the surface area equation for a cylinder to make sure that's correct. And that's all there was to it. Okay, go ahead and review that in case you have any confusion, but I hope it went well for you. Thanks, and I'll see you at the next lecture. Hello everyone, and welcome to Errors and Exception Handling. So this will be just a general overview of some of the keywords and concepts on exception handling in Python and how to deal with errors in your code. Okay, so let's take a quick look at an example error. Here I have a cell where I said print single quote hello, and I forgot to put a single quote at the end of that. So if I try to run that cell, I get this syntax error, and it says EOL while scanning the string literal. And so that actually stands for end of line error while scanning the string literal. So this sort of syntax error is known as an exception, and it's specific enough for me to see that I had an error there. So what is an exception? It's a specific description of types of errors. So even if a statement or expression is syntactically correct, it may cause an error when you attempt to execute it. So a lot of these errors that are detected during execution are called exceptions. So if we go back, this syntax error is a type of exception. But what's interesting to note here is that the errors detected during execution that are called exceptions, they're not unconditionally fatal. And what that phrase means is that it won't have to break your entire code. You can have one of those exceptions occur, and with the right syntax, with try and except, which we'll learn about in just a second, you can actually have the rest of your code run. So this is where the try and except keywords come into play. So the basic terminology and syntax used to handle errors in Python is known as this try and the except statements. So the code which can cause an exception to occur can be put in a try block, and then the handling of that exception can be implemented into the except block of code. So as far as syntax, it looks a little something like this. You have a try statement, and then you have a block of code within that try statement block, and you do your operations here that you may suspect will throw up some sort of exception. Just like earlier we could have had that syntax error. So let's say I said try, and I would have put print single quote hello with no end there, and then I have an except statement. And it says except, and you can actually specify the specific exception you're looking out for. So in the last case, it would have been syntax error, that phrase. And you can say, if a syntax error shows up, then execute a certain block of code. And you can also check for multiple exceptions, maybe some other sort of error. And there's a whole list, and there's a link in the Jupyter Notebook to all the official exceptions in Python. But granted, you don't actually need to know the name of the exception. You can just say except : and then in the case of any exception, it'll run this block of code. And we'll go over this in more detail when we go to the live coding. After all your except statements, what you can have is an else. So if there is no exception, then execute what's in the else block. Okay, so the finally keyword. The finally keyword allows us to place code that will always be run even if there are exceptions. So the finally block of code, like I said, will be run regardless if there was an exception in the try code block. And so what that looks like is I can say try some code block here, and due to any exception, you may skip this code, such as that print statement. So there's an error here, doesn't matter, finally I want you to execute the code block in the finally section of your code. And now you can combine all three keywords, try, except, finally, to make your code more robust to errors. So you can have a try block where you try to run some code where you think there may be an error, except to check for certain exceptions, and then finally, so even if there is an exception, I want you to run this code block, the finally code block. Okay, so I know that was quite a bit, but what we're going to do now is go over all those topics through some live coding sessions. All right, thanks, and I will see you there. Hello everyone, and welcome to the live coding section of the errors and exception handling part of this course. And now we're going to learn how to use try, except, and finally, which we learned about in context in the previous video. Now we're actually going to use them. So let's go ahead and see if we can get an exception to occur or some sort of error. I'm going to say 2 plus, and I'm going to try to add a string to it. Now clearly this isn't possible, so I get a type error. There's unsupported operands plus for an integer and a string. Okay, that makes sense. So I could have said try, and now here I'm going to put in code that I think may put an error out or some sort of exception. So it says try 2 plus s. And now I'm going to put in the except block. And I'm going to say except if there's a type error, print there was a type error. And let's see what happens now. So if you notice, I mentioned that some of these exceptions are not unconditionally fatal. Type error is one of them. So type error, since it's not unconditionally fatal, the rest of your code can actually still run using this try and except format. So what happens is the code tries to do 2 plus s, except there's a type error, so it prints there was a type error. And then the finally block will execute any code after these exceptions. So we'll say finally, we'll say print, finally this was printed. So now if we run this, we get both the except statement and finally this was printed. So something to note here is that I don't actually have to specify what error it is. Otherwise that would require you memorizing the entire list of exceptions. But if you go back to the Jupyter Notebook and scroll down, I do have a link there to check out the full list of built-in exceptions in Python. And you can check them out all here. So you can just go ahead and, if you want, generally browse this, but there's no point in memorizing all of these. This is just to help you debug your code later on. So if I just say except, I don't actually need to know or guess what kind of error is going to pop up. If I run this cell, you'll notice I get the exact same thing. Okay, so this is how you're usually going to see try except finally used in your own code. You're probably not going to type in the actual exceptions that you expect to occur. All right, so let's go ahead and break down exceptions with a try except else sort of statement. So I'm going to do this by trying to open a file. So I'm going to say try, say f equals open. I'm going to try to open test file with being able to write to it. I'm going to say f dot write test write this. And then what's going to happen is, let me go ahead and make sure I don't have this file by adding in some numbers. So it's going to try to open a file that's not there. And I'm going to say except print error in writing to the file. And I'm going to say else print file write was a success. And if I run this, it says file write was a success. Now that's because when I open a file like this, it'll actually create the file for me. So I opened the file, test file 1232. The file didn't exist, so Python went ahead and wrote it for me. And now if I look at my folder, I'll have a test file 1232 that says test write this. So file write was a success. So that's how you can use else. So when you don't have any exceptions, else will help you know that. So it says try this, except if there's an error, print out an error, else if there's no exceptions and everything went well, execute this code block. Now I'm going to try to induce an error by saying read. So remember from file opening and closing, if I just put R, that means I can only read the file. I don't have write permission. So now let's see what happens if I run this cell. No, I have an error in writing to the file. Great. So we only printed a statement and the code still ran. So we're able to continue doing actions and running code blocks even if I do have an error occur, which is really nice. So it's super useful when you have to account for possible input errors in your code. So you can be prepared for the error and keep running code instead of your code just breaking the minute it sees some sort of exception occur. So we could have also just said except if we weren't sure if a certain exception would occur. So for instance, I know that this sort of error is called an IO error, and that's fine. But I can also just put except. I just want to make that clear that you don't actually have to put in what kind of error will actually occur. All right, now continuing on. Right now we have this else statement, that will execute only if errors don't occur, right? But what if we wanted to continue doing stuff even if an error occurred? So that's where the finally block of code will run. So that will run regardless if there's an exception. Right now we have try except else, so it's going to try some code. If there's an exception, it'll do this. Otherwise, or else, it'll do that code block. But what if we wanted to do this code block regardless if there's an exception or not? So we're going to use finally to do that. So I'm going to say try. Let's say try this code right here and say finally print always execute finally code blocks. So if you notice, even if there was an error that occurred, finally was still able to print always execute finally code blocks. So what happened here? So I had to try this, I got an error, and then finally still occurred even if there was an IO error there. So I can write an except. I'll do it for any error and print there was an error. And let's see what happens now. So if you notice, this except block of code basically eliminates Python's built-in output for exception handling, or the errors popping up. So you can write in your own except and print there was an error, so your code's a little cleaner, and then have a finally block that will always execute. All right, so what we're going to do is use this in conjunction with asking a user for input. So I'm going to say make a function. Let me zoom in a bit here. Make a function def, and I'm going to call it ask int. And what it's going to do is it's going to try to set a variable val equal to raw input. I'm using raw input because I'm using Python 2. If you're using Python 3, you may just use input. I'm going to say please enter in integer. Okay, and what I'm going to try to do after that is convert it to an integer. I'm going to put an except statement that says print looks like you did not enter an integer. Then after that, I'm going to say finally print finally block executed. And then I'm going to say print the val. Okay, so let me zoom out now so we can see the whole thing. All right, so I have my function here, ask int. It's going to try to take whatever raw input the user puts in, convert it to an integer, and set that equal to val. If there's an exception that occurs, it's going to occur because I wasn't able to convert whatever they put in as an integer. So I'm going to print looks like you did not enter an integer. Finally, whether or not there's an exception, I'm going to print finally block executed. And then I'm going to print the val. So let's see if this works. Let's go ahead and ask int, close parentheses, there's no arguments. I run it. It says, please enter an integer. I'm going to enter 3. Finally block executed, val was equal to 3. All right, perfect. So let's try this again. I'm going to say ask int. It says, please enter an integer. Now let's say I was confused and I entered 5. So if you notice here, it says looks like you did not enter an integer. Finally block executed. And we have an extra error because we're trying to locate the variable val before it was actually assigned. And that's because this print val is outside the finally code block. Okay. So we got an error when we're trying to print val, notice, because it's never properly assigned. So we can go ahead and remedy this by asking the user and checking to make sure the input type is an integer. So what I'm going to do now is in my except block, I'm going to say val equals int raw input. I'm going to say try again. Please enter in integer. Okay, so let's break down what the code's doing. I'm going to space it out so it's a little more clear. So now my function, what it's going to do is it's going to try to take the raw input a user puts in, convert it to an integer, and set that equal to val. If there's an exception that occurs, it's going to say, looks like you did not enter an integer. And then it's going to do it again. It's going to try again, please enter an integer, raw input, convert it to an integer. Finally, it's going to print, finally block executed, print val. Okay, so I ran that. Let's go ahead and see what happens. Ask ints, put an integer. I'm going to put in 5. It says, looks like you did not enter an integer. Try again, please enter an integer. Now if I put in 5, everything works. Great. So that only did one check. If you notice, if I tried this again and mess up twice, so ask int, please enter an integer. Let's say I put in 5. It says try again, please enter an integer. Let's say I put in 5 again. We're going to get an error now, a value error, right? Because it's not able to convert 5 into an integer. So what can I do to try to keep continually checking? Well, hopefully your mind's thinking about a while loop, right? I want to do this statement over and over again, raw input, check for an integer, until the user actually puts in something correct. So I'm going to start again. I'm going to say def ask int, and I'm going to say while true, try to set val equal to that integer raw input of please enter an integer. If there's an exception that occurs, I say except print looks like you didn't, whoops. Let's make this a double quote so I don't have to worry about that single quote inside. Looks like you didn't enter in integer. And then I'm going to continue. Else, so remember, else happens when the try is actually correct, so I'm going to print correct. That is an integer. And then once I know it's correct, I'm just going to break out of that loop, that finally loop, or excuse me, that while loop. Then finally, after that, I'm going to print, again, finally block executed. And then outside of this, I'm going to print the value. Okay. So let's break down real quickly what's happening here. I'm going to say while true, so basically forever, try to get the input here, the first question. So this is like the very first output. It says, please enter an integer. And let's say there's an exception that occurs. I print, looks like you didn't enter an integer. Continue. And then it comes back up here, tries it again, accept, continue. So this is going to keep going forever until we get a correct input where there's no error. And it's going to say else, print correct, that's an integer, and that will break that while loop there. And then it's going to say finally print the code executed, print val. So let's go ahead and see if this works. I'm going to say ask int, please enter an integer. I'm going to put e, which I know it's not. I'm going to put r. So if you notice, my finally block is always being executed, even though I'm having these errors. But the second I put in a correct number, with that else statement, it says correct, this is an integer, and then the last time the finally block is executed. All right. So that's actually it for this video lecture. So we're just going to go quickly over everything we did. So try except finally. The very first thing we did was put in a type error exception. So 2 plus a string, that didn't make any sense. So we noticed we could use try. So I'm trying to execute this block of code, except if there's any sort of exception, I print finally there was a type error, or excuse me, I print there was a type error. Then finally, this block of code will always execute whether or not there is an exception that occurs. Again, here I said try. I said open this test file. Remember we switched from writing to reading permissions. So if there was an error that occurred, I said there was an error. Finally, always executes this code block. Then we started exploring how to deal with user inputs that are incorrect. So we made this function. In this case, I say try, take the raw input, try to convert it to an integer and set that as val. Is there any exception? Then I print, looks like you did not enter an integer. Put raw input again, try it again, but this only works twice, right? Since it's not in the while loop. And then finally, the block's executed, and we try to print, and then we print val. And again, if you mess up twice in a row, we're still getting a value error there. So how do we continue doing this forever? Well, that's where the while loop comes in. So we say while true, try this block. If there's an exception, print that and continue, which means it's going to try it again. And it's going to keep going, and then we can put an else block, which says if there's no exception there, then print correct, that's an integer, and then we break out of that loop. Then finally, this always executes whether or not there is an exception. So you notice here, even when there was an error here, and I say it looks like you didn't enter an integer, the finally block was always executed every single time. And then at the end, when I did get it right, it says correct, that is an integer, that else block executed, and then I printed finally block executed. Okay, great. So that's it for this lecture. Go ahead and explore try except finally a little more. It's going to be super useful in your beginning code when you're trying to handle user input that you think may be incorrect. But later on, you'll use it more and more. Just be careful with it though, because you don't want try statements everywhere in your code. Otherwise, it gets harder and harder to actually debug your code unless you put in very clear print statements for your exceptions. So you can imagine if your code's kind of always running these finally blocks and you have a ton of try blocks in there, it might be hard to pinpoint where the actual error is taking place if all your print statements are there was an error or something for the exception blocks. So this is super powerful and it's a really great tool, but just be careful with it and make sure you use it well in your code. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone. In this lecture we'll be going over the errors and exceptions homework assignment. Consists of a few problems, and I'm just going to go over them so you understand them all. Problem 1, you'll see I want you to handle the exception thrown by the code here by using try and except blocks. So you'll notice here I'm saying for I in this list, try to square the strings, but that's not going to work since they're not numbers. So I get this type error. What I want you to do is use try and except blocks to try this and then except if you get an error, do something else. Next up, for problem 2, what I want you to do is handle the exception thrown by the code below by using, again, try and except blocks. Then I also want you to add a finally block to print all done at the end. Problem 3, what I want you to do is write a function that asks for an integer and prints the square of it. I want you to use a while loop with a try except else block to account for incorrect inputs. So we went over this topic in lectures if you're trying to get an input from a user. So it should look something like this. When you run ask, it'll output input an integer. Notice I put null, so it says an error occurred, please try again. Then I say input an integer, I inputted 2, it says thank you, your number squared is 4. So remember we covered on how to do this using a while loop with a try except and else statement. So make sure you do that, and that's actually it for the errors and exceptions homework assignment. Okay, thank you, and I'll see you at the next lecture where we're going to go over the solutions to this assignment. Thank you. Hello everyone. In this video we'll be going over the errors and exceptions homework solutions. So problem 1, all you had to do was take the code, indent it into a try block, and then add an except block, and here I said except print an error occurred. Pretty simple. Problem 2, very similar. how to put try block with z equals x divided by y. I actually put in the specific error, zero division error. As always, you could have just said except, and for any error it would have printed can't divided by 0, and then I added the finally block to print all done. Problem 3 should have been pretty familiar given the lecture material. So for my function I said while true, try to get an input that says input integer and set it to variable n, except if some sort of error occurs, print an error occurred, please try again, then continue, else break, and then I said print, thank you, your number squared is n to the power of 2. And that was it. Alright, hopefully that was pretty straightforward given the lecture material. Take your time and read through the code in case anything was confusing, and as always, feel free to post a discussion question if you're having any trouble. Thank you. Hello everyone, and welcome to the modules lecture. In this lecture we'll be learning about what modules really are, how to import them with an import statement, how to use them in your workspace, and also how to install modules from the internet that are not included in your basic Python installation. So, here I have a notebook open called modules, and what we're going to start off with is how do you use them. And you've actually seen me use these modules a few times, but now let's formalize how we actually use them. So you are going to start with an import statement. So let me go ahead and jump over to an empty notebook. So to import from a module, you need to say import, notice the syntax highlighting, and then the name of the module. In this case, I'll import a built-in module in Python called the math module. For more built-in modules, you can check out that section of this course. But for right now, we'll start with a very basic one, the math module. Now, I can type in math, and since I'm using an IPython or Jupyter notebook, I can use .tab to see all the various functions that are available to me with this module. Alright, so let's do a very basic one called sqrt, which stands for square root. So I can take the square root of 4 and it'll output 2.0 or 2.0. Now modules are really useful, so it saves yourself from having to write a lot of code, and more likely than not, someone's already created a module for you either online or built into Python for code that you were thinking of writing before. So there's lots of various math functions that you won't have to write anymore because they're built into the Python module for math. Now another we could have used is to specifically import functions from the module. So to say import math is one way, but another way, if I just wanted to import the square root function, I could have said from math import sqrt. And now you'll notice the syntax for using square root will actually just be sqrt of 4. And I don't have to specify that it's coming from the math module anymore because I use this syntax, from math import square root. So I explicitly told Python what sqrt meant throughout the rest of my code. Now as far as formal syntax and code formatting, you should put all your import statements at the top of your code. If you're using this in a Jupyter notebook, you should put them all in the first cell. But if you're writing just a normal .py file or .py file, you should put all your import statements in the top of your code. Alright, as far as best practices, you want to try to use this syntax, from math import whatever functions you want. It'll save Python from having to load in the entire built-in module, and instead it'll just import the functions you need, so it'll save headspace that way. Let's jump back to the notebook and talk about how to download modules that are not built into Python. So there's two ways to do this. The best way is to check if Anaconda, the installation we used since the beginning, has the module already downloaded for you. So you notice the Anaconda distribution actually downloaded a bunch of scientific computing modules and other popular modules in Python for you. So the best way to install a module right now is to either open up your terminal or open up your Anaconda command prompt. I'll do that right now. So you notice here I have my Anaconda command prompt. If you're on a Mac, you can use the terminal. So what I'm going to do is open up my command prompt, and let's say I wanted to install a particular module I found online. And we'll discuss how to find these modules online in just a second. But what I could do is say conda, C-O-N-D-A, install, and then the name of either the package or the module I want to install. So let's say I wanted to install Flask. Flask is a web framework for creating websites with Python. So I would say conda install Flask. I'd hit enter. You'll notice a statement saying fetching package metadata. And because Anaconda comes with Flask built in, it'll actually install it using the Anaconda distribution. So you'll notice here, since I've already done this before, I don't get the typical message, but I'm just installing and updating right now Python. So that's one way to do it. I'm going to pause and jump the video to show you another way. Okay, so I installed that package or module using conda install. But what if Anaconda distribution doesn't include that particular module or package that you're looking for? Well, you can use pip install. Pip, P-I-P, is a package management system that's used to install and manage software packages, and it's written in Python. So most packages that are worth downloading can be found on what's called the Python Package Index, or PyPy. And that's spelled P-Y-P-I. And basically that's going to allow you to install packages from the internet. So how do you find these packages and modules that you want to install? Well, let's say I wanted to look for a package that allowed me to create PowerPoints in Python. You might think that you'd have to program that entire thing yourself, but you should always do a Google search. So for instance, I'm writing Python PowerPoint module. The first link is this python-pptx. So if I click this, I'm here at the documentation page. So what you should do is look around until you find an installing section on the page. So I click install here, and you'll notice I can install this python-pptx using pip install python-pptx. So let's go ahead and do that to show you what it looks like. So I go to my command interface, either terminal or command prompt. Notice I'm not in Python, I'm just at the terminal line, and I say pip install python-pptx. I hit enter, and you'll notice it'll begin to install. Now, I already have it installed, so my requirement's already satisfied. You can use -- to upgrade in case you want the latest version of this package. So, how do you find packages online? You can either just Google search them, or another fun thing to do is go to GitHub. So, if you go to GitHub, GitHub hosts a lot of these packages. So you can click Explore, go by programming languages, check those out. So those are actually the repositories for programming languages themselves. But if you want to find packages for Python, you can go ahead and check out Python, and we'll discuss this in the next video a little further. Sort by, let's say, most stars, and then make sure the language Python is selected. So you'll see here the second list, Awesome Python, and we discussed this a bit in the next video, where it's a curated list of a bunch of different packages for various things in Python. So let's say you want to deal with forms in Python, it'll let you know a bunch of libraries or packages for dealing with forms, etc. So another fun thing you can do is go to GitHub, search something that interests you, maybe web scraping, click enter, search, you'll notice a bunch of web scraping frameworks. Click Python, so you make sure you're only looking at Python languages. Go ahead and maybe check out this first one called 𝗟𝗲𝗁. So 𝗟𝗏's a web scraping framework. I've actually personally never heard of it, so this is also new for me. So it'll tell you what is 𝗟𝗏, it'll explain it to you, how to use it, etc. You can check out the documentation there. And you'll notice installation. And for most packages, pip is the recommended way to install it. So you can say, follow this line, pip install -u 𝗟𝗏, and it'll install 𝗟𝗏 and all its dependencies. Okay, so let's go ahead and review very quickly. How do you use a module or a package that you downloaded off the internet? You say import and then that module or package name. If you want to import particular functions, you use this notation. From math, import whatever that function is. So from the module or package, import that function or method. Then, if you want to download modules or packages that are not built into Python, I recommend you first try conda install whatever that module or package name is. If Anaconda distribution puts up an error that it doesn't have it, then I suggest you use pip install whatever that package name is. Okay, so that's it. In the next video, we'll go over a quick fun assignment for you to explore packages online. Thanks everyone, and I'll see you at the next lecture. Hello everyone, your homework assignment for this lecture is to download either module or library and explore GitHub, download one, and just play around with it, have fun. So what you're going to do is come to github.com, go enter Python in the search, and what I want you to do is then click here on languages, make sure it's in Python, and then sort by most stars. And now what I want you to do is just check out this second link that says awesome-python, click it. Or we can directly go to this just by going to github.com/vinta, VINTA/awesome-python. And here it's a curated list of frameworks and libraries all in Python. So what I want you to do is just check out this list, see what interests you. So for example, I'm going to zoom in here. Let's say I am interested in audio in Python. I can click that. It'll take me down and scroll down here to the audios. And here are all the amazing libraries that some people have written for Python. So for instance, PyEchonest is one of my personal favorite Python libraries, and it's the Econest API. So you can come here, read about it, play around with it, and it basically will let you, for instance, connect with Econest API, and you can ask for artists, IDs, songs, different features of the songs, etc. Some people put GIFs on their README page. So choose whatever interests you, download it, play around with it. Remember to use conda install first. If that doesn't work, then use pip install. Okay, so this is just a fun little assignment. Choose what interests you, and that's it. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and in this video lecture I'm just going to be going over the second milestone project, a blackjack game. First of all, congratulations for making it this far into the course. I know object-oriented programming is hard to learn, so you should be really proud of yourself to make it this far. And you've learned a lot, so it's time to put it to the test. So in this milestone project we're going to be creating a blackjack game, and I'm going to have you do the following requirements. So it's just a simple text-based blackjack game. You can click the link here in the Jupyter Notebook in case you're not familiar with blackjack. The rules are right here. Hopefully most people are familiar with it. It's basically otherwise known as 21 sometimes. It's a card game. So what you're going to do is learn blackjack if you don't know it in order to construct a blackjack game in Python. And the game needs just to have one player versus an automated dealer. So the computer is going to deal out cards, and the player can either stand or hit. And then the player must be able to pick their betting amount, and you need to keep track of the player's money, how much they have, and you also need to alert the player of wins, losses, busts, etc. So I'll give you a lot of freedom and how much you want to actually build out the blackjack game, but those are the basic requirements. If you want to keep building it out more, you can have multiple players versus the dealer. You can have double downs, additional blackjack rules, etc. So the most important thing throughout this milestone project is that you must use object-oriented programming in classes in some portion of your game. You cannot just use pure functions like you did for tic-tac-toe. So I want you to use classes to help you define the deck and the player's hand. There's a ton of right ways to do this, so explore it however you feel. But to give you a quick example, I'm going to hop over to the live coding. So in case it's unclear what I mean by using object-oriented programming or classes to help you define the deck and the player's hand, maybe start thinking of, we can have a class called, let's say, player, and it's going to have object. And then let's say player, one of the attributes, we'll initialize him or her. And maybe one of the attributes of this player is possibly how much money they have, so their bankroll. So we can initialize their bankroll with, let's say the standard is 100, but you can choose. And then we can say self.bankroll is equal to the bankroll you put in. And then instead of having to write a lot of functions, you can write another method that might be called like adjust bankroll. And then we can have, let's say, we'll always have to have a self argument. Let's say we can say if you're going to add or subtract, we can put in an argument for add or subtract. So we'll put in add equals true. So I'm actually going to say, I'm going to call this add bankroll, not adjust bankroll, since this will only work for adding money. So add equals true. Actually, we won't need that anymore. Let's say instead the amount. And what this is going to do is it's going to take your bankroll and add the amount to it. Okay, so now let's create a player. Call this player Sam. And we'll have them with a bankroll initially of 1,000. So now Sam, I can check his bankroll by calling that method 1,000. But something else I can do is add to his bankroll, right? Add bankroll. I'm just using tab complete here. Let's say I want to add $10 to his bankroll. Now if I check Sam's bankroll, he has 1,010. So this is the kind of thinking I want you to have as you approach this milestone project. So I want you to make a class for players, a class for maybe a deck, a hand. This is where you can really get creative and see what works for you. Okay, so that's enough of hints or examples, and I'll let you go ahead and explore that. Remember, take your time with this project, really explore it. Another reason I chose blackjack in particular is that this is kind of a common assignment. So you might even have this as a simple take-home project, maybe for another course in school, or even a basic interview position. And you can also find a lot of examples online. So feel free to explore online and Google to answer your own questions. But don't Google blackjack game in Python, otherwise you might get an example of an entire solution. Okay, thanks everyone, and remember, have fun with it. Okay, I'll see you at the next lecture. Hello everyone, and welcome to this quick video going over the second milestone project 2 solution, at least my implementation of a solution, and it's just a simple game of blackjack. So what I'm going to go over here is just how I use classes in my solution, since that's really the main purpose of this exercise in general. So I went ahead and made a card class, and in my card class, each card has an attribute, a suit, and a rank. And then I went ahead and made a string. So remember we had those special methods. So if I said print card, it would return its suit plus its rank, whatever those strings happen to be. And then I had a grab suit and grab rank method that returned those attributes. And then I had a draw, which basically returned the suit and the rank printed out. Okay, so then I made a hand class. And if you notice here, something I had to take care of were that aces can either be 1 or 11 in blackjack. So I had ace be basically a Boolean value, whether or not there was an ace in the hand. And then I had cards and value. So the cards, I used list as my data structure. And then this special method, the str for printing, basically will just return the string of a current hand composition. So maybe there's a better way of writing this out with a list comprehension possibly, but I just wanted to show for clarity a for loop here. So for every card in the cards list, I went ahead, called it out, its str method, and then used this to return the entire hand composition, which is basically just all the strings put together. Then moving on to the card add, which adds another card to the hand. I take my self.cards list and append the card to it. I check for aces, so if the card rank is equal to A for ace, I set self.ace equal to true. That way that Boolean value now knows that there's an ace in my hand. Then I have another method for calculating the value, and that calculates the value of a hand. So it makes aces an 11 if they don't bust a hand. So if ace is true, I have an ace in the hand, and my value is less than 12, then I return value plus 10. Else, I just return it as if it was a 1. Then I also have a draw method, which has these two factors, hidden and true. So I don't want to show the first hidden card, and that has to do with the way the dealer works. So we can also continue on to the deck class that I made. And remember, your solution might be totally different, but as long as you used object-oriented programming, that was the main point of this exercise. So I wanted to create a deck in order. So I have a deck here, and I say for suits and suits, for rank and ranking, append a tuple here, or a card, excuse me. So create a card object with a suit in that rank. And you might be thinking, well, where are these suits and rankings coming from? So I actually defined them up here, hearts, diamonds, clubs, spades, and then all the possible ranks, as well as a dictionary of point values for them. So moving on with this deck class, I had the creation of it, shuffle it, which I just used from the random library to shuffle. I used deal, which just popped items off of the list, that deck list, and then str was just for printing the deck composition. Okay, so that's it for the classes. I'll let you go ahead and check out the functions. I use global variables just because it's in the Jupyter notebook and it's a little easier that way, but you didn't have to. There's tons of ways to implement this game of blackjack, so as long as it works and as long as you're happy with it, great job. Okay, so I'll let you go ahead and read through the rest of that solution. Thanks, everyone. Hello, everyone, and welcome to this lecture on the map function. So map is a built-in function in Python. It's going to be one of the first built-in functions we work with. And it's a really useful function, especially when you use it in conjunction with a lambda expression. And we'll go into that a little further. So map comes in the form map, and then it takes in two arguments, a function and a sequence iterable, such as a list. And what it does, it applies this function to every element in this sequence, and then returns a new list with the elements changed by the function. So let's go ahead and see what this looks like in a live coding example. If you remember from the list comprehension lectures, we used list comprehension to convert temperatures, right? Fahrenheit to Celsius. So let's go ahead and see what that looks like with map. So I'm going to use map. I'm going to create a function called Fahrenheit, and it's going to take in a temperature that's in Celsius, and it's going to return the temperature in Fahrenheit. So it's going to return the temperature in Celsius, and that equation looks like this. You may remember it from the list comprehension tutorials. So here we have our Fahrenheit function. It takes in the temperature and then returns the temperature in Fahrenheit. So to give you an example, let's go ahead and look at Fahrenheit of 0 degrees Celsius is 32 degrees, right? The temperature where water freezes. Okay, so what if I had a list of temperatures in Celsius? So I could say, let's say 0, that's like room temperature, and then let's see, boiling water at 100 degrees Celsius. So what if I wanted to apply this function to every element in my temperature list? That's where map comes in. So I'm going to say map, the name of my function, Fahrenheit. And notice I'm not actually passing any parentheses. I'm just passing the name of my function. So I don't do this. It's just the name of the function. And then I pass in the sequence iterable, in this case my list. And what I get is every element in that list with the Fahrenheit function applied to it. Great. So in this example, we could have used a lambda expression, so we didn't have to actually define this whole Fahrenheit. So this is great when you want to do some sort of anonymous function call. So you don't want to have to define an entire function, so you use a lambda expression. And I mentioned before when we were covering lambda expressions that they would be really useful with map and filter and reduce. So now we're going to see them in their true action. So I'm going to say lambda, take in some t, multiply it by 9 divided by 5, and I'm using 9.0 so I don't get any floating point errors, I don't get any cutoffs. If you're using Python 3, you didn't have to worry about that. And that's my lambda expression. And now I'm going to apply it to my list, and we get the exact same result. Awesome. So now I actually, with map, don't even have to define an entire function name and call it. I can just use a lambda expression instead. And usually when you see map in someone else's code, it's almost always using a lambda expression. Okay, so how can we build on top of this? So if you remember, lambda expressions can actually take in multiple arguments. So I could have something like lambda xy return x plus y. So I can have that sort of lambda function. And we can incorporate that with map. So we actually can pass more than one sequence iterable, and I'll show you what I mean by that. I'm going to create two lists, actually three, 1, 2, A, B, and C. So let's go, A is going to have 1, 2, 3, B will have 4, 5, 6, and C will have 7, 8, 9. Okay, so I have A, B, C, and now what I'm going to do is map the lambda expression I had, which takes in two arguments, x and y, and then returns x and y added together. But remember, I'm going to take in two arguments now, a and b. So what map is going to do is it's going to be able to work with two or more sequence iterables. So it's going to apply this lambda function in order. So it's going to take the 0 index of A, 0 index of B, apply this lambda expression. Then the 1 index of A, 1 index of B, apply this lambda expression, and continually do that. So if we see the result, we basically get A plus B. So 1 plus 4, 2 plus 5, and 3 plus 6, 5, 7, 9. And we can actually extend this further to even more than 2. So I could say, let me put a space in here so it's really clear, x, y, z plus z input a, b, c. And you'll notice now we get 1 plus 4 plus 7, 2 plus 5 plus 8, 3 plus 6 plus 9. Usually you won't see something or map and lambda expressions used for this many sequence iterables. At least it's not too common from my own coding experience. But it is used sometimes if it's the right tool in that case. So maybe you would want to perhaps change these variables if it's more clear for you to see it this way. Although it may be unclear because it may think you're referencing those lists themselves, but you will get the exact same result. Okay, so let's go ahead and do one more example to really drive the point home of what map is doing. Let's go ahead and make an example that creates the, let's say, times every number in a list by -1. So I want to map some lambda expression, and the lambda is going to take in a number and return that number times -1, and I'm going to apply that to my A list. And there you have it, -1, -2, -3. So map, this idea is actually pretty simple. You put in a function, remember it's a function name, you don't actually pass in the parentheses, and then you pass in some sequence iterable like a list. And then it returns a list of that function applied to every element in that sequence. And that's really all there is to map. And it's super useful when you use it in conjunction with lambda. Alright, So go ahead and read over the other examples in the Jupyter notebook that we have here, and make sure you understand map before continuing on to the other built-in function lectures. All right, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the reduce function lecture. So reduce is another built-in function to Python that you're going to find is also really useful in conjunction with lambda expressions. And you'll notice that the format is really similar to map, except what it actually does is quite a bit different. So a lot of times students have difficulty understanding reduce, so go ahead and make sure you read the Jupyter notebook before coming to this lecture while I'll break it down for you. Okay, so what does the function actually look like? So the function looks like this. It has a reduce statement, and then just like map, it takes in a function and a sequence. But instead of mapping the function to every single element in that sequence, it's going to continually apply that function to the sequence. So what does that actually look like? It's going to end up returning a single value. So let's go ahead and break down all the steps here. And I know it's a lot of text, but we'll go through it slowly. So if your sequence looks like this, let's say you have a list where it's S1, S2, S3, all the way to some Sn, then calling the reduce function sequence looks something like this. So you grab the first two elements of your sequence, S1 and S2, and then you apply the function. So it would look like func S1, S2. Then you have that result, which is just some single number or single value, and you have now a list that looks like this, function, that result of S1, S2, S3, so on, so on, so on. And so the next step in the function would to take your previous result, whatever the result of S1, S2 function would be, and then take that and apply it to function of that answer with S3. So then the list keeps building in and reducing the functions that build into each other. And it keeps continuing like that until one element is left. So that's a little hard to understand in words. Let's go ahead and see an example. So I have my list, LST, equal to 47, 11, 42, 13. And then I created a lambda expression that adds numbers together. So it takes in two inputs, x and y, and then returns a single value, x plus y. And here, reduce, I'm inputting this lambda expression, that function, and then I'm also passing this list. And so what is reduce doing here? Well, it takes the first two elements, just like S1, S2 in that last example we saw, 47 and 11, and it applies that function to it, and then you output 58 here. So 47 plus 11 is 58. So now it keeps going on throughout the list, and then the next sequence is going to be that result passed into the function along with the third element, 42. So it's going to do 42 plus 58, which is 100. Then it's going to take that result of these three and pass it along to this lambda expression with the fourth value, 13. So 100 plus 13 is 113. And then your output is just 113. So make sure you really understand what's going on here. You keep reducing the sequence until a single final value is obtained. All right, let's go ahead and look at another example by hopping over to the live code. All right, so we're at our live code, and what we're going to do is create a reduce function that finds the maximum of a sequence. So let's say I have a list, and let's just put in some random numbers in here. Okay. So I have this list with some random numbers in it. And what I want to do is find the maximum of the sequence using reduce. So I could just use max of the list, and that would return the max of the list. That's another built-in function. But in this case, we actually want to build that out ourselves using reduce. So how can we do that? Well, I'm going to create an expression called maxFind, and I'm actually going to make it as a lambda expression, not a function. It's going to take in two arguments, a and b, and it's going to return a if a is greater than b, else it returns b. So that's what maxFind looks like. And let's go ahead and make sure we really understand what's going on with that lambda expression by rewriting it as a normal function, just so we really make sure what's going on here. So as a normal function, maxFind would look like this, right? I take in two arguments, a and b, and I will say if A is greater than B, return A. Else, return B. So that's what's going on here, and let's go ahead and make sure it works. Max find, say 12 versus 100, so it returns 100 here. So the reason I'm writing it as a lambda expression is just to have it in your mind that lambda expressions are used a lot with map, reduce, and filter. Okay, so remember I have my list of these random numbers, and what max find is going to do, if I reduce it, is find the maximum of that list. So max find and my list, and notice it found the maximum. So what is it actually doing? Well, it's taking these two numbers first and comparing them. It's going to say, okay, which one's greater, 34 or 23? Well, 34. Then it's going to compare 34 and 24. 34 still wins, and it's going to keep doing that until it finally reaches the max number. And then it's going to say, okay, well, 2333 is the max number, so return that. Compare that to 2, it's still the max. Compare that to 11, it's still the max. Well, then finally, return 2,333. And that's how we can find the max using reduce. So, just to reiterate, what reduce is doing is it's applying this function continuously throughout your sequence. And then it returns a single value as it keeps reducing the sequence further and further. All right, so go ahead and make sure you understand fully what this statement is saying here, how it's just reducing the function continually, the sequence continually, using whatever function you put into reduce. All right, so that's it for this lecture. You can go ahead and check out more examples by just Googling Python plus reduce, and there's more examples in the documentation of Python. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the filter lecture. And in this lecture we're going to be going over the built-in function filter. So let's go ahead and get started. So what the filter function does is, just like map and reduce, it takes in a function and then a sequence iterable, such as a list. And it offers a really convenient way to filter out all the elements of an iterable for which the function returns true. So what I mean by that is the function filter is going to take in a function, and then here I have just L, which stands for just some sort of list. So the function is the first argument, your list will be the second one, and then the function needs to return a Boolean value, either true or false. So maybe you're checking for even numbers or something like that, where you return true or false depending if the number is even or not. And then the function is going to be applied to every element in that iterable. And only if the function returns true will the element of the iterable be included in the result. So let's go ahead and go to the live code so we can see how this works. Alright, so we've jumped to the live code, so let's go ahead and see an example. First, let's make a function. In this case, I'm going to use normal DEF function notation, and let's have it be that even check that we were talking about. So here, if the num returns, actually what we can do, well, I'll show you two ways of doing this. You can say if num mod 2, or modulo 2, is equal to 0, return true. So let's use this version of the function, and I'll do an even check. Let's check 34, that's even. Let's go ahead and check 35. Nothing comes out, so we need to say, we could say else false, return false. All right, great. So we've created a way of filtering the numbers based on whether or not they're even. So we have a function that returns a Boolean. You could also just return this result if return num mod 2 equals 0, and Python will treat it the same way. But just for clarity's sake, we're going to build out the function completely. All right, so let's filter out a list of numbers. Let's go ahead and say that our list, LST, is equal to, let's just create a range to 10. And we check LST, and 0, 1 through 9. Okay, great. So let's go ahead and filter it. So I want to filter with even check and return only the even numbers, and that's exactly what it does. So As I mentioned before, just like map and reduce, filter is more commonly used with lambda expressions, just for a quick ad hoc job. So I could say lambda num where it's equal to 0, the num modulo 2, and apply that to my list. And filter works the exact same way. So hopefully this looks very familiar given what we learned about map and reduce. But basically, your first function is any function that returns a Boolean, and you can pass it a list, and it'll filter out everything that's not true. Let's go ahead and see one more example. Let's say I wanted to find every number in this list that was greater than 3. So I could say filter lambda num, given num greater than 3, pass my list, and now I have every number that's greater than 3. Okay, so hopefully that's all pretty straightforward. Remember, filter, you just put in the function name, no parentheses, the sequence interval you want to pass, in this case we're usually doing lists, and then it'll filter out and return everything where the element would pass with a true Boolean for that function. Okay, that's actually all I have for filter. You can go ahead and check out the Jupyter Notebook if you want some more in-depth explanation, but that's really all there is to it. Okay, thanks, and I'll see you at the next lecture. Hello everyone, and welcome to this lecture where we're going to discuss the built-in function zip, which basically makes an iterator that aggregates elements from 2 or more iterables. Okay, so let's go ahead and see how this works. Just to give you a quick note, zip, you could actually write it yourself. This is what the function is equal to, so if you want to explore if you had to make your own function that was similar to zip, this is how you would do it. What we're going to do is actually just go ahead and see it in action first, because I think it's best explained through example. So let's say you had 2 lists. We're going to make one list called x, 1, 2, 3, and another called y, 1, 2, let's make it different. Let's say 4, 5, 6. Okay, so you have these 2 lists, x and y. And now what we're going to do is use zip to essentially zip them together. So I'm going to say x, comma, y. And the output is going to be basically tuples, pairs of tuple, or pairs inside a tuple, excuse me, and a whole list of them. So let's go ahead and see an example of how we would use this. So what we're going to do now is create 2 more lists. A, which let's say is going to have 1, 2, 3, 4, 5, and B, which is going to not be sequential. It's going to say 2, 2, let's put in 10, 1, 1. Let's make sure they match up. Okay. So we could use zip to pick the largest between both of these. So what I mean by that is, let's say we only wanted to return a list that included the largest in each index. So between A and B, the first largest at the 0 index would be from B. The second largest would be from A, etc. So there's actually lots of ways to do this, but we're going to use it with zip. So let's go ahead and see how that would work. So I could say something like this. I could say for pair in zip of A, B, return the max of that pair. And let's see what we get. Oops, I have return outside a function. I need to put that in a function. Or I can just say, let's say print. And let's bring that back in. Okay, so what did I do here? Instead of writing a whole function, just a quick for loop. So I went through each pair in the zip for these guys, which would have looked something like this. Let's go ahead and copy and paste this so we know what we're looking at. So it went ahead, saw each pair, and returned the max from that tuple. So let's go ahead and do this now using map, since we learned about it earlier. So I could say map with a lambda expression. For every pair we want to return, let's say, the max of that pair, and go through zip AB. Let's see if that works. And notice now we have the exact same result, but as a list. So this should really show you how powerful zip can be. Now something you might be wondering is, what if one iterable is longer than the other? So let's say I have one list that says 1, 2, 3, and another list that's much longer. Let's say it's equal to 4, 5, 6, 7, 8. So what happens if I zip these two guys together now? Well, what happens is you're defined by the shortest iterable. So you can only go as far as the shortest iterable in that zip function. Okay, so what happens if we try to zip together dictionaries? So we've done lists, but let's go ahead and explore dictionaries. So I'm going to make two dictionaries. One with a key A with a value 1, one with a key B with a value 2, a dictionary D2, key C, value 4, key D, value 5. Okay, so let's go ahead and zip these and see what happens. Alright, so you notice we only get the keys, and that's because simply iterating through a dictionary, if you remember, will only give you the keys. So if I say for I in D1, print I, remember from the dictionaries lectures, we only get that key back out. So what if I want to get the values? Well, if you're using Python 2, you can use iter values, or if you're using Python 3, you can just use values. So I could do something like this. Let's say D2, and let's say I want the values from D1, so I can say iter values, and there we go. Alright, so that's a couple of methods we can use to mix keys and values. So what we're going to finally do is use zip to switch the keys and values of two dictionaries. So let's go ahead and make a function to do that. So I'm going to call this function 𝗟𝗲𝗁. And what it does, it takes in D1, D2, it takes in two dictionaries. I'm going to define an object called 𝗕𝗢𝗟𝗢𝗚 as an empty dictionary. That will be the dictionary it returns. So I'm going to say return 𝗕𝗢𝗟𝗢𝗚. And so how do we want to build this? So I want to say, let's say for D1 key and D2 val in zip the first dictionary keys and the second dictionary's values, iter values. And what I'm going to do is say 𝗕𝗢𝗟𝗢 D1 key has the value from D2 val. And whoops, that should have been an equal sign. And now let's go ahead and see what happens when we say 𝗟𝗲𝗁. So remember, D1 looks like that, D2 looks like that. And if I call 𝗟𝗲𝗁 on D1, D2, then I've switched the values from dictionary 1 with the values from dictionary 2. Okay, great. So hopefully you've seen how zip can save a lot of typing in a lot of situations, and you should have a good understanding of how to read zip and how to use it. So remember, zip is pretty simple. You just take two iterables and basically zip them up together in tuple pairs. Alright, and one last note is if one iterable is shorter than the other, you're defined by the shorter iterable. So feel free to play around with zip. It's going to be a great tool to have as you code more in Python. Okay everyone, I'll see you at the next lecture. Hello everyone, and welcome to the lecture on the built-in function enumerate. So we'll learn about enumerate, and we'll learn how to use it. So it's an extremely useful function, and you'll find yourself, I believe, using it all the time after this. And what it basically does, it allows you to keep a count as you iterate through an object. And it does this by the form, it returns a tuple, which has the count and then the element. So you could actually build out your own enumerate function with this definition here, but I think it's best learned just through examples. So let's go ahead and see what this looks like. First, what we're going to do is make a list. I'm just going to say a list L equal to, let's say, A, B, C. And you'll see in a second why I'm passing letters instead of just regular numbers. So I'm going to say for item in L, print item. Okay, so this is nice, but let's say I wanted to also print out the index of this item, or I wanted to keep track of how many items I had gone through. I could do something like this. I could say count equals 0, and then say for item in L, print item. Then let's say I could have said print count, and then count, add 1 to it. So what does that look like? So now I'm printing the count. So right now I start at 0, I print the item out, I add 1 to my count, and then I start over again. 1 is the count, B, 2, C. All right, so right now that's how you've probably usually been keeping track when you're iterating through items. But it's actually not necessary because it's such a tool, well, it's a task you want to do so often that Python actually has a built-in method, and it's called enumerate. So what enumerate does is it returns back a tuple. So I'm going to say enumerate L, and it returns a tuple in the form count item. So I've discussed before in tuple unpacking that you actually don't need these parentheses, but hopefully it just makes things a little more clear. And then I'm going to say print count. And you notice that's the exact same thing as we did before. So what it does is it basically just allows you to keep track of the count, or it enumerates your iterable as you go through it. Okay, so like I said, enumerate becomes particularly useful when you have a case where you need to have some sort of tracker. So for example, let's go ahead and make a new for loop that says for count item in enumerate of that list. Let's say if count is greater than 2, so I've gone through it 3 times, and let's go ahead and, or let's say, yeah, greater than or equal to 2. Let's go ahead and break that for loop. If not, I'm going to say print item. So I went ahead and ran it, and I only get A and B. So what's going on here? So using enumerate, I was able to keep track using that count, because with this if loop, if the count was either greater than or equal to 2, it went ahead and broke the loop. So it didn't actually print out C. Okay, great. So hopefully you have a good understanding of what enumerate's actually doing. It's quite simple, and I think you get the best view of what's actually going on through this example right here. So you just say for the count, comma, item, and enumerate of whatever your iterable is, and then you can use the count and use the item through tuple unpacking. A lot of times you'll see it used with an I if you're reading someone else's code. Whoops. Let's go ahead and change the count here to be I. So a lot of times people tend to use this notation I, or sometimes even N. Go ahead and use whatever notation works best for you, but just keep in mind that if you're reading someone else's code and they've used enumerate a lot, they'll probably use I as the count. And the most important thing to keep in mind for enumerate is that your count comes first, comma, and then it's your element in that iterable. Okay, that's really all there is to it for enumerate. Go ahead and explore it, make sure you understand it. But remember, it's just returning a tuple that looks like this. That's all enumerate's doing. Okay, so great. I will see you at the next lecture where we'll discuss another built-in function in Python. Thanks, everyone. Hello, everyone, and welcome to the next built-in function lecture. And we're going to be going over the built-in functions all and any. And all and any are basically built-in functions that allow us to conveniently check for booleans matching in an iterable. I've written out what you could actually type if you wanted to create your own all and any function. So let's just zoom in and go over it. So what is all doing? All is going to say that if all the elements in that iterable are true, then it returns true. So it says all takes in an iterable for elements in the iterable, if not element, which is basically a way of saying if not true, then return false. Otherwise, it returns true. So basically, as it's saying as a word, if they're all true, it returns true. Any, as you might have guessed, returns true if any of them are true. So you could type it out. So any, put in your iterable. For element and iterable, if element, so if one of them is true, it will return true. If that if case never becomes true, then none of them are true and it returns false. So hopefully this will be pretty straightforward after seeing a few examples. Let's go ahead and get started with some live code. I'm going to create a quick list, call it L, and it's going to just be straight booleans. True, true, false, false. All right, so let's go ahead and check first all. So go ahead and guess what you think will happen here, whether it's going to return true or false before running the cell. Okay, so all will return true if all of them are true, so it should return then false. So that makes sense, right? Because not all the elements are true. Okay, so what will any return then? So remember, any returns true if any of the elements in that iterable are true. And so in this case, it returns true. Okay, that's really all there is to it for all and any. So I will let you go ahead and explore them and see how you can use them or read them in your own code. But as far as their basic usage, it's really just that simple, all and any. And you can basically remember just by their names. If they're all true, this returns true. If any are true, that returns true. And then vice versa for the opposite of them. If they're not all true, it returns false. If any of them are true, it returns true. If that's not the case, then it returns false. So if they're all false, then any returns false. Okay, that's it for this quick built-in function lecture on all and any. I will see you at the next one. Thank you. Hello everyone, and welcome to the lecture on the complex built-in function, which returns complex numbers and can accept either a string or a pair of numbers as an input. And I'll show you what I mean by that in just a second. So if you're familiar with complex numbers, they have a real portion to them and then an imaginary portion to them. So if you're coming from a math or physics background where you need to use complex numbers in your code, complex is going to be your go-to function to make that happen. Okay, so here in the Jupyter Notebook, I've described the two ways of inputting into complex. So you can go ahead and read this first. But basically, if the first parameter is a string, then you don't call it with a second parameter. And then the other way of calling it is with a pair of numbers. So let's just go ahead and jump straight into the live code, because I think this is the easiest way to see what's actually going on. So let's go ahead and go over the first way to use the complex function. All right, so let's go ahead and get started. So there's two ways of inputting into the function complex. The first way is with two parameters, the numbers. So you want to put in the real number, the real part of the number first, and then the imaginary. So in this case, I've created 2 plus 3j, where 3j is the imaginary part of the complex number. Just to show you another example, complex, let's do 10 and 1. So your real part is 10 plus 1j. What's really interesting about the complex function, though, is it can actually read strings as well. So I could have gone complex and passed a string that says something like 10 plus 2j, and it'll understand it as well. Now, like I mentioned before, if you're passing in the string, you don't pass any second parameter, since you're already including the imaginary part in that string. And that's really all there is to it. So keeping this in mind, if you're ever dealing with complex numbers in Python, just know that Python's already thought of this for you, and there's a whole complex function to give you additional functionality as you deal with complex numbers in your code. Okay, it's a super short lecture, but hopefully it should have been really straightforward. Remember, there's two ways. First part's the real number, second parameter is the imaginary part, or you just pass a string through the complex function. Okay, that's all there is to it, and I'll see you at the next lecture. Hello everyone, and welcome to the Advanced Functions test. So for this test, the main requirement is that all the functions you should be able to write in line. So basically what this test is going to consist of are you filling in these problems with functions. But every single one of these functions can be done with just a single line using the built-in functions that we learned about, such as map, reduce, filter, etc. So let's just go ahead and go through the problems real quickly. First problem is use map to create a function which finds the length of each word in the phrase, broken by spaces, and returns the values in a list. So for instance, if you have a phrase here, how long are the words in this phrase? This function should be able to return a list that looks like this. So how has 3 letters in it, long has 4, etc. Now you should be able to do this all in one line here. So a return and then one line of code using the map function, and maybe some other stuff that you've learned about. Problem 2, I want you to use reduce to take in a list of digits and return the number they correspond to. So here I have a list of digits, 3, 4, 3, 2, 1, and you reduce it to this 34,321. Now what I do not want you to do is to directly convert the integers to strings. Figure out a better way to do it than that. Okay, problem 3. Here I want you to use filter to return the words from a list of words which start with a target letter. So you'll have a list of a bunch of words, and here the function will take in that list and a target letter, and will return a list of all the words that start with that target letter. And again, this is all done in one line. Problem 4, I want you to use zip and list comprehension to return a list of the same length where each value is the 2 strings from L1 and L2 concatenated together with a connector in between them. So what I want you to do is, for example, you take in one list, you take in another, and then you take in some sort of connector, and what you return using zip and list comprehension, remember this is all in one line, is a list that looks like this. The item from list 1, the connector, the item from list 2 for that index 0. Then at index 1, item from list 1, the connector, item from list 2. Okay. Problem 5, I want you to use enumerate and some other skills to return a dictionary which has the values of the list as keys and index as the value. And you can assume that a value will only appear once in the given list. So, for example, you'll have a list that says A, B, C, and you return a dictionary A of 0, B, 1, C, 2. Okay. So the index of A was 0, that becomes its value. Index of B was 1, that becomes its value, as B is the key. Last problem, I want you to use enumerate and other skills from above to return the count of the number of items in the list whose value equals its index. So for example, here you're going to take in count match index. Again, this should all be able to be done on one line. You take in a list and you check each of these numbers. So 0, the first one, does that number match its index? Yes, 0 is at 0, that's a +1. This is at index 1, so 2 does not match. This one is, however, at index 2, so 2 equals 2, so that matches, etc., all the way down. In this case, there's 4 matching here. All right, so those are the 6 problems. Remember, they should all be done on one line using things such as list comprehension and lambda expressions and all the built-in functions we learned about. Okay, best of luck, and I will see you at the next lecture. Hello everyone. In this lecture what we're going to do is I'm just going to go quickly over the solutions for the advanced functions test. So for problem 1, I used map, and I mapped the length function to phrase with the split method applied to it so I could get a list of all the words, and then mapping that I just cast it as a list and returned that. A little tricky, but it's all in one line. Problem 2, what I did was I used the lambda expression here to have x and y, and notice I could not convert the integers to string, so what I had to do was take x, multiply it by 10, and then add y, so I could keep moving along through this digits list. And then I used reduce to reduce this lambda expression on the digits list. Okay, problem 3, I had to use filter to return the words from a list of words which start with the target letter. So I made a lambda expression, set a word, where the first word, if it's equal to that letter, filter it out on the word list using that lambda expression. Again, one line. Problem 4, I used list comprehension and zip, just zipped up the 2 lists and then said word 1 plus that connector plus word 2 for the word 1 and word 2 result from that zip. Problem 5, did a little dictionary comprehension here where I said key value for value key in enumerate L. And then problem 6, finally what I did was said list comprehension here, num for count num in enumerate L if the num is equal to the count. So that basically means if that number is equal to the index, and then return the length of that list, which returns this count here. Okay, so these were all pretty tricky, especially if the requirement for that they are done in one line, but hopefully you can see how powerful the built-in functions now, and they can save you a lot of code. All right, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the decorators section of this course. So decorators can be thought as functions which modify the functionality of another function, which I know sounds weird, but they'll help make your code shorter and more Pythonic. It's a pretty advanced topic, and you run into it more when you start working with web frameworks such as Django or Flask with Python. So something I want to note before you start this lecture, restart Python and the Jupyter notebooks in order to keep track of some of the global functions we'll be working with. I think the lecture will make more sense that way. Okay, so we might have to split up this section into multiple videos, so we'll see how it goes. But what we're going to do is just start explaining decorators by slowly building up from functions. So let's go ahead and do a little bit of a functions review. So I'm going to make the simplest function I can. I'm going to make a function called def_func1. Let me zoom in a bit for you guys. And all it's going to do is return 1. So if I call func, func, I get 1. So let's go over a bit of a review with scope. So remember from the nested statements lecture that Python uses scope to know what a label it's referring to. So for instance, I'm going to create a variable called s, and it's going to be a string called this is a global variable. And notice how it's not inside any function, so it's global. And it's not inside a class either. And so now I'm going to make a function. I'm going to rewrite func, and it's going to print locals. Okay. So remember that Python functions create a new scope, meaning the function has its own namespace. So this function has its own namespace to find variable names when they're mentioned from within the function. So remember, it checks this first before checking the global scope. And we can check for local variables and global variables with locals and globals. Those are just built-in functions that you can call to get the globals and local variables. So let's say I wanted to figure out, okay, what are all the global variables I have? If I say print globals, we're going to get a large output right now. So we get all this. And this is basically a dictionary of a bunch of basically all the global variables we have right now. So what we can do is just call the keys of that dictionary. And so here are all the keys of that dictionary. And this basically are all the global variables right now that Python is holding on to. And so remember that we created this s. So it's a global variable. And if you notice, it's right here. So it's a key. So I can actually, since this is a dictionary, call s, and it treats them all as strings. It converts all the keys into strings. And now this is a global variable, pops out. So just to keep in mind, globals, it's a dictionary of all the global variables and what they stand for. And right now we've created one called s, which is just a string saying this is a global variable. But now what's interesting is if I run my function, remember this function just prints locals, but since there's no variables defined within that function, I get an empty dictionary out. Alright, so that's just something to keep in mind. So now we're going to continue with building out the logic of what a decorator actually is. And in order to do that, I want to remind you that in Python, as we've discussed before, everything is an object. That means functions are objects which can be assigned labels and passed into other functions. So let's start with a simple example of that. I'm going to create a function, and it's called hello, and it takes a name, and by default I'll just have the name be Jose. And I'll have it return hello space plus the name. Okay, so if I call hello right now, I get hello Jose. Now what I can do is assign a label to that function. So check this out. I'm going to say greet equals hello. And notice that I'm not using parentheses here because I'm not calling the function hello. Instead, I'm just assigning it to the variable. So if I do this and then call greet, it's a function which is hello. So then if I call greet closed, it'll print out hello Jose. So I set the greet variable equal to the hello function. And something to understand is that this assignment with greet is not attached to the original function. So if I delete hello, so notice I've deleted that function from memory now. So if I call hello, it says hello is not defined. I'd have to run this cell again to redefine it. But I want you to realize that greet isn't actually attached, so greet still works. Okay, so let's go over slowly what we've done. We're thinking about decorators, and we want to build our understanding off of functions. So here's an example of a simple function that just returns 1. So if I call that function, I get 1. Now let's remember about global variables. I set s to be a global variable, which is just a string saying this is a global variable. And I've called a function func, which prints locals. And since there's no other local variables defined within this function, just to remind us of scope, if I were to call that function, I get an empty dictionary out from that locals call. Now, something else, we wanted to check globals, which we could do with that globals function, which returns that dictionary of all the globals, and I can call the s key to get back the global variable. Next, we wanted to reiterate that functions can be assigned to variable labels because everything's an object in Python. So I created a function called hello. Default was name equals Jose, and it just returned hello plus name. So when I called hello, I got hello Jose. Since everything in Python is an object, I could assign hello to the variable greet. Now, something to note here is that greet wasn't attached to hello. So if I deleted hello, hello didn't work anymore, but greet still did. Okay, so that's it for now. In the next video, we're going to learn about functions within functions. And we're going to also be dealing with this same hello and greet function. Okay, I'll go ahead and stop the video here, and we'll continue on in the next video. Hello everyone, welcome to the second lecture in the decorator section of this course. And now we're going to be talking about functions within functions. So we saw previously how we can treat functions and objects. Remember, I assigned the hello function to that greet variable. Now let's see how we can define functions inside of other functions. So we're going to do this by defining a new function called def hello. And again, it's going to take in Jose as the default. And the first thing it's going to do when you call the hello function, it's going to print the hello function has been executed. Okay. Next, what's going to happen is I'm going to write a function within another function. And this function is going to be called greet. So what greet is going to do, and let me zoom out, reset. Here we go. Okay. So the function greet is within the hello function, and it's going to return a string. So let's have the string say, this is inside the greet function. And something I want to do here, just to make it extra clear when we're printing some of these things or running them, I'm going to put in a tab statement. Okay. So continuing on, I'm going to have another function within this function called welcome. It doesn't take any arguments, and what it's going to do is, similarly, it will return with a tab, this is inside the welcome function. And then outside of everything, I'm going to say print the result of greet, print the result of welcome, and print now we are back inside the hello function. Okay, so let's just break down what's happening in this function. So what's happening in this function is I have hello, the outside function, takes in the name Jose and says print the hello function has been executed. Then I have the greet function, which just returns this is inside the greet function. Then I have the welcome function, which returns this is inside the welcome function. Those two statements are inside those respective functions. So when you call hello, it prints the result of greet, which is this statement. It prints the result of welcome, which is this statement. And then finally it prints now we're back inside this main hello function. So let's go and see what happens when we call hello. Great. So it says the hello function has been executed, and then it says this is inside the greet function, that's the result of this line. It says this is inside the welcome function, that's the result of this line. Then it says now we're back inside the hello function. And the reason they're tabbed is because I'm putting this escape tab character there. So let's see what happens if we call welcome. So note when I call welcome, it's not defined. And that's because due to scope, the welcome function is not defined outside the hello function. So the only function that's aware that welcome exists is the hello function. Since it's not defined outside of hello, it's not globally defined, so Python doesn't know about it outside of the hello function. So now let's learn about returning functions from within functions. So what I'm going to do now is take this hello function that we made. I'm going to get rid of this line. I'm going to keep the greet and welcome lines, but what I'm going to do now is say this. If name is equal to Jose, that's string, return greet. And note, I'm returning greet, not the result of greet. So I'm actually returning the function. If I wanted to return the result, I would do this. But we're returning the actual function. Then I say else return welcome. Again, not returning the result, returning the function. So we don't have those parentheses there. All right, so I have my hello function. Now let's see what happens when we say x is equal to hello. So now let's see what happens. I'm going to set that equal. Let's go ahead and delete that. So something to note is that because this is closed parentheses, that means the name has already been defined as Jose, since that was the default of hello. So x already has the name Jose within it. So if I just call x right now, I get the function main greet. So now we can see how x is pointing to the greet function inside the hello function. So why is that? That's because hello had by default the name Jose, and I said if name is equal to Jose, return the greet function. And since the greet function is inside the hello function, that means right now, as far as scope is concerned, we are aware of it and we'll return this function to this variable, which means now x is equal to that function greet. So now on a global scale, I can say print greet or print, x, and it will print what's inside of the greet function. So again, let's take a quick look at this code. In the if-else clause, we are returning greet and welcome, not the actual results. We're returning the functions. And this is because when you put a pair of parentheses after, the function gets executed. Whereas if you don't put the parentheses after it, then it can be passed around and can be assigned to other variables without executing it. So when we write x equals hello, parentheses, hello gets executed. So we're actually executing this function when we assign it to x. And that's why the name Jose by default gets placed when you execute hello, which means this Boolean statement becomes true, which means we return the greet function that was inside the hello function, which allows x to be equal to the main greet function, and then printing x like so with parentheses means you're actually running the greet function. Okay, so we've learned how to deal with functions within functions, and we've also learned how to return functions. So now in the next video, what we're going to see is how we can pass functions as arguments into other functions. And we've seen this already a bit with functions such as map and reduce and filter, where we could even pass lambda expressions. So now we're just going to go and have an overview of functions as arguments. Okay, I'll stop this video here, and I will see you at the next video where we talk about functions as arguments. Thanks, and I'll see you there. Hello everyone, and welcome to the third lecture in the decorator section of this course. And now we're going to learn about passing functions as arguments. So in the last lecture, we learned about functions within functions and how we could return functions. And now we're going to learn about functions as arguments. So we'll see how we can pass functions into other functions. So again, continuing on with the hello, I'm going to reassign the hello function. I'm going to just say return the string hi Jose. So that's my hello function. And then I'm going to make another function that takes in the argument 𝗠𝗙𝗁𝗁, and it's going to print other code goes here, and then what we'll do, it's going to print the results of func. So it's expecting func to be a function. And so now if I call other, you'll notice we get an error because it's expecting an argument. So I'm actually going to pass the hello function. And so what happens here? Well, other function takes in a function, it prints other code goes here, which is one of the outputs, and then it prints the results of whatever that function happened to be, which in this case was hello, which returns hi Jose. Great. So we've seen how we can pass the function as objects and then use them within other functions. So now we can get started with manually creating our first decorator. So in the previous example, we kind of actually manually created a decorator. So we're going to modify it to make it very clear what's actually happening here. So I'm going to say def, and I'm going to call this function new decorator. And it takes in a function as an argument. And now there's a function here within it called wrap func, takes no arguments, and it prints, let's just say code would be, let's just say code here before executing the func. And then I'm going to call the function that you pass into this new decorator function. Then I'm going to print code, say code here will execute after the func. And then what I actually do is I return this wrap underscore func. Notice I'm returning the function itself, not the result of the function. So that's one function, and I'm going to create a new function called func needs decorator. And all this does is it says print this function needs a decorator. Okay, so what happens if I call func needs a decorator? It prints simply that statement. Okay, simple enough. So this is where we actually see how a decorator works. I'm going to say func needs decorator. I'm setting that function equal to the new decorator function with the func needs decorator passed within it. Okay, so let's kind of break down what we just did here. I have this func needs a decorator function. All it used to do was print this function needs a decorator. So what I ended up doing was I took this new decorator right here, that function, which accepts a function as an argument, and I passed it the func needs decorator. So notice how it's going to get used within this block of code. So if I call func needs decorator now and run it, notice what I get. I get code here before executing the func. This function needs a decorator, which was the original func needs a decorator. And then I said code here will execute after the func. And looks like I spelled execute wrong. My apologies. So if I run these cells, code here will execute after the func. So what happened here? So the decorator provided just simply wrapped the function and modified its behavior. So this decorator wrapped this function to modify its behavior. So this is exactly what a decorator is. And now I'm going to show you how you can rewrite this code using the @ symbol, which is a symbol that Python recognizes as a decorator symbol. So I'm going to do @new_decorator, and I'm going to copy and paste this original function needs a decorator. So notice what's going to happen now if I say func needs decorator and I call it. We get the exact same code as if it had done this. Okay, so we've just built out a decorator manually here, and then we saw how we can use the @ symbol to do this automatically in Python. Again, I'm going to just slowly break down exactly what happened here. Notice, all this statement is doing, this decorator, is exactly what we did here. It takes in this function that we called needs a decorator, and by decorating it with this function, we pass it into that new decorator function and reassign it to this function here, which allows us to basically do exactly what we did here, but with this @ symbol. So I really want you to take your time and read what's going on here. We created a function called new decorator. It takes in a function. It has a function inside of it called wrap func, which says print some code here before executing that passed function, does the function that you passed, prints code here will execute after the func, and then returns the wrap func. Then we created a very simple function called func needs a decorator. All it did was print this function needs a decorator. Originally, when we called it with no decoration, it just printed that statement. But we passed it into that new decorator function and set it reassigned it to its original name. So then when we called it, you got the code here before executing the function happening, this, because remember, we're returning the wrap func. So you get basically everything that's going on in the wrap func with the function included. So we got code here, this function needs a decorator, which was this statement, and then code here code executes here after the func is called. Now you could have done this line right here that I'm highlighting with this @new decorator symbol, and you'll realize it's the exact same thing. So when are you going to use this kind of behavior? This is really common when you're working with web frameworks such as Django and Flask, which you'll run into decorators a lot with web development. And you can even go through just the very beginning of the official Flask tutorial, and you'll notice that a decorator will be placed there. A lot of times that's what prevents beginners from working with web frameworks when they're just learning Python, because this sort of notation doesn't make any sense to them. But I hope now that when you see how we manually built out that decorator notation and that reassignment, you'll feel that it's actually a lot easier just to call the new decorator like this with the @ symbol. Okay, so that's it for decorators. And go ahead and check out the Jupyter Notebook if you're having any trouble. So let's go ahead and open it here and zoom out a bit. I want you to know that this entire Jupyter Notebook takes you step by step through decorators, functions review, the scope review, Then it takes you through the functions within functions, returning functions, functions as assignments, and then creating a decorator and using this decorator notation. So I encourage you, even if you went through all the videos, take your time and really read through this decorators Jupyter notebook. Okay, so that's it for decorators. As far as usage, you probably won't see them within your own code unless you're doing some more advanced function passing or you're interested in web frameworks. But I hope this entire breakdown really helps cement the topic for you. Okay, thanks everyone, and I'll see you at the next lecture. Hello and welcome to the iterators and generators section of this course. So in this section of the course, we'll be learning the difference between iteration and generation. We'll get started with a brief presentation on just the overall ideas of iteration versus generation. So, like I mentioned, here we're going to be discussing iteration and generation in Python and how to construct our own generators with the yield statement. So we've touched on this topic in the past when discussing the range function in Python 2 and the similar xRange function, with the difference between range and xRange was that the xRange was a generator. So let's talk about creating generators. We've learned how to create functions with a def and the return statement. What generator functions allow us to do is write a function that can send back a value and then later resume to pick up right where it left off. So this type of function is a generator in Python and allows us to generate a sequence of values over time. The main difference in syntax that you'll see is the use of a yield statement instead of a return statement. Otherwise, you'll see that a normal function that iterates versus a normal generator function will actually look really similar, the only difference being the return and the yield statement. So how do generators work? In most aspects, a generator function, like I said, appears super similar to a normal function. The main difference is when a generator function is compiled, they become an object that supports an iteration protocol. So that means when they're called in your code, they don't actually return a value and then exit. So you can think of range, just return the list and then exited. The generator functions will automatically suspend and resume their execution and state around the last point of value generation. And the main advantage here is that instead of having to compute an entire series of values up front, such as that entire range list, the generator functions can be suspended. And this feature is known as state suspension. And we'll explore that later on in this section of the course. So why use generators? Generators are best for calculating very large sets of results, particularly in calculations that involve loops themselves, in cases where we don't want to allocate the memory for all the results at the same time, just as I mentioned back in the range lecture. And like I mentioned, we noted before that a lot of the functions in the standard library that return lists in Python 2, such as range, have been modified to return generators in Python 3. Because generators are a better way of creating those objects. So let's go ahead and jump to the live code. Hello everyone, and welcome to the live code first lecture in the iterators and generators section of this course. So we already gotten a brief introduction of just the general concept of generators. Now let's actually make some generator functions to see how they work. So what I'm going to do is create a generator function, and it's going to look very similar to a normal function with one key difference being the yield keyword. So I'm going to call it gen_cubes, and it's going to take an argument n. And then for num in range n, so n is going to be a number, I'm going to yield, not return, that num to the power of 3. And then I'm going to say for x in gen_cubes, let's say 10, go ahead and print x. So if you notice what's going on here, since we have a generator function, we don't actually have to keep track of every single cube number that we created. So as I mentioned, generators are best for calculating large sets of results. So if I ended up putting some ginormous number here, yes, they would all print, which would be a little bit messy, but if I just wanted to do something with that number and not actually print it out, that would be a lot better than if I had a list return here. So the way this would look if it was a normal function, I would have some sort of list out, and then be saying out.append that number. But you can imagine if I were to, at the end, return out, and then say for x in gen cubes of 10, let's go ahead and run this. You'll notice it's the exact same thing, but Python's actually keeping out here in memory. So if this is a humongous number, you're going to run into errors or just general problems of your code slowing down. To show you a better example of this, I'm going to create an example generator that calculates Fibonacci numbers. So in case you're not familiar with Fibonacci numbers, you can go ahead and go to the Jupyter Notebook and click this link here. If you want, go ahead and pause the video so you can see what Fibonacci's numbers are. But basically, you can think of it as just an integer sequence where the last two numbers are getting summed together for the next one. So if you can zoom in here, check out this first integer, and in modern usage they usually start at 0. But what you're doing here is saying 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, etc., so on and so on. So there's a lot of interesting patterns that you can check out on this page, but that's all you need to know as far as this lecture video is concerned. So going back to the lecture for the live code, let's go ahead and make a generator called gen_fibon. It's going to take a number n, and it's going to generate a Fibonacci sequence up to n. So I'll make a equal 1 and b equal 1. So we'll go with that more classic starting point where it starts 1, 1. So that first line of that Wikipedia page. And then I'm going to say for I in range n, yield a. And then after you yield it, I'm going to say a is now equal to b, and then b is now equal to the sum of those two, a plus b. So now I can say for num in gen fibon 10, print num. And you'll notice here, we start printing, and you'll notice this sequence of numbers is actually incorrect. This is not a Fibonacci sequence. And I hope you spotted the error. The reason I showed this is because this is a common interview question mistake. But what's going on here is we need to actually assign a temporary variable. Since we're reassigning a to b here, this is actually a statement of just saying b plus b equals b. So what we can do, there's actually two ways to do this. I'll show you the more general way first. So I would say a temporary variable t is equal to a, then set a equal to b, and here I can have b equal to t plus b. And if I run that, now we have the Fibonacci sequence. Another way to do this is using tuple unpacking, and that will actually reduce this to one line where you can do the assignments at the same time, and that will look like this: ab equals b, a plus b, and you'll notice that's the same result. Just something to keep in mind, and we go over this tuple unpacking later on in the advanced tuples section of this course. Okay, just wanted to mention that since that's a common interview question, and it's also a common interview mistake as you're learning about generators. Okay, so moving along, we've created this Fibonacci sequence. So what would this look like if we wanted to create a normal function? Well, it would look something like this. I would have def fibon n. Let's go ahead and start it at 1 again. So a equals 1, b equals 1. Again, we can actually use tuple unpacking to do that assignment. A comma b equals 1 comma 1. But we won't do that for now. We have to assign an output list and then say for I in range n, output dot append a, and then do the assignment here. ab equals b, a plus b. And then at the end we return output, and then if I call fibon 10, I get the Fibonacci list sequence out. Okay, so notice again, if we call some very large value of n, you know, if I were to pass in a lot of zeros here, we would have to hold that entire list in memory. and we have to keep track of every single result. But for the generators, we only keep track of the current number in that sequence. So we don't keep track of every single result. Okay, so the key to fully understanding generators is the next function and the iter function. And this will really help you cement what's actually going on. So the next function, and it's literally looks like this, just next, allows us to access the next element in a sequence. So I'll show you through some simple examples. I'm going to create a function, or excuse me, a generator function, simple gen. It's not going to take in any arguments, and it's going to say for x in range 3, yield x. Okay, now what I'm going to do, since everything in Python is an object, I'm actually going to assign simple gen to the label g. Simple gen, close it off, and then say print, and this is where the next function comes in. I'm going to say print next g. First one's going to be 0. If I do this again, print next g, we'll get a 1. If I do this again, notice I'm going to keep going up and up. So now I'm going to copy this, control copy, and I'm going to keep going until we get an error. Here we go, stop iteration. So after yielding all the values, so notice all the values was up to 3 here. So that was 0, 1, 2. So up to 3, we have a stop iteration error. So what this error informs us of is that all the values have been yielded. So you might be wondering, why don't we get this error when we're using a for loop? And that's because the for loop automatically catches this error and then stops calling next. So let's go ahead and check out how to use the iter function, which is iter. So you remember that strings are iterables. So for example, I could say s equals the string hello for let in s, printlet, excuse me. So I'm going to print every letter in that string. So we can iterate through a string since they're iterables, but that doesn't mean the string itself is an iterator. What we can do is check this with the next function. So for instance, if I wanted to say, okay, give me the next one of s, it'll say string object is not an iterator. So it's an iterable, which means we can iterate through it, but it's not an iterator itself. It's not returning stuff like a function. All right, so that's where the iter function actually comes into play. So the string object supports iteration, but we cannot directly iterate over it as we could with a generator function, unless we use the iter function. So I can say s underscore iter is equal to iter s, shift enter, and then we can call next on it, and you'll notice we don't get an error. This will actually keep calling everything until we've yielded all the values. And then we have a stop iteration error. All right, so now you know how to convert objects that are iterables into iterators themselves. Okay, I know that was a lot and some of it may have been a little complicated, but the main takeaway from this lecture is that using the yield keyword at a function will cause the function to become an actual generator. And this change can save you a lot of memory for large use cases. So for more information on generators, I actually want you, and this is a bit of a homework assignment for you, go to the Jupyter Notebook, scroll all the way down, and click these 2 links, a Stack Overflow answer and another Stack Overflow answer. And they're basically explanations on understanding generators. So if we look at these 2 links, I want you to go ahead and read here. Now note this post assumes 3.x syntax, but it's okay, you should still be able to understand it. And it goes through some of the similar explanations that I did of next and the iter function. So I want you to go ahead and read this Stack Overflow answer. I know it's a lot, but it's definitely worth it. And he also points out some 2.x changes. So that's your first assignment, is read that Stack Overflow answer. And then I also want you to read this separate breakdown on the yield keyword. So there's another great breakdown of iterables versus generators here and the yield statement. Okay, So your assignment is to, after you're done reading that Jupyter notebook, read these 2 Stack Overflow questions, and that should complete your understanding of generators and the yield statement. Okay, so thanks for listening on to this lecture, everyone, and I will see you at the next section. Thanks, everyone. Hello, everyone. In this lecture, we're going to go over quickly the iterators and generators homework assignment. So the first problem, I want you to create a generator that generates the squares of numbers up to some number n. So fill this generator equation here, or this function, excuse me, and pass, remember it should use some sort of yield statement. So if I use it, for example, I can say for x in gen squares, print x. Okay. Problem 2, I want you to create a generator that yields n random numbers between a low and a high number that are inputs. So I made a note that use the random library, and you can do that by this line right here, import random, and then you can use random.rand_int with 2 numbers, a low and a high, and it will output a random number between the low and the high. So that's what I want you to use in this function. And I want you to use it to yield or generate those numbers. And then you can use it and make sure your code runs similar to this. Obviously, these numbers won't be exactly the same because you're randomly generating them. Problem 3, I want you to use the iter function to convert the string below into an iterator. Problem 4, I want you to explain a use case for a generator using a yield statement where you wouldn't want to use a normal function of a return statement. Then extra credit, what I want you to do is explain what GenComp is doing here. So we haven't actually covered this yet, but you may have to do some Googling and Stack Overflowing to understand what this line is actually doing. A quick hint, maybe you should Google what a generator comprehension is. Okay, that's it for the iterators and generators homework assignment. Best of luck, and I'll see you in the next lecture. Hello everyone, and welcome to the Iterators and Generators Homework Solution Lecture. So in this lecture we'll be quickly going over some of the solutions for the Iterators and Generators homework assignment. So problem 1, hopefully it was pretty simple. All you had to do was say for I in range n, and then yield that I squared. Problem 2, a little more complicated since we introduced this random library, but pretty similarly, you just had to say for I in range n, and then yield, and then basically this line, but with the inputs low, high. Okay, problem 3, what I really wanted you to do was to convert the s to an iterator using the iter function, and then be able to print next s, just like we did in the lecture. Problem 4, one use case for a generator is when your output's going to take, or has the potential to take up a large amount of memory, and you only intend to iterate through it, you'd want to use a generator. Obviously, multiple answers are acceptable here. Basically anything we mentioned in the lecture that you felt was appropriate. Then for the extra credit, basically this was a generator comprehension. Just like there are list comprehensions and dictionary comprehensions, you can actually create a generator comprehension. So it's just a quick way of basically, if we scroll up, a quick way of making these kind of generator functions, but instead of having to write this formal syntax, you just write this in parentheses. Okay, so you can Google generator comprehension or check out the official documentation if you're interested in exploring that topic further. Other than that, that's it for the iterators and generators section of this course. Main takeaway is just to keep in mind to use generators when they're appropriate, and the yield statement is what makes a normal function into a generator function. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the GUI lectures, or Graphical User Interface lectures. Make sure you read the lecture before this, the introduction to GUIs in Python in general. There's lots of different options out there for choosing a GUI or a GUI, and the best one really depends on what you want to do. So if you want to do games or apps on mobile, some libraries such as either Kiwi or Pygame will be better suited for you. If you want to do applications that run on Windows and Mac, maybe PyQt is a better choice for you. If you want to build dashboards that take in information and quickly show it to users who aren't familiar with the Python language, something like what we're about to learn today, the GUIs with IPython widgets, is super useful. So since you're already familiar with the Jupyter Notebook system, we're going to learn about how to use IPython widgets, mainly because 1, they're very easy to use, and 2, it's a nice leeway into future courses such as the Learning Python for Data Analysis and Visualization course. And another great reason for this is it makes it really easy for someone who doesn't have any experience with Python programming to go ahead and open up your dashboard or whatever widget you created and be able to use it without knowing how to program. Okay, so let's go ahead and get started. Before we begin, I want to make sure you know that at the Jupyter NB viewer or on GitHub, wherever you take the notebooks from, there's a folder called GUI or GUI. If you click on it, it'll take you to the lectures for this section of the course, and we're going to start off by learning about interact. Okay, so a quick note that the widgets in this notebook aren't going to be able to be rendered in NB Viewer or GitHub. To view the widgets, you'll have to interact with them. So you'll have to download this notebook either by forking it on GitHub, which you can click here, the link to take you to GitHub, or you can directly download it here by clicking on the top right download notebook link. Okay, so we're going to go ahead and get started by learning about interact. And I think you'll be really surprised at how easy and quickly it is to create functioning widgets in a Jupyter Notebook. First thing I'm going to do is from the notebook itself, I'm just going to copy some imports here. Edit, copy, edit, paste. I'm going to run this. I'm going to go ahead and zoom in so you can get a better view. So we're going to import just print function from the future so we can be in line with Python 3 printing. And then for the widgets themselves, I'm importing from IPyWidgets. I'm importing interact, interactive, fixed. And then I'm importing IPyWidgets as widgets in general in case I want to get more stuff from that library. I can just say widgets dot. Okay, so let's go ahead and start with interact. At the most basic level, interact will auto-generate a user interface or a UI control for function arguments. And then it calls the function of those arguments when you manipulate the controls interactively. So for instance, if I make a really basic function called, let's say, f, it takes in an x and just returns x. So it just returns the input it receives. You can use interact so you can actually manipulate this. So when you pass this function into interact, you pass the function as the first argument. So I'm passing f as the first argument, along with some integer keyword argument. So in this case, you say x is equal to some integer. And we'll go over what happens when you input things that aren't integers later on in this lecture. But if we start with an integer, it will automatically create a slider for you. So you can see here, I've already made a widget just with one line. So if I run this, you'll notice I get an out cell here until I start playing around with the widget. If you want to stop that from happening, you can put a semicolon, and then when I run it again with Shift Enter, you'll notice you won't get an out cell. So you'll notice me using semicolons in this fashion throughout this section of the course. As I mentioned before, usually semicolons aren't needed for Python programming, but in the Jupyter Notebook setting, if you want to prevent that output cell from showing up and you just want to display the widget, you can use a semicolon to kind of kill that output. Okay, so when you move the slider, what we're doing is we're calling the function, and it prints out here at the bottom the current value of x. So that's what happens when you use interact with a function and an integer. If you pass in a Boolean value, it's going to generate a checkbox. So the key thing to keep in mind here is that interact will auto-generate different widgets depending on the type you pass in as x. So if you pass in here a Boolean, you'll get a checkbox. And then you can close it here by clicking on that little x. So if you pass a string, let's go ahead and do that. I'm going to pass in a string called hello. Let me put some quotes around it to make it a string. It's going to get a little generate it's going to generate a little text area for you, which is really cool. So then I can say cool, and it'll output whatever string you want. Okay, so you can also use these sort of interact functions as decorators. So go ahead and review the decorator lecture if you haven't done it yet. But once you've reviewed it, you can actually check out that we can use interact as a decorator. We just pass the X we want. And in this case, let's go ahead and define a function that takes in 2 arguments. So I'm going to also have it take in Y. I'll start with a floating point there. And then I'm going to decorate my function. So I'm going to make a new function. It's going to take in 2 variables, X and Y, and it's going to go ahead and return them. There we go. And now we can actually run these 2 widgets at the same time by merely decorating it. If we wanted to just do a single one, we could have done something like this. And as if you remember from the decorator lecture, decorating this is the same as doing this, just passing in that function with an argument here into interact. You can decorate it. So whatever you feel looks nicer in your code, however you like to think about things, you can choose that on your own terms. All right. So hopefully we've seen now how powerful interact is and how automatic it is just for generating things. So that's pretty cool. So let's go ahead and learn about fixing arguments. So there's times when you may want to explore a function using interact, but fix one or more of its arguments to specific values. And this can be accomplished by wrapping values with the fixed function. So again, I'm going to make a really simple function. I'll call it h. It'll take in 2 arguments, pq, and it's going to return pq. And now when I'm going to call interact, I'm going to pass in my function, pass in what I want to start p as. I'll start p as 5. And then q, instead of just putting in a number like 20, I'm going to go ahead and fix it. And I will fix it to the value by calling fixed to it. Now, if you notice, we had to import this fixed in order for this to work. And let me go ahead and put a semicolon there so we don't get that output cell. And so now when I call interact, you'll notice I'm able to adjust the p value here for my function, but 20 remains fixed on that output. All right, great. So now let's learn about widget abbreviations. And if this is going just a little too quickly for you, remember you can always review the Jupyter notebook here. Everything I'm saying is written out, and you'll just have to download the notebook in order to play along with the functions. But keep in mind there's a whole notebook here for you to follow along with, because I know there's going to be a ton of widgets and a ton of information. And also keep in mind that in a future lecture in this section, we'll have a list of all the widgets for you to reference. All right. But as I mentioned, widget abbreviations. So when you pass an integer valued keyword argument, for instance, the 10 we did earlier, the x equals 10 to interact, what it does is it generates that integer value slider control with a range. And in this case, if I scroll back up here, remember when we were passing in, if I pass in 10 here, we get this range. So this slider, we can actually call it specifically. So I can actually specify interact, call f here, and then from widgets, I can call int slider, and then pass in more specific arguments. This is kind of what it's actually doing automatically, but if you want more control, you can start messing around with it. So it'll take a min and a max. You can also specify a step size, and then specify your starting value. And I need to fix that. It should be widgets, not widget. Sorry about that. All right. And you notice we get the exact same thing as when I called this automatically here, or for instance, automatically here. So here I'm calling interact f x equals 10. and I can do the slider. And what this is doing automatically is it's automatically calling widgets.int_slider slider or int slider for you with these specific parameters: min -10, max 30, step equals 1, value equals 10. So you can actually pass in those keyword arguments yourself. So hopefully this example clarifies how Interact processes its keyword arguments. So if the keyword argument is a widget instance with a value attribute, then that widget is used. So what we're going to do now is go ahead and jump to the notebook, where you can see a table here that describes the auto-generated widgets depending on the argument you pass. So as I mentioned before, if you pass in a Boolean, some sort of true or false, you'll get a checkbox widget automatically generated for you. If you pass in a string, you'll get a text widget. If you pass in just a single value or a tuple of values, or a tuple of 3 values, min, max, step size, if they're either integers or floats, you'll get an integer slider or float slider widget respectively. And then you can pass in a list of strings, or a tuple of strings, excuse me, and a dictionary, and you'll get a drop-down widget, which we'll see later on. So let's go ahead and start exploring these auto-generated widgets a little more. So we've seen how a checkbox has worked. We've seen how a text area widget has worked. So let's go ahead and check out how the min-max slider with tuples will work. So I can say interact, call that simple function again, and I'm going to pass a pair of numbers as a tuple here into interact. And you'll notice here, now it takes them in as a max and a min. So my minimum was 0 and my maximum is 4. So I can also specify as a third argument step size. And you can review that table that I just showed you guys if you need any reminders on this. So now you can see as I move the slider, I'm moving in a step size of 2 from 0 to 8. So I have my min, my max, and my step size. All right. So we can also use floating point numbers. And let's go ahead and change the numbers up. Let's just put in 10. And in this case, I'll leave the step size to be automatically generated for me. You'll notice it uses a 0.1 step size for floating points. But you can also specify that. So instead of 0.1, let's say I wanted more precision, I could say 0.01 there. Run it, and now you can see I get more precision as I move my slider back and forth. And in future lectures, don't worry, we're going to learn how to connect all these widgets to user inputs and outputs. All right. So for both integer and float valued sliders, we could actually put this in as a decorator. So for instance, I could say at interact, and I'm going to pass in this exact same tuple here. Decorate a function. Let's say this function starts at x equals 5. Or let's put it 5.5 since we're dealing with floating points. It just returns x. Whoops, sorry, looks like I have an extra pair of parentheses on accident. Now let's run it. And there we go. Same thing. So this is just to reiterate the concept that you can use decorating with interacts. It'll make your code look a little cleaner, but again, totally up to you depending on how you like to manage your code. All right. So finally, let's start talking about drop-down menus. So drop-down menus are constructed by passing a tuple of strings or a dictionary. So if I say interact, again, going to call my really simple function f, which just takes in an input and returns the exact same input. We've noticed that if I pass in an integer, it will create a slider. We remember that. But if I pass in tuples of strings, such as apples and oranges, then I get an automatically generated drop-down menu. And you'll notice the output is just that Unicode string. Cool. So I can also pass in dictionaries. So if I want a drop-down menu that passes non-string values to the Python function, then I pass the dictionaries. So the keys in the dictionaries are used for the names in the drop-down menu user interface, and then the values of that dictionary are the arguments that are passed to the underlying Python function. So for example, if I make my dictionary have keys, let's say 1 is 1, and 2 is 2, semicolon to kill that output. Oops. Messed up the string there. All right. Then we have a dropdown that takes in, notice how it's the key is what you see in the dropdown user interface. But the actual value to that key is what's getting passed into that function. So if I click 2 here, the 2 value gets passed into the function f, which gets returned. All right, so you can imagine we could make this a more complicated function like times it by 2. So for instance, I could say this function f takes in some number that multiplies it by 2 or puts it to the power of 5, etc. It would take this number and then do that function on it. All right. So last thing we're going to cover is using function annotations with interact. If you're using Python 3, you can go ahead and check out the notebook. It has a special notation for Python 3 where you can just use this sort of widget abbreviation here. If you're using Python 2, you'll have to import using the annotate function. So let's just go over this in the notebook itself. So for function annotations, if you're using Python 3, you can define a function of a checkbox widget just like the argument for the x here. So you can say x colon true, return x, and then you can just interact straight on that function because the widget's already been defined. If you're running Python 2, the function annotations can be used with the @annotate function. So you'll have to import this annotate, say @annotate equals true, decorate that function, and then you can call interact with just that function without passing that second argument. You can go ahead and read up on these in the Jupyter Notebook in case you're curious about them. All right. Really quickly, I want to mention one last thing, which is interactive, which is extremely similar to interact, but instead of producing the widget directly, it just returns a widget object. So I'll show you what I mean by that. So let's go ahead and make a really simple function again. This function is just going to be f. It's going to take in 2 arguments, a, b. It's going to return a plus b. And instead of calling interact, I'm going to call interactive. I'm going to call it on that function. I'm going to set a equal 10 and b equal to 20. So you notice if I run this, I'll get the widget. But unlike interact, what I can actually do is set that widget equal to a variable. So I can say w is equal to interactive here. And if I check the type of w, I get what's called a widget box, which is essentially a box container for other widgets. And then this box, or this w object, has other properties to it. It has children properties, which we'll discuss in another lecture. So here you can see it has 2 integer sliders within it, which makes sense. That's what we just saw. And if we ever want to actually call it, we can just say from ipython.display import display, and then we can actually just display that w object itself. So with interactive, you can save it to some variable name, and when you want to pull it back out as a UI, you can call display on it after you've imported ipython.display import display. Okay, so I know we went over a ton and this was a pretty long lecture, so make sure you review everything we went over in this Jupyter notebook. It's pretty thorough. Don't worry if you haven't been able to memorize all the interacts and interactives, what all the input arguments automatically generate. And don't worry too much about feeling bummed out that everything's auto-generated. There are a lot more options for personal control over things, and we'll be learning about that as this section goes on. But for this lecture, just make sure you have a nice understanding and feel comfortable using really basic interact and interactive function calls to create widgets. All right, that's it for this lecture. Make sure you review the Jupyter notebook. It's called Using Interact, and I will see you at the next lecture. Thank you, everyone. Hello, everyone, and welcome to the Widget Basics lecture. As always, there's a corresponding notebook, which you can find in the GUI or GUI folder. Once you click that, you'll see the available notebooks, and we'll be working on the second one, Widget Basics. Again, it should be noted that the actual widgets cannot be rendered either in GitHub or NB Viewer. You have to download or type up the notebook yourself in order to see the widgets. So, in this lecture, we're going to continue to build off our understanding of interact and interactive to begin building out useful widgets. So what are widgets exactly? Widgets are event Python objects that have a representation in the browser. So like a controller or a slider, a text box, we've seen this before. So to use the widget framework, what you have to say from ipywidgets, import, and in this case, I'm just going to import asterisks or everything. Okay, so you can use these widgets to build interactive GUIs for your notebooks, and you can also use widgets to synchronize stateful and stateless information between Python and JavaScript. And I'll show you what we mean by that in just a second. So widgets can be called by their own display representation. So if you remember from earlier, we could call integer slider, and this was generated automatically using the interact, but you can call them individually from ipywidgets. In this case, we've imported everything, so I can just call it like this. And remember, it comes with its own possible arguments. Whoops. So here is a slider widget that represents an integer bound by a minimum maximum. So you can check out the Jupyter notebook from earlier, and later on we'll have a list of widgets that you can check out for exactly what arguments you can pass into them. Another thing you can do, as mentioned earlier, is press X here to close out that widget. So I also want to mention, as we discussed earlier, you can specifically display the widget. So you could say, for instance, if we import from ipython .display import display, I can actually set a variable equal to int slider and then display that slider, and it'll work. So we saw a little bit about that in the earlier lecture, but something that's interesting to note, that is if we call this twice, so if I say display W and then call display W again, and I start editing one, you'll notice that they're both in sync. And this is because they're connected since we're displaying the same integer slider. And I'll do one more to drive the point home. So right now, when I change any one of these sliders, I'm just displaying W. And so each of these cells is going to display W. And we can actually close a widget by calling the close method on it. So I could do something like this and close all those widgets. And if I wanted to delete that output, I could just press exit there to hide any output. So all of the IPython widgets share a similar naming scheme. To read the value of a widget, you can query what's known as its value property. So I could say, if I display W, remember that's our, whoops. Since I closed it, I have to reset it. So I'm going to say W equals int slider, and now I can display it. So we see here. So that widget is going to have a value property, and I can actually call it like so. and it will tell me what the current value is at. So notice how I move the slider here to 22, and now if I call the value on that W, it sets it to, or puts out 22. But I can also set its value property. So I can say value is equal to, let's say in this case, 50, run that cell, and notice how the slider changed for that. So in addition to value, most widgets share keys, description, disabled, and visible. So to jump to the notebook to show you this, they share keys, description, disabled, and visible. So regardless of what the widget type actually is, they should have these 4 properties to them. So if we call keys on that variable W, we notice we get a bunch of various keys that have to do with the integer slider. And we'll go over these a little later. A lot of them have to do with styling, so you can actually style this slider to look however you want it. From the border size to the font size, color, etc. Remember, you can also set max and mins. So there's a lot of different things you can change here. And we'll get to that in the styling lecture. There's also a shorthand for setting the initial values of widget properties. So while creating a widget, you can set some or all of the initial values of that widget by defining them as keyword arguments in the widget's constructor. So for example, another widget that we've encountered is that text box widget, which is just text. And I can enter the value as hello world. And then I can input disabled equals true. So note if I put disabled equals true, I can no longer edit this. But if I put it as false, then I can come in and edit whatever is in that text box. So let's go ahead and now move on to thinking about how we can link 2 similar widgets. So you may need to display the same value 2 different ways, so you need 2 different widgets. And instead of attempting to manually synchronize the values of these 2 widgets, you can use what's known as a 𝗟𝗲𝗁 link function. So you can say from 𝗟𝗲𝗁s import link, and I'm going to say A is equal to a float text widget, and B is equal to a float slider widget. And if I call the display on both A and B, I can then use the link to link them together. So I can use it with this syntax. I can say my link equals link and then pass tuples. And on the first one, I'm going to fill out A with a string value and B with a string value. And whoops, this should have been 𝗟𝗲𝗁. There we go. And now you can see they're going to be linked together. So what did we do here? I said from 𝗟𝗲𝗁 import link, set the 2 similar widgets that you want to link together, call the display on both of them, and then in order to link them, you can say link and pass a tuple of the name of the widget and what you actually want to link. In this case, I just want to link the value. And there I can move it around and you can see that they're linked. So you can actually unlink them as well. So I can say my link and call unlink method on it. And now you'll notice that they're unlinked. So as I move this slider, nothing changes in that text box. So you should now begin to have a general idea of what's possible with the widgets and how they can interact with each other. Don't worry if you're confused about how to actually know what to call or what widgets to do. That will be further explained along in the widgets list lecture, because there's a lot of details there which you probably just have to look up as you need them. But for right now, the thing to get out of this lecture is just widget basics in general. That they each have names, you can call on them, you can set them as a variable and display them by importing display from ipython.display. You can call their values, call keys on them, and then you can see the various properties they have, which we'll learn about later on how to edit those. And again, you can be specific on some of these by passing parameters, such as disabled in the text function. Again, we'll learn more about other parameters you can pass in future lectures. And then lastly, you can say from traitlets import link, and that will allow you to link similar widgets together. In this case, we linked a float text with a float slider and passed in tuples. First argument was the variable that contained that widget, or remember that box object. And then the second one was the value we wanted to link together. And then we can unlink them by calling the unlink method on that variable name. All right, so that's it for widget basics. In the next lecture, we'll learn about widget events, further build our understanding of what's possible. Really, these early lectures in this portion of the GUI section is just to show you what's possible. Later on, you'll be able to implement them yourselves. Okay, so next is widget events. I will see you at the next lecture.